Mike died, so he
Anybody
won't be
like
able to
to?
reply.
Oh,
I'm
okay.
sorry, but
Alright.
my headphones ran out of battery in the middle of the discussion. Now I'm back again. So
Yeah,
I
what was
heard your question.
This is the same gentleman that claimed that a boat's angular size is only based on its whole entirety of the boat, not comprehending that each foot, each inch at the bottom of that boat, as it resides on the surface, will become unresolvable with that surface, with distance, not understanding that it doesn't take the whole entire boat to become unresolvable before it's unresolvable.
Well, you put it a lot more clearly than he put it, but yeah, that's what he was getting at.
My point is that the angular resolution cannot apparently obstruct the boat. At any rate, it can only make it appear more like a blob, you know, that you can resolve less amount of details, but it won't.
No, so
that's double
apparently
speak.
one object
What are you doing?
in the front of another.
It can't do this, but it does do this.
So
Is what you said effectively.
let me explain it real quick, right? So a surfboard or a kayak on the surface of the water, as it goes out in the distance, will that become unresolvable before a boat?
That would depend on the size of the kayak, on the distance, what's the final rate between them that it gives the
I'll make
angular
it very obvious. A kayak and a cruise ship leave the beach and they go off in the distance. Which one becomes unresolvable first?
If you used an optical instrument like a telescope or high zoom camera, that
your eyes, we're just using your eyes, bud. You are looking at these objects going off in the distance.
It's a one or the other type
so
answer.
it would be obviously the kayak that would disappear first.
Cool. So if we tie the kayak to the back of the cruise ship, does it then change the distance in which that kayak becomes unresolvable?
No, it doesn't.
Okay, cool. So that portion of the boat that is above the water, that is the size of the kayak, becomes unresolvable when the rest of the boat is still resolvable. Thank you very much. That continues as you go further off in the distance. This is how bottom-up obstruction takes place.
Maple. That's a really
It's not my fault you can't comprehend it. Not my fault you can't comprehend it.
Bottom of the cruise ship will still be visible because it will be bigger than 2 arc seconds. The kayak will be smaller than 2 arc seconds, which your eye will not be able to resolve. So you will not see the kayak, but you will see the bottom of the boat that the kayak is tied to.
That's not correct, because
this guy's
That's correct.
Your angle to the bottom of the boat is going to be the same as it is to the kayak, thus proving that it's not the whole entire object. It's an angle to any portion of that object that is going to be unresolvable due to the fact that your angle to it has become so acute that it becomes unresolvable.
Thank you for not
Hey, real quick.
You're talking through me, bud. You got to let
Yeah.
me finish, and then you can rebut me.
Yeah, Napalm.
That's why I didn't stop.
Don't interrupt him just to tell him that he was talking too long. He wasn't done.
Yeah, guys, you gotta be a little bit more considerate. You know, when somebody's trying to give their answer, we don't need to be talking over them. And who is that? Run, Boston Bear. You're hot micing real bad.
Oh yeah, Napalm's a fucking gentleman. I mean, he's an absolute gentleman. Ridiculous how nice this guy is.
Hey,
Well,
sorry about the.
It's funny that their only rebuttal is that they have to take into account the whole entire object, as if that object doesn't have a portion of it residing on the surface, very close to the surface, right? So when we talk about unresolvability, it's because of two different things, meaning you can no longer distinguish the difference between the sea or the surface, however you want to define that, and the boat itself, because your angle to both of these objects, that the difference between the first inch of the water and the first inch of the boat is such a small angle to your eye that it becomes unresolvable. You don't have to take into account.
But that's not how it works. But that's not how it. How it works is this.
That's exactly how it works.
No, let me
hold on.
I heard you. Let me respond. It'd be a quick response. I promise. You're telling me that just because what's near the water is a small angular size doesn't mean you can't resolve it if that angular size is within your resolvable limit. Now, you might not be able to delineate between the surface of the water and that object, but you sure as shit can see it based on the Rayleigh criterion and the diffractive limit of that object, even though it's above the water. You can't tell the line of the water and the object because they merge together. You can't tell that they're two objects. It might look like a nipple on the water.
It becomes
like one. Hold on, real quick. But
you said quick.
I know, but I just have to be more emphatic that object that is 0.02 angular size, that's the limit, can be seen even if it's next to the water. Thank you.
Is it ironic, Napalm, that the diffraction being two wavelengths where they meet at their peak, etc., happens to be where you can't resolve the image, and then they go to boats with waves and where they meet at a point against an object, and you can't.
That isn't what those aren't waves. That's a graph where you can and can't see.
Oh.
Yeah. Basically, if something is less than 2 arc seconds, your eye can't resolve it. So if they both would be less than 2 arc seconds, you most likely wouldn't see it. If you used an optical instrument that has higher optical resolution, like resolving capability, then you would be still able to see it. It just depends on how small of an object you can see with the optical instrument that you're using, and your eye is a pretty poor one.
If you had a
Oakley used to use the same. Oakley used to use the same kind of thing that you were saying, Napalm, and I've heard it. I've argued it myself. Where if you take a brick, you slide it away from you, until you can't see it anymore. But then if you keep building if you were to build a giant wall on top of that brick, you would see the upper bricks, right?
Yeah. So here's the thing. Your angle to the upper bricks is larger. It's a larger angle than it is towards the surface. The surface, right? That angle is always going to be more acute, meaning anything between the surface and your eye line over distance is always going to be the most acute angle. And then you get to the point where you have this diffraction line, right? So it's slowly becoming unresolvable from the bottom up, and then you hit the diffraction line, and then it's the steep curve. At least in my opinion, you have this steep optical effect that happens once you hit the diffraction line. So it's taking place slowly over distance, and then it's a huge steep curve once you hit the diffraction line. But that's just my opinion on how vision works. But whatever.
The thing is, though, with that brick analogy, hold on. With that brick analogy, though, if you were to take one brick and move it, I don't know, 100 feet above your head, and then move it out horizontally till you couldn't see it, and then build a wall underneath. Somebody's hot micing. And then built a wall underneath that. Somebody's hot micing.
You still can't see the individual brick.
And then you built a wall under. Hold on. And then you built a wall underneath that. Would you be able to see the top brick?
No, so there's no floor that's setting the steep angle. It's two different things. You can't remove the surface from the equation, which is what everybody tries to do. Like if you take this object and you just go straight up in the air and you're laying back on your back, you're not going to see bottom up disappearance because you have no floor that's setting a limitation, right? So it's strictly going to be unresolvable based on how it changes over distance. The problem is when we're talking about things over distance and a ground, we're fairly close to the surface. So that surface is setting, like, for lack of a better term, it's setting the floor. So that is always going to be your smaller angle. So you're going to lose some resolvability at a relatively slow rate as you're going off on the distance, depending on how close you are to that surface. And then once you hit the diffraction line, then it's going to be a steep decrease in resolvability from the bottom up because that diffraction limit has been set there. That floor, it's like almost going over a cliff at that point.
Okay, a little bit of monologue there. Listen, that's incorrect. And Jeremy had a good point there about the bottom brick, the Nathan description. And he put it in the sky. Put that brick in the sky. Can't see it. You start. Let's say this brick can grow horizontally in your field of view, up high, looking way above you. By the way, Napalm, there's nothing in any of these equations that ever has to do with an angle, an acute angle, or an obtuse angle, anything. By the way, but anyway, get back to the analogy.
The criteria, dude.
Hold on, just before I'll be finished with the analogy with Jeremy. Well, I'm traveling and I'm trying to go slower here. So
Well, then
real
focus
quick.
on traveling and shut up.
No, let me just finish the thought here. I know you can hear me.
What thought? You
So we
only
have to
chime
break
in
it.
to insult
We have.
people. That's incorrect.
No,
You're wrong.
not.
Blah
I'm
blah
not.
blah blah blah. It's
I'm trying to
boring.
build. Hey, why are you letting him interrupt me?
It's bad enough when your microphone works properly, and now
Hey,
your
what,
microphone's
stop
terrible.
interrupting me.
Elijah, just
Fucking
let him
hey,
finish.
Elijah. Thank you.
Just finish, Xander.
So yeah, real quick. So if you take that analogy that Jeremy said, and a brick's up in the sky, and you can't see it because it's below 0.02 resolution, and you build bricks on either side of it. Let's say it grows, and you still can't see that. Pardon me?
I already spoke to this. Did you not listen in my response?
Well, I was, but I want to say
in the middle of doing a bunch of shit.
I'm not talking to you about that. I'm talking to Jeremy, and I think it's a great analogy that you still can't see the individual brick. You can't reserve it; it just be a blur, but you know it's there. You can't verify it by looking at it because the brick is too small. It blurs into the rest of the object. The larger angular size stuff will be able to be visible. It doesn't disappear, in other words. And just because it's near a surface has nothing. Hold on. I know you're dying to get. I heard you monologue for freaking 5 minutes.
I thought you were done. Keep going.
I'm not done. You know I'm not done.
That's why I stopped and I didn't continue. Keep going. Fuck's sake.
I'll be done in a second.
Anyway, I'm limited in time.
Stop it. The angle, the acute angle or obtuse angle, any angle to the surface has no bearing on what you can see or not see. It only has to do with whether you can just see a line of delineation between the two objects. The object itself is strictly related to the diffractive limit or your limit of angular resolution. Thank you.
Yep, you just said absolutely nothing that dealt with how I already responded to that. So thank you very much.
But you didn't hear it.
I even gave the example, laying on your back, looking up at the sky. Maybe you just didn't pay attention because you're not dealing with the ground. You're not dealing with the smallest angle, which is being set by the ground because of how high you are from that. It absolutely does matter. Just because you don't think it does doesn't mean that it doesn't.
Your opinion said, you've admitted it was your opinion.
Your
You're
opinion
wrong,
doesn't matter.
and I can show you why you're wrong mathematically and in physics. We can tell you why you're wrong.
I don't know. Somebody's muffled out, but yeah, like I said, these arguments are always the worst, man. They're always like so subjective. Like you're never gonna pin each other down and agree.
Yeah. Witsit said it best. It's like Groundhog Day. You can predict pretty much how these conversations are going to go.
I mean, I'm just hearing it's just like science deniers, right? Like just denying refraction limit and diffraction limit and Rayleigh criteria. Just deny.
Science deniers. That's what they should be called.
Tanks.
Science deniers Globe Edition. Welcome to the room. What's your poison?
I'm in.
Tanks. When you have that 300-foot ship.
Why?
Tanks. When you have that 300-foot ship and all you can see is the smokestacks, where is the rest of the ship? Where did it go?
It's still there. It's not invisible.
Then why is the angular position of the smokestacks not?
I can prove it.
Are you not listening to me?
Yeah,
you just talking over me. No, I said, why is the exhaust in a different angular position in your field of view near the water when actually by their size, where they are above the surface, would put them far above the water, yet we're seeing close to the water. So the angular position is wrong, the ship's missing, and you're saying it's missing because of reasons.
Yeah, it's not actually disappearing.
No, that's what you said. Like you just straw man everyone and talk shit.
Yeah, I can prove it. I can walk in a straight line, or I can measure a straight line, a horizontal line, and I can walk in that straight line and touch it. It didn't disappear. It's still there.
What you said, what that even means, but that's just me.
Yeah, I mean, I can do it with my eyes closed. I can confirm that it didn't disappear behind anything, that it's still there. It's just an optical.
It's almost like you weren't even listening to what I said. It's almost like you didn't even hear what I said.
Irony Man strikes again.
Yeah, it's not a bad idea.
Yeah, I mean, so with your eyes closed, is the Earth flat or is it a globe? Like with your eyes closed.
Well, it's definitely not spinning when my eyes are closed. What's good, Elijah, by the way? Welcome to the chat.
Anyway, happy 4th of July, everybody. Hope you guys are enjoying it.
Thoughts, doing, Zanik?
And I'm over at the Delta where they have these 3-mile long, perfectly flat canals. I'd love to take Jesse in that big line of twine he purchased to do that experiment here. And I should have brought my telescope too, because there's some really cool things you can do over water that is exactly straight for, 3 miles.
That's great.
Conditions.
That's cool. You like talking?
Yeah, the Earth is a globe, over water mostly, right? But contrary to that, surveyors know the first thing not to do is to survey over water, but it turns into a globe over water. It's pretty cool.
Again, you can not to go back to what I've already said, but I'm going to say this: differential measurements will determine what the refractive value is at any elevation, and what the surface shape would be. It's not until you do that you can actually have a reasonable
surface. Doesn't have a surface has coplanar points, no shape.
Or does the circle have coplanar points? Does the sphere have coplanar points? Does the sphere have coplanar points?
You want to reverse engineer your perspective into what the ground is doing, and it's really weird, man.
No, it's not really weird. It's basic
yes, it is.
geometry.
It's just a basic way to explain perspective. It's a basic way to say, oh, that's because we live on a sphere, rather than actually understanding how your eyes work.
And see how your eyes work. It make any difference because you can have a camera that can see the exact same thing your eyes see.
So a camera sees the same thing your eyes see?
Yes.
Okay.
Is that right? Interesting.
Yeah.
Really interesting statement. Wow.
Let me guess. You're the citation for that, Zanik, yeah?
I'm the citation. You know that. Come on. Where
Yes. Yeah, just the proof of idiocy. That's what that is.
Okay. Okay. If the camera sees what your eyes see, can we bring it back to the star trails argument where they were saying the whole reason that the stars diverge and converge is because the camera, the CCD and the camera lens is flat and your eyes curved, so the camera doesn't see what we see?
No, the camera's not seeing anything different than your eyes see. But what you haven't said is you haven't talked about the time lapse. We don't have a time lapse mechanism in our brain. So if we look at a star,
but eventually over time,
you can't just stay still.
Eventually over time, you could stay still. You could keep your head still like the camera and just wait, and you would see the stars getting farther apart or converging.
No, they never get further apart. They always stay at the same distance.
We see that with the camera, though. The camera sees that.
Only when you do time lapse.
Okay, only when you look for a long time. And then if we look for a long time, we would see the same thing, right? The stars diverging and converging. Obviously not the trails, because we don't see trails, but we would see their positions, and their positions would be converging and diverging, right?
No, a better approximation and representation of what your eyes see would be to have the stationary mount, the equatorial mount, and that would allow you to do that. So no, that's incorrect.
Yes, we keep the camera stationary. We can see the stars converging and diverging over time. We keep our head stationary. We see the same thing the camera sees, right? The stars appearing to converge and diverge over time, right?
What you see is equivalent to the equatorial mount, not a time-lapse camera, which is using perspective to show a curved and diverging path. We don't see curving and divergent path. If you look at any star in your field of view with your center of your eye, it'll always be the same thing in the camera as it is in the center of your eye.
It's
regardless
of
what
perspective lapse, right? Is that what you're calling it? Not a time lapse?
Equatorial mount?
You just said
an equatorial mount, not a perspective. Equatorial mount would stay constant with the rate of rotation there, and all in the sky itself would move in unison without any angular position change of anything over that period of time that you have it exposed. Not exposed, but multiple frame rates. One's doing frame rate, one's doing
speaking, but for sure you're probably done talking.
One's exposure and one is frame rate, so they're different types of tests.
Yes, a lot of double speaking.
Well,
There's no double speak there at all.
Yeah,
You
we're going back to
speaking
things, Zanik. Yeah, I mean, if
No
there's
double
like a little bit of a No double speak. All right.
I'm being very clear and concise, and I'm being very accurate about my descriptions. You're not taking
You're the
just
best.
because you don't understand them doesn't mean it's my fault.
Yeah, I guess if we're going back to things, right? I just wanted to kind of just hear, I guess, it's about you too, right? So, you had said earlier that, so things appear to rise to eye level due to perspective at ground level, right? But then you said, no, that never actually happens, right? Is that right or is that wrong?
Right.
But do they ever actually get to eye level ever or no?
Get to eye level. What things are you talking about? Sure, something that's going to be moving away from you at eye level will stay at eye level. Things that are below eye level that move away from you will never get to eye level. Sure, they will always go up in your field of view, but they'll never get to eye level.
So no matter what, nothing will ever get to eye level.
Did you not hear what I said?
No, I didn't.
If I follow,
I'll say it again. Things at eye level. I'm repeating what I said because he didn't get it. Obviously, things at eye level will stay at eye level as they move away from you. Things that are below eye level will appear to rise eye level, but never get there. They'll never reach eye level.
Okay.
Hold on a second, Xanic. I can follow the sun and the moon with an equatorial mount, right?
Yes, you can.
Okay, now would you agree that the sun? Okay.
Holy shit, Brian! You just went back. You doubled backwards. Like I just wanted to clarify something while we had a minute, but then you went right back to the equatorial mount. While I was just like, hey, let me ask him about the thing.
Shit, dude. He's acting
That's Brian's way.
Well, he's acting like we can just set the equatorial mount. He's talking horse shit though, man. I had to
Brian, there's no need to call names and be insulting. We talked about not doing that anymore. So I'm not calling you an idiot, although I want to.
Where I'm at. Here's where I'm at. I'm right past Cancer. Okay, about 7 degrees past the Tropic of Cancer. So when my equatorial mount follows the sun, doesn't it watch it come from in the summertime from the north and then go right overhead and then deviate off back to the north? You're acting like we don't see deviation. You're acting like the equatorial mount proves no deviation. The equatorial mount literally demonstrates the fucking convergence and deviation, bro. You're full of shit, dude.
All right. Why don't you go find an equatorial mount example and show it to me, because I'll show you thousands of it. Okay. Well, go show me the time lapse. Show me the time lapse photography. Show that the entire sky moves in unison with other objects moving through it, and you will see what I'm talking about. But until that happens, Brian, we have no conversation to be had here.
Danik, if I take my equatorial mount and I literally watch the sun or a star start from the north, converge overhead, and then deviate back off to the north, and then start to straighten out over the equator, okay, and even smaller loop if I'm looking toward north, you obviously don't have an equatorial mount, bro. You don't even know what you're saying.
I don't think you've ever really even seen an equatorial mount camera or footage
Janet,
or
do you have an
picture.
equatorial mount?
So
Yes or no?
I have, and so I can show you some, and I can actually produce that. Why don't you if you want to show me your point, show me. Okay, I'm not going to do that. I'm going to get muted and banned, so I'm not going to talk to you anymore, Brian. Sorry. Thank you.
That's what I'm saying. Pre-ban yourself. If he had an equatorial mount, he wouldn't be saying this, bro. Because if I lined up with two stars, if I had two equatorial mounts back to back, one pointing toward the south, like southeast, and one pointing toward just like northeast, and I tracked a star, respective stars, it would literally do a frown and a smiley face. Literally, it tracks out. It's not just one axis. If he had an equatorial mount, he'd know it ain't just one little pivot. If that was the case, then you could just buy your equatorial mount and set it for each latitude and just track every star. So you just tilt it down and it does a pivot. It's like two axes. If he had an equatorial, he's just acting like he has one. I don't believe him, or else he's never used it. In fact, you don't even need equatorial mount. A stick and a shadow will show you the smiley face or the frown, depending, like the frown during winter solstice, the smiley face during summer solstice. Depending on where you're at. So Jeremy's right, dude. You watch some star trails, you get a little deviation. It's not like a giant. I mean, it's there. They don't want it to be there because that shit don't work on a globe.
I mean, if you want to say our eyeballs are seeing what the camera sees, fine with that. That means the positions that the camera sees and the positions that our eyeball sees are going to be the same. They're equivalent. It's the same. So if you take a time lapse of star trails, obviously you're not going to see the trails, but the positions of the stars will be the same in both cases. They have to be if they're the same. That's what the same means.
And that's what I mean when I say we could use sticks and shadows to show this. Like I've got flags laid out right here that I did the other day, and they're showing like a little frown, and then different times of the year, when the sun's over Capricorn, it shows the smiley face, or vice versa. I get them mixed up, but literally the shadows literally traced out. So that's depicting what the stars are doing. The sun for that day is doing exactly what a star is going to do for that night. Whatever declination it's at, it's going to follow that particular star for that 24-hour period. And the shadows literally spell it out. They draw it out for us on the ground, the deviation and the straightening toward the equator and shit. The shadows
Somebody
themselves.
sees Pete Shea, dude, smack him for me. Just had my son come up to me and tell me that Neil A for Armstrong backwards is alien. About fucking puked in my mouth. If he would have said "Go north, Mr. Alien," dude, I would have fucking lost my mind.
Dude, the Glovers don't want to put this argument together with these shadows because they're like, you can't get shadows from the stars and shit. I'm like, no shit. And the sun can't be in more than one place at one time. But just a little bit of logic, man. We know that like I said, the sun, it tracks exactly how the stars do. It would have to on a globe anyway. For whatever declination it's at, it's gonna take the same path. Same thing with the moon. Just for a 24-hour period, they're gonna all take the same path.
But I don't
And
know.
so
Hold on. I agree that the sun can't physically be in two places at the same time. However, optically, if you ever try to triangulate anything in the mirror with two people, they don't get the same position. So literally, what they're seeing is in what appears to be like it's in two different places at the same time. But obviously, it's not actually in two different places.
Absolutely.
yeah,
I agree.
I agree. We definitely get
It's apparent.
apparent locations. I definitely agree with that. But do y'all see what I'm saying though about like using the shadow? Like in other words, if we could get a shadow from a star, a shadow that's over 30 degrees north would trace the frown, or I mean the smiley face, and then a shadow from a star that's over like 30 south would do the opposite. They literally, like, the sun shows us this. Of course, we have to wait a whole year, like, or 6 months to show that, but we can, like these flags that I laid out to follow the shadow, or you can use little sticks and just set them every 10 or 15 minutes to trace the tip of the shadow, and it'll literally make that same. It makes that path. It's not like it's not like a giant smiley face. It's just a gentle little slant, but it's most certainly there. And so you got to wait 6 months later and lay another pattern with the same stick. You don't even have to move the stick, and it'll lay out a frown, like a gentle little frown. And so that's the same thing the stars are doing. Uh, if we could get shadows from the stars, that's exactly what they show us.
I don't know. We got to do something with all this plastic pollution, man. It's like making its way to Mars.
I'm more worried about the penguins. We must save the penguins.
Does it get to Mars via the radio waves, Tesla?
I'm not sure. Maybe the expansion of the atmosphere and microplastics coagulated and started forming, terraforming plastic onto Mars or something like. But yeah, they found a small piece of plastic on Mars.
Sounds believable.
You mean Canada?
Maybe. Yeah, wherever they're filming this shit. I got litter bugs on Mars.
Well, I have half a bridge to sell you if you're interested.
Like one other way to explain this is like, say if you pointed your telescope and you had an equatorial mount, you pointed it toward the star, and traced the, and say instead of putting your eye up to the telescope, you just let the light hit the ground. If you trace the equatorial mount, you get that same valley phase from where I'm at. And then if I'm tracing one like south, like 30 south, and tracking that line, I'm gonna get the frown. It's the same shit, dude. It's if you, even the telescope, the equatorial mount, literally demonstrates this, and that's why I had to jump in. He's acting like equatorial mount doesn't show us that. He's exactly wrong. He just says shit that I got an equatorial mount. He obviously never used it. He does. Probably just saying that, or he'd show us.
Brian, I'm pretty confident you've done way more physical experiments to back up your claims than all of these guys. The math doesn't compute.
Jeremy, you're hot micing. You're doing something funny.
I've been hot micing that whole time.
Yeah, bro, your vibrator's all up on the shit, bro.
Yeah.
Okay,
dude.
very funny. Very funny. I'm weed whacking.
You're whacking all right.
That's what the kids are calling it nowadays, huh?
You boys behind my shit whacking it.
Hey, one last thing.
No wonder he's got eye problems.
Does everybody have it in their mind? Like, if everybody's in America, I mean, we all agree we see the sun come from like a little bit north, a little bit north of east, and then it converges to east, like over our head. It gets as close to us as possible, and then it diverges back to north of east, and then when it's over the like south, like during summer solstice, we see it do the opposite. It starts further south, and then it gets as close to us as it's gonna overhead, and then it starts deviating south. Well, that's exactly what the stars do. I mean, did y'all see what I'm saying? I mean,
think
they're
you had that
denying.
backwards. I think you have that
Yeah,
backwards.
I might have it backwards. I might definitely have it backwards, but I think my point is made. Like they're not taking the same path all year round. When they're on the opposite sides of the equator, they're taking different paths, and I don't know why they deny that. They should come up with a different argument than just deny the movement of the fucking heavens. It just baffles me how they deny it even happened.
But we already established this a little bit ago. They're science deniers. The true embodiment of science denial is the glober.
I think it's reality denying is what it turns into.
Same difference, huh?
Yeah, it makes sense. They spend most of their time looking for models and mathematical descriptions of the reality right in front of them.
You know that thing they do in arguments with people? It's like, so what you're saying is, and then to twist every single word that you uttered, or just start making up words that you never even said. They do that with reality. They look at reality and go, so what you're saying is.
No, that's not what's done at all. We basically no. You said it 3 times. So we say, so what you're saying is, and we try to repeat something that we think how we understand it, so that you can validate.
So you're gonna come in. You're gonna come in and try to hyper analytically ruin a joke. Good one.
No, I didn't seem like it was very funny if it was a joke. So good one. Not.
No, because that's what you do. You look at reality. You go, no, well, actually, nah, that's not what's happening. Something else is happening.
Well, then you can say whether it is or not by your argument. So, do you have anything to stand up for that?
I mean, if it breaks off,
we just need to hear you speak. Go on, just let it rip.
Oh, but forget it. I definitely don't want to
denying the obvious.
Zanuck, why don't you come back when you're ready to open the box, bro?
The box is open.
Zanuck, would you agree the sun
show it.
Starts a little bit north of east and then converges closer to over our head?
Definitely not going to interact with you because you're just not making any sense whatsoever.
Would you agree with that, Zanuck? The sun starts a little bit north of east and then converges closer to over our head and then diverges back north of east, right? During the summer months. Wouldn't you agree to that? Simple observation, bro. Simple question.
Take your equatorial mount, look at the skies in the evening, or even 24 hours, and tell me what you see. Thank you.
So you won't even agree with a simple observation that the sun starts.
Dude, you make absolutely. I hate to say it, Brian, but you don't make any sense whatsoever.
Okay, the sun.
What?
Okay, it's coming up. It's summertime in the northern hemisphere. The sun comes up north of east. It converges closer to us at high noon, and then diverges back north of east during sunset. Would you agree to that simple observation?
You got to give him a reference frame, Brian. Otherwise, he's lost.
He won't answer a simple question, bro, because it does not compute. Does not compute. It's fucking weird, dude.
Do you have a model that you could show him?
But Zanuck, what's in the box, bro?
Come on, he can't go off script. He needs the script. Give him the script.
He can put a stick in the ground. He could go to sun calc. He could go to stellarium. He could just look at it in real life, bro. Anything. He's just denying reality, literally. It's fucking baffling, bro.
What's in the box, Zanuck? Did you ever open it?
Gwyneth Paltrow's head.
I was thinking like high heels, a wig, mini skirt, like I don't know, something along those lines. Like when his dad said he was going to NASA, it was really like something else.
Yeah. No, I sorry, I couldn't get myself unmuted here. Yeah, I can't wait I haven't had a chance to go to my mom's house, so when I go there, probably today.
Dude,
why do you feel compelled to talk when I'm speaking?
Because I don't know why we haven't opened this fucking box yet, bro. What are you doing?
No, Jeremy, sorry, you can do it.
You're stalling.
Believe me,
there's a person
I'm not stalling, but I'm so excited about it. That box, the picture of it, I showed my brother, and we're like, "Fuck, we got to get that box open."
You're stalling.
I'm not. Anticipation doesn't make the actual event give it more exciting. It's exciting. Tension's building.
Bro, this is women's
clothes and shit in there, bro. Women's.
What if it is? What if it is? Wouldn't that be funny?
Zanuck, this isn't sex. This is a box in your attic. Just open the shit, bro.
I should open it when I was there, but I was in the middle of some other technology. I couldn't do it. But I'm going back.
You were in the middle of a debate with us. You had plenty of time to open the box.
No, I wasn't taking. It wasn't a live picture. I was taking the day before, so I could show you guys the box and get you excited about it.
You came out and said, I got a box and I don't have time to open it. And then we proceeded for like 30 minutes to argue about some other shit. That's what happened, bro.
And I could have driven over there and picked it up. Right, I didn't.
Yeah, why didn't you take
some undeniable
how big is your box?
It's like
how big is your box?
2.5 feet by 2.5 feet, maybe? Maybe 2 feet by 2 feet? by 2 feet, 2 feet square. 6
Why
square
did you
feet.
take the box with you?
Oh, because it was up on that rafter. I took a picture from the. I was doing something else. And I had to get out of there. I couldn't stick around.
Oh, now it's on a rafter. I know.
In the attic. I told you it's in the attic.
Yeah, he did say that.
It's in the attic. I told you that. I'm gonna get it. Believe me. You don't think I'm gonna open that box up and I'm gonna tell you what's in there? I promise I will.
You're probably loading it with NASA bullshit as we speak.
Yeah, I'm gonna be like what's his name? Like Waterman. I'm gonna go to the friggin' thrift shop and here's all the NASA's hidden technology. I'm gonna buy a bunch of it and stuff it in the box. Bunch of papers, bunch of binders. Shuttle.
I was gonna put a
shuttle
I was
project
gonna put
2.0.
I was gonna make a box last night. I don't have a good box here to do it with, but I was gonna make a box, write NASA on it, and then put a whole bunch of stuff in it that says the Earth is flat and shit. All the documents.
Party
I was gonna
favors.
actually just print off all their documents they say about how they use a flat stationary planar Earth and put that in the
Right.
box.
Confidential.
That's the
Don't tell
documents
anybody.
they have.
Right? Don't tell anybody.
Yeah, that'd be a good
Jerry.
That'd be a good picture, Zanik. You should change your picture to that.
I should, right?
Danik,
Yeah.
would you agree?
To the
Danik,
net.
would you agree that? Go ahead, Jeremy.
Change his picture to the NASA box. Just take a picture of the box that says NASA on it, and that's his picture.
Yeah.
Go ahead, Brian.
Yeah, Danik, would you agree that if I was at the equator and I
Oh
took
my
a
God, I'm not
star,
talking to you, Brian.
and
I don't want to talk
this
to you.
is
You're obnoxious.
Man, it's a simple question, dude. Okay, I'm
It's
trying
not a
to be
simple question. I don't even know what they're asking.
Yeah, well, listen, dude. If I'm at the equator and I track a star coming from the east, coming from due east, if I'm at the equator, I can track it and it'll go straight over my head, right? If I'm tracking it with equatorial mount, it's going to go right over my head. It's going to rise due east, get right over my head, and then set due west, right? Is
I
there
don't know.
anywhere else on
What?
Earth? Is there anywhere else on Earth I can do that? Can I go to 30
What?
north and pick one due east and track it right over my head and then
Brian,
straight
you might as
due
well
west?
be speaking Swahili. I have no idea what you're talking about. What's your purpose of your question? Maybe that's a better question for you. What are you asking?
I'm trying to. I mean, you don't seem to think things happen the way they do. I'm just asking. Did you agree that I could track the sun straight over my head and at the equator? Simple question.
It depends on when. It doesn't happen all the time.
If a star though, that the sun might not, but a star that rises due
Brian,
east.
now suddenly
always
that's
go
not
right
the
over my
sun.
head
So which
and
is
set due
it?
west, right?
You can't even get a
Any heavenly
coherent
body.
thought out.
Any
Brian,
heavenly
let me try,
body that
Brian.
rises due east.
Brian, no one understands
Brian,
what you're saying, so I'm just gonna.
Brian, let me
I don't
try.
engage with you.
Let me try, Brian. Zanik, I'm underneath I'm at the subsolar point of one of the stars on the celestial equator, right? I track that. That makes a straight line, so to speak. It doesn't deviate left or right, right?
Straight line, so to speak. So that's not really a straight line, is it?
It doesn't deviate left or right.
Okay.
Is that level or plumb?
Is left to right the same
It
as when you
doesn't
start
matter.
as when you finish?
Dude,
Or
you
the
know,
greater
it's like
circle?
your great circle. It's like your great circle route. It doesn't deviate left or right, right?
Is there a gerbil involved, first of all? Are there any gerbils being hurt in this particular experiment?
Dude, there's no what? Listen, stop. Everyone, just give me 2 minutes with Zanik. There's a star above your head. We can draw a line on the ground of the subsolar point. It goes in a straight line, meaning not deviating left or right, right?
Okay.
Is that correct? Could we do that if we wanted to? If we were at the celestial equator, substellar point.
Substellar point? What's a substellar point?
We're underneath. We're directly underneath a star that's on the celestial equator.
Okay.
Okay, and we draw a
Got
line
it.
on the ground of the substellar points of the line that path takes. We draw a line. That line doesn't deviate left to right, right?
Correct.
Okay, and now we have another line. Now we're going to go north a little bit off the celestial equator. So we're going to get out from underneath the celestial equator. That line is that line, and now we're going to trace a star that's directly above us at that point. Is that star going to deviate left or right?
It might. I think it might have a smiley face path on the ground.
Okay.
I don't know.
And then
I
if
haven't
we
thought
go
about it.
south of the equator, it's going to be a frowny face.
Yeah, but what's your point? What are you getting at? I mean, I haven't really thought it through, so I'm not really.
So we now have lines on the ground of these substellar points. One of them is going in a straight line, not deviating
You've
left or right.
projected, yeah, you've projected those GPs or their positions in the sky onto the ground. Okay, good.
Yeah, well, we could do it on whatever. But there you go, Bry.
On whatever, whose favor.
Go ahead, Bry. My wife just came in. Go ahead, Bry.
Oh boy, I'm not engaged with Brian. It could be dangerous. I don't want to get banned.
Why would I get you banned, dude?
I figure out a way to hang their water.
Conspiracy against me. You guys put Brian as your front man to come after me and find my weaknesses and exploit them.
Bro,
One weakness is
calm
tolerant.
down, dude. Me and you clash, but dude, when me and you
Do I not sound calm? Do I not sound calm to you? You even doing it subvertedly. Yeah, you're doing it now, talking over me. Okay, I'm gonna stop.
I think your weakness is cocaine, but that's
gotta be. He leaves a
Do
little
I sound like I'm in the influence of cocaine? All I hear is people talking over me.
Anytime I talk, he talks and then says I'm talking over him. Bro. He won't have a conversation with me back and forth.
Isn't that funny how that's the only person that should have that problem with is you?
Yeah, no other channels do you ever get muted. Just this channel, right, Janet? So full of shit, dude. God, yeah. He don't want to talk because he can't respond to this. The other night we had a perfect conversation. I mean, other than when he jumps in and I get fired up. Yeah, as long as we're taking turns, bro, we have decent conversations. But he has no response to the fact that what Jeremy just did a good job of pointing it out. With the solar or stellar points. The stars right there at the equator. They go right overhead. You move north, they make the smiley face and the frown. There's a lot of different ways to lay it out, and he could try and confuse them. But you do the equatorial mount that shows you the smiley face and the frown and the straight line. You could use sticks and shadows. You could use stellarium. It shows it in time and date. Shows it, and just looking at the sun, just simple observations with your own eyes show it. Shows the sun or stars converging and diverging. They deny this for some reason because they know that you can't have that simultaneously and maintain a globe. Don't work. When they show that projection, they show the stars going parallel around the globe. They show the view like a God view, and they show a ball with a bunch of stars trailing, and then they get up under it, and all of a sudden it starts showing like deviation and coming together and spreading out. Like what changed from being above it? Now all of a sudden, when you show me underneath it, all of a sudden I get the convergence and the deviation. Like it's so dishonest. Even their little examples are freaking trickery. Like the way we see it from above, that's how we should see it from below. They show a whole different view, and it tricks a lot of people. It tricks a lot of flat earthers because they don't think about it. This is one of the things I look into, and I see the deception.
Hey, Brian. Here, I think I made a visual for what you're describing, Leaky. Use the Bislan's model, but so I did the difference between the sunrise and sunset in the same spot in the Northeast in America on like the summer versus winter solstice, and it arcs in like reversing direction. So now that I have a visual, I see what you're talking about.
Can you put that in live stream?
Yeah, man.
Hell yeah. What's up, Shane?
What's up?
Where
Oh,
you been at, man? Where can I find you at these days, dude?
my server or hanging out here usually.
What
But
server is it?
the ADL. I'm not on Discord a bunch, really.
Okay.
Mostly in the nights. But dude, so like you're talking about this effect because I never considered what like the sunrise angle for an observer would be compared for like the solstices. So in the summer versus the winter, when the sun is closer versus farther, it does make like if it rises like a little bit north of east for an observer in the summer, then it would be a little bit south of east in the winter, right? It makes like
Right.
a smiley versus a frowny face, as you so eloquently put it.
Right. And which is fine, but if it's us moving, you couldn't have that
Right.
simultaneously. Like so you could show it with the sun doing different tracks, but we know that the sun, basically wherever it's at, the stars that are at that same latitude do the same exact thing. So so they're constantly doing it, and they're doing it every day. And star trails do show it, and so does what you just showed. That's another example. That's a really good example. So it can't simultaneously do that if we're the ones moving. You know what I'm saying? It makes you think in your mind that yeah, that's perfect. That proves a globe. And in your mind, you're thinking that's good evidence for a globe, but that's a globe destroyer. If I'm the one moving, I can't get in other words, the ground couldn't know that I'm moving two opposite directions simultaneously. It's not possible. It can't work on a globe. You feel me?
I think you mean like unless the globe spins independent of its three axes of wobbly in the summer differently than in the winter. It probably has
Exactly.
another axis of wobbly that accounts for it. Or maybe it's like
Exactly.
that northern hemisphere refractivity or
But
something.
here's the thing, though. No, the stars above the southern hemisphere would have to know that we're on a globe and know to behave differently than the stars over the equator and the stars over the northern hemisphere. Wait, we're on a globe. We got to go this way. And then the
Unless
stars, yeah,
unless the whole thing is driven by optics and then the sun's position further away from you in the winter accounts for this. Weird.
it seems to be some kind of optics. I mean, it'd have to be, or else there'd have to be more than one rotation. So that's pretty much to me the two possibilities. It's got to be some kind of perspective, or it's got to be multiple rotations, literally, because we can measure it. And I think it's a point not brought up enough in this in this topic.
Unless what we're saying is correct, and that the observer-based azimuthal grid describing the curved limit of visual space is the responsible factor for why things set in the first place. That goes beyond your view, beyond your ability to see it. And in the summer, it's different. It's at a different elevation and angle than the winter, and then that would account perfectly for the summer rise and the sunrise angles differently in the winter and the summer solstice.
It would, dude. It's like when they see that though, they think somehow like the whole sky should shrink or something. Like I guess like when you get close to the south and you're looking south, like they see the uh the star trails, they just think star trails, and they think like maybe the whole night sky just reduces into little circles or something. Like I don't know what they're thinking.
Well, dude, an
Like probably
equatorial mount. You guys were talking about that earlier. That's funny because like so here's a gift someone from Witsit's Telegram made that I love, and it kind of just it exhibits what an equatorial mount does. If you're on a flat surface and the stars are in your little azimuthal grid around you, what an equatorial mount does is pretend that when you can't see the stars, they continue to rotate beneath your feet. So it literally assumes a celestial sphere. And if you do that and you line it up, then the timing when that star will come around next lines up as if it's been up beneath your feet, but it's not actually doing that, right? It's going away and coming back in the same cyclical time pattern as you're imagining that it goes beneath your feet to come around the edge of the ball.
yeah. And so here's the thing. I want that do it. Picture that simultaneously. Picture the circle of the stars that are going over the northern hemisphere and the southern hemisphere. That'd be two separate circles, right? Like if I'm looking at the stars over the southern hemisphere, I would have to, if I were looking at them both at the same time, I'd have to do some kind of inverted circle. Like I'd have to cave in on my eyes would have to cave in on themselves or something. Like it's weird because that literally shows it perfectly. I can't believe I never even thought of that to use as a demonstration. That's literally showing it perfectly what I try to describe.
Yeah, I was listening to you, but I wasn't getting it. So I went to my trusty Walter Bislin model to see if I could demonstrate what we're talking about. And look, it's perfect. Thanks, Walter, again.
Also, Walter made didn't he make the horizon calculator, like the flat Earth horizon calculator? And I think it's like 2.9 miles per 6-foot observer on a flat plane where the horizon would form due to angular resolution. And earlier I heard Zanuck and them talking about about the bricks and everything, but he wasn't acknowledging the ground in the limited angle. Like they don't like to acknowledge that, but they like Walter Bislin literally made a calculator, and it extends out on a plane. It doesn't follow the 1.22 times the square root of the observer's height in feet, but it does at, up close. It's pretty damn close, and then it starts to deviate the further away you get. Where on a flat plane you see a little further the higher you get. But the fact of the matter is there is a horizon formed and created from our vision that Globers have modeled and acknowledged, but most of them don't want to acknowledge it. They want to just stay in their world and act like they don't understand what you're saying when you try and describe the limited angle.
Dude, they literally look away from it and avoid it at all costs. They just can't even get their mind to wrap around it, because if they did, it's it. Because when you go out in reality and look around, you notice that that's exactly what you're seeing.
Yeah.
Apply
And then
it to real life, Yep.
And when you pin them down, like with a perfect example, they just act like they don't understand or don't want to talk to you no more, whatever. Their brain literally won't let them understand it. Like this happens a lot, like where their brain will just shut down. I'll even tell them before I even give them the example. And there's a few topics where I can give them a perfect example that everybody understands, and I'll tell them, you won't understand this. Your brain won't let you because it's a globe killer. Like with Orion, I'll explain the sun being on the other side of the Earth. No matter where you're at on that Earth, the sun is literally in between you and Orion's belt. And they just, I don't get it. I don't understand. Like, what are you talking about? You don't understand. Like, the brain won't let them understand. Weird. It makes me wonder if I'm doing that. Like, is my brain shutting down when they have a strong point? Like, I got to consider that because I see it where it happened with them, and I'm wondering, does my mind do that? Like, does it just shut down when they're trying to explain something that's real obvious? And I can't really. I try and come at it with a fair point of view, and I can't really think of any examples where I just like my brain wouldn't even comprehend it. But I don't know. I see it happening to them, so I got to assume it might happen to me. But nobody's been able to give me a good example of it. Because we can steelman their position, and so maybe I feel like I'm understanding it. If I could steelman it as good as any Glober and tell you your own position as a flat earther telling a Glober their own position, then that must mean I understand it. So we need to ask them to steelman when they come in with bullshit or act like they don't understand or this or that or trying to argue topics that I mean, I'm not saying the Globe doesn't have arguments, but the ones that they deviate and start red herring and going off topic, we need to ask them, back them up, and ask them to steelman our position to see if they even understand it. We need to do that a little more. Get them to steelman our position and see how good of a job
the
they
issue
do.
they're going to have there is, generally speaking, the positions that we bring forth are in opposition to their position. The only reason we even bring a position up is because they've presented an erroneous position. So they're gonna get, because unless they acknowledge that that's the case, that their position is erroneous and based on fallacious reasoning, then
it means they need a better
their
argument.
their only option is to get in their feelings. It's either concede or feelings.
Yeah. Well, then that would be a good way of pinning them down, like to get them to steelman. And if they don't do it properly, we can point that out, say and tell them, look, you don't got to agree with this, but you don't even understand the argument we're making. So you can't steel man it. You must not even understand it, which means your brain ain't letting you comprehend it. Doesn't mean you have to agree with it. But there's a couple of them. There's no way out, dude, and that's the ones where I think their brains shut down. Like there's literally no way out.
Brian, do you mind me asking something?
Go ahead, I insist.
So in the hypothetical scenario where, I don't know, you have an acceptable amount of evidence that proves something, let's say in this case that the Earth is a globe. I just because I can say that you're pretty hard in the flat Earth side, and there probably isn't much that's going to open your mind to the possibility of a globe. So is there any way that you would ever be open to it?
Wait, can you steelman the flat Earth before we go any further into this?
I don't necessarily need to. I'm just asking him a question.
See, he doesn't even know our position, and then he's
Why are you
asking
butting
for
in on
evidence.
Why are you butting in on a question I asked directly to Brian? If you want to ask me that question afterwards, you're more than welcome to. But I asked a question to Brian.
I was going to say that though. To be honest, I was going to ask you if you could steelman our position on the like the stars. But besides that, just to keep it a little more entry level, like I understand the globe model, and if we are on a globe, then I know that it has to be working the way most of the claims are made. It would have to work like that on a globe, but that doesn't mean that that's the way it is working. Would you? What? How sure are you that you're on a globe? Like, could you possibly be wrong? Is there any chance at all you might be wrong? Just seeing where you're coming from.
Yeah. So the way I would answer your question, to be open minded about it, because I like to have these conversations. Is we are on a stiffly curved surface.
Can you repeat that, bro? I lost you. I don't know if it's my mic or yours, but I lost you.
Could be me. So the way I would answer it in order to leave openness, right? Because I don't want to have these conversations to be closed off to either perspective. I would answer from my perspective in curved surface.
Yeah, you broke up again, dude. I'm afraid. You might have to say it for a third time.
Give me a sec. Is it better here?
That's better, yeah.
Yeah. Okay. Yeah, so sorry. Just okay. Good. So I completely agree with what you're saying. That too often we close ourselves off to possibilities. So the way I would answer your question is that, to me, in my perspective, is that we live on a continuously curved surface. I'm not going to call it a globe. Not going to call it a sphere. Not going to call it any of that. I'll just call it a continuously curved surface.
Like a toilet paper roll?
Sure. If you want to call it a toilet paper roll, whatever you can imagine a continuously curved surface could be, that's my perspective.
Yeah, because I would think you'd see it left to right, if it was a sphere. So what you're saying is like you just see it out in front of you all the time, like you're on a toilet paper roll.
Yeah, and I mean that's why perspective is important. You can only look in front of you, so that's why I'll say I'm not going to just flat out say it's a globe because based off objectively you can't see 360 degrees around you at all times. So I'll say it's a continuously curved surface.
Well, here's one of the points, like what he just said. Like, this is one of the points that a lot of things, it took a bunch of things for me to even consider the flat Earth, and then when you hear a lot of them, you're like, damn, that's fucking definite possibility. Like, so if I see 5 miles, like two little tips of islands, like Jaron showed it over in California, but I think it was actually 8 miles. But where you look at a boat go across, and I'm not talking about the horizon, I'm talking about an actual boat, and you could trace a path from left to right, 8 miles, a straight line, right? And then, but if you're standing on one of them islands, you'd literally see like like 30 foot, like the whole sailboat, damn near the whole sailboat disappear. So you'd see obstruction. But why didn't I see it left or right? So in other words, it'd have to be a paper, like a cylinder, every direction I look. So in other words, that cylinder would have to move around. To me, that can only work like that with perspective. Like the Earth can't be changing depending on what direction I'm looking. But that's I mean, how would you explain that on if it's a continually curved surface? Why ain't it curving left to right out in the distance?
Well, again, like, from my perspective and based off of the work that I do, the data that I get from my work would say that it does curve in each direction fairly symmetrically. But again, my point in these conversations is saying that doesn't necessarily bring anything to the conversation, because ultimately, to your point, you have to make observation based off what you can see, and I can only see in front of me. I can't necessarily see what's behind me at all times. So it's hard from that perspective to come up with a conclusive answer to say that, yeah, every direction I look in is curved, because at the end of the day, you can only look ahead of you, and you can only get a clear image of what's ahead of you and not what's behind you. But again,
can you steel man the flat Earth position, that it doesn't necessarily have to be curved, that it could be perspective? Can you steel man the flat Earth position? That's what you were asked.
Yeah, I mean, if you're asking me to steel man the flat Earth position, in what sense? In the sense that it's flat?
In the sense that you're talking about perspective, not curvature in front of you.
Well, I mean, I think you just did it for me, but
Can you do it? Can you see how it could be either way?
I personally can't, no, but I can understand why somebody would think that way, and I can be open to those ideas. Just for me, unfortunately, based on the information that I'm given on a daily basis, it just doesn't really match with what I do. But I can totally understand, again, based on a surface level, when you're looking at things, how it could definitely be that. I'm not closed off to that. I'm not one of those people that's going to say, well, it looks flat, but it's not, and too bad, so sad. No, I put some legitimate weight to the fact that there's limitations to what our eyes can see, and we can only deduce things based off what we can see. So there is validity to say that the Earth could be flat, 100%.
Yeah. One of the things is with our observations, I take the same 14-mile observation over and over, and there are some days that I can see the shoreline, and there's some days that I can't see the shoreline. So that curve, or whatever you're saying, that ever curving surface we live on, it's changing rates of curvature, atmospheric condition dependent.
Yeah, that doesn't seem right. How do you explain that?
Well, for me to explain it, I would take out the variable of eyesight per se, simply because I find eyesight is not a very good barometer for anything. I think your eyes are actually pretty shitty at seeing things, and in a general standpoint. For me, in my profession,
I use a camera to do that.
Okay, but even so, your eyes are still fairly limited, right?
Oh,
There's still things in the
something we take
atmosphere.
measurements without our eyes?
There's still things in the atmosphere, whether it's flat or curved, that will skew what you're actually seeing.
Okay,
Can we not agree on that? Right? Can we not agree on that?
So the thing that makes you believe you're on a globe isn't really relevant.
Well, the thing that makes me know that I'm on a globe is my job. My job has calculations and measurements that directly pertain to that.
What's your job?
Again, what's that?
What's your job?
I am part of an engineering firm that works directly with major housing developers to properly map out future, subdivisions and the infrastructure that follows with it.
Bro. Your job doesn't have damn dick to do with Earth curve, bro. I've been doing
subdivisions. It does, because we have to plan the routes of sewers.
Bro.
No, that's not true.
Rise over run, bro.
No, we have to route stuff for infrastructure, namely sewers. Sewers is the biggest one. So no, sewers are probably some of the better data that we have.
Sewers are fucking feet per second, rise over run. What are you talking about, bro? Sewers are feet per second, okay, with rise over run. No,
right, and sewers also need to have a particular elevation set to them at point from your various different points, and you can only do that if you have a very good understanding of the surface that you're currently working on. So yeah, sewers are very good because they require.
Wow, this is a new one. Sewers prove the curve. Okay, let's hear it. Let's hear how that happens.
Well, isn't elevation
sewers
based on sea level? And like Brian said, it's rise over run.
Sorry. Too many people talked at the same time. I didn't hear something.
Since when are we not using feet per second rise over run? Since when did that start? Like last year?
Well, Brian, the only way you would be able to determine a proper feet per second is to know at what your slope of your sewer is, and the only way to properly calculate the slope of your sewer is to have a good understanding of the surface in which you're putting it in. So before you even install your sewers and before you even get to any of that, you have to have a proper datum to figure out exactly where you're going to put your sewers, how deep you're going to put them.
You're assuming. So what's the
no,
minimum?
you're not assuming. You're using the data that's available to you to chart an infrastructure system.
So what's the minimum feet per second for residential culverts or sewage? Minimum.
I don't know the exact one. I don't know the exact measurement for that.
Then how is that part of your job, bro? I do the shit. I don't even do that every day, and I know that. Okay. Now here's the thing: what you're saying, you're literally assuming. If you're using the datum, then you're assuming curve, bro. It's not measured.
Well, how am I assuming curve? The datum is just the environment you're calculating. So how am I assuming anything? You're just taking measurements. You're taking measurements without any presupposition. You're just taking measurements that those measurements are correlated, and after that they're handed off to an engineering firm who will then try and lay out plans based off the datum. That's all it is.
Right, bro.
But
told you though.
Napalm made the point. Are you not taking off of sea level? Isn't that what your reference point is, sea level?
More or less.
Okay, so how did you prove sea level is curving?
Well, I mean, it's kind of in the name, right?
Sea level has curve in the name.
So in my industry, so I'll answer this. In my industry, level doesn't mean flat. Level would mean curved. So
no. When we're laying out these culverts, when we're laying out sewage, when we're laying out curbs, and to get the feet per second, we are literally using rise over run to get the percentage to convert to feet per second. Literally, bro. You're acting like we're figuring in earth curve, bro. We are not. You could do that in your plans.
No, you have to, Brian. You have to, Brian.
Assuming earth curve, but this how do you think we lay it out, bro?
So the problem is if you're not, so Brian, to answer your question, the problem is if you're not taking in that data correctly and you're not compensating for that in your infrastructure, what's going to happen is your sewer that's supposed to be at, let's say, 10 feet below the surface will actually end up at surface level if you're not taking into consideration those datums.
Bro, that is so wrong, dude. You're obviously not out here doing the work, bro.
Well, I am. So I am. So.
No, he said he's the engineer. He just writes it.
No, I work with the firm that does it. So there's probably.
Here, bro. I promise you're either okay, I'm not gonna call you a liar to your face, but you're ignorant of how we do it. And I promise you, on everything I love, bro, that's not how we do slopes. Okay.
Well, Brian, right back at you. You're being ignorant of the data. You're being ignorant of the industries that are dependent on this data, and those industries would not work if you think if you think somebody who's making stop. If you think somebody who's going to make a subdivision is going to accept improper datums, that doesn't happen. There's millions upon millions of dollars that are invested into this. So what you're saying is categorically wrong.
Wait, let him explain how he can get the proper datum without the assumption of earth curve. Go ahead, Brian.
Right. Here's the thing. When we do slope or grade in the field, doing any subdivision, any curb, any freaking culverts, any sewage, we literally measure it using rise over run. Literally.
Right. And what's your elevation, Brian?
You keep interrupting me before I get to my point, bro. If you want to insert, if you want to try and incorporate that onto a globe in your model, then by all means do it. But I'm telling you, in the real world, and I say, thank God you're not out building shit, bro, because that's not how we build shit. That's not how we determine slope and drainage, bro. And you didn't even know the feet per second. You didn't even know that it was measured in feet per second. So I highly doubt this is that you're even really a part of it. You might be somehow affiliated with that. But if you didn't know that, bro, then that's not what you do for a living.
So Brian, let me ask you, okay? At what elevation would you need to put a sewer at point A versus point B in order for that slope to be constant?
Rise over run. You divide the rise, the elevation, by the length. It's called rise over run. Okay, and that gives you a percentage. Okay, and then you get your feet per second flow, and it does vary like state to state, I'm sure. Okay, so I don't really know what state you're in, but I'm telling you over and over. Then you ask me how, like, bro,
right? Because you're missing
a living.
I do this for a living, and you're missing a major part of the equation. The major part of your equation is your elevation starting point. You have to set an elevation. Your point A starts, it starts at 1 point, and you need that elevation number to get your slope. That
Which
elevation.
is rise over your benchmark, bro. Rise over run, bro. You got hold on.
Yeah,
You
we're
have to
talking,
also have a starting point for your
we're
run too,
talking
right?
about the land. The land can curve anywhere, right? Like we don't have a consistent curvature to the land because the land has terrain. Terrain is going to give you your rise over run. It doesn't have anything to do with the curvature of the earth when you're talking about on land, bro.
Yeah, let's just get this straight. You do what's your name, Wilbur guy?
Who, me?
It's
Incarnation. You do rise over run for your job.
Yeah, so most part, mainly what I do is what our firm does is we set proper elevations for job sites so that people who come in afterwards, right, know what the surface elevation is, so that they can then set their proper job sites according to the elevation needed. So on a subdivision,
Hold on, Brian.
on a subdivision as an example, you're going to start off with a particular elevation, and that is what's going to set your datum for most of the job site.
Just relax. I got follow-up questions. Just real quick. You do rise over run. We can get elevation from rise over run, right?
Yeah.
Okay.
You can't get elevation from rise over run. Your rise over run is dependent on your elevation.
You start at an elevation. You make a horizontal line. If your mark's gone up 1 foot from the horizontal line, you've gone up 1 foot in elevation, right?
That's correct.
Okay. Now, tell me how that works on a ball, because if I have a basketball and the surface is all 0 elevation, and then I put a ruler on it and I say anywhere this straight line goes, that's our elevation. If I go up 1 foot, I've raised 1 foot in elevation or an inch or whatever. That doesn't work on a basketball.
Right. So take that line that you have and curve it, and it works on a basketball, and that's how we do it.
No, you don't curve the line. You make a horizontal line.
Your elevation is based.
Wait, we live on a basketball? When did that happen?
No, dude. Incarnation. You make a horizontal line. We just went through this like 5 seconds ago. You make a horizontal line. If you go up 1 foot, you've raised 1 foot in elevation from the horizontal line. That's equivalent to putting a ruler on top of a basketball and saying the same thing.
Right. And my point is in reality, if you do that, your sewers are coming out of the ground. So you can start at 10 feet. And if you run that sewer for 3 miles, it's out of the ground 3 miles later. So you have to compensate for it. That is reality.
Okay, so you're saying they don't use rise over. Okay. So you're saying they don't use. Hold on, guys. So you're saying they don't use rise over run like they claim they do, where they make a horizontal line, and if they go up 1 foot, they say they've raised 1 foot in elevation. I thought we just went through this too 5 seconds ago.
So we're going to put it this way: for every mile, you're going to have to compensate for curvature in order to keep your rise over run. If you do not do that, your sewer will end up out of the ground and not running in the direction you want it to.
Tell me how you do that, bud. Tell me how we do that, because in the real world, the ground doesn't matter. We don't look at the ground when we're laying out and calculating our rise over run. We literally forsake the ground. Doesn't matter. The ground's going to do whatever the ground does. You're taking the ground and even just you saying that we're using what the ground is doing in all these means you have no idea what you're talking about, bro. I guarantee you, bro. The ground is irrelevant in rise over run. It's what we end up with that's relevant.
Right. So, anyways, I'm not going to continue. I'm not going to continue arguing with it, bro. So you can keep saying I'm ignorant about it. That's fine, bro. I don't really care. That's the reality we live in. That's what I do for a job. I don't really care whether or not you agree with it, bro. I'm just telling you that what you're saying is demonstrably wrong, and our infrastructure has to compensate for these things. When you ask me to explain why I think that is how I know it is. So that's
if you're going to
that's it.
Listen. If you're going to come into this debate forum, when we started out with trying to steelman each other's position, right? We can't even steelman that position that you have, right? Because it's just an assumption about curvature on land, which has terrain, which varies from state to state, from city to city. That the land goes up and down everywhere. That's why they have to take a rise over run. It's not over water where you're going to have like some kind of level that you're talking about that's going to be curvature of the earth that you can compensate for. The land is always going to be different.
So
tell me, how do I incorporate curve? And if I'm going to lay out 3 miles with a 0.5% slope, how do I lay out curve in that? How? Tell me how. Give me a method of
Well,
how I would even do that.
so first of all, you wouldn't necessarily have a sewer that's running 3 miles without having any kind of deviation in it. You're not going to have a sewer that runs 3 miles straight without having any inputs or outputs on it. That's first of all. Second of all, what I'm trying to make you understand, right, in terms of topography, if you want to put it that way, we know things rise up and down. Yeah, generally speaking, on job sites and especially in subdivisions, what they try to do is establish an elevation, and that elevation will try and be as constant as possible throughout that entire subdivision. Where there's going to be differences, of course, is when you're dealing with bedrock. And if you need to compensate and deal with that bedrock, well, you either do one of two things. You either build above the bedrock or you get the bedrock out of there. You cut the bedrock down so that you can get straight.
Give me a
So,
method of how
with
I
that
do a
being
0.5%.
said, what you're saying is as true on a flat surface as it is on a curved surface. What you're saying isn't untrue. Your rise over run stays the same. The difference is on a curved surface, you're going to have to compensate your rise over run over a certain distance due to the fact that there is a curvature.
No, not at
I
all.
just
Not
asked
at
you.
all.
What is this, an assumed curvature or an actual curvature?
He's
This is an
forgetting my
actual
question, bro. How
This
do
is an
I do
actual
that?
curvature. It is in every single datum that we use that maps the entire world.
How do I incorporate this fucking compensation? How do I incorporate that into my real world layout?
So depending on how long your pipe is, you can bring in a formula that compensates. So let's use 8" per mile, which is the easiest one to use. You can take that 8" per mile and you can add it as a variable into your formula, and then you will make compensation.
Don't tell me the fucking mathematical. I'm telling you, out in the field, how do I incorporate this, dude? What do I just drop it down?
What do you
8
mean?
inches
Every
and
100 feet, every 100 feet, they usually reassess their elevation, and they make sure that they almost every 100 feet, they always will check their elevation and always make sure that they're in the right path, the right predetermined path that has all of those variables accounted for into them.
Right, rise over run. It has nothing to do with
you're
earth
telling me
curve.
that it does it automatically. So you're telling me it just happens automatically, then, right?
Most
When
people
they're
on
trenching it just
jobs.
happens automatically when they're doing the trenching for all this plumbing.
Yeah, so most people on job sites are told you need to be at this level at this particular location. Make sure you're at that level. Nobody on the field is making those calculations. They're done beforehand by engineering firms. So yeah, when they get to the job site, it's like, hey, you need to be at a certain elevation at this certain point in order for this to run. They're not doing on-field calculations about that. It's already predetermined for them.
That's for
Bro, we're the ones doing
topography.
the
That's not
layout,
for
bro.
earth curve,
That's
bro.
for
That's for
topography,
topography.
bro. Yeah, it has nothing to do with earth curvature, bro. You're totally wrong.
Bro, stop calling me bro. I'm not your bro.
You
No, you're
started the
totally
bro,
wrong.
dude. You started it.
This
No,
dude is
Brian
coming
does
at
because he
me.
keeps calling me bro, and I find
Bro,
it
you're
down,
full
bro.
of shit,
Relax.
dude.
Whatever. This is an
You won't
entire
answer my
server
question.
full of
How
shit.
do I
But if you really
incorporate
think
this?
I care about people who are full of shit calling me full of shit, I don't really care.
Bro, you're talking about what I do
If
for a
you
living
don't
now.
care,
So
then you can leave.
I'm just
Bye
asking you,
bye.
how do we incorporate it? You won't give an answer. How do you are you just saying that it just happens automatically? You saying that we look at the ground to do any of this? Because that shows you're wrong. So
We
how
use
do we
surveying
incorporate
data.
this?
We use surveying
How
data
do
to
we
establish an
incorporate this
elevation in order to
turf
have it
curve?
properly function. This is basic
I'm asking you,
construction. This is
how
basic
do we
infrastructure.
incorporate it, bro? If
I
you're the one
just told you. I just told you.
No, you didn't. No, you didn't. What's the method?
You compensate. The method is just that. Every 100 feet or so, they will recheck their elevation to make sure that they are at the right point. That's all they do on the site.
You're
That's
just saying
literally all
so it
they do.
happens automatically. So
What's that
I
got
need
to
to
do
know.
with curvature, dude? What are you talking about?
What I'm talking about is before he even gets to the job site, everything has been looked at. And we can all agree that a job site, things aren't constructed without a plan. Is it real or no?
Unless you live in
That
Texas,
has
right?
nothing to do with what I'm talking
Right.
about.
So
Like
a plan.
checking your
within a
position
plan-
every 100 feet has nothing to do with assumed curvature, dude.
Yeah, absolutely, because you need to make sure that your elevation is correct. So yes, it does. So if
Yeah,
you
but
have
that
a
has
continuously
nothing
curving
to
surface,
do with curvature. Do I
if you
need to
have a
sound it
continuously
out funny
curved
like?
surface, if you have a continuously curved surface every 100 or
Yeah,
so
but
feet,
that's an assumption. We're not dealing with assumptions. We're dealing with reality here, bro.
I'm trying to
be
remain
curved in
open
either
here.
direction, bro. The
Okay.
terrain can go up and down.
If I
Okay,
was
the
sat
two
on a
fucking people
donkey, I
talking
would
to-
be
if
sat on a
Axel wants to
donkey.
talk
It
to me at
doesn't
once,
matter,
talk to
dude.
me at
What
once,
does
and yes, it
checking
does
your
matter.
elevation every 100 feet have anything to do with curvature? It doesn't. It's
Yes,
just good
it
practice in
does.
anything you're doing to make sure you're doing it right.
Okay, bro. Let's
see
how open-minded you are. Let's run a hypothetical here. Okay, let's run a hypothetical. So if we live on a curved surface, right? Regardless of if we do or not, if we were to live on a curved surface, it would be pretty easy for you to acknowledge that there would be different elevations depending on where you are. If you're on a curved surface. So if your elevation is based off of the sea level and that sea level is continuously curving, then yes, in the construction that you have, there will have to be some compensation for curvature. This is not a concept that doesn't make sense. This makes sense if you're building things on a sphere, does it not?
You won't say
you're
how.
talking. There is no consistency to the curvature of the land, bro, because the land has terrain. It goes up and
We're
down
using
every direction.
sea level, and sea level is consistent. So never mind the land. We're using sea level. We're using mean. We're using mean sea level. We're using mean sea level to determine a surface elevation.
Hey, what
So
state
the
do you
land
do
doesn't
this
matter.
in? What state do you do this in? Do you do this in Florida?
Nope.
Okay, because in Florida we don't have all that topography, and I guarantee what you're saying right now is not indicative to Florida.
So I guarantee you, if you go talk to any major infrastructure engineering firm, they would tell you that you're wrong. And yes,
Yeah,
they do have to compensate
they're
for
definitely gonna check their sea level. They're gonna check their elevation every 100 feet because they want to make sure what you're describing would work on a flat surface or a curved surface.
I'm not disagreeing. I'm not disagreeing with it. The difference is that keeping your elevation on a curved surface means you have to compensate for the fact that it's curved. I'm not disagreeing with you on
you
that.
don't have to compensate for human error.
That's what I asked
who's
you.
denying
You said it happens automatically. How do we compensate?
Because in our plan, I've already told you, Brian.
No, you just say that we do.
I've already
You won't
told you,
tell
Brian.
me.
If we're on a curved surface, and you stretch that out long enough, your
See, you're just
elevation will
saying
actually
if, bro. You're just saying if. Look, I want to know what I've been doing wrong for 30 years. So please tell me, what have I been
Brian,
doing
I don't even know
wrong
what you do for a
30 years?
living, so how can I tell you what you're doing wrong?
Okay, laying out fucking shit that you're describing, dude. Subdivisions, okay, miles of fucking curb, okay. I've done culverts, I've done all that shit, bro.
Okay,
All the shit you're describing
culverts
is
are
what I've
tiny
done.
little
So what
things.
have I
Why are
done
we
wrong?
talking about culverts?
I'm asking you how?
Why
You're
are we
saying
talking about culverts? Well, what exactly do you do,
how?
Brian? Brian, what
It
exactly do
doesn't
you
matter
do?
how
I just
small
You
it
said what
is.
work
I
for a
did.
major construction
How
company that lays out
quit dodging.
infrastructure
Bro,
projects.
you're
Is that what you
interrupting me.
do?
You're interrupting me to dodge. How do we do this? How do we compensate? You're saying that we do. I'm asking you, how do we compensate?
Okay.
You
You asked him
dodging the question.
how. Now be quiet and let him respond.
So how do you compensate for curvature? Is precisely what you're asking?
He's saying, what's the method, dude? What's the method?
Right. So the method is to determine a elevation, and from that elevation, everything else will follow. So if your elevation on a curved surface isn't the same as on a flat surface, then your data would be different, would it not?
And rise or run is how we get rise or run is how we get and rise or run is how we hello. Can you hear me, bro? Can you hear me talking?
Irrelevant.
I don't know why you started. It's not irrelevant. We're talking about rise over run and how they use it to get elevation. Now, how they do it is they make a horizontal line.
No, they use elevation to use your elevation to function your rise over run. So you have to have something that is higher at point A. You have to have something that is higher at point A that has a particular angular velocity towards point B in order to determine your speed. So you need the elevation before you start your rise over run. It needs elevation to work. One side has to be higher than the other.
Okay, and how they know that it's higher, one side's higher than the other is they make a horizontal. Anybody can Google this. This is easy. Google rise over run. You'll see they make a horizontal line. If you went up 1 foot from the horizontal line, you've raised 1 foot in elevation. That's how they use rise over run to get elevation.
Right.
It's easy.
So in reality, your horizontal, your surface actually decreases. It actually goes lower. So to your point, right? Each time you set a vertical, you then set up a new horizontal. So this is how they do it in construction. They don't take one horizontal line and use that as their entire means of calculation. They use multiple different points. They set up multiple different verticals in order to establish different horizontals. And from that, they make calculations to determine how much they have to compensate for curve. That's how it's done in reality.
You won't tell us how, though. You just won't tell us how.
I literally just told you.
Don't interrupt.
I literally just told you.
You didn't even know. No, you didn't, because you still won't give us a method. You didn't even know the feet per second in your state, bro. The minimum feet per second. That's the most important thing in your trade that you claim that you're part of. You didn't even know the fucking minimum feet per second. I don't even know if you even knew about that or the percentage using rise over run. So you say you're doing this shit, but you can't answer any one of our questions. You still won't say how.
I just told you.
How are we
I literally just told you. They check their
just said we're
elevation.
using sea level, bro.
They
You
check
won't
their
say how do we
elevation.
compensate for Earth
That's
curve.
how they determine the rise over run. They check their elevation.
So they check their elevation from a horizontal base point.
From a planar standpoint, yes, they do, because it's the only way you can do short distance planar surveying is from if you assume that it's a flat surface. Yeah, absolutely. That's geometry 101. Who cares? What does that matter? What does that have to do with it possibly being a globe?
They're using rise
They're not
over run.
compensated.
What does it have to do with it? It was assuming it's a flat surface. What does it have to do with it being flat?
All right. Did I have a lot of background noise? Maybe. They're using rise over run to get your elevation and make a horizontal line. If you've gone up 1 foot from the horizontal line, you've gone up 1 foot in elevation. That's rise over run. Are you saying rise over run is wrong and that doesn't work and that's not how they do it?
Rise over run needs an elevation starting point in order to function. One spot has to be higher than the other. If not, you do not have a slope.
Okay, obviously that's not relevant. You have an elevation. You obviously have an elevation where you're at, and then you make a horizontal line. This is rise over run. You have an elevation, you make a horizontal line. If you go up 1 foot from that horizontal line, you've now raised 1 foot in elevation. That's how rise over run works.
Right. So you realize that rise over. So you realize that rise over run is a formula of slope.
Is what I'm saying wrong?
You're not saying what you're saying is not inherently wrong, but do you understand that rise over run is a calculation of slope?
Okay, so just relax. What I've said, hold on, Brian. Hold on, Brian. What I've said is correct then, right?
Partially correct. You're missing some information in it.
Okay, what's the information I'm missing? Because that's how I've seen them do rise over run and how they get elevations from using rise over run.
You don't get.
I have a lot of citations. I have a lot of citations that state this. They have pictures, diagrams, lots of stuff.
Okay, how does a slope work?
I'm not worried about the slope. I'm worried about the horizontal line, and when you go up from that, you've raised an elevation by that amount.
So again, my point's going to stay the same. You set a perpendicular. Okay. You set a perpendicular, and you throw a horizontal off of that perpendicular. If you follow that horizontal out, that hypothetical horizontal line out over 3 miles, it's going to raise an elevation simply due that the planet is curving it downwards. So
what's feet per second referring to? What's feet per second referring to?
Okay, so you're telling me, hold on, Brian. Okay, so you're telling Brian, I'll hand it over in 1 second. Just hold on a minute. So you're telling me the way they use rise over, when they do that method, they're getting wrong elevations. That's not how you're saying. You're telling me every time they do rise over run, they're getting wrong elevation.
The only way you can do rise over run is if you start at, let's say, 50 feet and you end up at 49 feet. That gives you a slope, and that's where your rise over run is.
And you've dropped 1 foot in elevation on that, right?
We're hypothetically speaking here. If you start at 50 feet and your slope ends at 49 feet, that is your slope, and that's where you can determine your feet per second for the fluid that's going through the slope. And when you add the variable of distance to that, the angle of your slope will be different. So rise over run is dependent on elevation. You need an elevation to begin with in order to make your slope.
Okay, we know. No one's
keep saying that,
no
bro.
one's
That's
disputing
so
you need
irrelevant,
an
bro. You keep saying
no
that.
one's disputing. Hold on, Brian. No one's saying you don't need an elevation to start. You're at a spot. You have an elevation. When they do rise over run, they make a horizontal from that elevation. And then if they raise 1 foot off the horizontal line, they've raised 1 foot in elevation. That is how it works. That's how they do it. That's not wrong. That's totally correct. That doesn't work on a ball. Otherwise, they would have wrong elevation.
Totally correct. No.
If Earth was a globe, they would have a wrong elevation.
If Earth was a globe, they would then have to factor in the fact that there is a curving surface. So yes, they would have to factor
But
that
we
into their
don't.
calculations.
But we
If
don't.
it's
No, we
it's
don't.
whether or not we live on a flat surface or not, the fact that your elevation on a sphere isn't exactly the same way as you would calculate it on a flat surface doesn't make either one impossible. Just means that one, if you're on a globe, you would have to compensate for the fact that your surface is continually curving, and on a flat surface, you wouldn't have to. Either process is still the same. The only thing is
You can bet your bottom dollar, bro, that if I lay out 1 mile and I drop it, which would be more than this, but just for conversation's sake, if I did a 5-inch drop for my horizontal, you could bet your bottom dollar that I'd have 5 inches of flow, which would be very little, but I would have 5 inches of water flow, bro. I wouldn't listen. I wouldn't have -3. I
how
would not have
far
-3.
how far away is your 5 inches?
I just said a mile. This is hypothetical, bro.
Okay,
Like I
so
would
yeah,
never do
so
a mile
right,
8 inches or 5 inches, but I'm just
right. So on
telling you,
a
I
mile,
wouldn't have -3 inches, bro. I promise you.
right. So over a mile, right? Over a mile at 5 inches, it probably wouldn't be that much of a problem. I don't
No,
know the
it's
exact
8
math on
inches
it.
per mile, bro.
Okay, so but he said 5 inches.
Exactly. So it would be
Right,
a
but if
negative
Earth was
3. It
curving, I'd have
wouldn't slope in the
-3.
proper
Yeah.
direction.
What's that?
It wouldn't slope in the proper direction. It'd be a -3. You wouldn't get flow.
Okay, so why doesn't it happen in real life then?
Because the Earth isn't fucking curved, bro.
Oh, okay. So you're coming at that from a position of authority. So if you go talk to people who actually lay out infrastructure, get your info from the actual people who do it, you'll see that, and in fact, they actually have to.
We are.
You mean like Ryan?
Went to the California aqueduct, bro. We went to the California aqueduct and showed that they did build it like with earth curve in mind, right? But then when we went down and measured the water, it rose up. In other words, when we first did the top of the aqueduct down like a 1 mile stretch, or it was actually a 2 mile stretch, we're like, interesting, it looked like an earth curve. Like, dude, they literally did factor in earth curve because they did the drop plus the earth curve. But then when we measured the water didn't give a fuck. The water, as it went down to each gate, it rose up the exact amount of earth curve, bro. It showed.
Are we talking about dams here? Like what do dams
hold on.
matter with curvature?
Hold on, okay, hold on, Brian. Before we go on, just real quick, just so we're clear, when surveyors do rise over run and they make a horizontal line and it goes up or down 1 foot, and they say they've either raised or lower an elevation 1 foot, they're always wrong. You're saying because Earth's a globe and that wouldn't work on a globe.
No, they're not wrong. But what they're doing is to compensate for it is they, instead of going at a mile, they'll go at 150 feet and then reestablish a horizontal. And they'll do that every 100 feet. And if you were to look at the geodetic data that you're getting from that, you will see from that data that it is not, in fact, a perfectly flat surface.
Okay, so you're saying that they are getting correct elevations when they do this. They're making a horizontal line. If they raise 1 foot,
so
from the horizontal line. Hold on, my man. I just want to get something clear.
I just want to add one thing. Add point 8.
I just want to get something clear, bro.
Add point 8.
Hold on, dude. You're at a point, you have an elevation. They make a horizontal line. You're telling me when they make a horizontal line and they go up 1 foot from it, that one foot in that new spot, they've raised 1 foot in elevation. That is correct.
By virtue of the planet curving downwards. Yes.
Okay, so they make a horizontal line. They go up 1 foot from the horizontal line. They go up 1 foot from the horizontal line. They have raised 1 foot in elevation. That is correct, you're saying.
By virtue of the planet curving downwards. It's not that the line is rising in elevation. It's not that the line has a slope to it. The line is perpendicular to point A.
But do you understand that? Hold on, man. Do you understand that doesn't work by virtue of it being a sphere? Because if it was a sphere, they would be incorrect in their elevation because the ground would be dropping beneath them as the distance increased.
Well,
do you understand that? Yes,
right,
or no?
and do you understand that they wouldn't be
Hold on, do you understand what I just said? Before we breeze by that, do you understand that they could never that method could never yield a correct elevation? Do you understand?
No, that's incorrect. I'm going to say that's incorrect because that's not how they would that's not the method they would employ to get an elevation.
Okay, look.
That is literally what they do to get elevation when they do rise over.
Let's put it like this.
We already went through this.
Okay, let's put it
And
like
I just
this. Let
typed in
me,
left
Brian,
text
just before we
one.
go, let me just answer this guy, and then after that, you can go. So the way that they would do it is that they would have point A, and at point A, they would establish a horizontal based from their vertical datum. So they use the vertical to establish their horizontal perpendicular to that vertical. If you extend that horizontal line indefinitely in either direction, then yes, there will be a rise in elevation on that horizontal line specifically established at point A. If you then go to point B, say point B is a mile further, which that mile further is even too far. They would never go that far. But point B is at a mile further. And from there, you establish a vertical. And from that vertical, you then establish another horizontal that runs perpendicular to point B. So when that horizontal reaches the vertical at point A, okay, that horizontal line from point A at point B will not be perpendicular.
Okay, let me show
Okay,
you what
but do you
happens.
understand? Hold on. Do you understand the fact that if you're on a basketball? Hold on. Do you understand the fact that if you're on a basketball and you make take a ruler, you say the surface of the basketball is all zero, and if I take a ruler and I say if I go up 1 inch above this ruler anywhere on the ruler, hold on. Why are you guys interrupting me? If I go 1 inch up off that ruler and say, oh, I've now increased 1 inch in elevation, even if it's 6 inches or a foot down the line, that elevation would be incorrect. You understand that?
That elevation would technically be correct, but the problem is that they're not going above. The problem is you're saying they're going above that. They're not going above that. It's the ground beneath them that is going lower. So by virtue of setting up that ruler, let's say at the top of the basketball, and this is assuming that the surface of the sphere, right, is where you are determining your elevation from. So every point, every area on the sphere is zero elevation. So you put a ruler on the top of your sphere and you start running your finger down on that sphere, then yes, there will be a difference in elevation based off of the point you initially established.
Look in live text
Yeah,
one. I just
so
posted
the
it.
elevation would always be wrong if you were to use that
There we go.
method
Get
on a
your point thing
basketball.
out, bro. Look in
If
live
you were to
text
use,
one.
hold
This
on,
is
Brian.
what happens when they
Hold on,
try to
Brian.
incorporate growth curve in this shit. I just posted
Yeah,
it in live
yeah.
text one.
Okay, thanks. Everyone look at that. So if you were to do that, if you were to use this method on a basketball where you make a horizontal line and say if something's a foot below it, it's changed 1 foot in elevation, that method would not work on a surface of a basketball. Okay? That method doesn't work on any sphere because you're automatically wrong even if you go out 10 feet, 100 feet. It doesn't matter how far you go. If you go out any amount, make a horizontal line, and you're just saying that horizontal line is zero elevation, that doesn't work if you have your elevation profile curving like you do on a globe or at the basketball.
You're not making any sense in what you're saying. If you're taking a horizontal line, which is a fictitious line, it's just a line. It's nothing real. So you in order to have a horizontal, you need a vertical. So in order to establish a vertical, in order to establish a horizontal, you establish your vertical and you create a 90-degree angle from that point, making it perpendicular and giving you a true horizontal. Are we in agreement on that concept?
Yeah, we have that horizontal line. We have an elevation to start. We go out 10 feet, 100 feet. It doesn't matter how far you go out. If your elevation profile is curving, in one instance, like you're on a sphere or a globe or a basketball, and you try to use a straight line, that is going to give you inaccurate elevations all day long because your line is straight and the elevation profile of the surface you're on is actually curving. So this method would never yield a correct elevation by using this.
Exactly.
Because you're missing
Notice how no ballers are
you're
coming in
missing a
here
part
to
to your
save you,
method.
bro. They know you're wrong. All the ballers know you're wrong too.
You're missing a method you're missing an equation to your method here, and is that the only way you could figure that out, okay, is by setting another perpendicular. And by doing that, by going from point A to point B using your horizontals, you would see that there is in fact a change in elevation from your horizontal at point A compared to your horizontal at point B. Over 100 feet, that doesn't matter. Over a mile, you start seeing it. Over 3 miles, you start seeing it. At 100 feet, you barely see it. It doesn't really matter. You don't need to account for it.
Dude, you're so wrong. No ballers are coming in to save you because you're wrong. They know you're wrong. This is the reason you believe you're on a globe, and it's totally wrong.
Okay, you can say that all you want.
Yeah, rise over run, just the method of making a horizontal line, and then if you go up or down, saying you raised or lowered by that much elevation, that method would never yield the correct result if the surface you're on is curving, and that curving surface is your elevation profile, a curving elevation profile.
Hence why, if we did live on a sphere, you would have to compensate for it. So if there's any evidence to it, is if they're in any infrastructure project, if they actually have to compensate for that, then it's pretty good evidence that we're not living on a perfectly flat surface.
One in that text, bro. If you look, just showed one where they did compensate for it, and it's make fucking.
Right now he's trying to straw man it, say perfectly flat. Like anybody thinks it's perfectly flat. Come on.
Well, my problem is my definition of flat doesn't talk about topography. So if I can just look at a surface of something and say it's flat, I think we're all in agreement that it's flat. A flat surface can have mountains on it and blah, 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 blah. But a flat surface is a flat surface.
Yeah, so
with terrain, which is why you have to do all the compensation that you're talking about because of the terrain.
Okay, so you're saying rise over run, the method they use doesn't work, but they add a calculation after to make it work. Is that what you're saying?
In a simplistic fashion, rise over run over a short distance would not be a problem. In sewer systems, it is a problem. They need to compensate for it, as the elevation that they set for their slope would be different by virtue of the planet curving. So if we were to construct these things on a sphere, can we agree that yes, they would in fact have to compensate for the fact that they are on a sphere when doing the rise over run? Can we agree on that?
I don't know. I almost forgot the question I asked. What did I ask? Did you answer it?
Yes, I did.
You said no, it doesn't work, but it doesn't give correct elevations, but they have a formula to make it give correct
No, so
elevation.
what I'm saying is if hypothetically speaking we lived on a if hypothetically speaking we lived on a globe, and what you're saying is true, based on your rise over run. But if we lived on a sphere, would they not have to compensate for that in their rise over run calculations?
Dude, I've done 3
I don't know.
hours.
I don't know. That's not my argument, though. My argument is even if you went out 100 feet, you wouldn't have the correct elevation, and the farther you went, the more incorrect your elevation would be.
I totally agree with you on that. I don't disagree with you on that concept. That is 100% spot on. So my question to you then, so yeah, on a sphere. So my question to you then is, if hypothetically speaking we lived on a sphere and they wanted to keep those rise over run calculations correct and correct, they would have to put in some compensations for the fact that we live on a sphere, would they not?
Sure. Well, I would just assume that they wouldn't even use that method since it's incorrect.
But you agree that if they did live on a sphere, they would have to factor that in, would they not?
I mean, yeah. Otherwise, it wouldn't be correct. Yeah. So, but I wouldn't even use that method because it's incorrect. If you go 100 feet or 10 miles.
He hasn't even given the method they do that with. He just assumes they do that, and it's all local and due to terrain anyway. It has nothing to do with the curvature of the Earth, bro. Sorry, your job is not prove curvature at all.
Is this what they do with rise over run when they go a mile or 2 miles or something? They add this formula in all the time.
Yes, depending on the steepness of their slope, they would have to factor some of it in. Yes, absolutely.
All right, so show how they do that. Show the method. Give us a citation where they do that.
So until they add this formula,
sure thing. So tomorrow when I'm in the office, I'll show you the citations from the books that they use to figure this shit out. I'll take pictures for you guys and I'll show them to you.
That's awesome. So you're saying until they add this curvature, until they add this curvature formula, every rise over run elevation is incorrect. You're saying.
Well, the rise over run calculations they use in reality works because they factor those variables in.
Did 3 miles of curb. You telling me like my last mile, like I was off by like 6 foot, and water would be flowing the opposite way? You're saying we do this shit, dude, because you've never done it.
Yeah, Brian. If they lay pipes out like you say they would lay pipes out, then yes, they would end up with a bunch of water in the middle of the pipe. You're absolutely correct.
Except we don't. When we don't factor curve, bro. You're just making shit up, dude. Yeah, we would have to do that if we lived on a ball, but we don't do that.
Great. So if ever you find an infrastructure company that does this and they tell you that they factor that in, will you accept that as evidence that we lived on a globe?
Show me a curved elevation. Okay, I'll show you one project. I texted.
I'm just asking a yes or no question.
Don't correct me, bro. I just posted where they did incorporate it, bro. They literally incorporated it into the aqueduct, into sections of the aqueduct. We went and measured them with precision instruments, showed it followed Earth curve, and showed the water didn't give a fuck. The water literally rose up over 20 inches in 2 miles. Literally, just watch the video, okay? This is what happens when you incorporate Earth curve into projects. The water don't give a fuck. The water stays level.
Right, and you just use the word level, which on a sphere means that it would be a curved surface. Thank you very much.
That's his strongest point. The level means curve to him, so that's all he needs.
It doesn't matter because curve, here it is, curve level was incorporated into it, and it didn't match true level. So if he just watched the video, okay, that I just posted 5 minutes ago, just skim through it, and you'll see that water don't care about your curved level. Doesn't care.
Water conforms to the surface of the planet.
Right, and I'm telling you that the aqueduct, these sections of aqueduct were assumed curved level, okay? So they match a globe 8 inches per mile squared over 2 miles. The water didn't follow that. So when you say that water is curved level, I call bullshit. I show you literally that water is not curved level by showing you what the water does in comparison to your curved level. But apparently you won't look at it.
Well, that's because our definition of level are completely different. So we're never going to get to an agreement on that because our definitions of level are completely different. Because the way I work level is that a level is a perpendicular set up at a vertical. So for me, that's what level is, and you can only be level at the point where you establish your vertical.
I get that. I just told you that the 2 miles was laid out as dropping 8 inches per mile squared. That would be curved level. Okay, matching.
Can you tag me in that link you sent? I can't find it in any of the chats. It looks like it's buried.
Yeah. What's your name?
Incarnation.
Yeah, I'll send it right to you.
Thanks.
Like, you think we didn't look into this shit? It's just crazy. You think we're just what the earth is, bro?
Listen, I'm making as many assumptions about the earth as you are. Let's put it that way.
Well, you need to watch this, bro, and then I'll welcome you when next time I see you. Hopefully in 10 minutes.
What happened? My wife was calling me. Check.
It just got calm for a moment.
Yeah, Jeremy, you're loud and clear.
Okay.
You're coming through, Jeremy.
We can hear you, Jeremy.
All right, if 5 more people can tell me they can hear me, that'd be great.
I can't hear you.
I can hear your thoughts.
Let's all relax. And that was weird, eggshells. But let's all relax a little bit. All right, let's not get crazy.
Stop thinking about me. Stop thinking about me naked. I'm wearing clothes.
Has anyone told you look like Ash from Evil Dead, though?
That's an awesome one. No, nobody's told me that. I used to get the drummer or somebody from Blink-182, but then I put on weight. But Ash from Evil Dead would be awesome.
Which is why now you look like Ash.
Grab his sparker.
Big fat boy. I'm going to go and get a chainsaw and amputate my hand and put it on instead of my hand.
I literally just posted a video where I DM'd it to him, directly to him, and it's where where he measures the 2 miles, or it's actually 1.5 miles. Okay, he measures the 1.5 miles, and at the is literally following Earth curve. So he tripped. He's a flat Earth. He was like, "What the fuck?" And then he went back out there and double checked it and got the same thing, another section, and he but he almost gave up. Then he went down. He thought about it. He's like, wait a minute, let me go measure the water, the stagnant water before the gates open and all that. And then the water rose up. So it's a trip, because when you first watch it, you think that it's showing Earth curve, because they literally built it to Earth curve specs, but the water didn't give a fuck. The water fucking rose up toward the ends. It's a trip. If it wasn't from the size of them, it wouldn't even flow. And they had to build the gates. The guy who went and telling the people, his bosses, how the water's flowing up under. Like, the water's flowing up under the gates when the gates open. And they didn't even give a shit. They're just like, they didn't even want to hear what he had to say. But the water's building up at each end. It's not dropping at the rate of the Earth curve. Like I said, the water is going to do what water does. Don't care what we build around it. We can drop our structures all we want. Water don't give a fuck. Water's going to stay nice and level, and not Earth curve level. It's one of the best flat.
Yeah, like go ahead and take your like sewer pipe and now do it in the ocean and do your rise over run and show me how much curvature you're accounting for to keep that sewer pipe at that same exact rise over run from the surface of the earth.
It shows you in his software and everything, whatever, if he does even do it, they're going off of a model and they're calling level curved and to lay out their benchmark. But that's not how we build shit, dude. And that's not how we lay shit out. Like, we do use rise over run, and we don't compensate. That's why I was trying to ask him how. How do we compensate? And at one point he was just saying it just happens. Well, then you're just saying that compensate at all, but maybe in his software. But I want him to show me a curved elevation profile. If he ever shows me, I'll go out and do what Jay Tolan did and debunk it. But it's already been done. They're assuming shit that ain't reality. They're modeling shit.
Why do I keep hearing rise over run being mentioned along with curvature lately?
Because they aren't going to rise up, so they're just going to run from it. That's the only answer I got. It's a shit one. I don't know.
It just kills me how they always talk about the ground. It's like, dude, when we're laying this, man, we literally use these to shape the ground. We're not letting the ground shape our fucking rise over run or our layouts. We're not using the ground by any means. We're using benchmarks, and then we're shaping the ground accordance to these horizontal lines or slopes or rises, grades, whatever, They keep talking about the ground and what the ground's doing, bro. The ground, anytime somebody mentions the ground, I know they have no idea what they're talking about. They mention the shit right off the bat, what the ground's doing. The ground's irrelevant. Ground's the final product. Has nothing to do with the layout. We use the layout to shape the fucking ground.
So I just watched your video on a preliminary standpoint. I'm going to dig into it a little bit more, but I don't think that video is really working in your favor from what I've seen so far. But let me do a deep dive into it, and I'll give you my analysis on it and what I think about it, and we can fight over it afterwards.
There's no question it, bro. He literally held the tape measure from the top of the water to the top of the aqueduct, bro. You can't say, I don't think he held, maybe he cut a 1.5 feet off the tape measure and duct taped it, I got to zoom into the tape measure, bro. He literally holds the fucking tape measure down to the water. You can't refute
I mean, what's your excuse, bro?
Well, yes, I can. It's a video. I'd rather see the data than just a simple video, and then I'll use the video to corroborate the data. So let me do that, and then once I do that, we can have an actual worthwhile conversation on it.
All right, and is this a video on your channel or something you posted?
I'll repost it. It's on my channel. It's using precision instruments to measure water level. And the guy literally holds a tape measure down after doing the layouts. He shows the shots through the instrument, okay? And they do match earth curve. He doesn't deny that. Then he goes down and literally holds the tape measure in like 5 different spots on the water and watches it fucking rise up. Like, bro, this guy's denying what the tape measure reads, which is weird. Which means he's looking for an out. Instead of just looking at what the tape measure's showing, he's looking for an out.
No, Brian, I'm not looking for an out. I'm looking to corroborate what you're telling me based off of this video. So I have to look at it, a little bit more than just 3 seconds here to actually have a decent look at it.
Let me help you out. About probably 100 people have come in here saying engineers must use curvature in their construction, but never has it been confirmed. Never can it be confirmed as on any blueprints. Brian was the first person who told us that they did it on this aqueduct, but it didn't work. So there you go.
I mean, the aqueduct works. So, I mean, at the end of the day, what they built works.
Well, go watch
Not according to the video.
Okay, sections. Okay, and it's done. And luckily, if the aqueduct was only like 2 foot tall, it wouldn't work. If each mile, 1 mile is only like a foot, it would barely work. It wouldn't work. They do it in sections is why it works. So them sections match the earth curve per section, and it's easily measures that the water doesn't match it. You just got to watch the video. It's not that long. If you're interested in the truth, you'll watch that whole 8-minute video.
Did you post it here in live stream, Brian?
Yeah, I just reposted it.
I'll check it out. Thank you. Ladder test, measuring water level, precision instruments.
Yep, that's it. That'll look, man. Anytime they try and tell you that it's incorporated in, there's your reality. And anything we do, like within 100 miles, like that, this is their claim. This is their way out. The actual engineers and shit. They're like, well, if it's a project less than 100 miles, then we use planar data, and it all works the same. I mean, most of them will tell you that it just happens, because we're changing angle every time we set up our instrument. Anybody who knows what they're saying, he would have knew this answer. Like George Numchucks and everybody, who I know is an actual engineer, would tell you that every time you set up your instrument, you're slightly curving. So, yeah, you can use rise over run up to 100 miles. This guy's acting like we're compensating for shit, bro. He don't even know the right globe answers, bro.
So, sorry, did you just say that they use the curvature in order to make the rise over run function?
No, they just say that it just works. It's the same when we change every time we set up our inch, we're literally changing angles.
Okay, so
we don't have to compensate. We do compensate for it, but any engineer, that's not their excuse. Any globe engineers, they say that it happens automatically, okay? That's why I was trying to get that answer from you to see if you knew the actual globe answer. You're just coming in like you know something, bro, and you're going against other globe engineers. And their excuse is you don't have to
what globe engineers? There's no engineer. There's no globe engineer. What are you talking about?
What are you talking about? There's no fucking globey engineers. I'm talking about people arguing for the globe, like George Numchucks, the guy who just died not long ago. Are you an engineer?
Me? No, I'm not an engineer.
All right, well, my mistake. Anyway, so because I went down the coastline, I went I set out to do 3 miles, dude. I did like a little less than I was approaching 1.5 miles. In one of my first videos I showed when I went out there, but nothing was changing, dude. I was just comparing it to the water, and it was just too tedious. It was nothing was changing. I'm like, how could it start changing the next mile when nothing changed this mile? And I started working on my second mile, and nothing was changing. Nothing was changing. So when I talked to George, he said that I was literally, every time I set up my instrument, I was changing angle, so it would work the same on a flat Earth as it would a globe. I don't believe that, but at least that's I'll say, okay, maybe. I mean, to me, highly doubtful, but at least that's an answer that matches real world projects.
Okay, sorry. Can you just repeat that one last thing? I'm just trying to wrap my head around it.
Yeah, he said that every time I set up my instrument, I changed angles ever so slightly.
Angle to what?
My perpendicular.
Well, your perpendicular is always a 90, and that is always perpendicular where you set up your vertical.
So you did understand what I said then, did you or didn't you?
No. Every time you set up at another spot, your angle from spot A will be different. Yes, he's right on that.
So in other words, when the dude who went down down Myrtle Beach, and in a 10-mile public stretch, and offered a 10,000 reward to anybody to show it other than planar. Okay, and this is the Glober's excuse, is that it's going to measure out the same on a globe because every time you set up your instrument, you're changing angle. So that's their excuse of why it measures flat, bro. You're saying that we compensate, but we don't. And I'm telling you we don't because it's what I do. It's what I've been doing. I've never compensated, ever, fucking ever. I've never heard of anybody compensating.
What's the largest project you've worked on? Like, what's the largest infrastructure project you've worked on?
The longest straight run I did with slope was 3 miles of curb at one time. But I've done enough of it. I've done enough curb to
for what, a sewer? For what exactly though? For what exactly? Like a sewer, a water line? What like a pressurized line? What?
It was a road.
Okay, so you're talking about a road specifically.
Yeah, the curb next to a road for drainage.
So you're talking about a drainage ditch, not a sewer.
No, a curb, dude.
Oh, a curb. Sorry, a curb. Okay, like a sidewalk curb, or to denote the end of the road.
It's like curb, like drainage curb.
Yeah. Okay.
But I've done like seawall, which is a good like a half mile. I've done skirting to bridges and shit like that. I've never done actual bridge or nothing like that, but I've done the skirts. I've done I quit doing commercial, dude, a while back, but I've done like my share of different things. I've done just about a little bit of everything. I've done bulkheads that are pretty good distance. Most of the shit I do is short range, but I've done some long range shit, and I'm just telling you how we gauge slope and how we drain water, and we do literally use rise over run, and it never deviates. And my point is this: like George and other engineers say why it measures flat is because we're changing angle and we just don't realize it because it's so insignificant. Either way, it fucking measures flat. There's no compensation. If we want water to drain, I don't believe that it's such an insignificant difference that I'm realizing it, but answer that matches reality, and the fact that is reality being that we don't measure it dropping away at 8 inches per mile squared. That's not what we measure in real life. Maybe it is fucking changing angle and we just don't realize it. But I doubt that. But at least that jibes with the fact that we're measuring it the way we're measuring it, flat. So when you come in these servers acting like compensating for shit, bro, you need to change that argument, bro. That's not even the globe argument, bro. And that might work against flat earthers, you know, not server. People, the server are people who are friends with people out in the field, you know. That's why there's so many of us in this server, dude. There's people pretty much in every field. So you're not going to get away with horse shit in this server, maybe in some other servers.
Hot mic in, Harry. Harry Key.
Yo, what have I done?
You're hot mic in a little bit, so you should hear a bit of rustling.
Thanks.
What's up, guys?
Set off way too many fireworks last night. Got me in a daze.
The 4th, right?
Yeah, I know. We're supposed to do it tonight, but my buddies and stuff had off yesterday, so we celebrated a little early. We set the bar for the rest of the neighborhood.
Dude, it's so stupid the way they do shit. Like, and they got a rule around here, like
You cut out.
Brian just talked and then quit. Kicked himself out.
It's weird though because there'd be like state lines, and it's like, well, on this side of the line it's legal, and then if you go, 2 miles over here, it's not legal anymore. It's weird.
Yeah, but here it ain't even statewide. It's like countywide, right? So we literally don't have to go to Georgia. We just go to St. Johns County, right? And or McClenny. I forgot the name of the county. I don't even think it's countywide. It's like citywide, but it might be countywide. But here's the thing. So everybody goes there, and then when you get to them counties, you got to sign something to where, like, you sign them where you're using them to either chase off.
Oh yeah, we
like,
were just scaring off varmint yesterday. That's all.
That's all. Nothing to see here.
But yeah, if you have crops and you could scare off, or if you raise pigeons, there's a few reasons where they serve a purpose, and you just got a sign saying that you're using them to serve a purpose, and so they got a whole stack of this paperwork, and literally these stores are jam packed. Fucking like a week before the 4th, and it's just crazy around here, bro. It's crazy. They're going off everywhere. Then they have the show at the beach, the downtown show. It sounds like thunder during 4th of July, bro.
How come they don't set up
Oh, shit.
fireworks?
Happy
Go
4th
ahead.
of July there to all the Americans. Forgot to say that when I came in.
Thank you. Now, how come they don't set off fireworks just higher in the air? Like, if you want to, don't you want them to be as high as possible? Like, why wouldn't you just set them shits off like the ISS should be shooting out fireworks or something?
Yeah, how high up you think fireworks go? Does anyone know? I was telling people last night I was at least 20 feet. And they were like, I said at least,
I mean, can you set off a firework in space? Do fireworks work in space?
They should. They're self-oxidizing.
That's what I'm talking about. Why are they not shooting that fireworks out like, hundreds of miles up, 100 miles up? People would be able to see it.
If I were,
Could we argue that rockets are kind of like fireworks?
wait, if I were to scale up my firework that comes out of the tube to the size of a rocket, the amount of speed it would have to come out of that tube is insane compared to what I watch happen at Cape Canaveral.
Go ahead, eggshells.
Yeah, my dad used to set them off all the time, and what we found was like if what you really want them is as low as possible, because like if you do them really high up or angle them away from the observer, they don't look that impressive. You can get a big 12-inch mortar, and it just looks like beep. But if you make it go low, like over the homestead where we're at, and it'd mushroom over the guests, it looks way cooler. So you could set them off in space, but you'd need like way bigger explosion, whereas this you get more wow factor for less bang.
Yeah, you just have to. But if you did want to have a fireworks show where like all of America could see it at once, like if you wanted to, you could put like an American flag fireworks like dumb high in the air, and then all of America would be able to look up and be like, "Oh shit, the fucking American flag!" Or like land them on the moon and set them off on the like land the colors that you want to go off on the moon, make it so it's big enough, and just have the moon fucking boom American flag for 5 seconds or whatever. That shit would be dope. Come on, bro. How many billions would it cost to do that? Because if I was Elon Musk or Bezos or some shit, I'd be like, yo, let's get crazy this year. I'm not gonna just set fireworks off in my backyard. Let's put the Amazon logo or the fucking Tesla logo on the moon or an American flag, something.
I did think of stuck today, as you may have seen, Jeremy, because we're now TikTok friends. I got stuck today behind the Tour de France, and it was making me think. Because, like, I don't know about you, but I always thought of like cycling, where I'm like, how is drafting really that big a deal? Like, I can't get how like a cyclist who's already like, shaped like a golly, gonna like really break the wind that much. But I was like, it's a good answer for the whole like can't show me gas pressure without containment thing. Is like cyclists have a low pressure front following them, so much so that if you tuck in behind them, you have to pedal less hard. That's pretty good evidence.
Yeah, there's less air resistance. What's it? You think it's evidence for gas pressure without a container?
Well, it's certainly evidence of a differential without a container. Yeah. Like and that was the other way I was thinking about it, where you're like, yeah, the rider in front, because there was a breakaway today, like at the point I was stuck watching, there was a breakaway with only 2 riders, and apparently a breakaway with 2 riders is like wild unsuccessful. There's like a 2% chance that either rider will win in a breakaway of 2, whereas if there's a breakaway of like 10, there's a 40% chance that one of them will win. Because like each one had into the thing, but I was like thinking about how you explain it and going, actually, you could go like the rider in front is like sucking the rider behind him. That sounds gross and sexual now. Forward, but in fact, it's like the collapsing air behind the second rider that's pushing him forward almost.
I always thought drafting was just the car or whatever's in front is breaking the wind, so that the person behind doesn't have to force their way through all that wind, so they can go faster.
Yeah, but that's it. But it's like the way to my understanding of the way to describe it in physics is as the lead rider rides into the wind, he creates high pressure in front of it. He applies a force to molecules, which increases the pressure in front of him, and then behind him there is low pressure. So that low pressure that then has surrounding ambient pressure collapsing in on it will draw along the rider behind with less effort.
How do you confirm for sure that the pressure gradient gets less and less and less? Like, has anyone gone above 200,000 feet and checked? Because one of the things I wonder is, like, if we just assume that with temperature, we'd be way off when we got to the thermosphere versus like 30,000 feet. We just assumed it kept going down, down, down. And
colder. Yeah.
Yeah. And then I just wonder, like, with the pressure, you're saying it just gets less and less and less. And I don't even know if like an amateur rocket could like what kind of barometer would you put on the outside, and wouldn't the air around the rocket be like affected and have a different pressure just because it's attached to the rocket? Like, what do you guys do? Like, what measurements do you have above 200,000 feet of this pressure?
I mean, I don't have any personally. I just think it's like lacking a different mechanism. I would assume it continues, but if somebody explains a different mechanism, that means pressure starts to go up again. I'll listen.
Yeah, because we have that problem with temperature, right? If we made that same assumption about temperature, we're way off, correct?
Sure, right. Yeah, lacking a mechanism.
Well, that's the problem when you try to. That's the problem when you try to extrapolate something.
Yeah, I
things
see.
Don't always extrapolate. You have a scaling fallacy on your hands or something.
Yeah, I see the balloons go up around 150,000 or whatever, and they take barometric pressure readings, and it seems to get lower. But like when you say, what's the mechanism of it? Like what's the mechanism making it hotter? Is it the sun heating up the thermosphere? Because from what I have like understood is that pressure and temperature can correlate a lot of times.
They're definitely correlated. It's PV nRT is the pressure formula.
So what I'm
Heat
reading
times
is
C.
you would still experience it cold because there's too few molecules. Because something that's been explained to me is gas's temperature is actually the excitation of the molecules, so how fast the molecules are moving. So the molecules up there moving very quick means technically the temperature is very high, but if you stuck your hand out, it'd freeze because there's so few molecules, it's actually very cold. Yeah, I don't know. It just sounds confusing.
Yeah, but we're not going to go by what we want to go by what humans feel. Our senses aren't really great measuring tools, right?
Well, I mean, if you stuck a thermometer out, it would also measure very cold because very few molecules are going to bounce off it. So it's going to be.
How do they get the temperature then? They have the temperature of the area, right? Like the thermosphere, they know the temperature of the thermosphere, right?
I don't think with the thermometer. I guess they would do it by something to do with calculating the presumed speed of molecules of air.
So it does. Well, I mean, there's a glaring contradiction here because they say it gets super hot when you're in the thermosphere, but you're saying it's actually cold. The thermosphere.
I don't know anything about it. Like you're asking a lay person.
What about temperature variations on the moon? Is it just one temperature there?
I don't know.
I'm just saying the thermosphere, they have a temperature for the thermosphere. Like you Google it, they give you a temperature of that area. What that area, the temperature of that area is. So
4,500 is Fahrenheit. They're giving on that
Whoa,
page I was reading.
degrees Fahrenheit. That comes from a thermometer.
Does it?
I don't know.
I don't know. How do we measure Fahrenheit? How else do we measure Fahrenheit?
I don't know. Torah seems to know. How do they measure
thermometers?
Dude,
I know how to measure Fahrenheit with a thermometer.
Yeah, exactly. I think you use a thermometer to do that for sure.
A thermometer.
Wow, I'd be surprised that measurement with an ordinary mercury one, because I think a mercury one would show you a very, very cold temperature.
But it's not cold though. They have the temperature for that region, and it's very hot.
Right. So there's a bit of an issue there, isn't there? How does one resolve
it? Not with us. Not with me. You got an issue. That's your model.
Wow, it might be a comprehension issue. It might be a model issue. So when you get up in the night, I had this question when I first started physics in high school. When you get up in the night and you go to the bathroom and you walk on the carpet feels a certain temperature. And then you touch a tap in the bathroom and that feels a far, far lower temperature. What's going on? Which one's which temperature?
I don't know.
That's water heater's probably in the garage.
Well, it's not about what you feel, though. We could take a thermometer or whatever and measure the temperature of those things, and we would know what temperature they are.
Like a space shuttle re-entering the atmosphere, don't it hit that atmosphere and
right, eggshells. We can just take a thermometer and measure. We can measure the carpet, measure the ceiling, the handle on the knob, all the stuff, and we can get their temperature.
So why does the carpet feel not nearly as cold as the tap?
Bro, we're not worried about what you feel. I thought maybe you didn't agree to it, but I just said a minute ago, like we wouldn't use our senses for this because they're subjective. You can run your hand under put one hand in ice cold water and then put both hands in the thing, and the one in ice cold water will feel different temperatures than the other one. But when it comes down to it, we could just measure the temperature of the thing. Right?
Sure. But the point I'm making is they're both the same temperature, but the density of the tap means that it can transfer its heat to you, or lack of heat to you. It actually, your heat transfers to it much more efficiently. So it feels colder. Well, the carpet's at exactly the same temperature because it's a poor because it's a poor thermal conductor. It doesn't feel cold to your feet. So the point can be something could be one temperature, and the thing I'm reading out where if you stuck your hand out it would actually feel cold still applies. So it's not a contradiction. It's a comprehension issue.
Actually, your hands are way more sensitive than your feet. First off, so I don't know if you accounted for that in your experiment.
Irrelevant.
Because why wouldn't you just measure the temperature of the floor and then measure the temperature of the faucet?
Yeah, it's like it just said, temperature subjective. You can have both your hands, one hand in a hot place, another hand in the normal temperature, and then if you introduce something cold to that, it's going to feel different, or hot, it's going to feel different depending on which hand you use. What's up?
Okay. Thermometer will read significantly below 0 degrees Celsius, at least at night, because the energy lost by thermal radiation would exceed the energy acquired from the atmospheric gas by direct contact. So exactly as I said, if you use a standard thermometer, you would measure it cold. Bing, bing, bing. Win for the guests from Eggshells who didn't really know anything about the whatever's it called, thermosphere, before we started this conversation. Guessed it
So the
right.
thermosphere is not hot; it's cold. It just happens to be some 4,000 degrees Fahrenheit.
Is that what I said? That's not what I don't remember reading.
That's what
that
you're
out.
getting at, dude. That's why you're telling us that we're flawed in our thinking, and I'm just trying to show you what your thinking is conclusive of.
No, that the conclusion you reached as a result of the thing I read out shows the point I made is correct, which is this is a comprehension issue.
It's 4,500 degrees hot or cold.
Sounds pretty hot to me.
So you have the comprehension issue.
So it's hot.
It's about
we're
how
in an
you measure.
area.
I've been saying.
If we're in an area. Hold on. If we're in an area that's 4,500 degrees. It's going to be hot.
What do you mean? It's going to be hot.
And 4,500 degrees is hot. So if we're in an area that is that temperature, that area is going to be hot, right?
Sure. And if you stick it, hot in what way? How would you know it was hot?
Well, we have the temperature of it.
How do you get the temperature of it?
I don't know, but clearly they've gotten the temperature of the thermosphere. They said it's 4,500 degrees. We know that temperature is hot. And if they're saying that's the temperature of the area, we know that area is going to be hot. You just did a ding, ding, ding and act like you declared victory 30 seconds ago. I don't know. I might have missed what you said, but did you hear what I just said, though?
Claiming victory because I was saying a thermometer. I think if you did it with an ordinary thermometer, it would measure it as very cold. And then I'm reading through the wiki page and it said exactly the thing that I'd predicted it would be the case. So yeah, I'm calling that a win. Like I'm not going to call it a win being able to explain it to people who are motivated to not get it. But if I make a guess,
I'm motivated.
And then that guess turns out to be right, yeah, I'll count that as a win.
I'm motivated to get it, bro. I get it. We know what temperature means, right? They claim that this area is this temperature.
Sure.
And we know that temperature is extremely hot. So if you go into that area, and the area is that hot temperature, that area is going to be hot because we know that temperature is hot. We just went through this like 2 minutes ago. I hear what you're saying about there's so few molecules and shit, but that is the temperature of the area, right? The thermosphere is an area, right? Surrounding Earth. Your model.
Yes, yeah, like a sort of altitude level.
Yeah, like 250,000 feet.
So that area, they said is very hot, so hot that it's 4,500 degrees. But now you're saying it's cold.
Nope. No, I'm not saying it is cold. I'm saying if you stuck your hand out or used a standard thermometer, it would not accurately measure the heat of the molecules passing by because there are very few of them. So to say that a thermometer doesn't register a heat is not the same as saying the heat is not there.
So you're saying thermometers don't give us an accurate temperature reading of an area?
Yeah, they're not always an accurate, like, for example, the thermometers that most of us are used to, that your mum sticks under your armpit or in your mouth or up your butt when you're sick, don't work without contact. Right? Like it's
What
the
about
same
an
as going.
infrared? What about an
saying
infrared thermometer?
Sure, yeah, it's something that could measure it in a different way, or directly measure the speed of a gas particle. That would probably be a far more effective way of going about it. But to say it's not measuring the temperature is like going, well, because that car's on the back of a truck, its speedo doesn't work, and speedos therefore don't work. It's like, no, it's just that's not a good way of measuring it.
So you want us to measure a non-physical thing?
No, I want you to
measure an
continue
electron, which is metaphysical, right? Is that what you're saying?
being motivated to not understand them. I think this is much more fun.
Well, I'm not understanding thermometers right now because I thought thermometers gave us the temperature of an area. Like if I stick a thermometer outside, it gives me the temperature of the area outside, and I bring it inside, it gives me the temperature of the area inside. Like that's how thermometers work, right?
No, I don't think it gives you. I don't think it gives you a temperature of an area. It gives you a temperature of probably only the thing it's designed to do. Like you've got those laser ones. That's not of an area. That's just of a point.
What is your
right? Or you've got
thermostat in your house doing?
So if I took
That's not-
thermometers and took,
if
I took
that's
thermometers,
something a house at a temperature. It's got a thermometer in it, but the idea is it turns on when the house gets below or above a certain thing. A thermostat's a different thing again.
Yeah, is it directly connected to something, or is it just taking a temperature of the air that's passing by it?
Look, if we stack up our lack of understanding of thermostats and thermospheres, I don't think that our combined ignorance is going to build a tower of competence.
Well, I work in air conditioning, so I know a lot about your thermostat, bro.
like a thermostat expert in the house. Listen, if I have thermometers in my room, eggshells, if I put thermometers all over my room, I'll be able to tell the temperature of every area of that room. It's just wall-to-wall thermometers, ceilings everywhere. There's just thermometers everywhere. We'll be able to tell the temperature in every area of that room. Right?
Sure, yeah.
Because that's how thermometers work. They give us the temperature of the area.
If that's how you want to say it. Like I said, that's not how I'm saying it.
Well, isn't that what thermometers do? They give us the temperature of the area.
I'd say they're designed to read temperature, but I don't think they give it to us. I don't get the idea of an area.
Well, if you put a thermometer in your living room, you get one temperature, and then it's the area of your living room. The thermometer gives you the temperature, and then if you bring it in the kitchen when you're baking shit and all kinds of stuff, it's going to give a different temperature. It's going to read hotter because that's the air. That's the temperature in that area.
I enjoy talking with you, Jeremy, and I like the way you deal with thoughts. But I just wish when we talked, if you want to say the temperature of an area, that's fine. I just wish when we talked, you didn't require that I agree to something when I'm like, no, that's not how I'd say it. I don't think that's how I'd put it. It doesn't quite make sense to me. If you just let me be like, okay, cool, eggshells doesn't put it like that, and then just go. You can keep going on with your way of doing it, but I wouldn't say the temperature of an area because it doesn't even make
So he
sense.
denies reality. Okay, we're okay with your reality denialism.
Sure, yeah. We're okay with your misunderstanding of the fact that the two poles are always diametrically opposed.
Well, I'm having a misunderstanding of how thermometers work right now, but all right.
Like the idea is surfaces or molecules or contact will hit, usually a mercury thermometer will hit the bottom, and if they're all higher than the mercury in it, then the mercury in it will increase temperature until it matches or gets close to matching. Mercury has a funny quality of expanding massively more than other things when it heats, so it sends it up the tube. But if that's not of an area, that's of usually a standard thermometer is usually of direct contact.
Okay, let me try this. We got a pot of water on the top of the stove. 200 degrees. We put the thermometer in it. It reads 200 degrees. We set the oven for 200 degrees. We put the thermometer in it. The thermometer reads us 200 degrees. Right? You with me so far?
Sure. Yeah.
So the water's 200 degrees. The inside the oven's 200 degrees.
Probably.
They're the same. What do you mean probably?
Well, all measurements have errors. So if it,
yeah, give or take.
Degrees, then it's probably pretty close to 200 degrees in there.
Okay, yeah. So give or take, it's about 200 degrees. Yeah. So they're different densities, right? But they're still the area of inside the oven and the area of the water is 200 degrees, right?
Yeah, that's what I'm saying. That's just not how I'd put it. Like, for example, in rooms, measurably, and in pots of water and in ovens, higher in that area. I mean, area is 2D to start off with. So do you mean volume?
Volume. Volume, yeah. Volume,
That
yes.
volume will be a higher temperature typically. Like the roof of a room will usually be hotter than the floor.
That's right. And we can, you know how we know that volume is different? With the thermometers. That's how we get the temperature of those volumes or areas or whatever you want to phrase it.
I think it'd be closer to a point. Couldn't we say it takes a temperature of a point?
I mean, I wouldn't phrase it like that.
Fair enough. I would. And then I'd relate it to the thing going back to space, which is like the challenge you have then is you need a molecule crashing past that point at exactly the right time and to read the temperature quick enough. Like you got to stick that thermometer in the boiling water for, a little bit of time before it, the stuff inside matches the temperature of the boiling and gives a correct temperature. So apparently I've found out how they do it. Well, I've read something about how they do it. I don't think I understand it yet. Measured using incoherent scatter radar. A radar sends a powerful radio beam of a single known frequency into the thermosphere that bounces off the electrons. As the electrons are in motion, the radar beam will be Doppler shifted, depending on if the electrons are moving towards or away from the radar. The radiation reflected back to the radar dish will show a range of frequencies. From the characteristics of range of frequencies, how wide the range of frequencies are, we may derive an electron temperature. That still makes no fucking sense to me. They shoot radio at it. That's and the other way is by measuring atmospheric drag on satellites or rockets.
Yeah, it's like no one took a physical temperature up there. That's weird.
They're getting temperature from drag? Come on, man. Really?
Not getting temperature from drag. I mean, if you want to say that's not that temperature, doesn't bother me. Like, to me, I kind of agree. The idea that you would say this thing is hot, but it would be experienced cold does sound weird. I'm not bothered by it. Caught it for you.
I'm just saying temperature and drag are independent. They're not even linked at all.
Well, this is saying you can infer it based on that. So the neutron may be measured indirectly by the atmospheric drag on satellites or rockets. The amount of drag depends on the density. When the density and composition are known, the temperature can be calculated. I don't get that either, but there you go.
It's an inference, and they're trying to,
Sure.
It doesn't make sense to me personally, but I mean, I don't know.
I'm with you there, man. It doesn't make sense to me either.
Because drag's totally independent of temperature. I mean, you have dragging hot or dragging cold. I mean, I don't understand.
Yeah. And I kind of get a bit where I certainly notice this riding where if I come down off a mountain, go into like thick coastal air, I'm like, wow, 100 kilometers an hour feels way different down by the coast than it does way up in the mountains. So I can kind of get how maybe they're going there, but I mean, for all I know, I've got it asked backwards. I don't get it either. I just don't infer anything from me not getting it except that I don't get it.
Also, just a quick research. It does seem like drag is affected by temperature. So if you technically could calculate drag, you know, the differences in drag between like in different temperatures, you could, in a way, get an idea of what temperature the satellite or what temperature it's at based off the drag from the satellite.
Does that have to do with friction?
Yeah.
Yes, of course. Drag is friction.
Okay, and you're saying in the thermosphere there's enough particles to have friction?
I'm not making any positive claims. All I'm saying is that drag will change based off of temperature.
Due to friction, right?
Drag is friction.
I was actually having an argument about superfluids, and there was a clear difference in that argument. Is Jesse Gordon here? Because he was having issues when I said zero friction equals zero drag. There's a serious issue with that.
Was he?
Well, like
I mean, maybe
based off what I'm reading, it's fairly minimal. Like a 3-degree change in temperature will equate to a 0.025 change in your drag coefficient. So it's very minute. It's fairly minor. You need to be very precise to make an adequate dissertation based off of that.
Yeah. And also, I'm saying I think drag is friction. I don't think that means friction is drag. So I think there are many kinds of friction, but drag is a kind of friction. So drag is friction. Friction is not necessarily drag, if that's the issue.
So we can have drag with no friction, but friction with no drag?
No. If you've got drag, you've got friction. If you've got friction, it could be drag, but you could have a sort of zero drag environment, like you're in a vacuum tube, but you have friction from some other cool thing, like physical brakes, like brake pads, like my tire on the road, right? So I could have multiple forms of friction slowing me down. One of them is drag of the air around me, but the other is like the tire deforming, the brakes, the engine brake, the fact that I'm a fat shit. That's my understanding anyway. Like, don't take that to the bank. I'm not a physicist.
So there's like extra drag then in the thermosphere versus the layer of the atmosphere right below it because it gets hotter. Is that where this is going?
No idea. I mean, I would have thought that it would get less and less and less, continually, fairly steadily less as you go up. I mean, I think I've even read and checked that that's the thing, that's what they say. But that doesn't preclude the possibility that there are like molecules moving. There are fewer molecules, still following that rule of getting less and less, but they're moving faster. And if that fast direction they're moving in is against you, that could mean more drag despite less dense atmosphere. I'm not saying that is the case, but I'm saying that that's something that could make what you're saying not be the case, despite the inference you're drawing.
Yeah, I think where we started was like the pressure gradient. If we treat it like the temperature gradient, and we just said, oh, the temperature just keeps getting colder as I got higher, we thought that would be a wrong assumption. But with pressure, it works out. And now we've got to the point that there's a more friction environment in the thermosphere than the layers below it. What could
we
cause
haven't
that friction?
that out. You've just posited that, and now you're running away with that as a fact. I don't know that's the case. Do you?
No, I was saying if we did run with that, we could, right?
Okay,
I'm not
yeah,
posing
sure.
as a fact. Nothing like that. I'm not making claims. I was just saying I think that's interesting. If we're going to say there's more friction, I'm almost like, maybe the pressure goes back up or something.
What would cause it? What would cause a turnaround in this? Like, we see a steady...
What causes the temperature to go from getting colder to all of a sudden getting hot?
I'd argue it's not. The experience temperature, like if I went up there, it would be colder than the altitudes below it. It would
So they
feel to
don't
me.
need any kind of heat shields on this equipment or anything for the environment of space. Like that's why I was getting like, what's the temperature on the moon? Do those suits protect from like extremely cold or extremely hot environments, or just both, or what's going on?
I don't know, man. You're kind of jumping around a bit. I'm not really able to follow. I'm like getting halfway through answering one question, then you're asking a totally massively unrelated one. Like heat shields are not due to the temperature of the air you're going through, but the speed you're going through the air. So it's like a massively, totally different topic that you just introduced midway through me answering. So I don't know. It's kind of weird.
All right, my bad. I didn't know the astronauts on the moon were going super fast when they were walking around.
So they're not wearing heat shields. Heat shields go on the bottom of a lander module.
Very good. So we could slow down to re-enter Earth, because that's what I've always said. Just slow down. Why the fuck are they trying to be going so fast at some certain angle? Just slow down. Avoid the fucking heat. Avoid fucking all the fucking heat shields. If it's just speed, then just slow the fuck down.
Because slowing down is like once you're, pretty much all of your rocket fuel is measured. You measure it. I know all this thanks to Kerbal in what's called delta V, change of velocity. This is how much fuel you've got on board based on how much weight you're currently carrying, that how much it can change your velocity. So if you're standing at a stock still,
just turn around and just drift up until they drop back down.
What do you
right? Just whatever direction
turn?
you're going, just fucking do a big old turn, like do a loop, a big giant
That's
loop, where you're going the other direction.
Doing a loop is a change of velocity.
No, you're
Any
not going to
change
change
of
velocity. I'm just saying change direction. In other words, if you're going down, going like from east to west, then do a fucking loop-de-loop and go from west to east at an upward angle until you just hit a stopping point where you just drop back down, or just pull, go straight up.
That is a change of velocity. Turning is changing your vector. So you've got a velocity in one direction, and it's then to do a right angle turn in space is extraordinarily expensive in terms of delta V.
Is it really? I thought they did slingshots, pretty regularly with all the fucking.
It's a slingshot.
So instead of slingshot and just slingshot straight up, slingshot instead of out, slingshot up. Okay, you're telling me that there's restrictions on the slingshots they can do, restrictions on the directions they can go. I don't get it. They're just free falling, bro. If they're just free falling and they can, turn around, then fucking just turn and go straight up.
Any change of direction, like when you're talking about a slingshot, I think you've got this idea that you go one way and then you fling back the other way. You're not. You're just going round and round and round. You generally launch on the path that you want to go into orbit, which will align with the direction you're going to fling off to after that. But almost always it's going to be around the equator, because the equator is pretty close to the ecliptic, which is on the plane of the solar system. So you go up, you shoot east because all planets are moving the same way anyway, and getting east you get free stuff. But like, slow down is like you are slowing down. You will generally do, or sometimes do, like a flip and burn, where you turn your rocket retrograde, I think it is, and
Yeah, like when they slow down for the moon landing. But I'm just saying, like
flip
a slingshot, when they dip down a little bit lower in orbit, and then they propel
flip,
out of it. You know, instead of
flipping.
propelling out of orbit, propel straight up.
Yeah, so flipping and burning, you will only do as much as is necessary. You're not going to bring extra fuel to slow down when you get free slowing down from the atmospheric drag on your rocket. Like, it's like going, oh, I should slow down so that I don't have to use this free slowing down I've got in the atmosphere. And then you're going to accelerate as you fall through the atmosphere anyway. Like, you're still going to get to terminal velocity. Why not just already do that? You get it for free.
So you
It
get
just
this
means
free slowing down where parachutes won't even open, but just the nose cone of a rocket. You know, in other words, you could try and eject a parachute in them low pressures, and they won't even open. They won't even open. But you get the free slowing down because of the nose of the cone, the nose cone of the rocket or the shuttle. And I mean, dude, you realize? I mean, you sound pretty sensible, bro. You do realize that you're just going along with all their fucking contradictions. Like, we didn't know that it was literally so cold up there. Like, we knew it got colder up higher, but we didn't realize it kept getting colder until amateurs were able to send up shit real high and see that it just literally continues to get colder, and then it might invert a little bit. But for the most part, the higher you go, the colder it gets. And in the 70-mile rockets, amateur rockets, we see that it hits almost absolute zero at 70 miles. You realize you're just sticking up for their contradictions, bro. At some point, you got to understand.
It's just you don't understand that like it becomes intuitive. Like for every time I have this conversation, I end up saying the same thing. If you want to understand this, why don't they just turn 90 degrees and blah blah blah? Just play Kerbal enough until you can land a rocket on the moon, and then we will be able to have a conversation that makes sense about it. Because a lot of the questions you're asking didn't make sense to me either. Like, why do the rockets roll over onto their back? Why don't they just shoot straight up? All of this kind of stuff. It's just because orbits take like a little bit of a knack to get used to, and then
well, you said the heat is caused from the speed.
Yep, yeah, I did. Heat's caused by the speed.
That's why I said if it's a speed, then why don't they just project upward? They won't lose their gravity, and it would be free. They're just fucking just. It wouldn't be. It maybe not completely free, but it ain't like they're turning all the way around. They're just curling up. Okay, they're obviously hitting something, so they would have the friction to curl up, right? You're not telling me they wouldn't have the drag to change direction, right? You would agree that with heat comes drag, so I would have the drag to change my direction, right? Or are you going to keep going along with their contradiction?
I don't understand what you're talking. It sounds like you're talking about using a heat shield for launch, but heat shields are, as far as I know, only used for re-entry. So I don't understand why you'd be going up when you're descending back to Earth.
How come the parachutes won't open with pressures that low, but nose cones heat up like fucking ridiculously? You see the contradiction?
It's not that the parachutes won't open. It's that if you open a parachute while going 24,000 kilometers an hour, it'll rip to shreds, and you get no benefit from it. If you come in slow, if you come in a low angle, then you can wash off a lot of that speed, just heating up your shuttle or your re-entry module a bit. And then once you've washed off a bit of that speed, then you can pop your parachute so you've got a nice safe landing.
The parachutes won't open at a certain pressure, bro. But if you're saying that we do have drag to open the parachutes, then
Who says
hold on, bro. Then we get a free turn. You're saying the turns aren't free, but if we have drag, then yes, we do get a free turn. You can't have both, bro. You can't have parachutes and fucking no free turn.
I don't understand either of the things you're making, nor do I understand where the claim comes from that they won't open.
If you have drag, you have rudders, which equate to a free turn.
What are you talking about? A free turn? You're only going to tumble. Your vector is going to remain the same. You will just change your orientation, but keep tumbling in the same vector.
I won't need rockets, bro. If I've got drag to open parachutes, then I've got drag for rudder to turn me. What don't you
I'm trying
understand?
to understand what you're saying, but I can never understand what you're talking about.
Okay, out to the left. I'll pull to the left, right? Just being
No.
facetious. Okay, so if I've got drag, I don't have rudders. So you're telling me that if I have drag, I won't have fucking drag? I mean, this is basically what you're saying. You got drag, but you don't have drag. If I've got
No.
drag, I can change my direction with rudder.
Do you even try to make sense? If you're talking about a re-entry
You know what a
module,
rudder is? You know what a rudder is, bro?
if you're talking about a re-entry module that's shaped like a teardrop, no. Generally, you've got to have no directional control of that. You just try and point at heat shield first, and then belly flop through the atmosphere until you slow down and the parachutes pop. If you're talking about the shuttle, then you're talking about a totally different thing that doesn't use parachutes until it's already hit the runway, and they're
You know
just
what a rudder
drag
is,
shoot.
bro? Just because maybe I wasn't making sense, but a rudder is like something you can put in the water or something on airplanes
What
that
rudder
uses
is.
drag it's something that goes on airplanes to give lift. I mean, to help with lift, to help with direction change, like or in a boat, like a rudder. You can have manual rudders, like which use drag to change direction. See, literally use drag to change vector. My point is if we've got enough drag to fucking heat up the nose cones, then we could easily use rudders to make it safer, to just change direction, to slow down, to just go up and just trickle back down, just drop back down free fall or whatever.
Okay, so it's already
Of course,
fairly
we'd
safe.
lose our parachute. Of course, we'd lose our parachutes at free fall, but we'd get them back to like at about 50 or 60,000 feet. You know.
So what you're saying in principle, yes, but you're talking about like a sort of it's switching back and forth. Shuttles don't have heat shields; they usually just have heat-resistant coating. Usually, only like a teardrop-shaped re-entry module will have heat shields, and that just belly flops through the atmosphere with no rudder, no directional control. In terms of planes, space planes like the shuttle, yes, it will have a rudder, and it can do something like what you're talking about, where it does lazy S-bend curves in the sky. But it's not. You're not getting. Sure, you're getting a free turn out of it, but it's not using parachutes anyway. It's just yes, these things are using the atmosphere to slow down. I don't get it. I just don't get it.
Bro, I think you drank the Kool-Aid too much, man, and you're like kind of making excuses in your own mind. Like, we're just kind of pinning you to what you're claiming. Like you were saying, free, it wouldn't be a free turn. You're saying it would cost fuel and all that. And I was just using your logic to point out that it would be a free turn. If there's shit heating up like that, then there'd be drag. So we could literally make a free turn. I'm just pointing out your excuses that you're making, bro. And the thing is like, I think you just drank the Kool-Aid. Or instead of thinking about this critically, you got a decent critical thinking mind, but it glitches out sometimes, bro. And I think this is one of them circumstances where me and Jeremy and we're all trying to tell you just what
Take a
doesn't
fucking
make sense of what they're telling us, bro. And you're like defending it for some reason against common sense.
Stop repeating yourself. What I was talking about was already exactly this thing. When you were saying, why don't they just slow down? I'm saying they do using the atmosphere. And now you're saying like it's a rebuttal. Why don't they slow down using the atmosphere? So in what way is that a rebuttal?
You said it's the heat, bro. You said it's the heat that's you said it's the speed that's causing the heat. And I'm gonna tell you right now, when there's no freaking, I mean, there's easy ways around that. We can avoid the heat, especially if that's the dangerous part. If it's the speed that's causing the heat, I don't think you're gonna get heat with any kind of speed when you have if the pressure was as low as they claim it is. I don't think it ever gets much lower than like 0.1 or something, which is like about
a totally different thing.
Maybe I'm wrong. Maybe I'm wrong.
We're coming in at like thousands and thousands of kilometers an hour relative to the Earth's surface. Tens of thousands of kilometers faster than the surface of the Earth, faster than the molecules of air that you're crashing into now. What I'm saying is you can get free slowing down from that, but it will heat up your craft.
Yeah, okay.
And you're saying,
Well, what
could
about the
turbulence
ISS that's doing 17,500 miles an hour? Does it get hot? Just out of curiosity.
What's that?
Does the ISS get hot from going 17,500 miles an hour?
I mean, if it started descending through thicker atmosphere, it fucking would.
But at that height, it's good. Fair enough.
Because it's in orbit.
Okay. So the ISS doesn't get hot, so we got to be a little lower than that.
You just keep changing topics, man. It's
I'm
getting
just
so
asking
confusing.
questions, man. I'm asking questions, bro. Because you just said the speed, so I'm asking questions so I could kind of get a grasp on, like, about what height does the, at what height would 17,500 miles per hour like require heat shields and shit? About, because that's a genuine question. It's not a gotcha.
I don't know the exact height. Like if you want legitimate questions to this, like they're out there. Or just play Kerbal. Just play like 10 hours of Kerbal and you'll just go, oh, okay, all makes sense now.
What would you guess, though? What would you guess?
It's only to debunk the whole thing and show that it's ridiculous. But
What
like,
would you guess, though?
it depends on the speed. You can heat up pretty significantly at ground level. I'm sure if you went quick enough where the ISS is, you would still burn up. I certainly know that in Kerbal, I've tried to, because I've failed to bring enough Delta V on board. Because that's the other thing that I was going to say before. Bringing Delta V for initial stages, like launch stages, is easy, but it's got a compounding factor. So if you're bringing more for later in the mission, that is a higher cost because you're carrying it for longer. So bringing it to slow down for re-entry is way, way more costlier than it. Anyway.
Yeah, but don't the meteorites burn up like above the ISS, like most of them? Or am I wrong with that?
I would have thought below, but I don't know.
Okay, no, I was wrong. The meteorites burn up at like 60 miles. So I guess that's where shit starts burning up. So when they say that the thermosphere, I think it starts at like 400 miles or something. So I guess they're full of shit then. If there's nothing up there to get hot, then it's not hot. Because me, here's how I gauge heat. Like, would ice freeze, or would it boil off? Like, would it melt, and would water freeze or boil off into
Very
vapor?
cold. I mean, you're going to run into difficulty with that one because my guess is it's going to be extraordinarily cold to the touch and boiling at the same time because it will be at such low pressure that it's boiling near freezing.
Dude, you're drinking Kool-Aid, bro. I'm sorry. You're saying it's gonna be boiling and extremely cold. Maybe.
You can do on the surface of the Earth, Brian.
So I wouldn't call it hot then, would I? I'd call it PV equals nRT, right? The pressure as the pressure goes up, the temperature goes up. I wouldn't call it hot. I would call it cold boiling or cold welding. You get cold enough, and shit will literally melt together. So it's cold. It ain't hot. Just because it's welding together, it's still. I wouldn't call that like cold welding because of low pressure.
I wouldn't call the thermosphere hot. I would go. Somebody said, "Is the thermosphere hot?" I would probably go, "Well, technically it is, but if you're up there, you wouldn't say so."
Fair enough.
Hey, Brian. Brian, do you ever know what the name of that part of the mission is when they come back from space? It starts to get real hot. Do you know what they call that?
Narnia.
What's that?
They call it
I think they call it
re-entry.
Narnia lately.
They call it re-entry. Re-entry. You know what that means?
Narnia.
That means that they were in a near vacuum
coming back from
space.
Narnia.
They were in a near vacuum of space, and now they're traveling through the atmosphere again. So this is why
they never left the atmosphere, bro. Remember, the atmosphere extends out past the moon.
Nice talking to you, Brian.
It's just,
That's your shit. You're fun, bro.
It's just gotchas. It's not really engaging, man.
Yeah, gotchas. You know how fucking humiliating it is to read an article to say that come to find out the atmosphere extends out past the fucking moon and all this shit, bro. just to make up for y'all's infinite fucking gradient. And then y'all don't. But when we're talking with y'all, and you just want to end a conversation instead of standing behind your physics and your fucking infinite gradient, y'all just want to just brush it off like it's my bad. Like I'm just trying to throw a gotcha. No, this is shit that fucking your
Molecules
fucking
pass.
science claims. So stand behind it all or don't stand behind any of it.
I don't need to stand anywhere. Like I can just tell you what I think. I think if you've got an infinite gradient, then you should find molecules past the moon. That's that. But they're both, one implies the other. Infinite gradient would be debunked by showing that you didn't get molecules very, very, very far out. But that's the thing. All of this is comprehension. None of this is science. All of this is just comprehension of the science.
Do you realize that an infinite
Of
gradient
concept.
would be fucking like almost zero, like a foot off the ground? If you're talking about a gradient, even a solar system wide gradient, you'd be almost zero right off the ground. You don't gradiate slowly until you hit a certain height and then start trickling down to nothing, bro. I mean, what do you think?
I mean, gradients can have curves in them, so that bit's wrong right from the get-go. But even if it's a linear gradient, why would it be zero right off the ground? That's a line can have a slope to it, like rise over run, right? We were talking about that earlier. It could be a steep gradient or a shallow gradient. Like oh my God, you're just saying
Bro, you're using a whole
incomprehensibly silly
universe.
things.
You're using a whole universe and saying that in the first 60 miles, it gradients down to 0.1, and then the rest of the fucking universe, it gradients down to fucking zero or damn near zero, bro. And then saying I'm saying stupid shit, bro. Unfucking real, bro.
Have you heard of asymptotes?
Great shoes.
Yeah, I've heard of
Asymptote is the question.
I've heard of asymptote.
Okay. Can gradients asymptote?
No, dude, you lick an asymptote, man. Or you put it on a dart. Blow dart. You don't even know what an asymptote is, man. I'm just kidding.
What is an asymptote?
It's when something approaches a value but doesn't reach it. So like
No.
easiest one is
No. I want Brian. I want Brian to answer. He kind of poked and said you didn't know what an asymptote was. I wanted him to tell me what it was.
Theoretical, man.
Right.
It's all theoretical.
No. What is
Not
the
real.
description of an asymptote, Brian?
It's not real, man. He just told you what it was. It's in any
Fucking hell,
gradient.
man.
It reaches zero.
Yeah, it's a line that approaches zero without touching it. And
Yeah, but that's
so
not real.
what's wrong with him
It's not
saying that?
real. It's
What do you
not,
mean
I
it's
mean,
not real?
it's not real. You can't show
Okay,
me that
I
in
was just
reality
wondering.
because we don't have the energy or whatever to prove that. I mean, because I could just claim, no, if you cooled it down a little bit more, or if you use more force to suck more air out or whatever, you know. I mean, I don't think you could ever prove that's real. I don't think.
Yeah,
Maybe I'm wrong.
what's the term?
like if you had a temperature controlled room and brought a hot cup of coffee into it, you would say both the room and the coffee are going to asymptote. So I think it would be better to say the coffee will asymptote towards the temperature of the room. Right? Now, in reality, in most rooms, there'll be fluctuations such that they end up crossing over and equaling. But you would say the temperature gets closer and closer and closer without reaching. So asymptotes exist everywhere. Like as eye health increases, the number of people with perfect vision approaches one perfect sighted person per person. Does it ever get there? No. Like you can be asymptotes in reality everywhere.
The coffee in the room will never reach the same temperature?
in a perfectly temperature controlled room is what I'm saying. Like in reality, it always will.
Right, I got it. I got you.
Yeah,
I'm
I
looking
hear
up the geometry of it. The geometry one. Yeah, it makes sense though. That's cool.
Like they exist everywhere. I'm trying to think of a bunch of other examples. Like oh, here's the one. You know, like you see this soap kills 99% of bacteria, and the joke's like, well, why didn't you just get the other last one? And that's because the typical effort is you get easiest amount with the first step. So just washing hands with soap gets rid of 80% of the germs. Then for every next percentage point you want gets inordinately harder until to kill every single germ on my hand is infinitely impossible. So it will asymptote.
What would the world be like without the second law, without entropy? Let's say without entropy, what do you think this world would be like? I'd say it'd be like kind of like your globe model, maybe. Like, or no, once you leave Earth and hit space and other planets and quasars, that's how I would describe a world without entropy. Would be like the heliocentric model once you leave the Earth.
All right, wait, real fast. So let me give an example. Let me give an example, okay? So they say that the whole universe started from a singularity with the Big Bang, and there has to be a very specific density, right? Or it's going to have a net positive or negative curvature, the universe. So it'd be like a closed ball, basically, or it'd be like an opened ball that's not closed. It's not finite, right? Or if it was right at zero, it would be flat. And so then they looked at the observations and it's like just flat. But they can't say it's exactly zero to be flat, like the exact density number. So they say that it's 0.0 and then 80 zeros, 1.
Right, it's a fiction. It's fiction.
So it's
That's
as
what
close to zero as you can imagine. 0.0000, all the 80 zeros, 1. And it just so happens to be flat. Right, with like any more or less, we're talking about, think about this, all the mass in the whole universe over set amount of volume. Just so happens when I boil this back retroactively to the first moment of the universe, the value is so close to zero that the universe is flat.
Bro,
That's
he
called the
brings up
flatness
coffee.
problem.
He brings up coffee in a room, and all the flat earthers are like, "Oh yeah, that makes sense." Like after I just said that shit's fucking horse shit, dude. Just the concept alone is fake shit, dude. That applies
It's
to
called the flat.
their model.
Real fast. What I described is called the flatness problem. It's a fine tuning problem because it's mathematically impossible that you would have just that right value so that the universe could become flat. That's why it's a fine tuning problem. It would require like specific attention or a fine tuner for that to happen, because out of all the possibility, there's like a 99.9 million % chance that it would be positive or negative curvature. So for it to be flat is like mathematically impossible. So they call it the flatness problem, the fine tuning problem. And since then, they've come up with this idea that this inflation theory, so that there was an inflaton, this particle that ends up turning into all other matter and particles, and that there was such rapid expansion that there was curvature at the beginning, but it just flattened out and looks perfectly flat to us.
Inflaton.
I swear. Yeah.
Simpler concept that if you're walking around, Brian, look at a wall in front of you and then walk half the distance towards that wall. So if you're 2 meters away from it, walk 1 meter towards it.
I get it, bro.
And then,
I cut it in half, and I'll never get to the wall. I get it, bro. That's mathematical shit, bro. Okay, but
you can.
inflaton. I'm gonna walk the wall and write inflaton and laugh my ass off.
I just want to know, like, how do people just defend that? Like, how do you guys just skate right past what I just said, your belief entails, and just like not even care or use your brain to think about it for a second and how incredibly laughable and improbable and pseudoscientific that is? Just breeze right past it.
Is that another reason why they keep bringing up the
don't follow it
multiverse, multiverse idea?
The multiverse is one of their outs. Yeah, they're invoking the multiverse now so they can say, well, no matter how improbable all of these things stack on top of each other seem to be, there's infinite amount of universes, and we just so happen to live in the one where all the coincidences happened.
Yep. Bro, remember when I said that they're not going to be? They fucked themselves out of being able to use the dark energy and dark matter being because that once they took us out of the center, They can't use the fact that it's different at different distances. Bro, like 2 weeks after I said that and shit, dude, they come out with some shit and they're still trying to say it's happening at different rates at different sections of the universe, bro. Like they fucking heard me and they're still trying to bootleg my fucking. But I was making the point that they screwed themselves by taking us out of the center. They can't use that excuse, and they're literally trying to use that as a potential excuse that at different sections of the universe there's different rates of gravity and shit or whatever. It's fucking bullshit, dude.
But
Like
wait,
they're
this is where it
listening
gets
to
so
me.
funny. This is where it gets even funnier, okay? So then there's something called the Hubble tension. This is what's really weird to me, right? Like the people that believe in this religion and cosmology, if that's what you want to call it, they don't know this stuff. I'm about to say it, and they're just
Yeah,
gonna
I don't
move
even
right
know.
past it. They're gonna move right past it and act like they know that their model's legit. So there's something called the Hubble tension, right? So the Hubble constant is the rate at which the universe is supposedly expanding, accelerative expansion. That's called the Hubble constant, right? The value at which the universe is supposedly expanding. So when they looked out at the universe, they have two primary methodologies. They have something called like the astronomical ladder. It uses like luminosity, mass readings, all these different things. It's called a ladder. And then they also have a different thing called the CMB, right? Cosmic microwave background. When they get the Hubble constant value from these two different methodologies, they don't match. And they've redone them many, many times in many different ways. And they keep on showing like up to a 7 megaparsec difference. That's like a number that's beyond comprehension, right? Just like, but what they do is they put these big numbers into smaller units so they can just say, oh, it's just 7 megaparsecs. That's a mind-blowingly large number. So anyway, that's called Hubble tension. They can't figure out how to explain discrepancy. So what do? Well, they're in a religion, so they say, oh, well, it's just must be instrumental error or some type of misinterpretation of the data, or one of the instruments are misreading the values, blah, blah, blah. But they invoke the astronomical ladder for all their distances, all their sizes, all their redshift interpretations, everything. They can't get rid of that. And then they invoke C and B as the evidence for the Big Bang. Right, so they need both of those things, but now they're claiming, oh, there just must be an instrumental error, data error, whatever, and they keep on getting this over and over and over. So it's called the Hubble tension. It's a well-known problem, right? Like I've talked to 3 different PhD astronomers that admit they have no idea how to explain it. Now, one of the proposed solutions to that is the idea that there was. So okay, I know I'm talking about. Just give me just a couple seconds. So you have the Hubble constant, the rate at which the universe expands. Then you have the cosmological constant. So that's the energy that causes the universe to expand, right? So for the universe to be accelerating and expanding all direction, there has to be some type of energy causing that. That's called the cosmological constant. Now they have claimed they think it's dark energy, right? They've called it dark energy. They don't know what that is or whatever. So then they're like, well, what energy could be in a vacuum that would explain this expansion? They went and looked at the quantum vacuum. They're like, well, there's energy here. This will fix the problem. So then they measure the quantum vacuum energy, and they're like, oh, this is 10 to the 120th power off. There's way too much energy in the quantum vacuum, so that doesn't explain the accelerative expansion. So then they can't really explain it. Okay, so all that being understood, so here's what they've come up with. They've come up with this theory called early dark energy. And that's the idea that the dark energy at the beginning of the universe was significantly stronger and different than it is now. And that explains why when we look at the CMB and look further out into the universe, that the value for the expansion is so different. But what that does is step all over the toes of the inflation theory, which they had to invoke to explain the flatness problem, the horizon problem, and many other problems.
Right.
So
It all boils down to their
they're at a
scale.
standstill. They're at a
Yeah, their
standstill where they
scale is
cannot
off.
explain the problems. They cannot explain the
They'll never
problems.
be able to fix it, bro. They're off
No.
by so much because their scale is so fucking dead wrong, and their forces are fictitious bullshit, dude. Their scale and their like gravity and the size that they're claiming, I think is just so lopsidedly wrong. They'll never fucking balance it.
Yeah, I just want to let you guys, like, I just laid out a high level explanation of like the problems in your paradigm at the highest levels. People know they can't answer this. Doesn't matter how much people laugh, gaslight, whatever you want to do, ignore it, blah, blah, blah. Your cosmology is inadmissible. It's not even viable on its face. Even if we pretend that you can just write a new creation account for your Bible and say, oh, early dark energy, oh, there was an inflaton. You can make up whatever you want to that happened at the beginning of the universe because no one can test it. It's just a religion. But now even the best you can come up with doesn't work. They contradict each other. So anyway, I know that was a lot, but just so you guys know, it's over. The game is over, right? You guys have run into the brick wall where there is nowhere else to go. You can't fix both of the problems. There's no way out.
They can say it's instrumental error or anything. That's crazy.
There's just no way out of this. You also have the horizon problem, which is if you look at the supposed 13.5 billion year age of the universe, and then you take the speed of light, so speed equals distance over time. So if you have c, that's the maximum speed of light, which means that's the maximum speed of any particle or transfer of information, right? Nothing can go faster than speed. So there's your speed equals distance over time. Your time is 13.5 billion years. So if you use those two values, you have a maximum distance that something can travel in the 13.5 billion years, right? But you need direct interaction to have like this homogeneous distribution of temperature and energy that they claim happens in the universe. So that's where you get the horizon. That's a radius distance from a certain point. The maximum distance out a particle can travel in the 13.5 billion years. So they can't have a direct interaction with the particle inside it, in the center of that radius with anything outside the horizon, but they need them to have directly interacted. So this is called the horizon problem. This is where they also tried to use inflation to fix that and to fix the other problem. But now they have the early dark energy problem because of the Hubble constant, and they cannot use them both. They contradict each other. So welcome to 2023. Your religion is legitimately dead. There is literally nowhere to go.
So the horizon problem, is it because they saw things outside of the area that they claim is the farthest that light could have traveled in that time?
Yeah, well, specifically, it's that when they look at the CMB, they're claiming that that's the remnants of the Big Bang, all right? And so for it to claim that there's like homogeneous temperature distribution, the particles would have to have interacted. They'd have had to be at the same place. They would have had to be in the same proximity, have like a commonality of interaction. But they couldn't have interacted because they're far beyond the limit of the maximum distance or the horizon. So you have 360-degree horizon limit. And I'm talking, dude, it's way off. It's not even close. If you look at the CMB, you could draw like a little bitty circle on it. And that's as far out as it can interact. It's supposed to interact with the whole entire map. It's not even close to working.
I can't believe they haven't looked at the assumptions they've made and tried to reevaluate everything. Because these are substantial problems.
Think about what they do. They can make up anything. They made up the inflaton, dude. The inflaton.
They need to go back all the way back to the very first assumption that Venus is the same size as Earth, and fucking check yourself, and go from there. That was the very first assumption, and that's where it all went wrong.
I think it was even before that, but yeah.
They literally built they had to make Earth. They had to make the lights in the sky huge, and they had to make Earth the same size as one of the lights in the sky to have any of this
731 513 168.
If you're giving personal details over the thing, I might want to be there.
Yeah, you have to make your personal shit.
Yeah, I wrote that down.
Yo, Witsit, is Witsit hot micing right here? What's going on?
Witsit, you're hot micing.
Witsit. All right. I server muted him. He can just unmute himself.
Yeah, good. But yeah, they did. They had to make that assumption. They made that assumption right off the bat that to make Earth the same size as these little lights in the sky, whether they're big, like, dude, I'll post this in a second. I took somebody CGI like a planet. It looks so much like Mars or something, like coming down on Earth, and it's obviously fake. Dude, it's about it looks like it's about a mile wide, but dude, it looks so massive. Maybe it's 2 miles wide, but it's how I literally imagine the size of a planet. If they are what they say they are, as far as shape and all that, it's spherical and being like right above my head, about to hit the ground, like it's literally massive, dude. But when you talk to them about it, they'd be like, "That's puny." But on a realistic scale, it's literally fucking massive and scary if it's close to the ground. But that's how I picture it in real life. In fact, I'm gonna post this. It's a trip. I wish y'all take a look at it. Hold on.
Yeah, my bad. Like when you guys said I was hot mic and I'm muted, you could keep hearing me.
Yeah, it sounded
Yeah, I
like
don't
you
know
were
what you
going
were
for it.
saying just now, but you were like
Sounded like
reading off numbers and shit, so I just muted you.
Oh yeah,
sounded
I
like
was
you were
checking
getting
out.
personal.
Yeah, I probably did send my number. Anyway.
Yeah, a lot of bitches calling you now.
Another
But don't you guys
major
think it's funny, dude? Like, if like real fast. So they'll be like, "Oh, then if the Earth is flat, then what is the moon?" But dude, and they're like, "Oh, you're just making stuff up, dude." They make up literally anything they can think of, and it's okay. The inflaton, dude, the inflaton, early dark energy. Well, what is dark energy? How can you give an age to it if you don't know what it is? Don't worry about it. It's the early version. It's so funny to me that you guys can like so confidently stick your chest out about how this is so much science and flat earthers have to make stuff up, and you guys literally make up the most nonsensical religious bullshit I've ever heard.
other assumption they make is just about that CMBR. And they say it's cosmic radiation that's left over from the Big Bang Theory, which happened 13.5 billion years ago. That's just an assumption. There's no way to prove that this stuff that they're seeing up there, this radiation, is from the Big Bang. You don't know. A lot of people think it's just from our own solar system.
Oh, the evidence actually shows it's not just from the Big Bang. And then this is what I was talking about in my last stream. What they do, like Jace will do this, whoever will do this, they'll come around, they'll invoke the CMB as evidence that verifies and validates their claim of the Big Bang. And what it actually does is directly refute it. It directly refutes it with the axis of evil. And then what they do is they say, nuh-uh, some people disagree with that interpretation. It must be wrong. And they said that for about 20 years and kept getting the same result. They just ignore that part and then claim it's actually evidence for. So when there's like evidence that's damning to their belief, they literally cherry pick it, hand wave dismiss it, and then turn around and invoke the error as if validation. And it's so effective because that way you basically avoid having to answer the discrepancies because you're invoking it as evidence for your own claim. It's so
Yeah,
much
they're cherry
worse.
picking parts from the CMB. I would agree on that because they'll say the CMB is wrong when it comes to the axis of evil, but then it's right for other things.
Yeah, bro. I mean, they do this with everything, like with dark matter. Dark matter is a direct refutation of the gravitational prediction. They'll invoke observations that show this discrepancy as if further validation of relativity. Dark matter has validated relativity when it actually refutes it. It's a very effective tactic. And then they can just say phrases like, that's the most tested and validated theory of all time. And it's like very effective. It's like very persuasive. I don't know. I think it's crazy, man. The more you look into this, like cold dark matter, Big Bang cosmology, it's like so laughably non-viable. Like it doesn't work. It has like tons of paradoxes and contradictions that can't be answered. And then you're honestly just intellectually lazy or inept to say stuff like, that's how science works. We don't have everything figured out. What we did figure out is that the theory doesn't work. It's fundamentally paradoxical and it goes against and contradicts the very observational evidence you built your entire belief off of. Your theory is wrong. But your theory can't be wrong because it's a religion. So that's why how do you falsify the Big Bang cosmology? They won't say any words out loud. They won't even say coherent sentences in response to that question because it's a religion. Like it's legitimately a religion. They're rewriting the creation account. They're rewriting their Genesis over and over and over. So how can you ever prove them wrong? They can just rewrite Genesis over and over. And, it's laughably stupid to me. Oh, and it turns out it was actually early dark energy. And there's something called the inflaton. I don't know. I think it's weird. And then the problem is now they're having to invoke the early dark energy, claim that there's way more dark energy at the beginning, claim that there was inflation with the inflaton that then turned into other matter and that it made it way faster of an expansion. Then they're looking out and they're seeing supposedly right near the beginning of the Big Bang is showing, way too much formation and magnitude of galaxies, which means it needed more time. But their other excuses is invoking that they had less time because it was such a faster expansion. And then when you combine inflation and early dark energy, they directly contradict each other. You can't actually make them both work together. I think this isn't just something you just be like, well, that's how science works. You have to figure stuff out. No, you've hit a wall where you can't plug up all the holes because your answers to plug them up now contradict each other. It's over. The game is over. I don't know. I was just hoping that maybe I could break through some cognitus here. Like, you guys should realize what's going on. It is for sure a religion.
Y'all see that in live clip? Y'all see that planet looking thing like it's about to hit the ground and they fire a rocket at it? Like that's like the size I picture. Like if planets are spheres and solid, like that's about the size I picture them. Like when they say like the stars fell to the earth in the Bible and shit like that. That's how I picture them right there. Like that size, like a mile across, which would be fucking incredibly massive. But I mean, I don't know. It's the way I picture it in my mind. I posted a couple pictures of it in live tech.
Or like even think about this. Think about like, okay, so the base idea of the heliocentric model, right? Let's start from the beginning. Since we've known for hundreds of years, okay, let's go back hundreds of years. So there's the Big Bang, but that's a later concept, right? So you have that the Earth is tucked away in an insignificant portion or corner of the universe. It's not special or unique. It's just a tiny little speck of dust in a tucked away little insignificant corner of this massive universe. And everything expanded and exploded out from a singularity called the Big Bang. Everything expanded out from there. So everything's distribution is central to that singularity, that initial singularity, right? Everything expanded out from there. But now the model says there is no center. So everything expanded out from a singularity, but there is no center. It's so stupid. That is so fundamentally stupid. I don't know. And then now it's like, now there's a bunch of pop sci articles and videos going around saying that James Webb has seen a picture of God and has taken images of before the Big Bang and it proved the multiverse. And they're going to start pushing the idea that there are infinite amount of parallel universes to explain away all the impossibilities in their model. And you guys are you guys actually just going to follow them right into that nonsense and keep believing it? Are you never going to step back and think maybe this is just wrong?
Yeah, I don't find it coincidental that they're coming up with this multiverse theory, and then you look at all the media that's going around, especially for children, and it directly is stating multiverse theories in the TV shows. Like these characters all of a sudden are traveling through different universes that can have different timelines that intersect, and I don't think it's any coincidence that it's happening.
Hey, you can haven't you heard that you can find your soulmate on the other side of the on a parallel universe? Sorry, and maybe there's a copy of you. Isn't that insane, dude? It's so cool, amazing. I love the heliocentric model, man. It's wonderful.
Yeah, when somebody tells you go fuck
It can
yourself, you
always
can go
it always
can.
gives me this comfortable lies to get away from understanding that there's a creator above. Oh, it's so
Yeah, this
nice,
is
man.
God of the gaps. God of the gaps for the atheist.
I love it because it's so comfortable. It makes me feel like that there's no consequences to my actions. Because there is no heaven above. It just goes straight into black void. Man, I love the heliocentric model. It's so comfortable.
Well, you can't just say like, oh, well, I don't really agree with the multiverse. you don't really have the luxury of saying that. They're not just randomly claiming the multiverse now for no reason. It's because the observations have refuted their model, and the only thing they can do to get out of it is claim. The reason we have such a fine-tuning problem and we have so many repetitive, mathematically impossible coincidences stacked on top of each other is because there's an infinite amount of universes, and we just so happen to occupy the one that has all of the coincidences. And since we're in this one, this is the only one we know about. So it just looks like a coincidence to us. But overall, with the infinite amount of possibilities in the infinite amount of universes, it's bound to have happened that way at some point.
But with contradictions still, you know what I mean? Like, I could see them trying to push for it, but when you're actually diving deep and finding these high level contradictions, they're still not explained by a multiverse, right? Like, even if we are that one universe that somehow it looks one way but is another, you're still finding contradictions within it.
That's right. Yeah. They still can't explain. They can't explain like they can't combine early dark energy and inflation. It doesn't matter if there's a quadrillion universes. Like there are many situations that can't be repaired just by saying there's a million universes.
It's just insane how far man has come to avoid many things in life, you know. Especially
I don't.
avoiding.
How do people not see this? Like, how are people in this room? How do you not see it? Like when we're discussing it right now, how is it that you enter a state of mind where you just compartmentalize it and just ignore this? Do you convince yourself I'm wrong and making stuff up? Do you like what? That's weird to me.
Well, once you have bought a couch that is very comfortable, you know, metaphorically, you just don't want to get up.
Dude, you can't threaten their ball. If it threatens their ball, they'll fucking fight it to the death. Basically, they'll defend any bullshit to the death.
Hey, have you seen
threaten their ball?
You see, like, there's a Harvard professor, and he was talking about, or he's a dean of law, actually at Harvard University or something, and he's on film talking about how, despite any affirmative action Supreme Court ruling, right, whatever, they're still going to use affirmative action, and he's literally on camera, and he says, if anyone tried to say that I said this, I deny it. And he's on camera saying
that
this.
on camera?
And he's like, and he's like, we're gonna do, you know, like, I want you to, you know, do affirmative action, but don't ever say you're doing affirmative action. Don't ever, like, you know, keep it in your mind is what he was saying, and keep towards the directive. And it's like, you know, it's so interesting that to hear the same attitude from like Democrats and like ballers and like this academia. It's like the same sound in their voice. You know they're full of shit, but they just got to keep up with the go. But whatever.
Yeah, what's even more interesting to me though is like if one does eventually speak up about any of the stuff I just said, what they're gonna do is they're actually gonna pretend that I'm just so stupid or like ignorant that I'm making a big deal out of something that's actually not a big deal, and they portray it as if there are easy explanations for all of it, and that's objectively and patently false. Objectively and patently false. At the highest levels of academia, they admit that they do not know the answers to these things and that they can't work out the discrepancies and contradictions within the multiple different attempts to plug the holes. That's a fact. But they will respond with, they'll laugh and be like, it's not that complicated. You're making a big deal out of nothing. It is easy to explain. We've already fixed the problems. We know that's instrumental error. Everyone agrees. You know, it's like just these really vague, like, posturing tactics.
You know what it reminds me of is like kind of like construction. Like, you know what I mean? You've got really good construction workers, right? That like, you know, will come in and be like, all right, this is going to be very expensive because I'm going to have to do this, 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 and this if you want this done correctly. And then you've got a guy that comes in and says, I can do it for half and we could da 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 da. You know, nothing's ever done like correctly. You know what I mean? Like, and that's just what we're witnessing is some people think about cosmology in the same way. You know what I mean? Like they're just like, there's nothing, you just do this, that. But if you don't, you know, address the real issues at hand that only a good carpenter's going to see, You know what I mean? Like, and it's just people, man. Don't be so wound up, brother. You know what I mean? Like, these people are everywhere.
Yeah, but I guess what frustrates me is it's like the layman isn't told any of this, and then they're trying to tell my children, like they're gonna tell kids that this is like real, bro. And it's such a like, it's so deep philosophically. It's this like morbid, dark, nihilistic belief that there's an infinite amount of universes that have tiny little specks of insignificant dust that things live on, and you're so unimportant that you don't really matter. And they say this like it's a fact, and they mock and berate and ridicule the people that point out what's wrong with it. I don't think they understand like the dark nature of what they're doing the bidding of, and so that's why I get worked up about it, 'cause I'm like, bro, you can be blissfully unaware, but that doesn't change the implications of what you're defending.
Right, but don't lose sight of the fact that like when you expose like these people or anybody, you know what I mean, for like not being intellectually honest, not being whatever, despite their denials, like there's a general atmosphere of everybody else around that sees it, senses it, and knows it. And it's up to them to make the decision of whether or not. That's why I always thought, like, same thing with Flat Earth Court, the person listening is the judge, because you can make all the arguments in the world, but they're going to make the final decision for them. There's no holding anyone accountable because there's no real ramifications in the real world of thinking the earth is flat or a ball. So all you can do is use them as a sounding board to convince the people around you. And remember that their goal, like your goal, I always used to put it like this, it's a dead even thing, because your goal is to change one person's mind. Their goal is to make sure that you only change one person's mind. So at the end of that awesome conversation, they think they've done a great job, and you think you've done a great job. But the difference is
It's so crazy, bro. Like it's I don't think they really realize. Sorry. Go.
Oh no, I was just gonna say, like, don't forget though, you're on the positive side of convincing one person at a time, despite how they win in their mind because they only want you to convince one person at a time. Your victory is not with them or through them. They're never going to get the penny to drop. They're paid not to get the penny to drop, in my opinion, and that's just what it is, bro.
Yeah, well, I don't think they've realized exactly the current state of events, right? So they think, oh, we're winning. Because like I say, if a person comes in this room, they're like genuinely curious and new to Flat Earth, bro, they'll get flooded in their DMs immediately. All the anti-Flat Earthers come off mute and they're like ready to go. Like they see fresh blood. They're like, no. Curious person must get them, right? It's this weird, dark motivation that they don't intellectualize. But what they don't realize is yes, they've had an effect. It's taken us a few years, and they've had like the monopolistic, depraving big tech companies on their side helping them hold it back. What they're losing, and they've effectively lost, and they're in denial of that. So it's very entertaining from that perspective, like to watch how they're unaware of the fact that they lost. They genuinely don't think they've lost. But if you go watch, like Mike Tyson just released a video, it has Graham Hancock on it. It's titled "Graham Hancock Disproves Flat Earth Theory in 47 Seconds." Right? And actually, Mike Tyson knows the Earth's flat. But anyway, it's like a clickbait title. He talks about boat disappearing over the curvature of the Earth, right? Graham Hancock. And dude, go read the comments. Go read the comments. Every single comment is just making a hilarious joke about Graham Hancock. Oh, well, if you had any questions about him being a shill, or the Earth has to be a ball, or my books won't sell anymore. And stuff like every single comment is pro Flat Earth. And this is a Mike Tyson channel with over 500,000 subs. They lost, bro. It's over. We're everywhere. You know what I'm saying? We're everywhere. Like you go to the top comments on that video or the newest, and it's all pro Flat Earth. So it's just like to that point now where now Lex Friedman is saying he wants to have a Flat Earther on. You have it's just kind of over. So it's like that period in between where people, you guys might not realize that you lost, but you did lose. And we did actually try to warn you for a while. Your behavior is going to make you lose.
The thing with that though, and this is the thing that even where I know we've talked about it before. It's just the idea of like should Flat Earth, you know what I mean, be the main, the cosmology, like the secular cosmology. I think like the problem is also too, you're dealing with like space agencies and like what people consider national security to some extent. And I just think like that's where it gets like touchy, and that's where it's like, oh, you know what I mean? Like, I don't know, man. It's just gets touchy, because like they're gonna go down with the ship on the lie. They're not gonna, you know what I mean? So it's like it's better to almost just like let it. I look at it like the slice was already made. It's like an anime thing where the cut was already made, and now you're just watching the body drop. You know what I mean?
Well,
Like,
yeah, but then let's use like the last 3 years as an analogy. Like, if people want to go around and be scared of the very thing that keeps them alive, and they want to be brainwashed by the TV, like I'm more than happy to sit back and let them do that. Like, for me, it's just like what sucked was that they were lying and censoring people with fear and propaganda and coercion, and then causing them to make life-altering decisions out of fear, and they didn't actually know all the information. Same thing with flat Earth. I would prefer it just be like an open-ended, open-minded cosmology across the board. You have a bunch of different ideas. No one really knows, but there is an aura of skepticism of the authoritative programming, right? Like that's the real important part, is that people aren't just consuming the propaganda hook, line, and sinker. They're like skeptical of it. They're skeptical of it. Even people that believe the Earth's a ball, they're like, yeah, but you guys are misrepresenting the flat earthers. One of my best friends, a flat earther. That's not what they think. To be fair, the globe earther just got destroyed. To be fair, NASA is suspect. Right. This is the tide turning that I'm talking about. It's not even about flat Earth becoming like an across the board cosmology or anything. It's about the fact that you guys lost, in the sense that you didn't get to sweep it under the rug. You guys thought you'd be able to sweep it under the rug so you could berate people and stuff and it'll go unnoticed, but you lost. It's not swept under the rug. It's never going to be. So that's really more so. I mean, like, for me, in the grand scheme, we've talked about this a lot. Like, I don't know that we fully agree on this. Like, if there is a truth, despite whatever the societal outfall would be of that, or fallout would be, I think that, truth should always just be pushed to the top, no matter what the ramifications are.
yeah, I mean, I think for myself, I hold that principle, right? But it's like, it's the idea of imposing like quote unquote truths. That's the issue, and that's where it becomes to sell some element. I mean, like, this is like an intellectual arena. That's how I look at it. You know what I mean? Like, in a sense, we're proselytizing our ideas because this is what we're here to do, right? Like, you know what I mean? But in the real world, there's another way, and I'm sure you're the same way. And I think like, I think philosophically, yeah, like flat Earth kicked the shit out of the globe, and like either people are hip to that or they're not.
Yeah, that's. I mean, I don't even. I agree. It shouldn't be imposed. Like I said, if people to this day are scared of the air, bro. Like, people in South Carolina are scared of the air to this day. It's like, my dude, if you want to go out and it's 93 degrees outside and you want to be scared of the air and suffocate yourself and stuff, like, by all means, go for it. If you want to wear a hazmat suit, crawling off fours, and bark like a dog, like, I don't even care what you do. It's just like, it's more so the lies being forcefully imposed that is the problem. I think that's more of a danger to society, right? Like, I think that's the danger, because then you're going to turn around and you're stuck. Like, I mean, it'll get to a point where there's no returning.
Well, I think the real threat to our society is fucking pharmaceutical industries, fucking medicating children and doing all kinds of shit like that. Never mind, like, putting that in the backdrop. This is why, like, I mean, for me, flat Earth is important to, because like they say, like art, even like flat Earth is like art almost. And it's like it's to disturb the comfortable, and comfort the disturbed, right? And I love that, like that idea that like flat Earth is like, it's like the real issue, the real threat to our society is these people that are drugging their kids at fucking whatever year old because they think they got a chemical imbalance, which God knows if that's even a possibility. You know what I mean? Like, it's so weird. Like, I just think flat Earth is a luxury, but like it is the backdrop to the nihilism, and that's what's crucial in exercising it.
Yeah. Well, don't you agree that flat Earth, the truth of flat Earth itself, wouldn't really fix society at all? It's not actually the shape of the Earth that matters at all. It's just that once you see that, you're forced to re-examine everything else. So, like, That's why it changes society. That's why I talk about flat Earth all the time. It's because it's not really about flat Earth. It's about the fact that we were put under a spell where they told us made up pseudoscientific stories that they're constantly changing, and they tell them to the layman who didn't devote their whole life to learn the pseudoscience as if it's fact, and then we're brainwashed. So, like, think about it. Now, what did flat earthers not do through the last 3 years? They weren't scared of the air. They weren't standing in line for bioweapons. What do they not do to their children? Attack them with bioweapons. Like what what do they not drink? Fluoride water. So like flat earthers are over the target, right? And it's not just because of the shape of the earth. It's just because they were forced to re-examine everything they previously took for granted because they realized, whoa, I took something this big for granted and was wrong. I definitely can't afford to take other things for granted that could have serious consequences. I think that's why flat Earth is important, right? I think we would maybe all agree with that. I think it's just the implications of figuring out the Earth is not what we were told. It's what people do afterwards.
I think it's not so much that the truth of flat Earth is this game-changing thing, like if it's flat versus it's globe. I think it's the magnitude of it. Like it's something that is so big that virtually everybody was taught, and it ends up being wrong. And then you realize, well, someone had to know, right? So that, I think, is why it lends itself so nicely to kind of wake people up to the other things, and that's why, like you said, flat earthers did not put a mask on their face. They did not, poison their children and themselves and all that. So I think just because it's not like super crucial, flat or globe, doesn't mean it's not a huge thing, if that makes sense.
Yeah, I mean, it's for sure. I mean, the evidence speaks for itself. Just look at the life that the average flat earther lives compared to the average person. They're distinctly different. Look at the goals for society the flat earther has compared to the average person. They're distinctly different. Now, there's crossover with like typically conservatives and truthers, meaning like they don't like sexualization of children in school. They don't like a bunch of stuff like that. But for example, like flat earthers are working together behind the scenes to create homeschool curriculum and programs that will pay the mother to be able to stay at home with their children. They're all learning about permaculture and electroculture and ensuring nutrition and food, because we see that around the corner is there will be no food shortage. There'll just be a nutrition shortage. Like we're able to start to piece together that there is, in fact, an orchestration behind the scenes to basically enslave mankind. And like we now flat earth makes you realize that. Flat earth makes you realize there's no more avoiding that. So then what else are they doing? And then you start to see, oh, look, big pharma, the Federal Reserve, right? You start to see all of it. And the flat earthers are the only ones that, just generally speaking, the ones that are going to check all the boxes. That's why it's important. And that's why some people, like, just bring up any topic with these ballers. It doesn't have to be flat earth. They're going to defend the status quo 9 times out of 10. They're going to defend the government, defend the system, defend big pharma, right? They're going to defend all of the propaganda. I mean, do you guys agree? 9 times out of 10, the generalization.
Yeah, man. I mean, we see it in here all the time,
Yeah, you have people that defend fluoride in drinking water to this day in this room.
Yep.
A proven neurotoxin that actually makes you age faster, scientifically proven to make you age faster, and scientifically proven to be a neurotoxin. And they're giving it to babies. And there will be people that defend it. I mean, so those are for sure my ideological enemies. Like we cannot be on the same team. Like, oh, we just disagree on cosmology, agree to disagree. Like, no, it's deeper than that.
It's ironic that they think that we're all conspiracy theorists who fell for these tricks, but really, the term conspiracy theorist and the connotation behind it and the design is tricking all of them. And they don't stop for a second to think about it, just the way they look at things. And they don't want to consider
taking the easy way out and conforming will always hurt you in the long run. But it's the easy way out in the short term. It's the more comfortable way in the short term. And so some people, they can't see right from like beyond right in front of their face. I feel like, but it's whatever. I'm just pointing out. I'm not like I think it's over. We won already, and you can just start to see that the average person is not going to do mental gymnastics to defend astronauts disappearing from footage. Right? The average person doesn't do that, and so really the only battle they had a chance to win and to hold us back or to prevent us from winning is to prevent us from being heard. That is the only chance they had to win. That's why they stepped in and shut it down. The average person will never, ever, ever defend babies being given neurotoxin. Never. Ever. So the only chance you have to win is to distract people and to keep the true information hidden. And I think that they lost. I think they tried their best and they lost. So now we're about to step into the next era. In the next 2-3 years, you're going to see the ramifications of them losing. So I'm pretty optimistic about the whole thing. But it was a nice run, guys. You gave it a valiant effort.
Speaking of which,
Here's the thing, though. Oh, go ahead, Justin. I was gonna say, wait, real quick. It's like they're thinking it's gonna take like a few generations or something, like the way shit used to spread. But they're forgetting, dude, with the internet, with the bigger populations and everything, things are happening way faster. So I think they're even getting caught off guard with the speed. Even with their attempts to shut it down, they're getting blindsided by the speed of the rate of shit. The fact it's happening. You know what I'm saying? But go ahead, Justin. Sorry about it.
oh yeah, Whitsit, you were trying to say something earlier, and I had to take off for work, but you were saying that the angular resolution matched the 6 feet, or the 6 feet and the 3 miles, and you're applying that to the Rayleigh.
2.9 miles to a 6-foot observer.
Dude, you notice when Jesse says "speaking of which," it's never actually anything to do with what we're talking about. He says "speaking of which," and then it has nothing to do with what we're talking about.
Well, you said we gave it a good try, right? I'm not done giving it a good try.
Okay, but I don't want to talk to you. I'm actually carrying my baby inside now, so I'll talk to you.
Doesn't Walter Bislin's flat Earth horizon calculator say 2.9 miles for a 6-foot observer? And then it starts deviating from the globe, but it starts off right about the same, right? For 3.1, it's like right around 3 miles. Guess I could do the math.
Yeah, a 6-foot tall object at 3 miles would have an angular height of about 0.02 arcs degrees, which is about the angular limit of the human eye.
Yeah, have you ever seen what you call it is the Walter Bislin's flat Earth horizon calculator?
I don't know.
I love.
I don't know if it's still out there.
Yeah, how come? It's interesting because a lot of you cats are heavy on Witsit, but not on talking to the ideas. Sometimes.
He's hot, man.
Yeah, I know. See, because he's the hot thing, and they're just trying to stand next to the light.
That's exactly it.
What's up, Kosho?
What's going on, man? You grilling
Was that
today?
you, yo, Kosho? Was that you leaving the coke in the White House, bro?
Oh, that's where I left it. Shit.
I told you, man. I swear to God, you're Hunter Biden. Kosho is Hunter Biden.
He's got a crazy life, dude. It'd be crazy to be Hunter Biden.
Right. Oh, fucking right. He's like, whatever. Fuck that gun charge. Just kidding, brother. Good shit.
So Jesse, the angular resolution of the eye is basically where the horizon is.
At a specific distance and target size. It's just like cherry picking. It just happens that for a 6 foot tall object at 3 miles, it's just right at the limit of the angular resolution of the human eye.
Yeah, then it starts deviating. Like it starts matching the refraction, the refracted globe value there for a little bit, don't it?
So it's just a coincidence. It doesn't cause the horizon in some way.
No, yeah, it's just a coincidence because you could take well, no, seriously, take something that's twice as tall and twice as far, and now compare that to the Earth curve dip
Bro,
calculator. What?
you think it's a coincidence that if we're on a flat plane and we move 69 miles and from underneath Polaris and we get a 1 degree change, that puts Polaris at 3,958.7 miles, the exact globe radius. You think that's a coincidence, bro? You think that the angular limit matches the horizon to a 6-foot observer is a coincidence? Bro, I can keep going on, bro. You think everything is a coincidence, man? I don't get it, dude. Like, you think that you're a coincidence theorist, bro?
Well, no, the fact is that two formula can produce a chart, a plot on a chart that, and the two lines can cross. That's what happens. If you think that your Rayleigh criterion works for the distance to the horizon, then try it at twice the distance, okay? According to the
We
Rayleigh
see further, bro. We see further than the globe curve calculator predicts. They have to invoke a refraction fix, bro. It matches the flat Earth better.
Okay, you're good at math, right, Brian?
I'm all right at math.
Okay, so do this. We know that at 3 miles, a 6-foot object is right at the angular limit of the human eye, right? Now, let's take this same formula. A 12-foot object at 6 miles, twice the height, twice the distance, is the same angular size, right?
What?
Yeah, I could turn Livestream 2 on. You guys could go debate there.
Yeah. In fact, I'm a pass.
It's just kind of a chill holiday day. I don't know. Does it have to be Jesse railing on about things that he wants to rail on about?
Well, he's giving it his best try. But he's all right, man. But I think it is interesting, the coincidences.
Sounds like a good way to reverse engineer something by hijacking perspective.
And calling it all coincidence. But I'll end it though, Jesse, by being fair and saying that it starts deviating a little bit further. But dude, for the most part, it matches what we see in reality. And then even out past 3 miles, like you go out past that, you start incorporating refraction, which flattens out the globe. It still matches flat better. The argument's going to be at even longer distances than that. And when you start getting up like thousands of feet, there is no horizon. You don't see blockage. Like even NASA's paper that Gleeman put out there for everybody, it showed that at half a mile in altitude, there's no defined horizon. It just is like a line into infinity. Basically, you don't see blockage of shit from a half-mile height like you do down toward ground level, where it literally does match, what we'd expect with variations. I would agree, but it does start deviating. But then there's a corridor, like there's a limit to.
Well, yeah, doesn't don't the eyes like create a false horizon?
Yeah.
So, like, if that's I would think that would kind of be evidence that your eyes kind of dictate where the horizon's going to be.
If I'm in New York City and I'm like a mile above New York City, why can't I see London?
Why can't I see the Eiffel Tower?
Well, Jesse just told you.
Angular resolution is why
Jesse
you
just
can't
told
see
you the
it.
horizon. Jesse just
Why
told
did
you
we
the
unmute
horizon's
him?
at 3 miles. You know, Jesse just told you the horizon on a flat plane is at 3 miles, and he's going to try and stretch it and say,
Come on,
well,
Lale.
That's not true.
at 12 feet, you know, how many miles this for something 12 feet? It don't matter, bro. The horizon is right there at 3 miles, so you're going to have to start getting higher to see shit behind that, no matter what the damn Earth
Lale.
is, bro.
But
Right,
you're
Lale?
not answering my question because you
But hold
claim.
on. But you know that angular resolution is a thing, right? Because if you don't know angular resolution isn't a thing, then you can't really entertain the idea of the limits of what you can see to.
Lale, if you let me respond, because this is something I had a problem with what he said to Jesse a minute ago about how there's a coincidence between the angular resolution of the eye.
Hold on, real quick,
and
Kosho.
And the horizon.
Kosho,
Yeah, what is it, sir?
Can you turn your mic up just a little bit? Say it with your chest.
Is that better?
Deep throat your mic. Do something, please.
Do something with it. Box with your
Is
tonsils.
that better?
Even.
I gotta change my settings, but until then, does this work? Okay.
Sounds better.
Yeah, it sounds better.
Anyways, all right. The point is, what was the point? Oh yeah, right. The point is angular resolution, angular resolution, and the horizon.
Atmosphere.
You're trailing off, dude. Come on, speak with your chest.
Jeremy threw me way off, dude. Hold on. So yeah, the angular resolution of the eye is what for? So it's like at a 6 foot observer or a 6 foot observer 3 miles away will be unresolvable. That's only a 6 foot observer. Not every, maybe not 6 foot observer. That's only a 6 foot target. Not every target 6 feet. Right. So it's not a coincidence. It's only a coincidence if you're looking at things that are 6 feet tall. Right.
But you'd agree that the atmosphere itself prevents us from seeing more than about 20, 30 miles around ground level.
Depends on the day.
Lale's asking why we don't see London, dude. At least we straighten him out on that, so he'll trust it. We can tell him every day for a year, but if he hears it from a Glober, it'll last like a week or two before he asks again. Can you straighten him out on that, Christian? You wouldn't see London.
No, I asked that question specifically because you said the angular resolution of someone at 1,000 feet can see 200 miles or whatever you said. But then what about like if you're high enough to see 2,000 or 3,000 miles, but you still can't see London from New York?
I
Why?
said infinite. I meant mathematically, Lale. Like it's just a spot that it's just like an infinite spot. You can't mark it with a distance when you get up a certain height because of the atmosphere. It's
You
just
sure
a
about that?
spot. It's just, I mean, according to the paper from NASA, you can't make out the horizon at like half a mile or something. You know, you got clouds and all this other shit. I'm just saying, you can't pinpoint. Let's say it like that. You can't pinpoint the horizon.
You can estimate it pretty good though.
But
I could estimate it, bro. But
you specifically stated that does not prevent blockage. And I specifically asked if I'm 5 miles above the city of New York, what is preventing me from seeing on a flat plane London?
Yeah, does
the atmosphere?
Isn't there a false horizon?
The limits.
Yeah, your body you will create a false horizon by the way your eyes see the world, right?
Have you ever taken in high altitude drone footage? Hold on, I was already going before you went. Let me just say, have you ever taken in high altitude drone footage?
I have not, but what's the point?
Okay, so hop onto YouTube. It's really simple. Just type in high altitude drone footage on YouTube. You can do it right now from your smartphone or computer, whatever device you're on now. Hold on a second. I'm going to walk with you on something here. And what I want you to see is, regardless of the camera that's being used, what you'll notice is as the drone gains altitude, that means it goes higher up in the sky, the horizon rises with the thing. Okay, just hand wave it away. Nice chatting with you, my friend. Be well.
Chris, you gotta let people. Hold on, Brian, hold on. Chris, you just gotta let people finish, man. Otherwise, they're not gonna let you finish. So, you gotta not cut people off. Okay, Chris.
All right, so back to what I was saying. Appreciate the space. What I was just going to say is that you'll never see a picture of you'll never see the horizon not present with drone footage. This is my point.
But isn't that exactly what we would see on a globe?
Bro, Jesse, you're not going to do the, oh, it works on a globe too. No. Realize that if we're gaining altitude on something that has a set geometry, claimed 3959 radius, right, then as we go up from the surface, the horizon should start to go convex or concave, depending on which way we want to do it. But it should start to arc. The issue is we don't see that. The higher up we go, the horizon stays steady. In fact, we just see further out, which makes perfect sense because that aligns with SOHCAHTOA, Pythagorean theorem, sine, cosine, tangent, etc., flat baseline.
But what if Earth were a large enough globe that at, say, 10,000 feet, the drop was only a half a degree? You probably wouldn't even notice that on a GoPro or a drone camera, right?
Jesse, you're not going to do that. The issue is, again, 3959 claimed radius. That's in miles. That means on a globe, if I travel 100 miles, there should be a 1.25 mile drop for every 100 miles that I travel, and that's an exponential drop. That means it gets deeper the further I go. The issue is, again, you guys have given us, you've gift wrapped it. We get to open it every single damn day, 3959 claimed radius, and the issue is it ain't showing up. Where's the curve, man?
It's slight, and geometrically it should be slight, and if you measure it with something that can measure a slight angle, then you will see it.
Where do we see it when you measure concave Earth? Do we see it there?
Nope, that
was good.
That would be the other way. But like, if you get a few hundred feet above the water and measure it, it's not going to be above eye level. It'll be below eye level.
Can I respond now, please?
Well, Lael, I was gonna.
Fine, whatever.
Well, if you want to go first, but I was going to actually ask you a question. So unless you do want to respond
to this question about the drone, I'm sorry to say, but no matter how far you are in what apparatus you're using, if you're above sea level on that, the water or this land is below that. So the horizon is the apparent line where the water and land meet, and that will always be below the context of what you were talking. An airplane flying at cruising altitude or a drone, that'll be below that point.
Lael, I respectfully, my friend, honestly, I say this respectfully, dude, the best thing you can do for yourself right now, instead of sitting here and saying nuh-uh, and I'm asking you on a human to a human level with intellectually honest observations, to please open up YouTube, right, and type in high altitude drone footage and just look at the scenery. Take in nature without the influence of other man's words. That is my advice to you right now.
I'm using my own observation on the last airplane ride I rode, and guess what? That goes higher than any drone. Any drone you've ever flown, the airplane ride I was on goes higher. The water of the ocean or lakes or rivers or the land is always below the airplane.
Lael, look at the world record footage, bro. It has a mountain.
I don't care. Are you guys disputing? Are you guys disputing that the water and land are below the airplane when the airplane is flying at 30,000 feet?
I'm trying to respond, dude, and then you cut
me
me
off. You're
off.
not. It's a yes/no question.
Yes, I am. I'm trying to respond.
It's a yes/no question. Is the land and water below the airplane at 30,000 feet? It's yes or no.
I say yes. Please quit cutting me off. Yes, but listen, you look at the world record footage, and it's not limited by Earth curve or it's not even limited by angular resolution. It's limited by the atmosphere. The 270 mile the lighthouse with the lighthouse that's on the mountain or on the edge of the mountain, whatever. That lighthouse, it's limited by atmosphere. It's nowhere near being cut off by Earth curve or being limited by angular resolution. It's halfway up the picture, Lil. It's
great.
Literally
that has nothing to do with what I said.
bro. It's limited by the atmosphere, Lil.
That has nothing to do with what my
yes,
point.
It does. You asked why can't we see
my
London?
Point is that if the water or land is below the thing that you're talking about, the horizon is down from that. It is not at eye level.
Yeah.
Period.
Are you just saying that the horizon on an airplane is below eye
level?
No.
If you are above the land or water at any altitude, the horizon is down, because the definition of horizon is the apparent line where the water or land meets the sky. And since water and land is below your eye level, the horizon therefore logically has to be below eye level.
The problem with your statement.
That's what a dip angle is. Yeah, of course.
The problem with what he said, though, it's not always below. Like I just said, Jesse Gordon has measurements above.
No, he's talking about at altitude.
Well, you said any altitude.
Any altitude. An airplane, the land, or the water is below the airplane. Therefore, when I'm looking out and I see land, or the apparent spot where land or water meets the sky, that is down from where I am at.
So you mean at a high
water is
we couldn't see
right
London
there.
from New York, bro. You asked us why we couldn't see London from New York. You realize that was a fallacious question. You realize that on either model, we're never going to see London from New York at any altitude, bro.
I am actually 100% correct. The water and land are always below an airplane flying at cruising altitude. Therefore, if the definition of a horizon is the apparent spot where the land or water meets the sky, that spot is actually down from the airplane. Even though it may appear to be at eye level, it is not. It is actually down.
Okay, yeah. Does anyone disagree with that?
No. And it's indistinguishable.
Okay, then I'm just wondering why. Yeah, Lael, I don't think anyone disagrees with that, unless anyone wants to speak up and say they do. But I think you're making a point that everyone agrees on.
Right, it's a function of distance, Lael. The national paper pointed out that there's no determinable horizon above half a mile in altitude. So when you start getting hundreds of miles out, it all depends on how far you can see that day. It's a function of distance on any model, Lael.
But I was going to ask you, Lael, the question you asked, why can't you see London from New York kind of thing? I was just going to ask, like, what would be your top 5 reasons you've heard people say that you wouldn't be able to see that over a planar surface? Just I was wondering, what are the top 5 ones? Because I know you've been in this for years, so what would you say the top 5 ones?
I care less what people say. It's what I believe. The Earth rotates, for one thing, and so that.
Okay, hold on. You're obfuscating the question. If you don't want to answer the question,
I'm answering it the way I want to answer it.
This is not answering.
The Earth rotates, and it's a sphere. Those things and many other things and the atmosphere of the Earth prevent me from seeing London from New York City, no matter how high I rise into the sky.
Okay, so what are the top 5 reasons you've heard that people that say the Earth is planar and not curved? What are the top 5 reasons you've heard why we can't see that over a planar surface? Because that's what you originally asked about. Do you know what have you heard 5 of them that people have said?
I could care less. It's what I believe.
All right, let's just start with 1. How about 1?
No.
Let me give 1.
Earth doesn't exist.
Is it that
it doesn't exist?
So you don't have any reasons why you've never heard anyone say any reason of why you couldn't see London from New York? Is that what you're saying?
I could care less because the planar Earth does not exist.
There you have it. Okay. Well, I mean, with all due respect, do you just not listen when you're in the convos, or can you not remember them, or?
Whatever your answer is, I don't care, because we don't live on a planar surface.
Yeah, but you have to give some sort of evidence, dude. That's the point. You can't just say cuss things and stuff. That's what Gio's saying.
Like all flat earthers do.
What?
You don't know what we do because you don't.
I just gave 3 examples. The Earth is a sphere, and it rotates, and the atmosphere causes us not to be able to see London from New York City.
I understand that's your assertion as to why you might believe that. It's
not an assertion; it's fact.
Right, you're interrupting. Hold on, man. You can go right after me. I understand why you're asserting what you think it is on a globe, but you asked us how is it working over a planar surface. So that's why it's just like we've been talking lately within debates that it'd be good to do more steelmans, where like if someone asks a question or if someone says something, the other person, before they respond, they could repeat back what the person said to make sure they understand it. So I was just asking you, in light of that, since you asked us, and I know you've been in these conversations for years, what reasons have you heard as to why you can't see London from New York over
the atmosphere? The atmosphere. Now, steelman my position and tell me exactly what I said the way I said it, and don't say it any other different way that I didn't say.
You asked the question as to why we can't see it.
Because the Earth's a
Yeah,
globe,
and I
and that's
answered
a
it.
fact. You said because the Earth's a globe, and that's a fact.
No, I said more than that. You're
You said, okay, it's a
misrepresenting
globe, and
again.
it's rotating, and that's a fact. Sorry.
You asked the question why we can't
The
see London.
atmosphere and the Earth's surface is curved. That's why we
Wait, we
cannot
can't
see it.
see London from the ISS. When the ISS is over New York, Lil, we can't see fucking London. So you're just talking shit, dude.
What?
Just
You
relax.
heard me. We can't see
That's
London
because the Earth
when
is a
the
360
ISS is over
degree
New York,
sphere.
Lil.
That's
You
because the
realize
Earth
that,
is
right?
a 360 degree sphere. And if
Why are you
London's on
bringing
the
it up?
opposite side of the Earth from New York, then of course the ISS, if it's facing New York, won't see it.
So why can't we measure the horizon then? If it's this perfect sphere, NASA says we can't make it out over half a
Did I say
mile.
you're
Yet it's just
misrepresenting me?
the
All right, let's
ISS
do
shows a
something
defined
constructive, though.
horizon, right?
How
Let me
about he
actually
doesn't
give the reasons.
misrepresent? I never said the Earth was a perfect sphere, so don't put words in my mouth I don't say.
Okay, let me just actually give some reasons why we wouldn't see it over a plain-like surface. One of them would be atmospheric turbidity. There's particles in the air. Another one, so that's specific. Like, let's get specific about the atmosphere. I mean, I don't know if anyone just says atmosphere. But there's also, you have bending of light through the atmosphere. That's another thing. It could be It could be magnification. We've actually shown how magnification can cause things to go below horizontal. What else?
I'd say the point at which the ground and the sky meets is way, 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 way closer than London would be. It's dramatically closer. Like,
Yeah, but why can we see the sun?
like-
If the sun is at least 3,000 miles above the surface of the Earth, why can we see that but not see London when London is closer to us?
Yeah, it's a decent point because the sun can be seen at thousands of miles in terms of when it's setting. So that is true. I would say it's because it's very, very bright and it's a massive bright object in the sky.
No, there's nothing big enough in London for us to see. We can barely see Canada at 200 miles with the sun behind it.
Well, yeah, just
We
the
can't
angular
see-
resolution. Yeah,
What
it
is
would
in
be too
London?
tiny.
What is in London that's 22 times bigger than Canada, Leo?
Right, it would be so.
And what?
Something if it's
The
that
whole
much
country
further,
of
if it's
the whole
2,400
country of
miles
England
away,
I cannot see from New York City. The whole country.
what's big enough there? We can at 200 miles.
The
okay,
whole entire country. The
Hold
whole
on, bro.
entire country. I cannot
Yeah,
see
but
the
if
whole entire
Canada,
country.
why do you interrupt me, bro? Right when I go to talk. If Canada is 2 miles high, right? It's 2 miles high, and we can barely see it from 200 miles away. Now you're talking something 2,600 miles away. What is 2 miles high in London? That it would have to be like 20 miles high for it to even look the size of Canada at 200 miles, bro. You're just not thinking.
Canada is a smaller object than the whole country of the United Kingdom. I'm sorry to tell you that, Brian, but that is
What's tall enough?
100% fact.
What's tall enough, Lil, in London? That's
I
over
could
200
You realize
about the size of the object. The size of the object is larger. Not London, the whole country of England. See, now you're straw
Leo, when you're looking at
the whole
something,
country of England is larger in angular size than
Well,
any.
if I stand under a building, I
hold
can't
on,
even see
Bri.
a tank window.
Bri, hold on. If you're looking at something, let's say I have I don't know, a square cracker, right? And I'm like, yo, the angular size of this shit is fucking nice size. And then I flip it on its side and I'm looking at it from a different angle. Its angular size is not going to be the same as it was when you were looking at it. It's not the same thing. You know what I mean? Like the mountain, you're looking at it side on. The whole country of England, you're not looking at that. It's not like that's sticking up out of the air for you to see vertically.
It's sticking out of the ocean.
What's up?
It's sticking out of the ocean. A lot of it's
How
above
much?
sea level.
Yeah, but not anything near Canada, though.
Yeah, but the angular size of England is larger than the angular size of London or of Canada.
So you're not listening. That's like when you're looking at Canada, you're looking at it, the vertical profile of it. You're not looking at England, the vertical profile of the whole country of England. It's horizontal to you.
Yeah,
Come
Brian's
on, bro.
original point was a good point. That you would not be able to see that even if you could see that. Like, okay, if you can see the sunset 1,000 miles when it sets, let's say London was right there at the horizon, and somehow you like the atmosphere somehow was not there, so you were able to see. The angular resolution would be so minuscule that you wouldn't be able to see it anyways. Just
If the horizon's only 3 miles away for the 6-foot observer, when the sun appears to set on the horizon, how far away is the sun?
It depends, but it can
or
be.
Let me rephrase that. How far away is that horizon? Does it change?
It's about 5,500 miles, maybe 6,000 miles. That's my guess.
So if my horizon is 3 miles and the sun appears to be setting on the horizon, how far away is the horizon?
Bro, you got to acknowledge our first point first. Acknowledge the fact that we wouldn't see London, okay, because there's nothing big enough in London or anywhere for that matter for us to see it 2,000 miles away. Can you acknowledge that first before we move on?
The whole country of London is pretty big.
But bro, we can't even see the top window if we're standing under a big building. So who cares how big London is?
If I move,
doesn't matter, bro.
Why do I have right underneath? If I'm like 50 feet away from the building, I can see the top of the building and see the top window.
You can't see the whole top window. No, you can't.
Yes, I can.
Not
50
with
feet isn't that tall. Now, if you're talking like 200 feet, that would be different. I'd have to be
even
further
see
away.
A 30-story building, you can't make out. You can't see the
Well,
whole.
a 30-story building is a lot larger than 50 feet. You said 50 feet. Now you're saying anything at 30 story.
Bro. I can't do this, Joe. It's like talking to a goddamn donkey.
Yeah, it's typically 10 foot per story, brother.
And now you're changing it to a 30-story building. There's quite a bit difference between those two.
Right, take 5.
Well, let us
settle down. It's a holiday, like Gio said.
Yo, guys, I just want to take an opportunity. I posted in the chat. I apologize. I'm saying angular resolution. It's actually optical resolution. Optical resolution is the thing that somebody talking about me.
Yeah.
Brian's hot micing. We fixed it.
All right, cool. Thanks, man. I appreciate that. Yeah, no, it's not angular resolution, guys. Optical resolution. Optical resolution describes the ability of any imaging system, which including your eyeball, telescope, things like that, to resolve detail in the object that is being imaged. An imaging system may have many individual components, including one or more lenses, et cetera, et cetera, et cetera. In any case, optical resolution is the thing that you're looking. You go to the optometrist, get your eyes tested, and yeah, optometry is it.
Like, for example, if a cruise liner with words on the side is traveling away from you and they get to a certain distance and you can no longer make out the details of those words even though you know what they are, that is the limit of your angular resolution, to make out that detail.
The optical resolution. It would be the limit of the optical resolution, meaning that the boat has sailed beyond the capability of whatever viewing device you're using. If it's your eye can no longer resolve that image. Therefore, it dissolves.
Yeah, I'll give you the.
What unit is optical resolution measured in?
Don't do that, Jesse. Don't.
I
put
actually
forward.
stated it right.
Hold on a second here. Hold on.
An angular resolution of 0.2.
I put forward an observation based, and it didn't talk about distances, nothing. It is specifically just a thing. There is no addressing of units at all. And the fact that you even asked that question, this is where I start to look at the witness that gives evidence, and I'm like, wait a second, witness Jesse, what did you just ask? What is units? The units measured of optical resolution? Like, no, man. You can't do that.
My eye,
You're measuring pixels, right?
What I specifically stated, which my eyes are optical, is that if a boat is traveling away from me, when the letters on that boat appear are at a spot where my eyes can no longer resolve them, that means those letters have reached my angular resolution limit. My eyes are optical. Anything you look through is optical. So yes, you have to look through an optical thing to see stuff.
Okay, that's profound actually. But yeah, we're measuring this shit in pixels these days too, right? We got some professional pixel measurers out this bitch.
I never
Have you had your eyes
in my mouth. I never said the word pixel.
Have you had your eyes checked, Lil?
I didn't say you. I just said that's how they are measuring this nowadays, right? Ruhif's out there measuring pixels. We got a bunch of pixel measurers running around.
You see here, Stoic is misrepresenting my argument. I said the angular resolution is a spot at which I can no longer make out those letters on that boat. The letters on that boat have reached the limit of my angular resolution, and therefore I can no longer make them out.
How long have you had that problem?
I wouldn't say I'm misrepresenting your.
Everyone has that problem.
Hold on a
What are
second.
you talking about?
Try eating a carrot.
Did you address me correctly, or address me directly?
Go ahead.
Yes,
okay, that's cool. I'm just checking in. So, you said that it has gone beyond your ability to resolve the image, and I'm misrepresenting you. The issue is
it went beyond my angular resolution to
angular
make
resolution.
out.
Right.
Angular resolution is the ability to make out detail. If I can't make the detail out of those letters, then it has passed beyond my angular resolution.
Okay, so if I presented a definition from Wikipedia, which I think is a trustworthy source, globe or flat, regardless, and it says what it is within the confines of it, is that not what it is you're describing?
There's an all or nothing fallacy incoming. Any second now.
No. I specifically said angular resolution is at the resolution at which when a thing passes beyond your ability to make detail out of that specific thing, that is your angular resolution.
Okay, so you go to the eye doctor and you get your eyes tested.
That's what I was
He's called an
I'm sorry. An eye doctor ain't going to make me be able
you're not
to see
walking
30
on me.
miles.
You got to talk. Now I'm just going to keep talking until you stop. Thanks. So you go to the eye doctor. He's called an optometrist, and he runs an optometry clinic, and they measure eyeballs. Now, when you can't, no, you're not going to do that again. Thanks. Now, if you can't see stuff when they're asking you to read stuff on the board, you say, sorry, I can't read it. And then he changes the lens, right? And that's where we get the idea of atmospheric lensing as an idea. But the idea of angular resolution, again, I corrected myself because I presented that forward about 10, 15 minutes ago. And then I've retracted it to state that it's optical. Right? You're not going to take the idea of angular and say that I can't see something because of the angle. Because the issue is I don't go to the optometrist to measure the angles of my eyeballs. Thanks, I withdraw.
Actually, what he is doing is he's changing the angles at which the light comes in when he changes those little knobs. He's changing the angles at which the light comes in so the resolution of your eye can see those letters better. That's exactly what he's doing.
No.
And you can go to one today and go ask him.
That's not what's happening.
What the lens does is change the direction which light is coming in.
It adjusts the angle at which the light comes in so that you can see that better.
You tried eating a carrot, Lil.
That doesn't matter. If the object is 5 feet away from me and I can read it perfectly, and now it's 300 feet away from me and I can't read the letters anymore, there's no doctor that can make my eyes all of a sudden read those letters better. It has beyond the point at which doctors can change my angular resolution, which is 0.02 degrees, to be able to read those letters.
It's called an optometrist, dude.
Yeah, I understand. You don't need to talk to me like I'm an idiot. I know what optometry is.
You're an idiot.
It's a study of the eye.
Thank you. I already know that.
So I'm just saying, you got to
relax, guys. Slow, relax.
I would like to know why, in the example that I provided, more of the ship is gone than the angular resolution of the device. If we're talking about the bottom of the ship is missing due to angular resolution, we can see in the example I provided, the angular resolution allows you to resolve really tiny details, and the very large portion that is missing is still missing.
There's other effects other than angular size, maybe in conjunction with angular size.
Such
So
as
not angular resolution then.
It could be in conjunction with another effect. You know, you get two effects mixing in, you mix it up for a little party punch.
Well, if we know the angular resolution is such that very tiny details can be made out, then the very large portion that we cannot see cannot be because of angular resolution. That's not why it's gone.
It does cause objects to become smaller in the distance. So
Angular
that is
resolution does
valid
not
for-
change the size of anything. Don't say that bullshit.
when you get farther away from something, the angle to it decreases and it gets harder to see. What do you mean?
right, the angular size.
Why are you so aggressive? Yeah, why are you so aggressive? Just relax, man. This doesn't have to be whatever you're trying to make it.
Right. But you're not describing angular resolution anymore. You're describing something else.
What's something
is
else?
angular resolution the angular size of something, or
No. Angular size
what's
is angular
angular
size.
resolution?
Angular resolution is angular resolution. Those two are different
Okay, what's
things.
angular resolution?
Angular resolution is the smallest detail that you can make out. Anything smaller than
What do you
that
call it?
won't be
Wait, hold
resolved
on.
as separate.
I
What
thought
do you call it when we're looking at a building and we're standing up under it, and as we get closer to directly up under it, we can't see the window of the top floor. What do you call that? So I'll know what to call it.
Well done.
What do you call that?
Right.
Where
The
I lost
size
my
of the
angle.
window in your
Wait, hold on.
particular example.
No, I'm talking about I
I
lost my
guess I
angle.
don't get to reply yet.
No, I want to be clear, bro. So you answer first and foremost. Okay, I'm not talking about the size of the window. I literally lost the angle to the window, and now I can't make out the whole window. What do you call that? Angular limitation or what? I'm just asking.
All right. Do I get to reply this time, or are you going to talk over it again?
Yeah, I just didn't want you talking about size.
All right. Here's my reply in full, regardless of your feelings on the matter. The angular size of the window has dropped below the angular resolution in your specific example. However, in the example that I provided, the bottom of the ship is much larger than the angular resolution of the capabilities of the device. So your explanation, your example, does not address my example.
Do you agree that on a flat Earth we wouldn't see London from New York, right? Just to where
Depends on what particular in London you're talking about.
we're dealing with 5-year anti-flat earthers, bro, and we're literally back to square one, where they think we should see London from New York, dude. This is a joke. They're so dishonest, dude.
Right. And your argumentation skills provided a reasonable
No,
rebuttal.
dude, he just explained to you how a small
Don't
little
interrupt.
window.
Yo, don't interrupt. Do this was mid sentence. Let's not just everyone relax, please.
This ain't a
And
conversation.
Brian, you really didn't even address his point, so you did kind of
Me?
You did you didn't even address
Ask him a question, bro. He
You
addressed
kind
my
of
point.
you actually just did a bunch of ad homs is mostly what happened. So do you have any actual
Oh, I'm
response?
sorry, bro. I asked him a question. I asked him not to say size because I know they don't call that size. I literally said, besides size, what do you call it when we lose? Because they're saying that it's not that. So I'm asking them what they call it when the angular limitation, what do they call it? So I'll know what to call it in the future when I'm describing losing the angle. In other words, I've still got a positive angle, but it's just not big enough for me to see that window up on the top floor. And I'm asking him, what do they call that? Because they obviously don't call that uh, angular resolution. So I'm asking him, what do they call it? I asked him, please don't refer to size because I understand it ain't that. It's something else. But I wonder if they even have a name for it because it's real, right? We do lose the angle. It's still a positive angle, but we can't see the whole window on the top floor. So I'm asking him, what should we call that? So I know how to move forward honestly.
Just say it
When we're
again.
talking about that detail on that window and you can't resolve it anymore, the window is below the angular resolution.
Limit,
That
yeah.
window's angular size is below the angular resolution.
Yeah.
But when I gave an example of more of the bottom of the boat was missing than the smallest detail we can still make out, that your example does not address my example, Brian.
No, that's simple magnification, bro. Anytime you see bottom up obstruction, it is accompanied by magnification without fail. Always.
I would actually agree with that.
If I may jump in if
Yeah,
I can jump in for a quick second, just to say that's what I understood as well, is that optical resolution is the ability to resolve objects. If it's the boat sails away from you, you're losing your optical resolution on the object. Now, if a car, as an example, you're looking at a car, you're looking at it from the front, and you want to understand further geometry or further massing of the car, you change your viewing angle of the car to understand the depth of it and further characteristics of it. Change your viewing angle. That's what I thought.
Angular perspective.
Okay, we'll try this one more time. We
No.
can see in this
You don't have
particular
to
example
demean
that the
my
size of
observation
the
by saying
smallest
it like
thing that
that,
you can
dude.
make out is
Hold on.
very
Okay.
small. However,
Hold on, yo. You
somebody's
went, bro.
trying to interrupt again, of course.
Hold on, Doofus. Yeah. Just let him go, and then you can go next.
All right, in this particular example, we can see that the size of the smallest thing that we can make out is very small. Therefore, we know the angular resolution is very high for this particular example. The amount that we cannot see of the bottom of that boat is much larger than the smallest detail that we can resolve. Therefore, the bottom of that ship is not missing because of angular resolution.
Well, I like what Brian said
Let
about
me
the
tell you, we can
magnification
zoom in. Yeah, we can
because
zoom
I
in
also
angular size. We can't zoom in a better angle. You realize that from wherever we're zooming at, we've got that same angle. We're not zooming in a bigger angle. We can zoom in and make things bigger angular, like their angular size bigger, but we can't change the angle that we're viewing from. So once you lose something due to angular limitation, that's it. You could zoom it in all you want. You're not changing the angle, but but magnification is usually accompanied. Like I said, in fact, it's always accompanied with these. When you show a container out in the distance and one's closer, like the one in the distance is just the same damn size as the one up close, and the one in the distance is like almost 3/4 blocked. Why is it the same size if it's 10, 20 miles further? I'm just saying.
What you're describing, Brian, is no longer angular resolution. You're saying it's some kind of angular limitation, but it is wholly separate and completely described differently than angular resolution.
Right. That's what I was asking the
well,
definition for. What do you call that?
hold on. Depending on how you change your angle to something, it could change its angular resolution. So you get up higher, you can see more of the squares on a chessboard, for instance, as opposed to having your eyeball right down against the surface.
The angular resolution of an optical device does not depend upon the orientation of the thing in the distance. The thing in the distance has nothing to do with it. It's the optical device where the angular resolution is occurring.
Yeah, but if I'm standing under that building, I can have a camera and I can zoom up. I'm not going to see any more of that top floor. Whatever I can see, it'll be bigger, but I won't get anything back angle-wise. So if you're looking at something out in the distance that's blocked from perspective from an angular limitation, you can zoom in all you want, make the ship bigger. You're not increasing your angle to see the shit that's missing due to angular limitation, due to converging in with the ocean floor.
I feel like the angle you look at things definitely plays a huge factor in how you see them. especially when we're dealing with long distances over the atmosphere. Now you're looking at different mediums and shit.
Right, but the words I used wasn't just how we see them. The orientation of the object in the distance does not change the optical device's angular resolution.
Does
Impossible.
that mean how much it can zoom in?
No, that means how small of a detail an object can be, or the details can be resolved.
At a certain distance?
It has nothing to do with distance.
How small the angular size is of a thing that can be resolved?
Right.
Okay. Now what?
I saw a thing like this. Sorry, Doofus. I saw a thing like this once where, and I haven't got it, so I'm happy for you to dismiss it because I couldn't go find it. But it was, I can't even remember if it was a ship or a building, but it was just like that. And he changed the lens, and he put an infrared lens on it, and you saw more of it. You saw more of the thing. So what does that mean?
I don't know. I'd need to see it.
Yeah, I get it. But
Maybe
it just,
you could zoom in better.
Do you think it's Earth curve? Is that why you can't see it?
Well, I don't know what you're asking me to pontificate on something I can't see.
No, I'm talking about your image. Do you think that's a sphere edge horizon? Is that what you're saying?
Spheres don't have edges. What I see in front of me is that the water is in the way of the ship. If I'm going to trust my senses, what I'm seeing is that the water's in the way.
Right, but why is it? So it's not like behind the curve then of the Earth. You're not saying that, are you?
I mean, flat surfaces don't do that, but the water's in the way.
Oh, okay.
So is that due to the curve of the Earth, or is it a limit to your vision? What are you thinking?
I thought I just got through saying flat surfaces don't do that.
So you can
Question-
see whatever on flat Earth?
Question for you, Doofus. How high is the thing taking the picture? How high is that above grade?
Above the surface of the water, about 9 to 10 feet. I can't remember exactly the observer altitude, but it's somewhere in that very narrow range.
So there's the potential for this the visual ramping to be occurring as well, correct?
Can you describe visual ramping and how it's important here?
Well, if we take, like, let's say I'll exaggerate the numbers. Let's say we have something that's maybe 20 feet above the surface that is taking a picture of. We know that as, again, like I was saying earlier to Lael, as we gain altitude, that horizon line will rise up to meet with us. So my question becomes, if we're taking a picture of the horizon composition across a body of water, then there's the potential that that body of water would rise to the eye level of the thing taking the picture of whatever it is, and it would happen to catch, if there's buildings in the distance, happen to catch those buildings as well. So that's my main question, is what is the height of the thing taking a picture of this right now? Because that will give us an idea of what we're dealing with.
All right, after answers that, I'm next.
I'm good. Thank you for the space.
Answer to do this. You're on.
Yeah, you're suggesting that the surface, which you presume is flat, is somehow getting in the way of something that is above that same surface in the distance, which geometrically doesn't make any sense.
Okay, please don't put words in my mouth. What I'm going to say is, right, it's the idea that, and we had the definition presented by Lael earlier, that basically the definition of horizon is where the floor meets the ceiling. Yeah, I made it really, really short, but that's basically what it composes of. So my question is, again, if this is a picture taken across a body of water, which I know for a fact it is, because my mind can extrapolate what's actually happening here, right? There's a camera mounted on a body on land, and then it's over a body of water. I don't know what it is, what lake it is, or a coastline, but then there's a city behind there, and there's a distance between the city and the horizon, right? So the floor, so to speak, is rising to meet the thing taking the picture of the horizon line. It's just like when you stand in a hallway, right? You stand up and sit down, as an example. If you've ever done that in a hallway, you'll see the ceiling lights get closer to your head, closer together as you stand up, and as you go down, they get further apart.
Okay, but you're still suggesting that the flat surface, you presume it's a flat surface because it's water, is somehow ramping up to be in front of something that is farther away from you and still on top of that very same surface, which geometrically doesn't make any sense.
Yeah, it makes tons of sense because again, right? And at this point, we're just going to be like arguing back and forth, which is pointless. But one of the laws of nature is that in fact water seeks its level. So we know for a fact that water is level in this picture, right? So again, the only thing that I think we really, if we're being intellectually honest with this observation that you're presenting, right, what's missing is us being able to say how high above this water are we when we're taking this picture. That's all.
9 to 10 feet, I already gave that to you.
Thank you.
Right, and the amount missing on the distant ship is more than 30 feet. Or 30 feet and more. Somewhere around 30 feet.
Yeah, what about tomorrow
Just
when
to,
nothing?
hold on, Bri.
What about
Hold
tomorrow
on,
when
Bri. I
nothing?
was next. I was next, bro. Relax for a second.
Yeah, Jeremy called it.
You can go next. You can go next. I called it. Yeah, it's like shotgun, bro. You can't. You know, I got Moran shotgun if I call it. So listen, I would actually agree. The angular resolution, if that means how much you can zoom in on angular size and shit of an object, you know what I mean, or whatever. The better camera you pull out, like you're not gonna be able to resolve that cut off part of the ship or whatever, the building that's cut off. That's not an angular resolution. I'd actually agree with that. And as far as what what's his name? King Clown? I don't know, just change your name. Whoever was just talking, the higher up you get in the hallway, you see. Who was
Yeah,
it?
what's up, homie? Kiwi, whatever you want to call me, dude. It's all good, man. Thanks, Jer. Appreciate it.
Kiwi?
Sure, man.
I'd like to disagree with that hallway example. When an observer is in the hallway does not rise to their eye level. Not that reality does either, but it definitely doesn't in an eye level. And when an observer is in a hallway, they could point to whether it's their horizon or the ground, and they'll be pointing to the ground. Unlike the ocean, where when you stand over it and you point to the water, you're pointing above the ground. And if you were so happen to go higher, then we're really fucked then. This doesn't happen in a hallway.
Yeah, it
Well, no, hold on. Let me address. All right, go ahead, Bri. Well, all right, real quick. The hallway thing, right? We're on the ground at the beach. We see more of the sky than we do. If we were to raise an elevation, we would start seeing more of the ground and less of the sky. When you're in a hallway, it's very analogous because when you're in the hallway and you're on the floor, you see more of the ceiling. Right? It's just like a hallway. You go up, you start to see more of the floor, less of the ceiling. I like it, and Jeranism had this guy, I forget what his name was, but Jeranism had a guy on that went over this hallway thing in depth, in detail for like 3 hours. It was awesome. I don't know who caught that.
I think I know what you're talking about. But I hate when
Somebody
people say
post
the
that.
horizon's down.
Somebody post that if they got it. That shit was fire, bro.
You talking about Life Short? He's got
I don't know who it was. He had all the squares laid out of the floor tiles and the ceiling tiles and shit, and all the lines. It was crazy, bro. It was like crazy in depth for like 2-3 hours.
I hate when people say that the horizon's down. Like the horizon is never down. It's always out. We're never looking down at a fucking horizon. Not from an airplane, not from the Red Bull jump. It's always out. Like to the untrained eye, without some kind of instrumentation to measure minute little angles, it's always out, way the fuck out in front of us. We're never pointing down at it, dude. I can't stand listening to flat earthers saying the horizon's down. Like my feet are down.
Yeah,
You know what I'm saying?
and that's one of the things that is one of the proofs that even people will state is that we see too far, right? We gain altitude, we go higher and higher, and it literally it would suggest an infinite plane. And the only reason we can double back and come back down to the fact that there is in fact an enclosure or something is because of this observable gas pressure. We know we're in a closed system. But the actual visual observations that we have is like, bro, I constantly see the floor meeting the ceiling no matter how high I go.
Yeah.
that's a problem because eventually you get high enough where you start pointing to the horizon like in an airplane, and you're pointing 30,000 feet in the air. And if water is level, your water is not 30,000 feet in the air. So so what's happening then? So the only solution I know of would be it's perspective. Okay, so if it's perspective, I can point to the ground that I'm standing on directly below me and I know it's there. But now if I point to the horizon and I'm pointing a positive angle of inclination, I'm pointing to something above the ground, which in flat earth means I'm not pointing to it. It's not actually there, such as water when you're in an airplane 30,000 feet in the air. So the question is, if I'm pointing to the ground that I'm standing directly below me and it is there, and I'm pointing to the horizon and it is not there, where from where I'm standing to the horizon is the point of discontinuity? Where does this break? Where am I no longer pointing to something that it is there directly? Yeah, that's the question.
It's a function of distance, man. That's where the horizon's at. Always, always, always depends on how far you can see. Even fucking at ground level, if it's foggy, your horizon's literally going to be a couple hundred feet in front of you. And if it's a crystal clear day, then you might not have a distinguishable horizon. It depends on the atmosphere and all that, but it always is a function of distance. Period. That's how you know it's not a globe. Globe, it would be a calculatable spot, bar a little refraction, but it varies wildly. Like that, even the ship Doofus is talking about. What about when we go there the next day, Doofus, and we see the whole entire ship and a horizon behind it? Like that doesn't. And he says there's no edges on a sphere. When for years they claimed that the horizon was the leading edge of a sphere and blocking ships. And now they don't claim that no more. No longer is there a spear edge blocking ships. You hear Doofus? There's no spear edge.
The question was mainly for flat Earth. It's an explanation for flat Earth, not globe, therefore flat Earth. You're pointing to the ground below you and it's there, and you point to the horizon above the ground and it's for flat Earth not there because you're pointing higher than the ground. So where is the discontinuity from where I'm standing to 3.1 miles away at the horizon? Where does it break? Because concave Earth doesn't have this problem.
Dude, when you're pointing, you're never pointing up. You're pointing out. And if you want to get a technical instrument, you could measure the 0.01 freaking. You could, but with the eyes, you're just looking out. Okay, it's always technically below you. And like I said, with proper instrumentation, you can measure that angle, and it's very, very slight. That's the point. It's all a function of distance. As the fog clears up, the horizon starts reaching out further. It just depends on how far you can see that day. Period. It's never above you. It might appear like with waves and shit might be above you if you're at the beach. I will agree that I've seen, boats that I know are under my feet that look a little bit above me out on waves and shit like that. But you point out, it's never up. Concave Earth, maybe, but it just, it just kind of. Well, how does concave Earth explain bottom of ships missing?
They just have light bending differently. I don't understand. All you have to do is presuppose the shape you want, or the surface shape, or whatever you want to call it. Presuppose the surface you want. Presuppose how the light's bending. You can make anything fucking happen.
No, you can't make boats disappear bottom up just from bending light on a concave Earth. You can do it on a globe if they're obstructing because you're trying to. Well, they sort of try to claim it that's bending around the curve and all that. But how would that happen on concave? Because in concave, the boat would be going up, like all the water and the boat would be slanting up from you.
That's a good point.
I have another question too for flat.
How would you have the light bending? Hold on. How does this concave thing?
I mean, I could probably list 1,000 problems with concave Earth. It's just not even close.
It seems like a pretty big one.
Well, I have another question for concave too, though.
I mean, I do think in a way it's concave because like we're on a stationary plane within like a system, a plasma field. I think ultimately like a plasma spiritual field. So in that way, you could say we're in like a concavity. You could say that, but I don't. The land is not going up around in a sphere though.
There's this guy called Neophyte that you'd really like to talk to, Geo.
Well,
like but going back since the dawn of time in the spiritual traditions, there's the physical plane of existence, the middle earth, the middle layer. Then you have the upper, the heavens, and the lower, the underworld.
Yeah, the plane of inertia. We're not finding curvature in any direction.
And that's my thought is like, even with time zone observations, we know that the sun travels around, and in each of those places that the sun goes to, it's going to be 12 p.m. for them, and the sun's going to be overhead, and they all have kitchen counters where they're at. They all have things that are level where they're at, and they're measuring level too. So if they have a relationship with the sun where they can say the sun's overhead, it's 12 p.m. and I'm measuring level, where does the concavity?
The measuring the level is the observer is let's say standing at the beach, and they're 6 feet up high. So directly the ground directly below them, which is 6 feet below their eye level, that's the lowest point in concave Earth for that observer. That means wherever they're standing, they're at the lowest point, and it's curving up in a way in all directions.
We know inside of a ball shit. We gotcha. Why do things disappear bottom up?
Okay, well, no,
Why do
I'll
things
get to
disappear?
bottom up first. I'm asking a Stoics question. What was your question again? I had to say that part. What was that question again?
No, you explained it. You just said that the where they are, that person is at, they're experiencing their local level, right? And then everything is kind of just upturned from there, which you've answered the question. I appreciate it. Thank you.
Yeah. So the way I see it is, we're not seeing reality as it is. We're seeing reality as our visual apparatus delivers it to the consciousness. When I'm standing at the beach, my feet is at this is if concave Earth is true. So let me finish it, and then you guys can. If I'm standing at the beach, my feet is at the lowest point. If I point to the horizon, for like a 6 feet tall observer, 3.1 miles away, I'm pointing above the ground. I'm pointing directly in front of me to the horizon. My feet is the lowest point, and the horizon that is visible to the observer is their visible highest point based on how high they are. The further up you go, the further out your expansive vision comes, and it rises with you as you're doing this. Now, how does the bottoming out work? So back to the beach. You're 6 feet tall observer. You're standing at the beach. You're looking out towards the water. What the observer is seeing, what your eye is delivering to you, is how far away you can see is an effect of your perspective. It's an effect of how the light crosses into your eyes. So when you're looking up and you're pointing up to the water that's cut off there, globers think it's curving down. Flat earthers think that's just my perspective, and concave earthers think, oh, it's actually going up. The way boats bottom out in concave Earth, as it's going towards the horizon, once it reaches that cusp of how far you can see, which is given based on how high up the observer is. Once that cusp is passed, and the boat is and the boat is still going up, but due to the way that the light is crossing in your eyes, it basically just disappears. I can't explain it better than that. Like I don't have the means to explain it better than that. It's the same thing you think is happening with flat Earth.
And it's the issue that I have with that, and I say this obviously respectfully to you, is that when I point to wherever it is off in the distance, let's say I happen to see a city off in the distance, and I'm like, oh, there's a city, and I go to that place, I'm no longer experiencing a concavity. I'm still experiencing the level. And that's the issue, is that when I travel to these different places, I still, from my perspective, always see the same stuff consistently.
If this theory is true, you have to retrain your eyes again. Just like, because I was a flat earther too. Just like we retrained our eyes for flat Earth, we started to see perspective. We started to see, oh, I'm seeing too far. You have to retrain your eyes. What I'm seeing upwards curvature.
Yeah, I mean, when you see it, train lines converge, for instance, right? Because everything sort of smashes together, doesn't it? But when we go over there, we know they're not actually coming together. It just looks like that.
Yeah, but this is just it, dude. I'll give the vision part, like, maybe. I've considered this a lot. But here's the thing, man. When we're measuring shit or when we're using auto levels and extending horizontals, when we're draining water, it always conforms to the drop from that horizontal or the rise from that horizontal. So if the Earth is concave, then it's disobeying the fucking reality, just like the globe is.
Yeah.
Because when we build shit in reality, bro, it's fucking, we literally do slope and grades and rises with rise over run. That's how we build our reality. And so that's the main thing that has me argue with my wife, the concave earther, is it doesn't agree with reality. But I like the idea better than the globe just because it's different. So I'll give you that.
That was interesting earlier, Brian. I appreciated you talking on that earlier with that guy. I mean, I don't like shit talking. Look, there's nothing. Let me just be clear. There's nothing I'd never say behind anybody's back. I wouldn't say to the face because that's just how I live my life. But that guy was lying, and I think everyone in the panel knew that guy was lying.
He didn't even know what he's talking about.
We're back
Sewage.
2
He
minutes.
didn't know what feet per second meant. But dude, feet per second is how they even like they go. The engineers and the architects and all that go beyond the percentages which are passed on to us and deal with the feet per second, which is he didn't even know that was the water flow. There's minimum water flows for sewage. He didn't know any of that shit, dude. And and like I said, he was arguing against the main globe argument is that we it just happens and we don't recognize it because it's so gradual. He's just saying that we account for this shit. He's full of shit, dude. He ain't never accounted, and he couldn't tell me how. How do you account for it? And remember how many times I asked him, he just sidetracked. And other people asked him, he wouldn't say, "How do we compensate?" You're saying we compensate. Please tell me how. He couldn't answer it because we don't. But yeah, thank you, man.
Yeah, that's why I specifically asked him the 9/11 question. I really wanted to hear his answer, and he was quite clever about it as well. I mean, a lot of the other people spoke out, but in particular, he said something like, "Yeah, well, there's something fishy about it for sure," but and he was just very cagey, and that's why I asked him specifically because I was just really wanting to hear his answer. But yeah, when he comes back, I'll call him a shit talking liar. Sorry, Gio, I'm joking. I'm joking. Yeah, something I was thinking about was the that shot that we always see where they show us the big arc in front of you when from NASA or whatever space agency. We see that shot where we see the arc. You'd never see that because I was thinking about that because Hoymar posted. I'm doing it again. Shit, but he posted this this GIF where it starts on the ground and it just like goes up until you can see that. Let me just post something so you know what I'm talking about. That they always show us this shot, and it would never look like that. You'd never see that. I said to Hoymar, I said, what's behind you? Another arc? And he said yes. It would never look like that. Think about it. Anyway, shout out Del from Beyond the Imaginary Curve because I was listening to him talking about it, and I just thought, yeah, it never even occurred to me. I was like, yeah, of course, it never looked like that.
I'm back.
Wait, say that again. What did Dell say? I missed you for a second.
If you were raising up off a ball, you'd never see an arc in front of you like that. Of course you wouldn't. Complete the circle. This is why I said to Hoymar, what's behind you? Another arc? And he said yes.
Yeah, like a daisy. Like it's a daisy or Everywhere you look is a pedal.
It's ridiculous.
Then they say that, like in Mage, he's saying, "Look at this left to right curvature." Bro, what are you talking about? I thought that the horizon is so how many degrees is the horizon out in front of us? And they'll be like 6 degrees or 5 degrees or something. Okay, and how much is it to the right of me? I mean, it's supposed to be like 5 degrees that way, and then 5 degrees. Like, How could you be toying out a curve if it's fucking the same angle all the way around me? They say whatever. They just blurt shit out and run with it until they talk to us, and then all of a sudden the argument just goes away. They leave their videos up, but their argument they quit mentioning it because it's stupid.
Imagine this reality. Imagine this reality. There is curvature, and the Globers are measuring it correct, but they're seeing it wrong. Imagine there is curvature. Earth is stationary. It is not rotating. Inside, everything's rotating. It appears like an extended plane. It appears flat, just like you see it.
Yeah, but I think once it stops moving, it breaks down one crumb after another, dude. It's if we could prove that it's stationary, we've killed the globe.
Well,
But,
yeah. How is the water?
killing the globe does not do anybody anything.
How is the water sticking to the sides of the walls in this concave Earth? Like, I almost thought if it was spinning, it like could make sense.
Imagine the curvature of the Earth is solved. There is curvature. There has to be curvature, but not downwards curvature. If this theory is true, the Globers can't give you shit on anymore on measured curvature. Same thing with the stars.
We don't have to make
9
our
degree per mile. That's happening. That's the celestial
measured
sphere
curvature?
above. I'm explaining concave Earth real fast. I'm just appreciate it if you don't speak over me. The curvature of the Earth, check. You're good. Curvature of the stars and the working stars, you're good. Water appearing level and flat, just like you see at the oceans, you're good.
Andy and Brian, I kind of wanted to talk about that arc being in front of you and behind you at the same time thing real quick.
Go ahead, Doofus.
Well, what curvature was that guy mentioning? As far as I can tell, no curvature has ever been proven.
Yeah, he thinks it's going the other
for
way.
like years.
So what Brian was mentioning was like, yeah, it's the same distance all around you and the same angle downward, right? If you have, for example, a hula hoop, and it's, let's say, at your location, it's horizontal. It's lying in a plane that's parallel to horizontal in your location, but it's slightly below eye level. Now, to you, you see that as an arc in front of you. And if you turn around, you'll see still another arc in front of you. And that's what's going on with the horizon too, is it's a circle around you, not in front of you.
But to me, I would have thought, I mean, if you've got a demonstration of that, I'd love to see it. I don't know if you've got a video or something. Or
well, that's why I mentioned the hula hoop.
Right. Well, if you've got anything like, I'd love to see that. But to me, as you rise up, it should be falling away at every point away from you. That's the way I see it. I don't think you'd see an arc in front of you unless you were away from it, really far away from it.
Yeah, that's the deal. Like if you were up at ISS altitudes, what is that distance? I don't even know. Actually, let's do something a little bit more practical, like an airplane altitude. That horizon is about 200 miles away from you. So, yeah, it's far from you.
But again, I'm not seeing any curve there from certainly from there.
Doofus sees a dip angle, and because of the dip angle, he's absolutely convinced it's curving down. The existence of a dip angle is the final straw for Globers.
I mean, I personally photographed the horizon curving, but all right.
That's a good point. What that kid just said. The dip angle being the final straw for globers, because I see a lot of globers come in here and say like, "Oh, I don't want to debate heliocentrism. Oh, I don't want to debate the Big Bang. I just want to debate that I know there's a curve." I feel that's kind of true.
For the glober, try playing devil's advocate. Understand there is a dip angle, but perhaps consider that even with the dip angle, the horizon's still too high.
Yeah, like it doesn't match a sphere of their dimensions at all.
Horizon's too high. It appears
Based
too
on
high.
what information?
Based on our eyes, based on all of our eyes, based
Wouldn't
on our
you need a
finger when we
measurement?
point to it.
Yeah, wouldn't you need a measurement?
Just consider it.
I mean, plain windows also can make give you this sort of apparent curvature. It looks curved, but because they show you on the tarmac, don't they? There's that meme. You must have seen that, Doofus, where you can see the tarmac and the fucking ground looks curved when it's on the floor.
Well,
So,
in this particular example, I'm in an A320, and an A320 window is curved in only one axis.
A32. I don't know my planes. I'm just gonna have to have a.
It's a smaller Airbus.
Yeah. A3. All right.
Doofus, can you tell me exactly where the horizon is? Where would you gauge the horizon to be in that image there? If you don't mind. Because it is a bit vague. You know, you have the cloud layer ever thickening for a flat earther as you go into the greater distance. I guess at some point it drops away severely for the ball earther. But where exactly is the horizon, where the land
I have a better question.
actually
Doofus,
apart from the sky, you know? Okay,
I have
go
a
ahead.
better question. Doofus, how did you take this photo?
Yes, I took this photo.
What did you take the photo with?
A cell phone camera.
It's not a rectangular linear lens. A curve is going to appear in the image. So
What's interesting that you mentioned that because I took three photos at the same time.
This curving
Why,
in the
why are you
image.
both talking at the same time? Jeez.
I don't know, dude. I asked him a question, he answered it, and then I went on to give an explanation dependent on his answer. And so, yeah, dude, look what Gleam just circled. But anyways, you take a picture of
not an
something
A320.
you take a picture of something without a rectilinear lens, and getting a rectilinear is near impossible. It's an ideal, not a thing that you get to in reality. There's always going to be a curve below the midline, curving downwards, and so this looks like an effect of that, as well as an effect at the point where you couldn't see all the land forever. Light dissipates after a while when it's going through the air. So yeah, this doesn't, and then compressing the image horizontally doesn't actually like prove anything. It just accentuates the distortion that you've already taken a photo of. Thank you. Sorry it was so long-winded.
Oh, it's good.
All right.
That's
Very
actually have
interesting that you mentioned the lens distortion as a possibility because I took three photos at the same at the same altitude with the horizon at different points of the frame. So if it's caused by radial distortion on the lens, then the horizon should change shape if I have it in a different spot in the frame, which it doesn't.
Yo, the thing is, we actually have straight objects, known straight objects like rulers and shit. And if you compress them, you can make them more curved by compressing them.
But if that curve was induced by the lens, me putting the horizon in different points in the frame would disambiguate that problem. Doing that makes it so that you know that if it maintains the same shape at different points in the frame, the lens is not the cause.
Did you see what Tora for Ya posted? Maybe I'll have to repost it for him. But this is no one even needs to make an argument at this point. We can just show this picture.
That's it. So it's funny too because he even described it as a flat hula hoop, like a plane, like parallel planar to the Earth's surface. I thought it's a sphere, isn't it? So why would it look like a hula hoop?
The horizon on a sphere lies in a plane that is perpendicular to your normal. So, I mean, me saying the horizon is a circle is not revolutionary information because that's what it should be on a sphere.
Well, can we just
Perpendicular to normal? What is the normal?
A normal vector is the direction that is directly away from the surface.
What's the altitude of this? What's the point? What is this? Is this the ground? Is this the ground that the observer is standing on, or the eye level of the observer? Big difference.
No, normal in this particular instance, I said was a direction from the surface, and I would hope the surface is not your eye level. The surface is the surface of the Earth.
So the altitude, the normal is just the direction. I'm asking. So is the normal just a direction? It doesn't matter how high the normal is. The point to put it.
The normal is extending from the surface upward.
Now, can we get back to the? Yeah, let me get back to a consideration. We've all been in an airplane, so we're looking at this. Okay, let's leave the technology behind in a sense. Just let's try to decode the image. This is where I think Doofus, you might answer, because there's, I guess, two considerations. It looks flat, it looks extended outwards, but now we're considering an horizon. Oh, if it was a ball Earth, where would you identify the horizon? And I think you have to take into account what the clouds are actually doing as well, because the clouds would necessarily be doing something different on a flat Earth. So, for instance, if that cloud layer in a hula hoop all around was actually removed, then that horizon line or the extended Earth would go much further than the seeming horizon here. You know what I'm saying? So I think you just get it clear what terms we're using in your example, which is beautiful, by the way. I'm looking at it zoomed in. Wonderful.
Right,
It's
you
flat
said
all
it
the
looks
way.
flat, but I did show that it is not flat.
It's flat all the way. Remember, on a flat Earth, as you rise above the clouds, right, you see the clouds then, like the water surface on the Earth's surface itself, seeming to rise to eye level as you go back. Right? But you have a distinction here where the clouds are. I guess it depends on how high you are and where you're going to make. You're going to have to draw a line in the clouds as well to say where exactly they go over the hump. You know what I'm saying?
Something special about the past 30 minutes, Pete. We're also now considering real concavity. Hopefully, it'll help move this 8-year debate forward a little bit.
Very good. Everything is on the table. Old glory.
What I love about concave Earth that I tip my hat to is the idea of containment. Because the edge would suggest that there is some kind of a interaction happening, whether it's a flat with a dome meeting or there's an upturned edge, but there's some kind of connection happening there. So I can kind of see that, but it's interesting talk nonetheless.
Are we not going to talk about why the horizon is still curved in the photos that I provided?
Didn't we already respond to this?
Yeah.
Didn't we already respond to this though with the picture? Here.
Right, you said it was the lens,
Well,
and I showed you why it isn't the lens.
Let's just post that image in the chat again. There we go. 34 minutes after the hour. There it is.
Right, which is great if you have one photo of one object. What I have is 3 photos of the same object with it in different places in the frame.
If you look at
So
the
if the
image I
curvature is caused by the
you're not really
lens.
addressing it, are
Hello?
you?
Hello?
You're not
Hello?
addressing.
Can you hear me? Can you hear while I'm talking?
You're not addressing.
Hold on, guys.
And here,
You're
Doofus.
not.
Oh man.
Hold on, guys.
Guys,
I don't know
right
what happened, but whoever was talking, please continue, and then whoever was trying to interrupt can go
Yeah,
next.
Doofy's not addressing.
Yeah,
what I'm
let's go ahead and let me finish because I was in the middle of talking, right?
Doofy's not addressing what I'm saying.
Why are
All right,
you
well,
speaking over him, man?
Relax. Doofus, go ahead. Noah, you can respond after.
Okay, so if I've got the same image photographed 3 times, or the same object photographed 3 times, but I have that object in 3 different points in the frame, then a radial distortion would cause that object to have a different bend to it at those different points in the frame. I photographed the horizon at 3 different points in the frame, and it had the same shape in all 3 places. So it's not caused by the lens.
Did he address your point,
said,
Noah?
he is now blatantly ignoring what I said in the picture I posted 3 times from Toro for Yah. He's not even responding to what I said. He's fighting a phantasm of what he imagines the argument from this side to be.
Okay, well, what's your point? Why don't you just state your point
I'll
clearly?
post the image one more time so we can see it. You know what? I'll grab his image too. Where is it?
What's your point? What's the point?
Post it at once. Doofy
What's
says
the point of the?
Doofy said he took a picture of the globe Earth from his airplane. So I'm going to demonstrate how this is not exclusively a globe Earth proof, and it just can go in the bin that doesn't prove doesn't prove globe Earth whatsoever. So you see these two photos, how both of them show the same thing. They're analogous. He's not going to respond to this. He's just going to attack some phantasm now. 36 minutes after the hour.
Yeah, the horizon is curved in my photograph.
Yep, just like the picture I posted here. I'll post it again so you can see it one more time, since you clearly aren't looking.
Okay. We've got a red line added to an image.
The straw.
Okay. The claim that I was addressing with my photographs was that the horizon is flat. So since I provided an example where the horizon is not flat, that's what I'm addressing.
The horizon's a visual phenomena, so, I mean, it's great if you can find instances where it's not a straight line. No, if it waves, if it curves, that's fine. It's just a visual phenomena, so...
You can agree that the person that said the horizon is flat is wrong,
really
then.
shown any evidence for the globe, so we can kind of chuck that in the bin of not proving the globe.
It's a flat circle.
You can agree then that the person that said the horizon is flat is wrong, then, right?
The horizon doesn't have a shape, dude. What are you talking about? I mean, it's like a one-dimensional shape, not a three-dimensional shape.
Wait a second, though.
A visual phenomena in the distance.
Geez.
It's neither flat
now
nor
it's one-dimensional.
It's a one. Yeah, it's a line in 2 dimensions, right? Because you see in 2 dimensions.
Well,
How
Neil
is it
deGrasse
aligned,
Tyson said you wouldn't see any curvature.
Yeah.
You wouldn't see curvature from like even 200,000 feet. I think you were talking about. So I know people don't respect Neil deGrasse Tyson, whatever. But I think that's where the word's derived from, right? Horizontal. So I don't know exactly. This is
How is
obviously
it aligned? Yeah. Can we dwell on this issue for a second, please? Because how is it aligned? Because we have to take both considerations in play. If it's the apparent line, as where Doofus here is seeming to represent, okay, we can see how that works. But then how does the top of the cloud layer work in relation to that apparent line? You know, so we need sort of advanced defining on this. But the same thing for a flat earther then. For instance, if it wasn't such a cloudy day and you could see further, if you could evaporate some of that ever thickening cloud, would the land then just extend backwards, which would sort of kill Doofus's claim? You know what I'm saying? So I think we have to get terms appropriately delivered. Make sense? Let me just say, for instance, we've all seen high altitude balloon footage, which goes up much, much, much higher. As you're looking at the peripheral, we see this greater circle enveloping, but the cloud layer that we're looking at is ever thickening. So by the time you get to the very extremity of that cloud layer, many thousands of miles, you don't know how to gauge the exact distance, but you do know that if that cloud layer was somehow miraculously just taken away, evaporated away, then the land would extend much further. So you know what I mean? A horizon is sort of meaningless in that sense then. All right, saying.
Yeah, it's next little video here. It definitely looks concave. Let's wrap it up, folks. It's over.
No, fuck that. Show me this curve that Doofus is talking about out over the water. Like you're literally showing continents, which are going to be higher in one spot, no matter what. You know, unless you're over Florida, and I bet you're not going to see that same shit over Florida, where it's level. Show me out over water this curve you're talking about.
That photograph that we're all talking about is actually over Florida.
No, it ain't. Not Mage.
Yes, it is. Look at the fucking marina,
dude. The one he just took. I thought it was Cape Canaveral. Is it, Doofus? That's what I thought you were looking at there.
Nah, it's just random coastline along the Florida there. But I mean, you can see the water that they've got behind that that they've got all the ships in there, the boats. I mean, that's Florida.
Hey, can you DM me, man? I'm actually leaving Walmart. Can I get you to DM me that, please?
The
Pretty please.
photograph.
Yeah.
DM you the. I mean, you could grab it from chat, but okay, hold on.
Is it the east or west coast of Florida, Doofus?
That's out to the Atlantic. That's the east coast.
Dude, it looks just like Cape Canaveral.
Yeah, I was flying from near the southern edge of Florida, and we were pretty far along in the trip. So
yeah, that's pretty far from the southern edge, Cape Canaveral.
Yeah.
It's like almost a middle marker. You could almost consider it like the middle.
Doofus, did it look flat? Did it look flat on this pad?
Hold on, you're saying we're looking
did it
at.
look
Hold
flat?
on, Pete. Pete, hold on. You're saying in your picture we're looking at the east coast of Florida, right? Oh, that's right underneath you. I see it.
On a globe on that height, it would never curve. If you don't understand that, look again at your model. It's not possible. In all directions, it goes away in the same amount. And you look in a circle, so it will never curve. If there is a curve, it's caused by something else.
That was my point. Well said, dude. You said it way better than I did.
No. So there is a dip angle. No model can deny a dip angle. Even concave Earth, it cannot deny a dip. There is a dip angle even when you're at the beach. And as you go higher and higher, it goes more and more of a dip angle. But in my opinion, even factoring in this dip angle, the horizon's still too high.
I don't know
We
what
still
you
see too far.
I don't know what you mean with dip angle.
Okay. So you know how flat earthers and a lot of people, they say the horizon rises to your eye level as you go higher and higher.
I don't.
Right? Or
they don't
like
say that, do they?
Or I used to say it. So I used to say as a flat earther, the horizon's at your eye level. When you're in a high altitude balloon, 120,000 feet in the air, in the stratosphere, the horizon is at your eye level. It's directly in front of you. I used to say that as a flat earther.
Yeah, that's
and a lot of flat earthers say that. But the truth is there is a dip angle, meaning that the horizon is not exactly directly at your fucking eye level, center frame. You know what I'm saying? The higher up you go, something within our world is causing a dip angle, meaning a visual drop. The land, the hard, crisp horizon line drops and goes lower and lower the higher and higher you go up. And
No hard horizon line.
As their last resort, and nobody can counter them on this, as their last resort, they say the dip angle, therefore the globe. That's it.
But there's no hard, crisp horizon line. There never is. Even at Doofus's picture here, there isn't. It's a vague line, and it becomes more vague the further you go back into the image. And just to focus on his image again, you as a concaver would say, if that cloud layer was somehow miraculously evaporated, then you would see the land ever increasing backwards and upwards, though. Backwards and upwards, right? So where it would end, there would have to be some other reason for a divide. A flat earther would say, yes, the land actually goes backwards. So in a sense, it's meaningless to talk about a horizon, except as a baller. And of course, they use it for justification that everything is dropping away in spite of all experience. And can I just say one thing to LW? Yes, but last thing I'll say to like Water, how you doing, bud? Yes, exactly. As he's looking out the window here, you can see 200 miles either way. High altitude balloon, much further, let's say 400 miles either way. All you'd need is about 60 of these taking a panorama stitched together, and there'd be no sign of any curvature anywhere over the surface of the Earth. That's how easy it would be.
I would just like to say dip angle, has this dip angle been shown to match the geometry of a 3959 sphere? If not, then it's not evidence for a globe.
I don't think in reality it does, because I think the horizon's too high, but to
Right, that's
them
what I'm
they
saying,
do.
though.
To them they do, yes.
Yeah, but they haven't shown that. You could claim that, but all it'll be is a claim. And for this to be like exclusive evidence of a globe Earth, it would need to match the predicted globe geometry. And if that's not shown, then this really can't even be considered as evidence for the globe whatsoever. So that's my whole problem with it is if I bring up something that could be either flat or globe, and then I just claim it's a flat proof, don't you think that would be kind of unfair? So if you apply the same thing, if you apply that same logic of what's fair and what's not fair as an argument, this, if it doesn't actually match the geometric predictions, is just evidence of a of a visual dip angle. It's not actually evidence of a physical globe Earth whatsoever.
But they think it is.
They rely on it, yeah.
So
It sounds like
when I speak about it, it doesn't necessarily mean I agree with it, but they think it is.
no,
And
yeah. It
Go ahead.
sounds like a concave Earth is like you're like conceding to curvature. Like you came to this conclusion because globe Earths have dip angles. Like it sounds like you're like, well, I guess I don't have a good enough argument for it, so I'm just gonna give up on it and switch to the Earth is
Yeah.
curved, just in the wrong direction.
Yes, everybody perceives and perceives what they hear at their level.
Yeah, but I've come up with an explanation for the dip angle, and that's why the baller relies on it. You remember, there's no extended plane for the baller. There is for a flat earther. So now as we consider the sky and the land or the water, we're looking at an illusory horizon for the most part when they measure their dip angle. But it's still water all the way back. And just it's so compressed and due to scale distance that it actually mirrors. As we know, water can do, a thin rainfall can make your whole street mirror. Anyway, yes, so we have a few different horizons. And the horizon we should actually be considering is the astronomical horizon, which is sort of more appropriate to this extended view. But yes, it's only illusory, this dip angle all glory. Definitely. Especially, last thing I'll say, especially as you rise up then.
Okay, so if
You're
you're
gonna
debating
measure
a
it.
globe, you say it's illusory, they'll say no. You could measure it, you could prove it, you could observe it. They'll say no.
Okay,
Tell
so
me an inferior mirage.
It doesn't prove a globe Earth. Like that's
They
the
tell me an
problem.
inferior
They'll
mirage.
say
Yeah,
they'll
go ahead.
say the dip angle is the hard cut of the Earth. That is the Earth that you're seeing. And as you're going higher and higher, the dip angle is proof of the convexity of the Earth. You could see it, you could measure it. It's a literal dip angle. And then the counter thus far we've heard is it's an illusion, which I'm not saying it's an illusion. I don't think the Earth's curving down, but if you're debating a glober and you say and you're trying to counter what they just said with it's an illusion, that's a losing argument.
Well, it's been
Did I say
explained
that? No, I
actually.
didn't say that.
Yeah, it's been explained actually before that it's a cause of perspective, because when you go higher, more of the ground comes into view. When you're lower, less of the ground, more of the sky is in view.
Yeah, well, I'll
And
just
even the Globers say it's an illusion. They say
Because it doesn't match their mass.
it's not the geometric horizon; it's just this
Yeah.
apparent one.
This sounds like a great debate we could
You
have
hear
with the
Jeremy
Globers.
just said? That's exactly what they say, and that's why it can't be classified as globe evidence.
All
Because
right, I
it
would
doesn't
like
actually match their model. Doesn't match their measure.
I would like to actually respond to that. I've been trying for a while.
Go ahead, Doofus.
I don't
Right.
care.
So Noah, the thing that you're looking for, the horizon, you would have to look for it optically. So you would have to consider optics, which the globe says, under standard conditions, makes it look a little bit bigger. So you would have to not look for something to be precisely at where a geometric edge would be for a 3,959 mile radius. You'd have to look for it for something slightly larger, which the Nautical Almanac definitely does already.
A geometric edge, you mean the sphere edge?
A geometric, yeah, a geometric horizon. Trying to use the terms that you guys use.
Oh, not edge though. All right, gotcha.
Yeah.
The proper term,
You know,
still capable.
if not the edge,
Oh,
what would you
actually,
call it? The sagitta? Well, like, what do you want to call it?
a horizon.
Wouldn't that be the leading edge of the sphere?
It's not really an edge. I mean, you'd say it's the last part of the surface that you can see. But actually, Brian, I did want to mention that I did DM you those 3 photographs.
Thank you, sir. Thank you, sir. I just got to. Thank you. I really appreciate it.
Yep,
So
no
Even
problem.
still, I
the
appreciate that. I'm still, that's fuck
nautical
with you.
almanac was not predicted using the globe. It was
Excuse me?
collected. It was collected. Yes. Is there a reason? Do you need me to repeat? So they did not predict with the globe the nautical almanac. They used the nautical almanac as evidence for the globe. It's the other way around, right? When they're looking at the horizon, they're not predicting it with the globe because it doesn't actually match what the actual geometric shape matches. So they collect the evidence from this almanac, right? The actual visualization, like people looked at it, seen it, measured it, put it in a book, right? And then later they adapted the model so that it would subsume those measurements, which at that point, I mean, if anything I show that disproves it, you then absorb and somehow explain away, then I mean your model just can become infinitely complex and never be disproven. It would be unfalsifiable. It would just be not science.
That's
Well,
exactly
we
what
could
he
take
has to offer.
we could
That's
take a look
exactly
at
what the ball Earth is.
we could take a look at what the actual formula is that they use in the almanac, and that's what is that? 0.97 times the square root.
So yeah, they
Somebody
do.
else wants to bump in there.
I'm agreeing with you. They use the haversack, but that's to line shit out to get distances and all that. That doesn't prove the
All right,
circle
but
that
Fry,
the
you can go next though, bro. You can go next right after Doofus. Well, I don't know why.
Yeah, that's not the Haversine. It's a square root. The dip that they have, the formula that predicts that amount of dip, is exactly what you would expect geometrically for something spherical. That's the formula you would use.
or spherical or celestial.
Drop the formula in the Livestream 1 text chat, please.
Okay. I guess you guys don't know the Celestial Almanac. Hold on.
Do you have a problem with presenting evidence for your argument? Is that
Well,
what
you
I'm
guys
hearing?
like to talk about celestial navigation.
I'm
You don't have the Celestial
I'm
Almanac.
asking so we can discuss it further, and it seems like you have an issue with presenting evidence for arguments, which is
Right.
kind of strange.
I have an issue presenting something that you guys continually say that you're experts in.
Okay,
But
so
I'm going to get it for you right now.
You're not going to present the evidence. You're just going to make your claim. And
I
then
just finished saying I'm going to get it for you right now. Don't lie to me like that.
I'm not lying to you, so there's no reason for you to say I'm lying.
Well, just wait till he posts it. Let's have a look at it. Jeez.
You know, settle down, guys.
But then he was fucking crying around like a baby.
No, that's not helpful. That's not going to settle things down. We gotta, as mods, we gotta try to de-escalate these situations.
Oh wait, yeah, don't call names.
Say this, y'all. With celestial navigation and the ephemeris, it's just the stars doing circles around one central point, and then it does give the declinations from the center point, what we call equator. And then as far as lining out the distances, that's model dependent. So he's going to give you there's a couple different formulas for the globe, a way to work it, and he's going to give you that formula that you could use whatever model to use the actual track of the stars, the actual 360-degree circle they do year after fucking year, and he's just going to give you the globe way to line out distances. It's a celestial sphere, same difference.
Yeah, that's what I thought.
And also, of course, plain sailing. They're I think it was 500 square miles you can treat as what do you call it, as flat. But I'm thinking then someone else confirmed that it was actually 500 miles in any direction. In any direction, 500 miles you can treat as flat. Plain sailing. Isa Mahalski made that point many times. So there goes the need to take the sphericity of the Earth into consideration, especially at local levels.
How does concave explain, like fluid mechanics, like sea level? Just out of curiosity.
I haven't got that far into it. It's more involved in a bunch of stuff.
Now, are you seeing that formula?
Yes, I'm looking at it right now. Thank you for grabbing that. So we have a formula that predicts what we've already observed and measured and found that this formula predicts it. So I'm kind of missing where the physical bending of earth and sea is, like, I guess, exclusively proven by this formula and what you claim.
The statement was made that the formula or the almanac is not predicting what we should see from a sphere. It's just using measurements from reality, and then we're just using that to justify the sphere. That's not the case. The almanac is showing, right? The almanac is predicting what is expected for a sphere, and that's matching reality.
That trigonometric sine and cosine.
That's not correct because the formula had to be created in the first place, and the way they created the formula was they took actual, like, how to say, measurements, visual measurements, optical measurements, and then they came up with a formula. And then they put the formula. I'm sorry. They put the formula in the almanac. So the almanac is not predicting anything. It's just matching a formula that models what we see visually. But I'm gonna ask again. This visual model, this mathematical model that shows us that I guess predicts for us what we should see visually. How does that have exclusive evidence for water and earth curving away from us physically, not just visually? Thank you.
Okay. You made a statement in that question. Again, I'm going to have to correct you. The almanac, the formula that's used in there is what is expected for a sphere. It's not a formula that they just made fit the measurements. Specifically, that's the geometric relationship that is expected for a sphere.
What's the difference between doing that?
So what does it?
And down to the center, it's making a flat plane, a celestial plane, and doing the trigonometric formula to the surface of a curved Earth. Same difference, bro.
Yeah, that's exactly what they do, Brian.
No.
Right. So you're saying that there's a sphere somewhere in this equation? I don't see it.
What do you?
That was the claim you just made, right? And second off, even if there was a sphere in the equation, it doesn't matter if I put a cube in the equation. Does that make it a cube Earth now? Because
if the cube could accurately predict what we see.
I'm almost done. One more statement. We're talking about observations made in reality, then modeled mathematically through a formula, then the formula being written down in the book, and then you saying, no, the formula just predicts reality. There's a sphere in it. First off, I don't even see the sphere in this formula. Maybe I'm not seeing it. But it doesn't say sphere anywhere. It says square root. Maybe is that what you're referring to? Pythagoras theorem right here?
Yeah, that's all trigonometric. It's all fucking trigonometric, and they have to take it down to a celestial plane. And they're like I said, they're just taking the curved Earth and going down. It's a hemisphere, not even a sphere. It's hemispherical trigonometry, if you want to put it like that. It's the same as doing it from a flat plane to a celestial sphere. That's what they're not telling you.
No, Brian, the horizon dip correction. Horizon dip correction is.
You haven't logically necessitated that this formula you came up with by doing observations.
I will if you let me.
Yeah.
Okay, sorry, go ahead.
Jesus Christ, dude.
Get your
Okay.
fucking panties out of a twist.
Bro, chill
But
out.
if you would let me answer, I would be able to answer, wouldn't I?
Yeah, but you get so girly about it. Like, just get on with it.
Right, girly. Thank you for that.
He's doofus Manfred.
Oh, shut up, Pete. All right, let's try this again. The formula that's there, you're not seeing a sphere there, which is weird because that's how you would find out what the angle of depression would be for a horizon on a spherical object. That's literally the formula. That's what that is. Secondly, for a spherical prediction to match reality, and we're talking about a prediction of the surface, not the sky, Brian. For that to match reality, reality ought to be something close to something that's spherical, wouldn't it?
Okay, so could you mathematically derive 3959 miles from this equation for me real quick?
No, because what I mentioned before with the start of this conversation was that the Nautical Almanac considers optics when making an optical observation. The radius would be slightly apparently larger. That's what this formula is doing.
I thought you were giving
so
formula. It's the wrong
so you
one.
have
I
a
thought you
different
pressed and apologize.
Jesus fucking Christ. So you have a different radius now, all of the sudden, is what I'm hearing.
Not all of a
It's like-
sudden you've heard of 7/6 hard.
Okay, yeah, you don't need to complain. You don't need to cry about what I'm saying. You get the message. That
Yeah,
there's
it's
a
not all of a
different-
sudden though. You lied.
Okay, nobody cares about the rhetorical points. Stop being a little baby. Get over
Bro,
it.
hey, chill out with the attacks. Pretend you have some respect for him. Pretend you have some respect for him.
Address the main point, which you keep fundy muted. I just been fundy muted 3 times from making a main point. It's kind of weird. It needs to get in check. So, you said there's a new radius, which is kind of weird. When did 3959 not become the radius of the Earth?
As I mentioned, and I'll do it again because you want me to say it again for some stupid reason. When you're doing an optical observation to the horizon, you need to consider optics. And because there's a persistent pressure gradient in the atmosphere, everything looms a little bit, so the radius would appear to be slightly larger. So the radius that they used is slightly larger than 3959. Did you get it this time?
Okay, so you have an apparent radius and you have the predicted globe radius. Okay. So what's to say there isn't a similar apparent radius on a flat Earth? How is this exclusive to a globe Earth? Doesn't even match the globe Earth prediction.
It does, because we're considering the atmosphere. I would be really shocked if we didn't consider that we had an atmosphere.
Okay. That doesn't really answer the question I posed.
It does. Because if you were talking about the globe prediction includes the fact that we have an atmosphere and we need to look through it. There's no expectation for the geometric horizon to be precisely where a 3,959 mile radius would say it should be, because, as we're all aware, we breathe air, and that air is not a homogeneous medium.
Okay, so we have the measured apparent radius, right? You claimed exists. Then we have the globe Earth radius, 3959 miles. Then we have the flat Earth radius, which we could consider infinite miles because it's actually just a straight plane, right? So, what exactly is exclusively showing that this apparent radius is a globe or is somehow related? Like, you're saying there's an atmosphere. Is there something you're missing a step in logic here? You're kind of just making your claim and then just having some other random like nonsense on the side, and it doesn't really connect. Like, the physical radius is not even the same as the apparent radius. So couldn't I just claim that there's an apparent radius on a flat Earth? It doesn't seem exclusive to me. I'm just gonna go ahead and claim there's an apparent radius on a flat Earth. And now what? You have the exact same claim. On a globe Earth, there's an apparent claim of this radius. There we go. So now we're even in the pissing match. You have no exclusive evidence.
Okay.
Did you say there's a
the
radius
reason
of
why
100?
that we have this apparent radius in there is because, again, the atmosphere is not a homogeneous medium. It's not isotropic. You need to consider then that density of the atmosphere increasing as you get closer to the surface would cause things to loom up in the distance, which means that the radius would appear to be larger. So the reason why the radius is larger for this particular calculation is given to you and has a physical mechanism for its explanation. Your explanation, when you say the radius, the flat Earth has an apparent radius, comes with no physical explanation. You just will it into being.
Wait, so how do you know it's gonna loom up the amount it's gonna loom up though? That just seems like like you're saying, oh, you don't have a support or whatever, but your support is just another claim. So now you have a claim that is your support. So you're gonna have to support that claim that everything should loom up a certain amount that you decreed.
Yeah, my support comes in the entire field of gradient index optics, which you may not have heard of.
What's the distance it's used over?
What is the distance it's used over? As long as the medium is that they're using it on. What do you mean?
All right, so how can you tell how much something is looming in the distance if you don't know how physically far up or down it actually is?
You would measure the specifics of the optical medium in order to figure that out.
Right. So now you're gonna have to go on and explain all of this, and show how it logically, I guess, implicates the other thing.
I have to explain gradient index optics from its base level to you in order for it to be something substantial.
You have to show. You just claiming that. You just saying those words doesn't act. You have to then show how it actually logically necessitates the other thing, right? Or else you just have two claims that are still not connected. There's the original claim, the claim that's the support of the claim, and now you have to bring in the support for that claim, but you've just said a field of study. You haven't actually logically necessitated it. Like if I just came in here and said astronomy, that's not an actual explanation. That's just the name of a field of study.
But and in a typical adult conversation, you would say, "Oh, that sounds like an interesting field. I should look into that," instead of just making the other person do all the work for you. But I'll do some of the base level work for you right now.
We're trying to logically prove
Gradient index optics requires you. You're going to talk over it, isn't? You're just going to. You're going to ask for the thing and then talk over it.
Stop being a fucking baby.
Okay, then why don't you do it first? All right. Well, let's try this again. Gradient index optics.
You have a claim.
Okay, it seems like he's not trying to hear it.
You have a claim. The support for your
Yeah, he's
claim
totally not trying to hear it because that's why he's talking right now, because he's a piece of shit.
Hold up. You have a claim.
Yeah, no, you hold up because you asked me a question and you don't want to hear it.
Yeah, no, I'm trying to get to the bottom of this, and you're fucking screaming like a lunatic. You have a claim. The support for your claim is another claim. And then I asked for the support of that claim. You just gave the name of a field of study. You didn't actually logically necessitate anything. So as far as I'm concerned, you haven't proved anything to the room.
So he interrupted me and I get muted. Is that how this goes?
Yeah, it is apparently.
Bro, you're being a baby. You should listen to yourself over again. You should go back and listen to yourself on the live stream. That's ridiculous.
You've been attacking him disrespectfully nonstop. Are you gonna cut it out, or are you just gonna remain angry?
I'm completely.
Why don't you explain how when you're up in an airplane, since everything's perspective and you're pointing to the horizon, how do you know if anything's looming up or not? You're sitting there throwing all these questions at him, and you're sitting on garbage.
Huh? So this is now distracting from the point of what was happening.
Can I answer your question now, or are you going to talk over it?
You already left the point when you verbally attacked him.
Wait, we were asking.
Can I answer your question you asked me, or are you going to talk over it?
I'm out.
All right, let's try this one more time.
What was the original?
So gradient index optics, motherfucker.
Go ahead. You have the floor.
Okay, so gradient index optics deals with a medium where the index of refraction, that's the index part of gradient index optics, is in a gradient, that's the gradient part of gradient index optics, so that the index of refraction changes gradually in some direction. That field of study, gradient index optics, tells you what light will do through a medium that has a gradient in its index of refraction. You get that?
Over how long of a distance have these tests been done?
Tests? Over what tests?
Experiments, it's scientific method experiments.
Right. Anytime we look at any medium at any length that we've looked at, this holds true that the gradient in the index of refraction, the direction in which the index of refraction increases is the direction the light will bend towards. All distances, all mediums, everything.
Okay, so can you answer my question and give me an answer to how far of a length the experiments in this field of study are? Could you please answer that with a number?
Right. Millimeters, meters, kilometers. All of the distances. Who the fuck cares?
Okay, so you have an experiment over the course of a kilometer in this field of study. Could you present it, please?
Right. Actually, I first have to ask you, what does the distance change if it works over a small distance or a large distance?
The scale changes.
So the direction would be the same.
You may have a scaling fallacy.
Yeah, scaling fallacy.
Scaling fallacy. Please explain a scaling fallacy.
Considerations.
You don't know what that is? Come on.
Yeah, just because I need twice the guys in a local street fight doesn't mean I need twice the guys in an army on army situation. That would be, I guess, analogous to a scaling fallacy.
Okay, that doesn't apply here because the direction is what's important.
Sir, it's what? That doesn't even like
the
I
scale.
Feel like you're not listening. It doesn't address what I said.
The scale has nothing to do with the qualitative direction over which
have you proven that
direction that the light will change.
We have no evidence that would suggest that we have no evidence that would suggest that if you were to have a beam of light going 2 kilometers, that it would cease to bend towards the denser medium. Right. There's nothing that suggests that. I don't know why you're suggesting that we should have to immediately give to you every little single thing that you have when there's no evidence that would support that being a thing. Do you have evidence that there's? Do you have evidence that light ever? Do you have evidence that light? Do you have evidence that light ever bends away from the denser medium?
Stop moving the burden of proof.
I'm not. This isn't the moving of the burden of proof. The burden of proof is actually met on our end because the entire field of optics is based on this.
Sir, you just didn't address what I said, and then I tried to correct you so you can address what we're talking about, and then you talked right through me.
What are you guys?
We're on a diatribe about how this guy is proving the globe Earth because he looks at the horizon, and it's not even the same as an actual geometric globe, and then he's saying how he has a field of study that proves that when applied, it will match the globe model. And so I'm questioning him on the field of study, and we got to the point where we were talking about the scale.
I'm aware of what's going on.
The scale of these experiments.
I'm aware of what's going on, but
I asked him for a specific experiment and to show the scale or distance, because we're talking about distance here as the scale of distance of this experiment, and he still has not presented it. So as far as I can tell, he has no claim. He has no evidence whatsoever thus far.
Okay, with that question, you're suggesting that there is some distance in which gradient index optics no longer applies.
You don't even have evidence for your claim yet, sir, so we can't even get it. We can't even unpack that.
No, the entire field.
Yeah, actually, I do. The entire field of gradient index optics shows what I'm talking about is true.
That's another claim.
Okay, go ahead and keep talking.
I would like a specific experiment from that field.
Why though? Why should he give it to you?
Because if I make a general claim about a field, like I say astronomy supports me, you should be able to ask me then, okay, show me the study in astronomy that supports you, and then I should provide it. So if that is how it should go, then he should just go along and follow those, I guess, courtesies.
Should it go for 45 minutes? The Glober just has to do every little thing asked of them.
Well, if he showed support or evidence for his claim that wasn't just another claim, it wouldn't have to take that long, would it?
I'm sure Doofus would like to know how the Earth is flat. Maybe we could pause on the questions and you could go on how the Earth is flat.
That's a different argument entirely. We're trying to drill down to get to the bottom of something,
you're right,
and you guys are constantly diverting from it for some strange
This is-
reason.
okay, so here's a true non-diversion on this issue. When it comes to light changing its path according to a density gradient, it is a well understood portion of science. It is understood throughout optics. That is why glasses work for short distance and long distances. It's why we're able to focus in column A beams using lenses. There is nothing on this planet that suggests, even remotely, that light will suddenly start to bend the opposite direction of the gradient if you give it more distance. Now, given that we don't have evidence that would support light bending opposite, as you are claiming, do you have evidence that would support the idea that after a certain distance, light will no longer bend according to the density gradient, where it bends towards the denser gradient as it passes through it?
That is completely not addressing at all what I said.
It is.
It is.
No, it's not. So the problem is, I'm trying to get the distances that this field we're talking about, trying to get the distances that they're doing the experiments over, so then we can look at it and come to a logical and rational conclusion.
You're not being logical or rational about this.
What's going on with light in the atmosphere? You still have not presented the evidence for your claim, and have just blown.
The evidence for our claim is that there's no counter evidence to the idea that light bends towards the denser gradient.
And I've just blown a lot of hot gas at me. So now it's really bad at this point, because I
agree, you're really bad.
Your claim rests on nothing. I asked for an experiment because in fields of scientific study they have experiments. That's the body of the field itself, right? So I would like that experiment. Can we bring that forth, or are you going to keep diverting to me?
I don't know of an experiment in particular that is judging different distances in order to determine if light will bend towards a denser gradient or not. What we do understand is that light, the path of a light ray, no matter how far it travels, will always bend towards the denser portion of a gradient median. No, that's not a claim. That is observation.
That's another claim.
Do you have a counterexample to that? I don't have the experiment. Wait, just listen for the rest of it. Just listen for the rest of this. I don't have the example you're looking for. Do you have a counterexample?
So if you don't have the example I'm looking for, why are you talking instead of Doofus Manfred?
Because Doofus, much like the rest of us, gets bogged down.
No, this is bullshit.
Because Doofus, like the rest of us, gets bogged down in going and searching for you.
You don't even have the evidence I asked for earlier.
I would like to get them. I would like to respond to you. Can you let me? Thank you. Fuck yourself. Okay, now let's get back to this.
There goes Noah again.
You're not addressing what I'm saying.
I am. I've addressed it multiple times.
We could if we could talk, dumbass.
Let's tone it down 2 levels. Let's continue, please.
Yeah, Noah, I've given you my answer a couple of times because a lot of us tend to get bogged down in going and hunting. I'm telling you right now that I don't have specifically what you're looking for because I don't think you know what you're looking for. But I can tell you that there is no counterexample that you can provide that would show that light over distance will start to bend away from the denser medium.
Okay, Jeremy.
I know exactly what he's looking for. I've been listening this whole time. I know exactly what Noah's looking for. I think Noah knows what he's looking for. He wants to know how long of a distance have these measurements or experiments or whatever you have been done on Earth.
That's fine, Jeremy. Do you have a counterexample for light ever bending away from the denser portion of the gradient?
Jeremy, you see what
you guys are making a claim. I know.
Jeremy,
no.
Jeremy, wait. Let me come in real quick. I've been silent the whole time, waiting for you guys to whatever. me and Doofus, for the last fucking 2 minutes, you fucking kid. You're older than me and you're acting like a kid. Okay, Jeremy, I've been asking these guys for this evidence the whole time. And I was originally having a conversation with Doofus where every time I asked for support of a claim,
Doofus. I should have let you continue that.
He just brought up another claim. And so I kept on going along this line, stringing me along these claims as evidence for other claims. And we're like getting to the bottom of it. And then this guy, Dr. Brian Peck, because I mean, I'm still trying to get this evidence, experimental evidence for this field of study and how long they're doing
You're
it
really
over.
not,
And
though.
Brian Peck keeps diverting from my conversation with Doofus, and he keeps addressing me and trying to like attack some sort of position he thinks I have, when really I'm just trying to get to the bottom. I'm just trying to get to the bottom of Doofus's claim, and it's really distracting my argument, Jeremy.
Right. So let's say I give you an example of a grid lens that's half an inch thick. Then I give you another example of an anisotropic medium that's 1 meter in length. Now, before I gave you that example of the 1 meter anisotropic medium, what suggestion do you have that the half-inch grid lens and the 1 meter anisotropic medium behave differently? What is your evidence that they behave differently?
I don't need to have an opinion if they behave the same or differently. My opinion can be I don't know. It doesn't even matter. It doesn't matter if I'm for or against it, because we're talking about your claim, not mine. You guys need to stop deflecting to me and keep it on the argument. The ball earth you guys are claiming, I guess you guys are, you're essentially defending this globe earth. So I'm trying to get to the bottom of this globe earth claim, and you keep attacking me and some position you think I have. You
Didn't do
need
that
to
at all.
stop that, and you need to then move to this atmospheric evidence. Can you present it or not, Doofus?
All I'll know is that you guys are making a claim, light's bending in a certain direction. You say
Jeff, we understand what he's saying. We don't need you to repeat it again.
All this, dude. Whoever just said that, just relax for a second. So I'm just trying
Jeremy,
to clarify.
you're unneeded.
No, is that?
Yeah, we don't need a summary, really.
Okay, well, do you have what he's asking for?
He's asking for a test over a kilometer because he thinks for some reason that it will behave differently. We have.
You said you had
specifically asked. You asked me for something over a kilometer. You asked me that. So don't tell me. Don't tell me that you didn't ask for that. Don't say that shit.
Yeah, because you
first hold on, Noah. No, hold on a second. No, hold on. This is why I wanted to clarify. Doofus said they had studies on this over a kilometer. Noah asked for. Noah, my wife's laughing because your name's Doofus. All right.
Mm-hmm.
So you said you had shit over a kilometer. Noah's asking for the thing over the kilometer, the measurement of the light bending in a certain direction. Do you have it? Yes or no?
I can give you studies on atmospheric gradients. The way that they conducted this study was to measure the index of refraction at different conditions for the air. Then they measured the air to confirm what the index of refraction would be for that particular piece of air. That's how they figured out what direction the light was going to change direction in.
So did they measure the light bending over the kilometer or no?
Yes, by the method that I just explained to you.
Okay, say it one more time.
Okay. They measured the index of refraction for different air at different conditions. Then they measured the conditions of the air. Since they know the index of refraction for the air, they know which direction the light is going to change direction in.
So they didn't actually measure the light bending. They measured the refraction and then, made some assumptions that that's what's happening in the atmosphere over long distances. But did they actually measure it? No. Do you actually have a measurement or not? Because if not, I'm not even interested in continuing this. You can go on with Noah if you want.
Can you explain why the method that I explained to you is not sufficient for determining which direction the light is going?
The assumed part at the end is
you see how he just never actually answers the question?
I am.
Do you have a measurement of the light bending or not?
Yes, by the method that I outlined to you.
That's not. So you actually measured the light bending, or did you presuppose what's going on in the atmosphere over long distance, and there's a gradient, and then it's bending this way, or did you actually measure it?
Okay, it's not a presupposition. What they did was they measured the conditions of the air. Since they know that the conditions of the air give a particular index of refraction, and they measured those conditions, they know what the gradient of the index of refraction is, so they know which way the light is changing direction in.
Yeah, and they presuppose those were the only variables going on. I know, blah, blah, blah. But they didn't actually measure the light bending, which is what we're actually looking for, since you guys are claiming the light's bending. You're measuring temperature, pressure, humidity. You're measuring all kinds of stuff except for the light actually bending, which is the thing you're claiming.
All right, can you tell me then why the method, specifically, why the method that I outlined to you is insufficient for determining which way the light is going?
Because you're not actually measuring which way the light's going. You're presupposing that those are the only variables in the atmosphere over long distance.
Okay, what
Like
other
said,
variables
if
would
you
you
don't have a
say?
measurement,
Jeremy, thank you.
if you don't have a measurement, I'm not even interested in continuing this. You can go on with no if you want. So, see ya.
I mean, you haven't given me what variables. You just say there are variables.
Doesn't matter if there are or aren't. You haven't isolated that there are.
It does
or aren't.
matter.
You haven't
Thanks for
done
the
it over that
explanation,
long
though.
of a you haven't done it for that long of a distance. Unless you
We-
can bring up the evidence that you've done it for that long of a distance, which you still haven't. You've literally avoided it like it's fire.
Right? Because if I give you a 1/2 inch wide grin lens, and then I give you a 1 meter anisotropic medium, before I gave you the 1 meter anisotropic medium, you don't have any evidence yet that they will perform differently. But then when I give you a meter long, why are you talking?
Because your claim was about the atmosphere, not glass.
Could you just let him finish?
My claim was about gradient index optics, and you know it was this whole fucking time. Don't play that stupid ass game with me right now, you lying piece of
The first claim
shit.
was about the atmosphere. The second claim was about index.
The claim was about gradient index optics, and it.
Yes, pertaining to the atmosphere.
No, well, we got to try to de-escalate these situations, dude. Seriously,
It's not
bro.
my fault. He's a baby.
Dude,
that's not de-escalating the situation. That's the opposite of de-escalation.
Yeah, bro, but like he's literally yelling at the top of his lungs, getting emotional, like nearly breaking down emotionally, like
because you're interrupting. He's getting mad because you're interrupting.
Yeah, because
he's getting mad because you're interrupting.
He just says shit that doesn't pertain to things. Like he was about to go on for 30 minutes about fucking the optics of.
But that's nonsense. You know that's not true.
The optics of glass. When the original reason we brought up these optics was because it was pertaining to the atmosphere. What he was saying wasn't even pertaining to atmosphere whatsoever. So he was gonna go on and waste a bunch of time on that. Like
that's not true at all. That's not true at all.
I won't interrupt, but he keeps going into the weeds and not actually addressing the point.
That's simply untrue.
Okay,
I think the real issue is that your impulse control is low right now. You get annoyed and then you interrupt.
Okay, relax, Veach. We can't interrupt because we can't interrupt because otherwise it turns into a crazy Mickey Mouse mess. Right? We got to just let people finish, and we can address if they didn't address the point or whatever happens afterwards. We got to address it after. I mean, I don't know.
I mean, yeah, the whole reason he brought up this optics field of study is because it was pertaining to the atmosphere and how the atmosphere caused this observation to match the globe reality when added in. So I think I'm well within a reason when he starts going on about explaining the optics in a piece of glass to say, hold up, we're not talking about glass. You understand, Jeremy? Like I don't think it's so unreasonable.
Do I get a chance to talk now, or are you going to interrupt again? Okay, here we go. The reason why we're having this conversation in the first place is to discuss the field of study which you specifically asked me to discuss. So when I talk about this field of study, as it applies to any anisotropic medium, you cannot butt in and say, oh, we're not talking about this field of study anymore. That's a bullshit thing to do, because we were definitely talking about the thing you asked me to talk about.
Okay, so, but the problem is we were talking about that field of study pertaining to the atmosphere specifically. So that would limit all of its applications on random doodahs, rocks, glass, whatever you want to look at. We're talking about the atmosphere, right? That was your claim. I'm repeating your claim from the beginning. You said that what we see optically matches the globe
if we factor in the atmosphere, so you specifically said, I said, oh, how so? You bitched and moaned, named a subject, and so we're asking about how that subject, specifically pertaining to the atmosphere, causes the globe to match what we see optically. You then brought up glass and seashells or something random, and then I said, wait, no, that's not,
no seashells.
That's kind of in the weeds, and this is where we're at now.
Okay. You said you wanted to know about this field of study. I was telling you about this field of study. Any anisotropic medium, that includes air, light will change direction toward where the index of refraction is greatest. That is gradient index optics in a nutshell. It applies to all mediums, which includes air. So if you want to tell me what evidence you have that it does not apply to air, I would love to have that. Please provide it.
Right. So if it's applying to air, that's nice. But you still haven't cited any experiments in this field pertaining to the air and the distances you made your optical observation from.
All right. How about this one? I'll make it easy for you. It's even a visual example since you guys like pictures so much. Have you heard of green flash?
Do you have a pop-up book? Because those are my favorite.
A what? Oh, pop-up book. Yeah, that's funny. Copy.
Okay, go on about your green flash.
I heard it a green flash.
Well, green flash is interesting because we can see as it's occurring, the red light from the sun sets first, then the green light, then the blue light. And as we all know from basic optics, that lower wavelengths or lower frequency light is less affected by refraction, correct?
Do you have a demonstration of this happening in the atmosphere over a long distance?
Meaning red bends less than violet or purple or blue.
Okay. Do you have a demonstration of this happening of long distance? The measurement of it bending less in the atmosphere over a long distance.
A rainbow.
Yeah, this thing that I just posted, that's that green flash video, that's the evidence right there.
Yeah, but do you have you said the light bends this much in the atmosphere. Like, do you have a measurement of that?
This thing that I just posted, this green flash video, that's evidence of that happening. Yes, because the red light from the sun is setting first, then the green light, then the blue light.
The red light from the sun sets first?
Yep. That's under typical conditions.
The bottom of the sun is red and then the top's green, you're saying? What?
Yes. Actually, yeah, that's right.
The sun's not just the same color, all the sunlight?
Not the entirety of what we can observe near sunset or sunrise, because as it's close to the horizon, that's where refraction is greatest.
Isn't this similar to pointing a light through your skin and you only see the red color because the other shit's kind of filtered out? Is that same thing or no?
That happens to all of the light, whereas in this particular example, the different wavelengths of light are being displaced more upward as the frequency increases.
You have a measurement of that?
That's the video that I posted, which has the green flash examples in it, has that, yes.
It has a measurement of it? What tool did they use to measure it?
A camera.
So just you point cameras at that shit and now you're measuring stuff?
It's not a measurement tool.
Oh, we're showing that the light from the sun is displaced based on what frequency the light is.
Okay,
now,
so
if we look at this second thing that I posted, which is what is expected for when light is taking a downward path or when light is taking an upward path. We expect light that's taking a downward path for the green to appear higher than the red, which is what we see during a green flash.
okay, so how does this necessitate that what we optically see matches the globe when the atmosphere is factored in, specifically?
Well, since the green is being displaced higher, apparently, than the red light from the sun, we know then that since refraction affects green more than it affects red, that the total displacement must be upward, aka looming.
So what does that have to do with the optical horizon being at where we observe it to be and it not matching the globe geometry, but then matching it when we apply the atmosphere in? And where are those specific, like, I'm asking for something specific, and this doesn't seem to cut the cake.
Right, because you don't know what's going on. I'm showing you that looming is occurring in our atmosphere, and you're asking how is it that I'm able to say that the surface of the Earth is looming up on average? I'm connecting the two. I have looming and looming. Those are the same thing.
Okay, so you're saying that the horizon looms a specific amount. How did you measure that?
I'm saying that there is looming, that the surface of the Earth appears to be loomed up in the distance. That's what I'm saying. The reason why I can say this is because observations back up that assertion.
Yeah, so how did you measure how much is looming up? And then how did you confirm that when you subtracted that looming, it equaled geometric ball Earth? Specifically, please.
Okay. So in order to explain all of that, I have to explain gradient index optics to you again, so we get to do all that fun. So if we know the index of refraction of air at different conditions, and then we measure the conditions of the air, we know what the index of refraction is at various points in the atmosphere. Therefore, we know then what the gradient of the index of Jesus Christ, dude.
How far has that been tested?
No, because you keep asking me while I'm still talking.
All right, hold on. All right. Hopefully you guys don't interrupt. If you do, we can do mute and unmute. You know, just manually mute and unmute you guys.
But he's just repeating himself and then not addressing the questions I have for him every single time. Or he's saying that we know because of this field of study, this is what happens over a distance in the air. And I'm saying, where is your experiment showing that it looms like that over that specific amount of distance in the air? And he keeps passing by it, not providing the evidence and repeating his rhetoric.
Yeah,
I just gave you
that's
direct
why,
evidence of looming.
Like if we were utilizing like a more advanced kind of debate type structure, almost like we've been talking like almost the courtroom style, you could have like your jury, your judge, and you could actually like let's say you were asking a question, you know, it could then be taken to the audience. We could even do it now with like a voting system that the audience could then vote, as it were. Or there's different ways to do it like that, to where, because like if let's say one person hasn't answered another person's question and the whole room agrees, or there is like a, you know, you have to question how to do that, whether you do the voting system or some other system of like a jury judge type scenario. Because then it could be, you know, because then you like in that type environment, like one person could actually sort of, if you want to view it that way, like kind of win the point in the sense if the other person didn't address it. Not that it has to be some kind of big win-lose, you know, competition thing, but just saying like if it has that kind of dynamic to it.
Right. But like the whole reason we're kind of stuck in this loop is I've been asking for something very specific, right? Because he's now claiming there's this looming, this apparent horizon, and I'm saying, how do you know the amount it's looming and the difference between where it physically is and apparently is? Where has those experiments over that distance been done? And he just never presents them. He just keeps diverting to something else. And we've been
okay.
That something else is the field of study.
All right,
the thing that you need to use to
hold on 1 second, Doofus. I'm just gonna say I'm gonna mute you, Noah. Okay, just for a second, just so he can have confidence that there'd be zero interruptions, because you and I just said a lot. Let's just give him the feeling that there'll be no interruptions for him. And Doofus, go ahead. Obviously, keep in mind to keep it concise. Maybe if you want to respond directly to it, but you got the floor. Go ahead. And Noah's muted, so there'll be no interruptions, just in case. Go ahead.
Okay, I just gave Noah the field of study that you would use in order to figure out how much looming there is. He keeps telling me, no, you didn't provide how you would know how much looming there is. Every fucking time, I'm telling you, you use the gradient of the index of refraction in order to find out what is happening to the light on the way from you to it, from its light source. So, I mean, there's no other way for me to say this. Gradient index optics is how you know what is happening to the light between the object and you.
Okay, you're done. I'm gonna throw you on mute. Noah, you're unmuted. He's on mute, so he won't interrupt you. Go ahead, bro.
Yeah, we already went through this loop before. I've already asked him a follow-up question to the exact thing he just said. But yeah, so this gradient optics, it's a field of study. Fields of study are composed of experiments and observations. So I was asking for a specific experiment that I get that had a distance comparable to what we're observing optically with this horizon. And, you know, to just say the name of a field of study, like if you said, how do you explain the southern star trails on the flat earth? And I just said astronomy back to you, that wouldn't be a sufficient explanation. That's just a name of a field of study. So I was trying to, you know, get a little deeper into it, see the actual brass tacks, matter of fact information, and see this experiment, right? Because that's what the field of study is. So can you present this experiment over the comparable distance? Please, for me. This is what I've been looking for the entire time. I've been asking for it for about 40 minutes now.
Go ahead, Doofus.
All right. If I give you gradient index optics being done over half an inch, over a meter, and over a kilometer, the difference is that there's no difference in the principles over any of those distances. So if I give you an inch or half an inch and I give you a meter, why is it that you need to see what the results are over a kilometer first? Second, I gave you a visual example. You could visually see that looming was definitely occurring in our atmosphere. And you're saying I haven't provided that knowledge that we have looming in our atmosphere. It's right there. You can fucking see it. Now what?
Okay, so to address the second point first, I never claimed there wasn't looming in the atmosphere, so that's absurdly ridiculous. I guess how you misquoted me. My question was specifically, how did you get that? How did you mathematically and scientifically, through experiment and modeling, specifically find that looming value and how it perfectly went back to the globe geometry prediction? Because that was the original claim, was that the globe Earth doesn't match what we optically see, but when you put, I guess, the factors of the atmosphere in, then it does match it. So I was asking specifically how you got these looming numbers, not claiming that there wasn't any looming. So maybe that clarifies misunderstanding. And what was the first point, Gio, that he? Oh, he said the scale. Why wouldn't something work over an inch versus over a mile? And I don't need to provide why it wouldn't work or would work. I just know that it is an unknown unless it is tested. So, and I know that fields of study are composed of experiments. And so that's the thing that I've been specifically asking for, is an experiment that I guess shows his specific looming value over a comparable distance and how it matches up with the globe.
All right. So the way that we know how much looming is occurring is we apply gradient index optics. So if you measure the air and the index of refraction of various different conditions for air, then you measure the conditions of the air, you know what the index of refraction is at various points in the atmosphere. Then you also know what the gradient in the index of refraction is. When you apply that knowledge, you can determine exactly how much the light is changing direction. Secondly, this is the fun part, Noah just disproved flat Earth by agreeing that looming is what's happening to the sun as it sets, since that means the sun would have to be geometrically lower than the horizon. So that's awkward. I'm going to go because this is a stupid conversation.
Okay, so that second part he said was a lie. I just admitted that looming exists, and we are speaking pertaining to the geometric and optical horizon, geometric predicted horizon of the flat globe Earth, and the optical, real, tangible, experienceable, and observable reality of an optical horizon. And I was talking about looming in regards to that, not a sun. He didn't disprove anything about a flat Earth. He just misquoted me and did some weird snide comment on the way out. Very strange. And yeah, claiming something happens over an inch and then claiming it happens over 20 miles is a claim, and you can abstractly impose your model on it, but it doesn't make it a reality until you do an actual real life experiment, which I've been asking you for about, 45 minutes now, and you've never provided once whatsoever. Thank you. And nobody's flustered. That's just an absolute outright lie.
Yeah, it did seem like Doofus kind of ad-hommed you, kind of ad-hommed like the whole discussion, tried to say a bunch of negative vibes and then bounced. So he didn't seem to want to actually confront what you. Yeah, it was a forfeit on his.
He ran away. He forfeited.
If we were to view it as a duel in that sense, if it was a back and forth.
Don't the Globers have light bending down in their model? Why is anything looming up?
When the light bends down, it looms up. Because when the light bends down, it comes in at your eye at a high angle. From a high angle, it makes it seem like it's higher. So the bending down causes looming.
No.
What's your reasoning on that? Say that again.
That shit is
so, our sense when we look at something, our sense of whether it's high or
right.
low is based on what angle does the light come into our eyeball at. If it comes in from like above the center point of our eye, we're going to see it as high. If it's coming in from low, we see it as low. And so when the light bends down, what that causes to happen is light that was above your head bends down, hitting your eyeball, coming in at an angle, making you think that the object is higher than it actually is.
That's your reasoning for it?
That is correct. What does make sense? Maybe I didn't explain it well, but that is correct. But what doesn't make sense?
Another example they have is the sun. They have the real sun lower. Like they'll even diagram it. The real sun is lower. Then they have the apparent sun, which is above the real sun, and they call that light bending down. The real thing is here, and the apparent thing is above it. So how did the apparent? That doesn't make. That's it.
Just think, if the angle it comes into your eye is what determines whether you see it as high or low. Does that make sense?
Yeah, but when you're saying that, you're talking about like, okay, if you're out looking on the globe and you're claiming this light's bending around, you're claiming that the light is coming from around the other side of an Earth, of a globe, to somehow, once it gets into your view above the physical curve, as it were, you're claiming that there's this very teeny tiny, very slight little angle that's going a little bit on your, if your little tiny eyeball is like, an inch at most, like your little eyeball, and then you're looking out over like huge distances, you're telling me that like, you'd have to describe what you even mean by that, because it's not even really how they describe it. I'm surprised. Like, go ahead. I just want to hear what you're actually, how you're.
All I was doing, so someone said, they say the light bends down, so why do they have looming? And I was just explaining that light bending down is what causes looming. And the reason, one other way to think about it is, the light that was going above your head before, or hitting your eyebrow before, not getting your eye, but hitting your eyebrow, that's the light that's bending down into your eye. So light that is higher is now hitting your eye where it wasn't before. So you're seeing the object as if it was that much higher, basically. So it comes in at your eye at an angle, and that's what gives you a sense of its height. And because it's coming in at a high angle, it looks higher.
You notice how you just said higher and above and high like 8 times, but you didn't say lower or beneath or any of that. So
it works the other way too. Because the light is coming into your eye. If the light bends down, it comes into your eye from a high angle, right? If if the light normally is going to hit your eye straight on, no angle at all, just hit your eye for the straight line. Now let's assume we have light bending down. That means the light that was going to hit your eye, well, that's not hitting your eye anymore. Now it's hitting like your lip or something. The light that was hitting above your head, now it's bending down and hitting your eye, right?
But if that was happening to that teeny tiny of a level, like inches, then you should be able to move your head up and down and get these dramatic, like, whoa, like see around the curve and then not around the curve. I mean, I've never even really heard this explanation of it in this way.
This is correct. This is correct. But the reason
dude, in the mainstream, they describe it as like a periscope effect, that the refraction effect creates like the image to be refracted through the medium, through the
that's different.
Well, that's
I'm just talking about what makes you think
because you know how a periscope has mirrors that angle it and it makes it look like it's straight ahead. Because like if you use a periscope and you look over a fence and your eyeballs, you're like 3 feet down looking right at the fence. So obviously you can't see through it. You look through the periscope, it looks like it's right in front of you when you look through it.
Yeah.
So they describe it in the heliocentric model where you have like the actual, curve creates that periscope effect and then lifts everything up.
That's basically true, but the reason why it looks like it's lifted up is because the periscope is making that light that's hitting the periscope is hitting higher than normal. That's light that's bending down. In that case, it's sort of bending down in a funny way by hitting those mirrors and going in a crisscross way. But it's bending down, right? That's light that was above your head bending down into your eye, right?
I don't think of it that way. No. What do you mean bending down? I mean, you're talking about like straight paths of light that are warping around a curve and then hitting a little bit higher on your eye.
Just imagine, forget the curve. Just imagine you're standing somewhere and light's just coming at you straight into your eye. Okay. Now, stuff that's on the ground is coming into your eye at a low angle, from a low angle, right? That's because it's on the ground. It's below your eye, so it's coming in upwards and hitting your eye. Stuff that's way in the sky, it's coming down and hitting your eye from above, right?
Okay.
So, and if you think about it, the things that are coming in from above, hitting at a high angle, that's stuff that we see as high above us. Things that are coming in from low, hitting from a low angle, that's stuff that we see below us. So now imagine light that used to be straight is now being bent downward just a little bit. That means that the straight light that was hitting your eye a minute ago no longer hits your eye. It's being bent down, so now it's hitting like a little bit below your eye. So what does hit your eye? Well, the light that used to be above it a little bit, that bends down to hit your eye, and because it bends down, it comes into your eyeball at an angle just like everything else that's above you. So it makes the thing look a little bit higher because it's coming in from the spot, from the angle that is things higher.
I've posted this, just posting that one. So you're telling me that one on the bottom, which is what we see, somehow the angles of those lines would tilt and let you see around a curve?
Well, I'm just saying that all I'm saying is that when light bends down.
Well, before you go, let me just post this one too. Is this what you're referring to?
Sort of, yeah. You see how the stuff that's coming into the eye from a high angle, that's going to be perceived as higher than the stuff that's coming in from a low angle, right?
Oh, I agree with that part. I mean, to a degree, like the eye, because the lens does obviously take its like field of view, so it's going to have its upper half and bottom half. Okay, I mean that's what will look like is up or down from you. But how is this letting us see around a curve?
Well, again, I'm not addressing that. I was just saying that when light bends down, so imagine light bending down. That means it's coming in from a high angle. That's why bending down light makes things appear higher than they were before, because it
by
makes
how
the
much
light come in at an angle. Well, it depends on how much percentage. It's bending. Depends on how much it's bending. It's proportional to the bend of the light. So if it's a little tiny bit, it'll just be a little bit higher. If it's a really dramatic bend down, it'll be much higher. It just depends. Doofus said he posted a visual that I'll try and find. I'm looking for it right now.
But I mean, if you look at that little thing of the eye that I posted there, I mean, you've got these radial lines coming out, even if you want to call them like that, even if you want to use paths of light and photons, whatever you want. Either way, like when you're seeing out radially, of the field of view, that is what you're seeing of what you can see. So if you can see, if the door's open, you can see through the door, then that's what you'll see through this system, what's above or below. If the door's closed and you can't see through it, then you'll just see up to the door, this same thing. So how does the component of angles hitting the eye and creating up things higher or lower in our view, how does that correlate with
curve?
in your mind, yeah, a massive globular Earth in which you're looking out over long distances, and somehow the claim that path is curving. How does the angle of your eye somehow make that you see around essentially the tons of water and rock?
So the way that works is so if you think about something that's just barely obfuscated, just barely above, like across the horizon or hidden behind something, the light that's bouncing off that object, well, the light that would be hitting your eye is being blocked by something, right? So let's say it's a I don't know, a fire hydrant. The light bounces off the fire hydrant. The reason you can't see it is because it hits something before it gets to you, right? But there's some light bouncing off that fire hydrant that's going above the thing that it hit. So if it's the horizon, it's that, or if it's like maybe it's a box in front of the fire hydrant, it's going right above that box. Now it's going above the box at an angle that light's never going to reach your eye. If you bend that light down though, then suddenly you'll see something that was behind the box before, because it used to be going over your head. That light used to be going over your head, but now it's been bent down. So now it's hitting your eye, and you're seeing it higher than it is really, but you're seeing something that would have been hidden if the light had not been bent down.
Okay, so you believe that like when you're looking out over the like when we see too far, as it were, we see land masses and islands and things way off in the distance, and in all the detail, etc. You're saying that the light is bouncing off those rocks, even though it is around a curve. It is actually on the other side of a ball. You're saying that the light that's bouncing up off those mountains way out there over the ball, somehow, like a rocket ship, it blasts up off the mountain and then makes an exact curve to the 8 inches per mile squared that's required to then curve to be in line with your eye, to then hit your eye at a slightly different angle to where it lets you see around the curve?
Well,
is that a decent steel man, or am I off on that, or what?
Well, the only part that's you don't need it to be the exact same curve. There's some reasons why it kind of approximates that and does kind of do that, but it doesn't need to be. All it needs to be is light that was going above your head a minute ago, or light that would normally go above your head. If that light is being bent down such that it hits your eye, you're seeing something that you would have been hidden to you in a normal situation. By bending that light down that was going above your head to the point where you can see it, well, then now you're seeing light that you would not normally have seen. So therefore, it's bringing something into view. And it's pretty small. It's like the amount of bend here we're talking is pretty subtle. It's like it's not.
Yeah,
like
some would say insignificant.
Well, it depends. I mean, some days it is super insignificant. Every once in a while, it's pretty significant, but it just depends on the conditions, I guess.
And what's causing this like periscope looking around, like bending light that travels that way, like a laser beam to your eye and then makes things look higher in your eye? Like what is causing that then?
The bend, I guess it's
that whole
air pressure, air density, well, the part about your eye is just it's the way your brain and your optics, I guess, have learned to read things. But the reason why the light bends, my understanding, I'm not an expert in this, is because of air density. So the more dense the air is, the slower the light has to move through it, and essentially it ends up being the equivalent of a bend, using like that Snell's equation. I've seen it before, but I'm not really that familiar with it. So probably Doofus or somebody would be able to explain it better. But I do know this: it's the thing that affects it is the density of the air. So temperature will do that too.
Have you ever questioned within yourself that effect you're talking about is what all is needed to describe the fact that we see the Earth as an extended plane?
What do you mean? Let me say that more about that.
Well, meaning that just like the brass tacks bottom line type scenario is the further we see extended planar geometry, and we're able to see tremendously far. So I'm saying, have you ever considered like that whole explanation you had to give of that and the light having to bend and then do all of that is all a way to try to explain how the Earth is actually a globe, even though it's observed directly as a extended.
I see what you're saying. Well, I guess a little bit I've thought about that, but we know this. We know that light bending like this happens. We've experimentally, right? We've seen this in laboratories. You've probably seen videos of it happening. So we know that light does do this phenomena. And then if it does do the phenomena, then how much it's doing in any given case, I know, it's probably a matter of empirical exploration. But then you can at least expect it to happen at some level. It's not, you wouldn't expect it to be made up. If you can see it happening in a lab, you would expect it would happen maybe in other conditions. I guess I would at least. And I don't know I don't feel like we can see that far. Like when you say the farther we can see, I feel like we can see farther than we should based on pure geometry, but not so far that it makes me think, oh, well, it's a planet. You know what I mean? We see farther, but just a little bit, as far as I'm aware.
Well, I mean, the world record Canigou. I mean, there's a 3-mile Sagitta. That's 3 miles worth of a hump of water, basically.
No big deal.
Well, but that Canigou was taken at like 260 miles up, or no, I'm sorry, not 260 miles up, 260 feet up, or something, or 1,000 feet up, or something.
Well, all the numbers are accounted for. Yeah, we know all the numbers. Yeah.
I don't know. I guess I feel like at that height, I don't have an intuition about whether that's too much or not.
Well, it is. It's 3 miles with the height included. Yeah.
I know what I'm saying. At that height, is that 3 miles that you're talking about? Is that a dramatic amount, or is that is that to be expected when you're at that kind of elevation? I guess I don't have an intuition. If you tell me that you've thought deeply about it and say it's surprising, I believe you.
Well, from that position where they took the photo compared to where the mountain is, there would be a 3-mile drop, a 3-mile Sagitta, meaning 3 miles in length is how big it would be. So essentially, that is like if you were to take a hump that's like a dome between you and Canigou, and then you were to make a radius from the baseline of it, the chord line or the kind of baseline, all the way up to the peak of it, that would be 3 miles. So yeah.
Just 16,000 feet.
And that's with the height included. Like that's how far the mountains would be behind the curve of the earth if it was a globe.
You're saying they're being elevated 3 miles. I don't actually remember, but if you say so, I believe you.
I mean, if someone wanted to try to assert the Earth's a globe, however, it has this planar geometry to it at these incredibly long distances. If you were to try to explain it, then yes, you would have to then explain how that mountain is the image, the entire, well, the details of it. It's not only that though. The sun is setting behind it, so it's even more poignant. Because see, on a globe, the sun would be straight because that's the horizon there. That's the curve of the Earth, right? That's it. So it's like that would be straight. But this mountain is over around a curve. So it would have to bring the mountain up and put it in front of the sun, even though it's not really there.
What do you mean?
It has to place a fake mountain, a fake image of the mountain in front of the sun on a globe Earth to happen. Instead of it just being what it is, which is extended plane with the sun setting behind it.
Well, but don't forget though that when you say fake mountain, right? But it's we're seeing the light that's bouncing off the real mountain, and the sun is going behind that mountain at some from some perspective, right? So all we're really doing is taking what's really happening and shifting where we can see it from slightly.
I don't think he gets it.
I think I do. I mean, I think what I said is true. So the sun would be behind that mountain, right? If I was standing, I don't know, say 100 feet from that mountain, I could see the sun going behind it. What the refraction does is take that image, that real image that I would see if I was, say, 100 feet from the mountain or a mile from the mountain or something. It takes that same image and it bends that image downward so that I can see it from farther away. But it's still the same image. It's still the same light,
Yeah, but dude, so on a globe. All right, so let's say you're up on a mountain, you're looking out over Canigou. There should be a 3-mile hump of Earth that would be between you and Canigou. The sun on a globe Earth model would be straight. It wouldn't. The sun's not going to be bent around unless you're saying the sun's bending too. Both the sun and the mountain are somehow both refracting simultaneously to bring it all up on the horizon. Like that's not possible because you have two different lines. Like the mountains. Think of if you're looking at it from above, the sun is straight. The mountain's curved off to the left. Somehow on the globe, you have to somehow bring the mountain all the way up to be planar and have it be intersecting with the sun exactly how it would over a planar surface.
But it's already intersecting with the sun from an angle. Like there's a place where we could stand and see it, the sun going behind the mountain, right?
Yeah, but if the whole mountain's on the globe, well, not necessarily from that position. It wouldn't be in that position.
Well, not from that position, but there's a position where we could see it, right?
If you were in a totally different area where you could, like where the curve was able to let you see it, then yeah.
Yeah, if you were much closer or something, right? So that same light that's giving you that image, the one you're watching the sun go behind it, that's the same light that you're seeing in a place you shouldn't normally see it. It's being bent, but that same light that's showing you the image that you would see normally if you're closer and it would look normal, it's just you're seeing it where you shouldn't see it because of the refraction part. But it's not like it has to put it together or something. It's the same, Go ahead.
Yeah, well, I hear you. It's kind of a sub point. It was actually not because the original one was just the fact that we shouldn't be able to see it, and then this is kind of like a more subtle point. And I think this one like ultimately needs a visual to say exactly what I'm saying because,
Yeah.
but I think you may also kind of get what I'm saying. It's kind of a subtlety. Your way of describing it, I don't think fits though because the Earth has already curved, or the Earth has already rotated to the points where that mountain would be on the backside of it. So it wouldn't really be lighting it up on a globe from the back anymore.
What do you mean? What do you mean?
Because it would already be like it would already be 3 miles around the bend, 3 miles around the bend. So the sun really wouldn't be shining right behind it like that.
Why not? What do you mean? Why not?
Because it's already at the time you're seeing it on a globe, that mountain should be all the way, under the horizon, gone and out of sight.
It depends on where you're standing from, because right.
And then the sun's coming directly at you. So if it's coming at you, then anything that it's coming at you from would have to be between it. But on a globe, that should be 3 miles around the bend. They wouldn't line up like that.
Yeah, this part I'm not following. I guess I don't fully understand what you're trying to say here.
Make sure you write this down if it's true.
So the sun is the setting is happening because of the rotation of the Earth on our model, and so as the mountain moves to the east, right, it's causing the sun to appear to drop below the mountain, and that image, that light, we can see that from a certain place and normally without any refraction, and that same image is going to happen, right, at some point that will happen. Whenever that point happens, all that refraction does is let somebody who would not normally see it be able to see it because of the bending, but it's going to happen at a certain time. It will happen, right? That's sunset does occur at some point. So whenever that point is, it just means somebody else can see it that wouldn't normally see it.
Does anybody have? I'm just googling it now. I think I can probably find one on just a quick search here. You know that one that shows the Selenelian bending of the sun?
I don't.
Someone has that. What's that?
Oh, so I thought you were doing me.
Yeah, it's like you. I think you even posted it. Oh, here it is. Something like this. Okay, so with that Canada observation, imagine the dude is the dude. Imagine that the perceived position is the sun, and then the true position. See how it's like warped down there?
Yeah.
Now, just for the moment, let's just erase the fact that this has to do with the Selenelian, just for a second, and just take that basic thing, kind of perceived true. The true position, I'm gonna say that that's Mount Canada because it's around the curve of the Earth. I'm just using that little drawing to just show like that orange kind of curve. Imagine that's the actual curve of the Earth. No, it's not quite that. It wouldn't be because then you'd be able to see it. Anyways, just the thing is that true position. Imagine that that's Canada. And then the perceived position would be the actual sun. So I'm just showing that to show the general geometry. So what would have to happen on a globe is that the line of the sun is not actually in line with the mountain because it's 3 miles behind the curve. So to even explain it on a globe, you'd have to somehow explain how the mountain lifts all the way up 3 miles. And not only that, but an image that's lifted of bendy light is now able to obstruct the sun.
Oh, okay, so you're saying that the true position, the orange circle, that's the top of the mountain, right?
I guess I'm actually kind of more using it just to show that something is behind the curve and out of position, and then the sun is straight in line. So that the mountain that's out of position can't be lifted up and can be intersecting with the sun to make a straight line. The fact that that's all lining up straight is because of the planar geometry. That's the ultimate.
Okay, but in the model where we're seeing a sunset, if let's say that bottom one is the mountain, okay, this means that the Earth is rotating to the right. So the mountain would be, the whole thing's shifting to the, circling to the right. That top sun would not be there. The top sun's way off to the left, a million miles or 93 million miles. And as the mountain shifts to the right, it's occluding where that sun is way off to the left. And that's where the sunset appears to happen, right? And so that light coming in above the top of the mountain there, that's normal sunset. You would see that if you're close enough to it. Now just imagine backing up so that you can't see that happening, but then bend the light down so that you do see it happening. I mean, it's really just a normal sunset, being being bent such that somebody can see it from farther back than they should normally.
Well, it's like, okay, so if the sunset is at the point at which the Earth, the globe Earth meets the sky, that's where the actual sunset's occurring, right at that meeting point. And if that was the end of a ball, the edge of a ball, how did the mountain that actually is 3 miles around the curve somehow end up to be in line? Like the curvature is completely missing.
So I'm trying to think about what there's definitely a disconnect. Like, I think you're saying something I'm not catching, but when you say in a line, I guess I don't fully know why you keep saying that, because when you say in a line, the sun is, way off in the distance, the Earth is rotating, and eventually anything on the Earth is going to be blocking the sun out, because we're going to rotate up and around so that we can't see the sun anymore. As that happens, we call that a sunset. Where you're standing in a spot, you only see, one area where that happens, because you can only see the one time when the sun is being occluded by stuff. And so that's just the normal sunset. Are we agreed on that? Does that make sense?
That is the curve of the Earth?
Or just that in our model, that's how a sunset happens, is rotation causes things on the Earth to occlude the sun, basically.
Yeah.
Okay. So that will happen for every point on Earth is going to have a sunset, right? Depending on the time, everything's going to eventually get around to the point where it's going to occlude the sun. The sun's going to appear to go down below the horizon. So whenever that happens for the mountain, that's going to happen from Kanegu at some point in the day, right? Whenever it happens, all I'm saying is that moment that happens, only certain people that are in eye shot of Kanegu can see it. But what if somebody was further back and then refraction bit the light down, so now they could also see that? So it would be the normal sunset that everyone would see if they're close enough. All we're doing differently is letting somebody who's too far away to see it by bending the light down.
But you have light coming from the sun, and then you have the light coming off the mountain. And on a globe Earth, the sun is a straight line from your eyeball because it's 93 million miles away, whereas the mountain is the thing that's curved on the other side of the globe.
Oh, but yeah, but
every time on a sunset, the sun doesn't jump around in the zodiac. Like, it doesn't hop around degrees or whatever. So that's the problem. That's one of the problems with the Selinellian argument. The sun doesn't move position in the actual timepiece of the sky, which if it was warping like this, it would have to. It would be moving like multiple degrees. But it doesn't do that. So that's a whole issue with that in and of itself. But I mean, it's, even if we just ignore that for the moment, like the edge of the Earth, and then you have, it's like a straight line between you, the edge, and the sun.
Yeah, during a sunset, right?
Right. But so if you're with me right there, when the mountain is 3 miles beneath the curve, it's down around the curve. How could those all be lined up? Because one of them's off, one of them's tilted down. Now, even if you want to say that the light somehow bending and warping and hitting your eye at an angle, or like way you were describing it earlier,
I understand.
The thing with that is that then you would have to somehow describe why that bendy light that's coming from around a curve is now obstructing the entire sun in a position that it isn't actually in. And a position that matches a planar surface.
I think I see the problem. So, okay, after a sunset has happened, right? When it's dark outside, you can think about where your position is relative to that sunset, right? And you can see how something to the west is now having its sunset, but you're done. You're not going to see the sunset at all, right? So the situation where you're seeing Kanegu because of refraction, where you're seeing that sunset because of refraction, that's a situation where normally the observer is going to be in darkness. If it wasn't for refraction, their sunset's over. They're already on the far bend. So it's not the Kanegu that's down too low. It's the person observing is sort of too far past the sunset, and Kanegu is exactly at the right spot for the sunset.
Yeah, but there's not differences in the time of day that it sets. It's not like a special refraction that just that day it changes how the light lighting up the environment.
No, but the sunset sets for a different time for every spot on the Earth, right? As the Earth rotates, only one place is experiencing its sunset at that moment. So you can be done with your sunset, you can be having your sunset, and only one place on Earth is having its sunset at any given moment, right? When Canada is having its sunset, we know it's in the right position to have the sunset. When it's time for it to have its sunset, there's only one time. Only Canada is doing it, and it's in the right position to be occluding the sun. There's a straight line. All that stuff you're saying is it true? Then otherwise it wouldn't be having its sunset. So that's the situation. The sunset is happening for Canada. It's in the right spot for that. The person that's seeing it would normally be in dark, but instead, because of the refraction, are now able to watch that sunset, even though they normally would. It's too late. They would be in darkness. They wouldn't see it at all. But the mountain itself is in the right spot for that.
Well, it sounds like you're just describing if you move positions to a totally different area and then claim that the bending would have been dark there. But that doesn't still match with the fact that for that to be the case, the sun would have to the Earth would have to be 3 miles rewinded. You have to rewind it by 3 miles, and then if you saw Canada, then that would be different. But it's 3 miles behind a curve.
It's 3 miles behind the curve because you've been rotated forward, right? So you're past your sunset. You're way into you're into nighttime, and so that's why it's 3 miles back. But it happens to be exactly the right spot for the sunset. It's in the straight line with the sun. You're no longer, the observer is no longer in that sunset that straight line, but the mountain is, because the mountain's the one experiencing the sunset at that moment.
So you're saying the whole thing is bending like this and making it so that it would be darkness all the time at that time of year on a globe Earth, except there's the same type of refraction that happens every year that is always doing this?
No. I mean, no. My understanding of refraction is it's highly variable, in that, like for example, if you can see Canada at a time, that one time, it very well might be that most of the time you can't see it at all. You're just going to get, there's just darkness in that same spot. But that every once in a while, if refraction conditions are correct, you might be able to see it. That's my
Yeah, but if you're trying to say that the amount of the light in the environment would have been dark if it wasn't refracting, that doesn't fit, because then you either have to choose that it has to be refracting that time, every time of year, all the time, consistently the same, or you'd have to admit that the amount of daylight or darkness is not different on that day when the world record photo is taken. It's the same.
Why can't it?
The year before, and the year before, and the year before, in terms of the amount of light that's in the environment.
Why does it have to be the same, though? Why can't it just be a phenomenon that happened that one time?
Well, what I'm saying is that if you were hanging out like next to the dude with the camera and you just had a little light meter and you were testing the light, I'm just saying that amount of light and how it dissipates is the same every year. So it's not, because the way you described it was like that whole area would be dark otherwise, but it's like doing this whole bending thing to where I think you were trying to say it where like, so, okay, when I was saying,
I don't think it would be.
You're trying to make the whole thing be when the Earth was rotated 3 miles apart, 3 miles different. So where you could see the whole sun actually setting behind Canada, and then that whole thing is curved. That sounds like the way you were describing it, but that doesn't work with these other things.
And I would claim, though, that it won't be the same every year. In fact, my understanding is that Canada shot was like a once in a very rare occurrence. Like you wouldn't normally get that. And probably normally it is basically dark there.
I thought it was like once a year. I might be thinking about something else though.
It is once a year, yeah, because the sun has to be lined up with it, is why. The sun has to actually be lined up with the mountain.
Yeah, but then didn't they also need conditions to be just right for it too? Like it has to be that one day of the year, that one weekend of the year, and then it has to be conditions that are good for it, right? That's my understanding, at least.
Yeah, I believe so. But I mean, that doesn't really address like what we were, because you were trying to say that the bending light. Okay, let me just see if we're on the same page with this part. If you're on a globe and you're up on the top of a mountain and you're looking for Mount Canada and the sun is setting, if we think of the sun, if you're going to think of the sun as a straight line, because during the Selenelian, they say the whole thing's curving, but then normally they say it's straight. So if we're going to say it's straight, there's problems with that too. But anyways, if we're going to say it's straight, then then the sun's light is being occluded by the curve of the Earth in the globe model, right?
Yeah.
So as that sun is setting, It's the curve of the Earth. It's the last bit of Earth you can see that is going to be, visually obstructing the sun, right?
Yeah, right.
Okay. So on that day, when that's happening on a globe Earth, the entire mountain of Canigou should be over 3 miles of hump. I'm thinking of it off to the left for some reason. I don't know why. I'm thinking of the globe to your left. You're kind of straight line. It's off to the left. It's hanging off to the left.
But
So
rotate.
if the last bit of just let me finish. If the last bit of Earth you can see is what the globe is obstructing due to its globiness, its globularity, if that's why it's doing it, then this mountain that is over around the bend, how is that mountain the last bit of Earth that's occluding the sun when it's all the way bended around on the other side of the globe?
Because I think the right way to visualize it is I see the way you're visualizing it, but now take that same thing you're saying and now like, reach out and grab the Earth, rotate it to the right about, I don't know, 20 degrees so that now the mountain is at the top, okay? Because that's the situation. Now, relative to the observer, it's the same exact situation, right? The observer doesn't know any difference, but you got to rotate it around so the mountain is at the top, the observer is more off to the right and lower, and that's the situation we're talking about because the mountain is in a straight line with the sun in order for the sunset to be happening.
Okay, so you're just saying like warp reality.
No, I'm saying that is the reality I'm describing. You have
that doesn't fit with the physical reality of the fact that it's 3 miles behind the curve. How is it doing all that? What you just said?
Because it's still 3 miles behind the curve from the observer's perspective. Because if you do what I said, where you rotate it, right? There's no difference about like when we look at the image and we see the top of the image. There's nothing on the Earth. There is no such thing, right? Like you wouldn't know the difference, right? So when you rotate it to the right, so that the mountain is at the top of our image, the person that's observing it, it's the exact same situation for them. It's still curvature between them and the mountain. Normally, they're still a certain distance away. Everything is exactly the same. You just have to angle them away from the sun a little bit. That's all. That's the reality, and I'm saying that's the actual physical reality.
Right. So then how is refraction causing the entire Earth to turn to put the mountain in line with it as to what it would be when the way we actually see it? How is refraction causing the Earth to make a
it's not. It's not. No, it's the other way around. It's refraction is letting somebody who would not normally see the normal sunset, the straight line sunset, not a refraction caused sunset, but a normal sunset. It's letting somebody who would not normally see that sunset be able to see it. So what's happening is the sunset's happening like it happens every day, normal sunset, nothing weird about it, no refraction involved, it's normal sunset. What's happening though is that the light bouncing off that sunset, the image of the sunset, is being bent so that somebody who would normally see it is seeing it.
I guess I'm imagining like if you were to take like a coat hanger and put a curve on it and then put it around a basketball and there'd be different angles. Like if you had that kind of curve thing, is that what you're saying? That like refraction somehow causes like a totally different vantage point, than you where you actually are? Because it kind of sounds like what you're saying now, like almost like, okay, if I'm on a globe and the mountain's all the way over there, well, if there was a dude way out over to my right or whatever it is to where he would be able to see the mountain, like that dude, that's like the coat hanger that's angling off over there. You're saying that the refraction bends and warps that entire reality to somehow like just, I mean, that's a massive amount of just physical world. Like a dude that's way over there that would actually see the mountain. That whole thing is bent and warped and then aimed right into my eye.
Well, it's not right into your eye. It just bends a little bit, and then because all the light is being bent a little bit, like it works like normal light anyway. Just the same way that if you were standing there and seeing it, some of the light's going directly into your eye. That's true. Same thing. It's just if you bend it a little bit, you can stand back farther, and now it'll go into your eye. That's the only difference, really. If you just think of the I was going to say, if you just think of all the light bouncing off of anything happening is going, it bounces normally is like say going in a straight line. If all you really have to do is imagine that those light rays, all bazillion infinity of them, just bend them a little bit, and you can see how it would make somebody who would not normally see it be able to see it because normally that light would have gone above their head. Now it hits their eye.
I mean, there's a certain limitation to curvy bendy light that any discussion could go because I mean, I know if I were to ask you for like any measurement of this or like validation of it, I mean, unless you do have that now, I've never seen anyone actually provide that. So if we were to go into that, like actually, because that's a huge claim you're making. So I mean, you would have to back that, right, with like actual measurements or something very tangible. Because I mean, otherwise, somebody could say the Earth is anything. Oh, it has a radius of 15,000 miles, or it's concave, or any other thing, and just claim that it's bendy light that's just making it look like an extended plane.
Yeah. Well, the diffraction is a phenomenon. What I know about for sure, I assume they've done it in the field too, but what I know about for sure is that there's lots and lots of lab experiments that do it. We have equations to do it. And this is stuff that was figured out by like not Newton, but like the scientists right after Newton. They played around with light a bunch and they figured out like, oh, it'll do this bending. It's like what a prism does, by the way. But anyway, so they figured out all this stuff that light will do when it's going through different mediums and different densities, and they worked out equations for it. And all that stuff has been experimentally confirmed. And that's what's happening here. Now, I don't know to what extent people have done it at 5 miles, 10 miles. I have no idea. I assume probably some of that's been done. We could probably find if we went into research mode. But so refraction is a thing I think is pretty well established, and then we're just applying that well established thing to this situation.
Well, there's a couple other points there. I don't necessarily agree that it's been experimentally validated at all. In fact, Andrew Thomas Young really kind of has nothing at the end of the day. He has some theories and ideas, and there's calculations that they plug a radius value in, but he really never showed anything measured in the physical world either. It's all kind of theory. And I'm just saying, like, Andrew Thomas Young's work, like, when I say he has nothing, I'm not trying to say he didn't do anything. He definitely has knowledge of certain things, and he's done some decent writings in some scenarios, but what does he walk away with in terms of like validating anything? That's what I'm saying. It's like zero. Like, he has nothing.
Well, have you seen the experiments? Have you seen experiments with like lasers where they put them like through cold air and it bends the laser?
Yeah, you can have refraction like that. Yeah.
Yeah, and so what I mean,
you'd have to validate that our line of sight works like that, and that a line of sight can bend light and make it look like an extended planar surface.
Well,
that's kind of what you need to validate, is why it looks like a plane and how it's bending, and measure the actual physical position of something, and then show how the light is actually bending to be showing in a different position. Because otherwise, the default is just to take it as it is, which is what, as is.
I guess I feel like that most of that stuff falls out of the stuff that confirms that refraction is a thing and based on certain aspects. And then, by the way, something you keep saying, I don't think that it does actually end up looking like I think a lot of the observations we have contradict an extended plane. There's some things that look more extended plane than not, but not everything. Like lots of things look not like an extended plane in my mind. So I guess you keep saying that like it's a given, but I'm not sure I fully agree with it's a given.
I would say it always does. It just has to do with how far the horizon is due to distance to where the ground and the sky are going to meet. There's going to be that limit. But other than that, and that's just how far you can see. But the further we can see, the more the planar geometry continues to extend out. And even if there's visual obscuration, is that what you're saying? Doesn't look like because that still looks like a plane. Actually, I could explain why in my viewpoint. But I can understand why that in my viewpoint could be misinterpreted as curvature. Like I understand the kind of boats cutting off kind of thing and things that cut off. I can see why that can be kind of.
Yeah, that's exactly what I'm thinking, because like the very first thing I ever sort of like went and did is exactly that, where I was actually at the Black Swan location. This is way before Black Swan, but I was in a crane on a film set and going up and down. As you go up and down, you can very dramatically see those oil rigs out there. You can very dramatically see them getting like basically cut off at the fulcrum of the water. It was kind of a cool effect because you go up so fast. And I've heard some tries at some explaining that away with like perspective and stuff that have never resonated with me. I've never found one that felt compelling. But if you know a way to explain that isn't, there's actually blockage by the horizon, I'm all ears.
It is blockage by the horizon.
Yeah, I mean, they were getting. Sorry, I missed. I hit my ear funny. You going up in a crane, and they were getting what? They were getting cut off as you were going lower, or you were going higher?
As I went lower, they were getting to the bottom. They were obscuring bottom up, and then if I went higher, they were being revealed top to bottom.
So you could see more when you went higher.
Yeah.
Yeah, of course. That makes sense.
Not on a flat plane, does it? On a flat plane, I should see the whole thing the whole time, I feel like.
No, because you have the horizon point, the place at which the ground and sky meets.
That's not going to cause obstruction of the bottom of an object, though.
Yeah, it absolutely will.
Why?
So if you let's say you're at the water and you're looking out, the place where the ground and the sky meets is going to be at a particular distance on that day. Some days it might be 3 miles, some day 8 miles, 12 miles, etc. Obviously with Canigou, it's far beyond 200 miles, 275 and beyond. So that changes due to the environment. Of course, if it's like super cloudy and rainy and rainstormy, then yeah, that's going to be like, 2 miles out or 1 mile or whatever. So that limit where the horizon manifests is the furthest distance of ground that you can see, because the rest of its sky is way more expansive. So obviously you can see, the sky going all the way up. So that's the last point of the ground you're able to see. So let's say that's at 3 miles due to those conditions on that day. Anything on the planar surface beyond that 3 miles is going to be visually obscured, because that little bit of water, like let's say at the 3 mile point, that's the last bit of ground you can see. That's the last little bit of water, the little spray there, if you want to say. That's the last bit of water you can see. So anything beyond that is going to be visually obscured from the bottom up over a planar surface.
So I hear what you're saying, but to be fair, it seems like you're just sort of fiating it by saying it like that. Because when I say I don't see why that would be the case, I'm thinking about it in terms of just like the physics of the light, and I'm just saying the light's going to bounce off the bottom of that oil rig, and that's going to come bouncing off the bottom, and it's going to be going in all directions. There's no thing to get in the way of me seeing it. And if I go a little higher, suddenly it comes into perfect clarity. I can see it perfectly. The thing that was getting in the way of me seeing it, I claim, is the curvature. And if there was no curvature, there would be no object obscuring it. I wouldn't be able to see the top, the part where I can see perfectly clear, and the part I can't see just cut off, suddenly.
I didn't really understand that. I'm sorry, but if it's the curvature that's climbing the fucking things, you wouldn't see the horizon behind the things. That's the point.
Well, that's a different. We're not talking about the black swan picture. I know what you mean by that, but we're just talking in terms of cutting things off in general.
Well, you mentioned oil rigs, and actually, I had this queued up to post, so I'm going to post it because it links exactly what we're saying. Okay, so like the one on the left there, obviously you can see a lot further. You see way beyond the oil rigs. The horizon's behind the oil rigs, which of course is discussed with this, that's not possible on a globe and all of that the actual horizon is constellating far beyond the oil rigs. Now the one on the right, the horizon is much, I would say, closer. See, I think it has to do with magnification as well. See how the water layer on the right literally looks magnified? It looks like, it's like more detailed and almost looks blown up. Well, let me just finish though. But anyways, the one on the right, the place which the ground and the sky meets, in the way I'm describing it, is closer than those oil rigs. Therefore, that's the last bit of water you can see due to the conditions of that day. So anything beyond it over the planar surface will absolutely be visually obscured by that line.
But why? What's stopping the light from hitting my eye? What's actually causing this obstruction?
Causing the distance difference? Like that's ultimately what it is.
The hiding of the bottom part. Like, why is it that there's a phenomenon, a flat plane, that would cause this to do this?
Yes, I agree. I would say that's because, like over a planar surface, there is a functioning of a lens. Ultimately, it functions as a lens, which creates, it's interesting. I mean, how like even when you do like zoom, like when you zoom into something, things like this, it's all like the way I see it. It's like the distance of how far we can see due to I think it has to do with a lot of factors. It has to do with the conditions. I would even say like electromagnetic fields, the ether. It has to do with, and there's magnification. There's a magnification quotient, I should say, that's a part of it as well. And it has to do with the conditions, of course, like the materials in the air, temperatures, all of these different factors, to where it's simply a ground distance limit. It's like an optical extinction point on the ground. And that's what changes. So some days it's 10 miles, some days it's 3 miles. You know, so if it's 10 miles on one day and there's a boat at 9 miles, you'll see the whole boat. You'll see the whole thing. Just like these oil rigs on the left, you see the whole thing. On another day, if that lens kind of ground distance of how far you can see on the ground is only 3 miles because the conditions are different, then that boat at 9 miles, you're going to see probably, you know, half of it cut off visually.
May I ask a question real quick? Why choose flat and flat when you can choose concave? Why choose something that'll leave you with so many problems, like 69 miles per degree of stars, when you can choose concave? Like, besides the obvious, you know, we were shown flat Earth first.
I mean, like I said earlier, I mean, sea level. Sea level.
It's not I was going to say, it's not really on topic. Does anyone want to? I mean, I don't know. Scott and I were in the middle of something, but I mean, does somebody want to respond to that? Because I don't know. It's not really on topic. It's just an open question to the room, or is that a question to someone? Or
Yeah, because what Scott is trying to figure out is how this limiting works. And you listed off a lot of things that do limit our vision, but that didn't explain his question really. Like, why not choose concavity? Why not choose the option that gives you measurable curvature rather than its perspective? And that's what we're measuring.
well, Scott, I mean, we could go to that topic if you want, but I guess like I think it might be fair to let Scott respond because he asked me how my viewpoints on it, and I shared all that. So I would like to hear his response if he has one. Okay, he's actually not in the VC. Well, I mean, it's just that question of why things visually obscure from the bottom. And people want to claim that over a plane, you would only see all the way down to the base of everything at infinite distances. And it's just not true because you have an actual distance on the ground of how far you're able to see due to the conditions on that day. And you have the limit of your actual eye as well. Like, and I think that's linking to how the stars work. There's different limits. There's atmospheric limit, meaning the ground layer and where the ground layer meets the sky. And then there's the actual limit of our actual eye on the larger scale too. Like I think our eye is like a toroidal field ultimately, and it projects a toroidal field that has a particular distance. But usually the horizon is much closer than that. You know, usually we can see a lot. We could see a lot further than what the horizon is.
Do you reckon someone living on a theoretical flat Earth would be able to correctly point to the general location of things? Like, let me give you an example. If we're living on I've said this before. This is not a gotcha. The horizon we see when we're in an airplane, we could point to it. If the Earth is flat, that thing that we're pointing to is an illusion. It's not actually there because your horizon, the location where water and sky meet, is not 30,000 feet in the air. So yes.
For what observation? Maybe I missed.
Yeah, like let's pretend there's no globers butting in right now, and both of us agree that the horizon, the Earth is not curving down, and either the horizon rises on up with you, or how I don't want to put words in your mouth. Point to the horizon when you're in an airplane. If the Earth is flat, sorry, I don't mean to yell. So, if the Earth is flat, what is it exactly that our finger is pointing to?
Yeah, I got you. Well, I would say, I mean, out of an airplane, it looks pretty horizontal. Like it looks pretty eye level to the untrained eye, just, without equipment to measure it. It depends. But I mean, especially how cloudy it is. I mean, sometimes the horizon is not very far away on an airplane because it's really cloudy. But I mean, I would say that it is amazing, like how much the horizon does rise, towards eye level. People say to eye level. And so it basically does. I mean, even that claim it rises to eye level, essentially when you take off on an airplane, it does. It goes right up with you. And when you look out that window, it's horizontal right out there. Like it doesn't seem to lower. Although when you actually do precise measuring tools, it does technically lower because there's a dip angle. There's a right angle triangle between the horizon and you and that point.
So check this out. If the Earth were concave and you're in an airplane and you point to the horizon, you're pointing to the horizon. You're pointing to relatively. We all know there's refraction, all that bullshit. You're relatively the thing you're pointing to is plus or minus a little bit. It's there. We're not saying the globe is fucked here. And if it's flat Earth, nothing is in front of you because the Earth is down there. The water isn't, if you're flying over the ocean, your horizon is fucking in the air. So
yeah, that's because it's I think that's actually that's what I was saying. That's actually validation in a sense of or a very strong indication of an extended plane, because if you have an extended plane that's just massive, let's just say it's infinite for the moment. Let's just say it's infinite. As you go up, you're seeing like that angle between the ground is getting greater and greater and greater, and so you're seeing more ground layer. And therefore, you're also seeing more sky because of the extended planar nature of it. So that is what would happen. Like that's why I was saying, like when I first realized this about the Earth, and the next time I went up on an airplane, I was like breathtaking. I was like, wow, look at the horizon. Like it really does have that effect. Now you could argue on a globe it'd be similar because they would get into like, well, when does it start curving and what altitude? So there's all that kind of stuff. But it is said that more on a globe that it would fade away from you because the curvature rate would come into play. Whereas over an extended surface, it's going to rise because you're seeing out with a bigger angle over a massive plane.
The thing you're pointing to the sky, you're pointing to where the water and the land meet in the sky, but it's not actually there. What you're pointing to isn't the water and the land isn't there. So is this an inherent flaw in a flat world? In a hypothetical flat world, do the inhabitants not have the ability to point to things relatively correctly where they are? Because this is the reality in this flat Earth. If Earth is flat, there. Go ahead.
I got you. Well, no, I'm just saying I don't agree that you would look down to see the horizon over a plane, and I would say that what you're seeing when you see a horizon out of an airplane, or even like we've all seen those high altitude footages. You see like a black sky and then like either white or blue. So I would say that over a planar surface that's just the limit of how much ground you can see with the sky. It's like the biggest angle, biggest limit, and it still is horizontal. That's how massive the plane is. It's still horizontal even at that altitude.
Dude, I like this concave guy.
I'm really trying here. I'm really trying not to all right, can we get an acknowledgement in one form or another that at the higher and higher up we go in flat Earth, the more and more wrong you are when you're pointing at things at your horizon, due to the reality that your horizon rises up with us as we go higher and higher.
No, but the thing is, like I said earlier, fluid mechanics, sea level. That disproves concave. Any curvature.
No. That's not
on
what
its
the
face.
question was. But let's stay on topic here.
Yeah, I agree.
Should I repeat that?
You made a statement that I personally don't agree with. You said that it makes it more and more false or something. I think it's the opposite, because I think the horizon functions precisely how it would over a plane.
All right. So if a flat earther is on a flat Earth and they're standing next to the beach and water lays level on a flat Earth, and they're standing at the beach where the shores are, and they're standing at sea level, and they point to the water, that is where the water, they're pointing down to the water, standing up. As they ascend higher and higher, especially when you're 30,000 feet in the air, double especially if you're a high altitude balloon, the horizon should not be in front of you. If you point to the horizon and you're 30,000 feet in the air, and we're not a glober and we don't think Earth is curving down, how could the water, how could you be pointing in front of you, almost horizontally, 30,000 feet? What are you pointing horizontally at, 30,000 feet in the air?
You're still pointing at the ground, the meeting place of the ground and the sky, which has been extended dramatically because of your altitude. And so it continually will stay at horizontal.
Okay. Now we must clarify what is apparent and what is real, because I believe what you just said is what is apparent. It appears to do so, but it isn't actually doing so, because the ground stays down there. It's relatively level. It's topography, yes, there's mountains, but it's level. So what am I pointing horizontally to? I'm pointing to where the water and land meets horizontally, 30,000 feet in the air.
Yeah, because you've raised all that amount, you're able to see like for every like foot you go up in altitude, you can see more land. So another foot up, more land, another foot up, more land, more land, more land. So that land, just due to perspective, is going to continue. You know how everything like converges right at the horizon line? The land's still going to ramp up, sky ramping down, and then because I think the planar nature, that's why that horizon will rise all the way up with you, because you're seeing more and more land as you're raising an altitude that will equate for the more ramping up to keep it at your horizontal.
Isn't it a part of perspective that as an object that's on the ground gets closer to the horizon, the more it rises up in your vision, I guess, so to speak?
Yeah.
Yes.
Yeah.
Yes. But what's happening is you have your initial like frame, and as it gets further and further away, each of those rectangles, each of your frame of vision gets proportionally smaller and smaller and smaller and smaller. So in a true leveled, flat leveled hallway, the ground plane, the ground, like the tiling, the white tile or the checkerboard tile floor, never, if it's flat, never actually appears to rise to the center frame of the camera. It never rises to the center frame of the camera.
Can I ask a question then? If you're in a hallway, right? Let's just assume that the hallway is strictly Euclidean, geometrically flat and level. There's no topology. This is not even Earth. This is not Earth. It's not water. This is Mathemagic land, right?
Yeah.
You're in a mathematical hallway that's straight. There's no curving. There's nothing. It's just a perfectly straight line. And that perfectly straight hallway goes for infinity. When you look off to where that plane goes, what would you then see?
I believe it'll appear to rise near the eye level, but if you zoom in as much as possible, we're not going to get what happens in this world where you go near an ocean and you go up. I don't think we'll see the same thing. I don't know. I don't know if that answered your question or not, but I don't think we would see the same thing. Like if you go next to an ocean, point a camera like a drone and go up, and you do the same thing in an infinitely fucking flat, hallway, theoretically, like you explained, I don't think we would see the same image.
Okay.
Well, if everything was curving up enough to like circle around us above our heads, the way a concave says, I think that would be pretty apparent. But I mean, that's a whole other argument. Hey, Alan and Shane, are you in here, by the way? Sorry.
If it's curving up and
What
up
up?
and
Yep.
it being apparent, it would be.
What would be the difference
What'll be the difference for what?
between the infinite hallway and if we were on a beach with a drone and the drone could just go up and just keep going forever up?
On a beach as a drone, as a concaver, I actually do see clear curvature in the water with my eyes, and the gradient shading of the light that I observe on the water, to me, this is what it means to me. So to me, proves that there is curvature in the water. The reflection of the sunlight of the nice spherical sun over the ocean, the way it distorts and bows out, to me, a lot of things.
So you think the water curves up and eventually water is above us, just like the ocean, but it's like hanging.
We're having a decent conversation before your rude dismissal and jumping in and trying to change.
I was just asking if that's what
we're
you
actually
think.
engaged in this conversation, please.
I was asking if that's what you think. It curves up and then just keeps curving up and up and up and then goes above us.
I don't want to force this, so if there's no more questions, we could move on. But thank you guys.
Well, yeah, we could move on. I was just gonna post real quick. I was looking for this one. I just wanted to post it. So
in here. If we're moving
I
on,
want to check that out.
If we are moving on, though, Alan and Shane, I'd like Geo. I'd like you to hear the interferometry stuff. I don't know if you guys want to try to lay that on Geo at all, but I think he would totally get the interferometry stuff you've been working on, and that is like huge glow killer. It's amazing. There's some interesting things that you would totally get as far as their recent findings on that, or recent.
Well, you could just
resurfacing.
say Alan, right? Because he did everything.
Alan,
I
yeah.
don't know why you keep including me. I mean, it's cool, but
Shane's chiming in always, but yeah.
Alan,
Alan,
I chime in. That's about my contribution.
Yeah. So you want to start with satellites or interferometry or both?
Let's just do it, man. Whatever you think.
All right.
Listen to this, Gio. This is good shit.
Give me 1 second to
You,
pull up the paper.
Yeah, if you want a screen share, I could share it in the live stream as well. Just let me know.
Nice. You should do that.
Yep. Give me 1 sec. Let me prepare.
All right, cool. I'll get it ready too.
Wow, what timing. Perfect. I'm glad that you're actually ready to do this. That'd be great. Because it's like, oh my God, okay. Well, that's huge. That's a big deal. That's a big deal. Like the thanks Bob is out the window, guys. I mean, it was actually the opposite the whole time, of course, just like everything else they try to claim.
Go figure, just like everything always is.
Yeah. And it would be crazy if the opposite, if these guys are trying to say there's no way that it's flat, but it's actually concave. That would be hilarious.
Walter.
That it's actually so much so that it's going above us instead.
Thanks, Walter Bislin.
Yeah,
And then
I
there's
like
the
that one
thanks
much better.
Walter, which is a totally another thing. Yeah.
Well, it's kind of the same thing, right? It's meant to replace things, Bob, for sure.
Yeah. But yeah, the thanks Bob, the interferometry stuff is kind of a big deal. It's hard to condense this argument as far as I can see so far. There's a lot of information. So just have patience with what Alan's going to, there's a lot to it. But at the same time, it's very simple if you just look at it as the simple measurements that are again, reverse engineered on the back end, it looks like. So just keep that in mind.
Yeah, I mean, that 15 degree, why they linked that to Bob so severely was bizarre. They were just, I guess, trolling him or trying to attack him. But I mean, that actual 15 degree is the sidereal rotation. And I mean, that's been known about since Michelson-Morley and even the original interferometry and fiber optic and ring laser gyros, that even the ones they install in planes have that 15 degree, and they have to adjust it essentially for that in order to get, like on an airplane, in order to get pitch and yaw, to get all of that accurate with the Honeywell systems that they also use several other pieces of equipment as well. But in terms of the fiber optic gyro and the ring laser gyros, they have to be able to precisely pick up, roll, pitch, and yaw with precision. And the fact that the interferometer is always picking up that 15 degrees, that has to be calculated out of it, essentially, if that makes sense. Like,
yeah, that's why I knew
it has to be nullified. It has to be nullified in order for the sidereal rotation has to be nullified in order for it to actually work. In terms of
Gio already gets it, Alan. He already gets it. That's why the way that some further things that Alan's been put together totally complement. I mean, you already get it, obviously. But yeah,
that's awesome, dude. I'll just jump into GPS then, since you're already familiar with the interferometry. The right one. I'm gonna try and share a screen here.
But I'm sure everyone would like to hear,
Oh yeah, no. Well, I'll jump in on the back end on that. We'll close on the interferometry then, because the GPS thing is kind of a new thing. I think it's super interesting. All right, so.
All right. Yep. It's shared on the live stream, so you're good.
All right. Cool. All right. So we got they account for the Sagnac effect in GPS, but what's really interesting about that is that it's with the way that they do it, it's shown to be a non-relativistic effect, and there's some other violations that go on with GPS and how it functions. So they have relative simultaneity, where an observer won't see the same event happening simultaneously in the same frame as another observer, right? So they get to like the train situation and the lightning strikes, right? So we'll get into how GPS violates that as well. So we'll start off with the range measurement equation in GPS, which is this right here, which is the absolute value R sub R times T sub R minus R sub S times T sub S. equals C times T sub R minus T sub S. So to get into what that
got all that.
Yeah. So hold on a second. So to get into what all that means exactly is, hold on, I have the definitions here. So here, T sub S is the instant of transmission of the signal from the source. T sub R is the instant of reception. The instant of reception at the receiver. T sub S times T sub. I'm sorry. R sub S times T sub S is the position of the source at transmission time. And the other one is the position of the receiver at reception time. So basically, what they do is they have this is a time ranging system instead of like a distant measurement system. So he goes on to explain what the difference is in that. So to continue on real quick, he says the Sagnac effect, which is extensively used in GPS, must be accounted for. And then when he goes on to talk about the framework of how they calculate for that, he wants to say that the correct coordinate system for this range measurement equation is the Earth-centered inertial frame. And what you can note about the Earth-centered inertial frame is that it's from the perspective of the center of the ball, right? So you're not experiencing any rotation, you're not experiencing any motion, right? So there's velocity around the sun or anything like that. And then it like a ground station would be, in motion, with the daily rotation or whatever. So there would be rotation with respect to this absolute frame, right? So they use this framework in with their timing equation to instantaneously derive the distance to something on that coordinate system. And when they transfer it to a different coordinate system, they have to like recalibrate everything and recalculate it, with quote unquote relativistic effects and all this stuff. So here the guy shows a simple Galilean transformation. He takes a stationary receiver and then he just adds motion to the x-axis. And in doing that, the distance derived, the way that distance is derived in the first coordinate system, becomes invariant, which means it requires post calculation corrections. So when they transfer out of this coordinate system to the ECEF, which is the GSW oblate spheroid, whatever model, and the way that they calculate motion on that is different than how they do it with the range measurement equation, which already is basically what it's doing there is it's minusing plus or minus the speed of light. And then there's a relative correction on, there's a preferred direction west to east. Light travels faster west to east is basically what they're accounting for in this Sagnac correction than it does going east to west. So moving on here, he shows through this example here, a moving receiver and a stationary receiver. I'm sorry, a moving source and a stationary source are emitting a signal to a stationary receiver. They both emit it at the same time. The stationary receiver receives the signal at the same time, and that's in alignment with electromagnetic wave propagation being independent of the source of motion, right, or whatever. And then he does a follow up here where it's the moving stationary receiver and a moving receiver from a stationary source. And what's interesting here is when these two are both in alignment at that moment, when the signal is sent, the stationary receiver receives the signal first, and the moving receiver receives the signal second. Now, if you remember back to the Earth-centered inertial frame coordinate system, that accounts for relative motion, relative rotation to the absolute frame in the center. But what's happening here, what's being shown here, and how GPS works and how this math works out, the guy that's at rest is truly at rest, right? Because if he wasn't at rest, then the two motions would be the same, right? The Earth's rotation and him and this guy being in motion, there would be no difference. So they should both receive the signal at the same time, but they don't. So there's a preferred direction in the propagation. There's a preferred recipient and simultaneity and all that. let's see. Continue on.
Did you already go over how they calculate distance?
Yeah, so I kind of touched on that. So for the distance thing, where was the distance?
Because I love that one.
Yeah, I think it was this part right here. No, that's not it. But I'll read about the global simultaneity versus relative simultaneity real quick, right? Because relative simultaneity is a big part of special relativity. And if any of these postulates, by the way, the first postulate of special relativity, all frames are equally valid. There's no preferred frame, right? But what's being shown here is that there is absolutely a preferred frame, and light propagating west to east is faster. And so, anyway, real quick before we move on to the simultaneity, I kind of got sidetracked. In the Earth-centered inertial frame system, right? So the way that you would equate the stationary observer, it would just be with respect to an ether wind. So when you're at rest, you're actually at rest, and that's provable by GPS and how, and mathematically, right? So that's a direct violation of special relativity. And the way that I interpret that coordinate system is that when they're talking about Earth rotation corrections, this is just ether wind propagation, right? Anything west to east, and obviously there's what's it called, like a speed relative, to the quote unquote latitude, right? So, and that's all works out in that initial equation that doesn't account for any relativistic effects and assumes a framework with an absolute frame at rest. So, global simultaneity versus relative simultaneity. In any debate about the speed of light, the problem of simultaneity is always a focus. Special relativity claims that relativity of simultaneity, which states that two events occurring at two different places, which are received as simultaneous for an observer in a system, usually will not be simultaneous if viewed viewed by an observer in another system. But contrary to this, simultaneity is key to GPS operations. GPS timing in the range measurement system, it does not directly measure distance between two places where two events, i.e. the signal transmitting or the signal receiving, occurs. It measures the difference in the instance between when these events happen, and the distance is calculated using the range measurement equation. GPS, especially its space segment, its space segment and its control segment, make a huge effort to establish and maintain GPS system time, or simply GPS time, in a scope where GPS is applied roughly in a scope of a diameter of 50,000 kilometers or bigger. If one is using GPS, one is using GPS time, and therefore the concept of simultaneity of GPS. Two events happened at two different places, and it gives the coordinate system for one event happening here, and a coordinate system for another event. And if these two events, are simultaneous, if T1 equals if T sub 1 equals T sub 2, this is true no matter who the observer or the receiver is, where the receiver is, what its status is, or what speed is. This is the basic operational principle of GPS. We call it global simultaneity. I like to call it planar simultaneity, but that's okay for now. In the books about special relativity, the most commonly cited example of example of relative simultaneity is the example about the railway platform and the moving train. It says that two events, e.g. the two strokes of lightning, A and B, which are simultaneous with a reference frame or reference to the platform, are not simultaneous with respect to a moving train, and vice versa. But now GPS receivers have been utilized extensively on railway platforms, moving trains, and lightning at two different places, A and B. Conceptually, it is the same emission of GPS signals from two satellites or two DGPS stations. In fact, if two signals are emitted from two satellites or two GPS stations at the same time, at the same GPS time, both receivers on the railway platform and both the GPS receivers in the moving train would acknowledge the two events, and the emissions of the signals would be simultaneous. Without this basic acknowledgement, GPS would not function at all. And keep in mind, this original equation with its absolute reference frame is accurate down to the millimeter, without any corrections and already assuming, the preferred direction of light and all that stuff. So to close up on the simultaneity stuff, actually, I think that was pretty much it. Shane, what was the thing that you wanted to talk about?
Well,
so the distances, right? So they said that it's not calculating distances anywhere in reality. What it's doing is computing distances based on two parameters of given coordinate sets, and then it computes back like the geodesic distance between those two. And what that means is like, prefab curvature included, i.e. spherical excess over long distances on Google Earth, pre-included in the result of any distance calculation that we use. Anything so like GPS, Google Earth, the internet, all that uses essentially prefab geodesic distances is what I've been calling it.
Yeah, and on top of that, the Sagnac effect situation, like this isn't the only source of this paper, right? Like there's multiple people that have realized the situation and the issues at hand here. And one of the things that they don't account for is the Earth's velocity around the sun, right? So the linear velocity of Earth's rotation, and there's also the linear velocity of Earth's velocity around the sun. So this would also have to be accounted for in the range measurement equation, and it's not. It only corresponds to the sidereal rotation, like at latitude, right? Like how we were saying with the interferometry stuff. So at bare minimum, best case scenario, it's a globe that's not moving anywhere, right? If you were to give them the benefit of the doubt. So. What are your thoughts?
Let me start. Can I just check? Why would it be calculating the data in a geodesic if it didn't need to? And why are you saying they just?
Because that's sorry, I'll answer that. That's just the coordinate system that they transfer it to. After they have the initial accurate measurement distances, then once they apply that to whatever coordinate system, it'll just automatically input the corrections to whatever. So it doesn't matter. Like when you say, if you were to look at it, like why would they do it if they didn't have to? Well, they could do it to any coordinate system. It doesn't matter. In fact, isn't there two different coordinate systems? Isn't there a public GPS and a military GPS? And like one's probably way more accurate than the other. And this is the process by which you would have that how that would function, right? These coordinate system transformations.
Yeah, and this is a lot of information, and for someone that's a little bit more familiar with it, my understanding of the basics of it is that first of all, we have two positions that they're taking into account. One is stationary, and then one is in accordance with what would be the ether wind, correct?
Yeah. So So in the in what was it, example 2 or 3? Yeah, there's a preferred person who gets the information first, and it's the one who's truly at rest with respect to the ether. And then if you're in motion, you receive it second. So how people are like, oh, do you think the universe revolves around you? It's like, well, if you're standing still, it actually does. Like, isn't that something?
Right. But the stationary part, the thing that got me that when it comes down to like the bare bones of this is that they're not accounting for the movement of both positions, which they would have to if the Earth were actually rotating. Right. So they're treating one as completely stationary, which wouldn't be possible if the Earth were rotating, because that would also be a moving position, but they can't do it that way.
Right? Well, if the stationary guy were truly moving with respect to the Earth mode or with the rotation of the Earth, right? Then the moving observer too, like it would be like indifferent, right? Like there would be no difference. So they would still receive the information at the same time.
Right. But there is a difference.
But there is a difference, correct.
So that's the crux of it right there. Because if the Earth were actually moving, there would be no difference. But there is a difference. Because one is stationary.
and then on top of that, so I found another paper, which let me see if I can pull it up here. Let me just share my full monitor. So this other guy realized this issue and the fact that they don't have to account for Earth's orbital velocity. So what he proposed was that there's like a local ether that's like entrained with the Earth, and the way that all these people try and interpret this is that there's a stationary ether, and then the Earth is rotating through it. But the obvious conclusion is that if there's no Earth velocity to be accounted for, then the Earth's not moving. And then we get into the stationary topographical plane nature of it with respect to an ether wind. So it's like literally the same coordinate system. They're just talking about it in a different way because they're in the heliocentric paradigm where like the assumed motion is a given no matter what. Like, even though there's countless interferometry experiments that prove otherwise, right? So
there's direct contradiction that they have to like think of in both ways for them to keep saying that it's actually moving and it's the local one as opposed to the universal or whatever. That's interesting.
Screen. Let's see. So this should.
So we got the Ernst Machian principle, which would be like the moving bodies above that affect the ether wind within what the realm we're in, and then that's affected by this, and all of the things line up with that, but then they have to correct it on the back end to make it somehow seem like it's still a spinning Earth, but that's not even necessary, right?
Correct. Yeah. So this guy right here, Ching Chong Su, points out the same situation, and his solution was a stationary ether. My solution is a ether in motion, or an ether wind, if you will. So it's just it's obvious, and this whole GPS SAGNEC thing is a real like black hole in physics. Like surface level narrative of the SAGNEC effect is that it's a quote unquote predicted by relativity and all this stuff. But this dude right here, Bruyong Wang, he actually did a linear Sagnac effect. So like basically, how they say the Michelson-Morley was a null result and all that, but the Sagnac effect is good to go because it's a non-inertial frame and all that. Well, anyway, your boy linearized it and also derived the circular solution from his equations too. So like this, I mean, there's an obvious preferred direction of light, and it's west to east. It goes faster. It's undeniable proof,
And that in and of itself debunks
it directly refutes the postulates of framework of special relativity. So like we've always heard that GPS is proof of relativity and wouldn't work in time dilation, all these things. It's actually not the case. It works way better without these things. The post calculation corrections to the coordinate systems that they want us to believe that we live on. I'm sure it's very necessary to account for things like the bending and warping of space time to make the corrections necessary to fit us on that coordinate system. But it's verbosely superfluous, as they say.
But so preferred direction of the speed of light in and of itself as a phenomenon debunks the pivotal constant speed of c. So literally, if they built the model on the speed of light, the average speed of light, so that the presumed speed of light, the whole thing is built upon this. But actually, that's not true. It goes faster in one direction, so the whole framework is retarded. Sorry,
dude. So check this out. The first postulate: all inertial frames are equally valid, right? So the first postulate, the only inertial frame that these people that have ever been in is on Earth, right? And the only thing that they've had to interact with light or base anything off of is that there's a preferred direction, right? But they just ignore that, and then they say, "Here's a coordinate system where everything is the same in all these frames." And this frame that they started with, it's not even the same dog. Like it's such a well played, boys. Like they got us. But we're figuring it out now. We're coming out of the darkness.
Dude, imagine nobody looking into this stuff and us just assuming thanks Bob wrapped it up for the globe, and look at that Earth spin. Nothing we can do about it.
Yeah.
This is huge.
So would you like to move on to interferometry, or is there any follow-up questions on GIPS?
Go ahead. Yeah, go ahead.
Okay. So I was reading this last night before we get into interferometry, the Aries failure. I thought this was hilarious. I was reading Michelson-Morley. Michelson-Morley says, but it failed to account for the fact proved by the experiment of the aberration was unchanged when observed with a telescope filled with water, referring to Aries failure. And then he goes on to say, for if the tangent of the angle of the aberration is the ratio of the velocity of the Earth to the velocity of light, then since the latter velocity in water is 3/4 the velocity in a vacuum, the aberration observed in the telescope would be 4/3 its true value, and then there's a little notation here. So you read the notation. So maybe notice that most writers admit the sufficiency of the explanation according with the emission theory of light, while the fact of the difficulty is even greater than according to the eudolitary theory. For the emission theory, the velocity of light must be greater in the water in the telescope, and therefore the angle of the aberration would be less. Hence, in order to reduce it to its true value, we must make the absurd hypothesis that the motion of the water in the telescope carries the ray of light in the opposite direction. So for those familiar with Airy's failure, they were supposed to correct the telescope to account for the Earth's velocity, through the stars or whatever, and they didn't have to account for it. Well, this is what they said that they had to account for. It was 0.8 seconds of arc, which is, 0.000222222 twos of a degree. So, no correction necessary, really. And yeah, so in order to believe that there, the reason why there was no correction, they have to believe that the water was carrying the light ray in the opposite direction of the motion of the water if the Earth were moving. That's pretty crazy. Any thoughts on that or rebuttals? Anyone heard of that or read that before?
I think, did I hear Witsy banging on about that? But that is interesting. I think that's the first time I've seen that. I don't know.
Yeah,
Can you
crazy.
repeat that, Alan? Like just a little bit more, like just slower and like okay. So they would have to assume that.
Yeah.
that
So the guy, Professor Klinkelfuse or whatever this guy's name is, hypothesized that they would have to correct by about 15 arc seconds. I'm sorry, like 30 arc seconds. So that they would have to, meaning that they would have to tilt the telescope to look at the starlight when the telescope is filled with water. Otherwise, they wouldn't see it in the center of the telescope if the Earth were moving. And if the Earth were still, they could just look at it and there wouldn't be any motion, right? Or there wouldn't be any need to correct for it because the Earth isn't moving underneath the star, right? So to speak. So they say that in order to maintain their belief system, in order to reduce it to its true value, we must make the absurd hypothesis that the motion of the water in the telescope carries the ray of light in the opposite direction. So they're saying that in order to believe that, to derive motion out of this Airy's failure, you have to believe that the water is carrying the light ray in the opposite direction that it would even carry it in if the Earth were in motion, so that the light would just automatically account for it, basically, so that it would just bend naturally, so that you wouldn't have to account for it.
So for someone to believe that that's the case, they would have to just it would contradict all common sense, right? Like that.
Yeah, I mean, he refers to it in his own words, the absurd hypothesis. So, I think that really kind of says it all about the nature of this hypothesis to explain why there was
Yeah. So your guy Wang.
Why the correction angle was 0.88 arc seconds.
You're cutting out a little bit, but your guy Wang is one of the ones that you've been focusing on. And who's the other guy that did all the many tests that ended up dying in his tell a little bit of that story, because that was interesting.
Dayton Miller. So
yeah, Dayton Miller.
So following the Michelson-Morley experiment, hold on, I'll just catch everyone up to speed. Give me 1 second. Let me take Shane's advice here and do a full screen. All right. So from the initial Michelson-Morley experiment, they expected to get a French shift pattern that corresponds with 30 kilometers a second. So that would have been 0.4 of a fringe displacement. So these fringe displacements, what they're measuring here is how much of the distance between these fringe patterns corresponds to velocity, right? Similarly to how dude was saying in the Aries experiment, how it's inversely proportional to, or inversely proportional to the velocity of the motion of the Earth and all that to the ray of light. So same situation here. So they just so they had this prediction, right, that they were going to get this curve here is the prediction pattern for what they expected to measure if the Copernican principle were true, meaning that the Earth is going around the sun. This is what they measured. They measured a very slight fluctuation, 1/8 to 1/6 the value. So instead of 30 kilometers a second, they got around 5 to 7.5 kilometers a second. And remember, the Copernican principle was supposed to be 30 kilometers a second. So the implication here that they get away with is they say that they failed to detect the ether and the Earth is still moving or whatever. And then Lorentz came along and was like, "Hey, have you guys heard of length contraction? Maybe the apparatus is bumping against the ether and it's contracting or whatever." He did some work with electrons in a couple years prior and was hypothesizing about this contraction situation. So he just applied it there, and they kind of went with that for a little bit. And that was the explanation for a while, was basically that the apparatus shrank, and that caused the displacement to not give an actual reading or an actual full reading of the 30 kilometers a second, right? So, and then Einstein came along, and I'll just read off here. In 1905, Einstein offered new insights into the Michelson-Morley experiment with two postulates for the framework of special relativity. And these are, the postulates that he proposes for special relativity. And what this means is this is going to be the framework of interpretation moving forward on how they're going to talk about light and the velocity of light, relative to movement and stuff like that. So this is what he says. He says the laws of physics are invariant to all observers in inertial frames. So if you remember earlier, with the GPS thing, like, that's completely out the window. But let's pretend like we're baby fresh and new to this. So the speed of light in a vacuum is constant in all reference frames and is independent of the motion of the source or observer. Moving forward with this framework, the Michelson-Morley experiment null result is reinterpreted as being due to the constancy of the speed of light irrespective to the motion of the source or observer, which produced the null result. Additionally, it is suggested that the null result and the constancy of the speed of light is indeed due to length contraction, but this time due to a different mechanism. And in this case, it is the space-time coordinate system itself, which are the length and time axes of the coordinate system, which contract and dilate, which they say physically manifest as the null result as seen in the Michelson-Morley experiment. By attributing the manifestation of the assumed effects of the coordinate system itself, the ether framework was abandoned as a tenable framework, right? So this was necessary for them to say that the Earth was still in motion, right? This is what they came up with, and instead of the ether compressing the apparatus, he's saying that space-time contracted, and that's what, and time dilated and all that stuff. So that's how they that's how they were going to move forward with their new interpretation. Then we got the Michelson-Gale-Pearson experiment done shortly after, which they detected the sidereal rotation at the north 40 first parallel, and the fringe shift pattern was consistent with the globular predictions, where how they say at a certain latitude the rotation relative blah blah blah, that sort of thing. So the ether wind speed rotation situation exactly the same. So the interesting thing to note here is that Michelson derives his equations from classical wave mechanics and the Galilean reference frame, which is an absolute reference frame and relative motion type stuff. So like that's what they derive the the solution for it to show like the quote unquote globular prediction. So they didn't even start with the right coordinate system to interpret these effects. So, yeah, basically what he's showing here with these equations, though, is that light going west to east is the velocity of light minus the ether wind speed. So light will be traveling faster in that direction, and then plus, adding to the east direction. Oops. All right. So that's it for the Sagnac, or I'm sorry, that's it for Michelson-Gale. Then right after, or before that, actually, was the Sagnac effect, which also detected the same sidereal rotation. And the thing to be noted with this experiment is that the devices have to be axially aligned to the axis of rotation, right? So on the globe, they say that they point to Polaris. They make planar correction angles to Polaris relative to their latitude, and that gives them the that allows them to extrapolate the 15 degrees per hour after taking a measurement on the first axis, and then they flip the device. They basically invert it, take a second reading, and that's how they get the 15 degrees per hour. So what I've seen in my personal experience looking into this, one second. What I've seen in my personal experience with this is that the only places where they'll show where they'll talk about the axial tilt corrections needed is they're always around the 45th parallel, and the corrections are always around 45 degrees. So the only examples I have, or that I was able to find, were planar correction angles to Polaris, basically. So it would be the same thing if there's an ether vortex over the plane, or you would align your device in the same situation. You would align it with Polaris. You would tilt it to that. You would tilt the device to be in alignment with the axis of the rotation. Everything would be like there would be the ether wind and the globe rotation are pretty much indistinguishable effects. Is basically what I'm getting at here. And then so to touch on the Dayton Miller stuff really quickly. Let's see. So after the Nicholson-Morley null result, Dayton Miller stepped in with his interferometry experiments, and he ended up doing 5,200,000 experiments. And I'll just kind of read off from here because the story is really interesting. And what this guy basically, what he did was he measured the sidereal rotation of the sky and found a fringe shift change that corresponds with how the sun moves. So we'll get into Dayton Miller now.
And that was a real number, 5 million experiments.
5,200,000 measurements. So his interferometer, the way that how many laser beam splits it breaks off into, they can count it that way. So it's not like he did 5,200,000 individual ones. He did like a lot, but like the way that it equals out, it would be the equivalent of doing it that way.
Yeah, it's like counting each line item in a total experiment graph, dude. I asked the same question.
Yeah, no, it's all good. So Dayton Miller, 1902 to 1933. Quick history lesson. Dayton Miller conducted the most extensive experimentation using laser interferometry during the mid 1900s, conducting a total of 5,200,000 measurements. He was able to determine a direct cause and effect relationship with the speed of the ether in the movement of the sun and the axial tilt of the CMB. The fringe shift patterns reach their minimum and maximum dimensions in accordance with the equinoxes. This directly relating a translation of motion from the sky to the earth. The subsequent Michelson-Morley experiments done in modern times that are trending towards zero only further prove Miller's hypothesis. As you get closer to the surface of the earth, less motion will be translated than at altitude. He also made considerations for the environment of the apparatus, i.e. enclosed material, shielding, etc. For this reason, Miller's later work consisted of measurements at altitude, and this allowed him to make consistent measurements of the ether fluctuation speed. A quote from Miller, a very striking consistency of their principal characteristics for azimuth and magnitude as they are as they were related in a common cause. The observed effect is independent upon the sidereal time and is independent of the diurnal. Oh, I'm sorry. The effect is dependent on the sidereal time and is independent of the diurnal and seasonal changes of temperature and other terrestrial causes of the cosmological phenomenon. Miller, 1933. So what he's saying there is that the effects that he extrapolated aren't relative to like, hey, was it hot at this time of the year? Was it cold at this time of the year? What was the temperature fluctuation? Like that kind of stuff. The graph data doesn't show any corresponding causation relationships with that. It's only when you plot it against the sidereal time coordinate system that he extrapolates these minimum and maximum dimensions. So continuing on, as the universe completes its yearly circuit around us on its 23-degree axial tilt, the CMB, the motion corresponds to the movement of the sun as it travels along its axis of the Tropic of Capricorn and Cancer, which produces seasons. Dayton Miller's controlled experiments, 1902 to 1933. It should be noted that while Miller was alive, his work could not be refuted. Miller undertook extensive control experiments to produce and guard against laboratory artifacts and objectively determine the sensitivity of the apparatus to external influences. So adjusting the mirrors, he had this like really precise screw situation, so you could basically turn through like half a degree or whatever, and it would realign the mirror very precisely. He would add weights to the device to balance out for the rotation to make sure that it was rotating evenly and all that, minimalizing mechanical vibrations. So any vibrations in the system, people walking around, that sort of stuff, because the device was floating in a mercury tank. Guarding against magnetism and all that stuff. So he used a interferometer made of aluminum and brass to reduce electromagnetic influences. He took great care to do all these things. This is just a list of some of the stuff. So the thermal insulation and the temperature evaluation stuff. So the major criticisms of his work that you'll find is, quote unquote, Miller didn't know about temperature gradients and temperature differentials. Well, he explicitly went through great care to account for these factors. He would use like direct heat sources on the device. He would have his assistant take measurements at different positions, next to the device to see if even body heat would affect it. He did all kinds of stuff and found that those effects were minimal and didn't really account for anything. So again, when he plotted it against the diurnal seasonal effects, right? So temperature, daily temperature variations relative to the time that when he took the measurements, there's no like fluctuation, causation, correlation with the temperature. And it was actually publicly criticized by Einstein for not accounting for temperature differential stuff. And a quote from Miller in response to this in a Pennsylvania newspaper was, he said basically, here's how I know Einstein isn't familiar with my work. His criticism of me is that I don't know about temperature differentials. So yeah, like he was just kindly saying that that's a retarded hand waveful dismissal. If you're going to come at me, at least come correct, right? So,
and it seems like that's like the only way that they had to like hand wave excuse it. I mean, Einstein probably knew he was correct, but he was throwing that in there as a criticism that he knew would be taken seriously because it was Einstein. But then I don't know if you want to go into that now, because it's just after Miller died, then his assistant went on to claim the same things, which was totally untrue. But once he's dead, it's okay to do that, right?
And nobody touched him while he was alive. I think that's the main point.
So another criticism he'll often get is Miller tried to just do a broad spectrum test and do this probability chance thing where he just gathered as much data as possible so he could extrapolate any result from it or whatever. It's not the case. What he was doing, the reason why he was doing the continued experimentations, was he was directly refuting criticisms of their experiments. So while Michelson Morley dropped off and dropped out of the game of interferometry, basically, your boy Dayton Miller picked up and was accounting for all the stuff. So what the thing that Miller notes about the ether detection stuff is that the Michelson-Morley experiment was done in a basement, filled with concrete and all these things, and all these factors would affect the detection rate. So if you remember, the Michelson-Morley fringe pattern was 5 to 7 kilometers a second. In Dayton Miller's work, he detects 8 to 10 kilometers a second. And the difference being there is when he figured out that when you're at altitude and you have more open access to the elements, so to speak, there's like freely, everything's like freely flowing or whatever. It's easy. You get more concise measurements. And so what they do nowadays, they say that the Michelson-Morley results are trending towards 0, and they attribute that to the devices are getting more accurate. And they're saying that the Michelson-Morley was in air, and speed of light's constant and all that stuff, and just pretend that GPS doesn't violate all that. So what they do is the modern interferometers, they change the length of the arms of the apparatus, they change the location of the sensor, they change the medium of the tube. So sometimes they'll do it in a vacuum, sometimes they'll do it with a medium. And they'll use different mediums, and they'll interchange any one of these variations, and they'll do it in a basement, and they'll go, oh my god, look, it's trending towards 0. But Miller specifically addressed that while he was alive, and Maurice Elias also addressed that in his analysis of Miller's work. And Maurice Elias, for those of you who don't know who that is, he's a French physicist and Nobel Prize award-winning economist. Came up with some really cool theorem or whatever for economics. But anyway, he did an independent analysis of Miller's work and found that, he did absolutely find a friendship pattern that corresponds with the equinoxes to the day. So so you kind of got ahead a little bit on the Shanklin stuff, but in response to Miller's work, Shanklin was hired, and he was Miller's former assistant. So after Miller died and couldn't do any more interferometry experiments, 5,200,000 was good enough for him. He called it quits, and died. After he was done with that, Shanklin came in and basically undermined his entire body of work and said that Miller didn't.
Oh, you cut out a little bit for me.
Or temperature differentials, and even in Shanklin's, oh, sorry. Yeah, I can see it's lagging.
Go back to that last. Yeah, go back just a little bit.
How is it now?
After he died, Shanklin shanked him. Go from there.
Yeah. So Shanklin comes in and he's like, hey, Miller didn't account for temperature differentials and all that. And even in Miller's own paper, he states that he doesn't even have enough temperature data to make that deduction and claim, but he's going to go ahead and roll with it anyway. And he had his assistant, his research assistant, basically, quote unquote, do the math. And he published that in this paper, and the math from the research assistant that Shanklin didn't even do himself. He didn't even want to put his name on it. He gives his assistant a special credit in the paper for the math that's based on incomplete data, right? To undermine 30 years of interferometry that unequivocally proves a translational speed of the motion of the sky, right? So Miller conclusion. Dayton Miller's work on the ether drift was conducted with precision and diligence, which has been disregarded and omitted from history, and has been omitted from the history of science, despite Miller's response to his critics and his consistent demonstration of ether drift phenomenon. He was viewed as a threat by Einstein and his followers, who sought to explain Miller's work away. The Shanklin team, in their attempt to discredit Miller's work, selectively analyzed his data and failed to systematically evaluate the most important part of his experiment, which was while the Shanklin conclusions were negative and inadvertently confirmed Miller's claim that the periodic effect of the interferometry data, which was not due to random temperature errors or mechanical effects, it was due to the sidereal, it was related to the sky. Let's see, this Team Shanklin just basically focused on the temperature aspect of it, because it was the only thing that they could attack to undermine his work. And people will, accuse us of cherry picking things and all this stuff. And it's like, look at the, the character assassination work that goes on in high levels of academia when they need to protect a theory. Like, while this guy was alive, his work could not be refuted, guys. Somebody would talk smack, and he would go, "Hold on one second, let me bang out a couple 100,000 interferometry experiments and account for all the variables that you described."
Right. This is huge. This is huge.
So here's some graphs plotted from Miller's data, and I'll just read this up, and we'll close on that. I've been talking for a while, and appreciate you guys' time.
That's awesome that you're able to do this. Go ahead.
So the periodicity of the global ether drift from Dayton Miller's Mount Wilson ether drift experiments, 1925 to 1926. The top graph plots the data from four separate months or epochs measured at different times of the year, organized by sidereal time, showing a definite periodic curve. The heavy line is the mean of the four epochs. The bottom graph above plots the same data organized by the civil clock time coordinates. Here, the plot data spreads along the graph without the periodicity, or without the apparent periodicity. This demonstrates that the detected axis and periodicity of the ether drift is the same is the same for different times of the year, but can only be seen when the data is viewed from the cosmological sidereal coordinates. Yeah, 1 second. Can you hear me now?
Yeah.
you buy.
Can only be seen.
Okay, but can only be seen when the data is viewed within the cosmological or sidereal coordinate system from Miller. These data curves are organized along the azimuthal means, were later recomputed by Miller in his 1933 publication. So against the temperature effects and all that stuff, no causation, no correlation. Against sidereal time, you're getting the peaks and corresponding with the equinoxes. And so to close out on this, we got one more. The average velocity of the azimuth of global ether drift from Dayton Miller's Mount Wilson ether experiment, 1925, top graph. Average variation of the observed magnitude of the ether drift of all four epochs of measurement. Minimum or maximum velocities occur at 5 hours sidereal time. Within the maximum velocity occurs at 17 hours sidereal, while Miller's 1933 paper assumed the Earth was pushing through the ether, moving towards Dorado, near the southern pole of the plane of the ecliptic. The movement of the direction of the ether past the interferometer was exactly opposite to this, towards Draco, near the North Pole to the plane of the ecliptic. 17 hours right ascension, declination of plus 70 or 68 degrees. It is important from this standpoint of this working theory to clarify the concept of the net motion of Earth versus the direction of the ether drift. However, if the ether drift itself is in motion, acting on a cosmic prime mover, the direction of the ether and the net motion of the Earth would be identical though at different velocities. Bottom graph averages variation of the observed azimuth readings according to sidereal time. This graph uses the same average data curve from Figure 11, published by Miller in 1928, but at this time, given a different baseline average. The graph is presented here for the first time using Miller's revised seasonal averages published in 1933, which help define the axis of the ether drift. Amazingly, the independent averages of the four epochs provided by Miller: February equals minus 10 degrees west of north, April plus 40 degrees east, August plus 10 degrees east, September plus 55 degrees east, yield together a mean displacement of 23.75 degrees north of east. This is close to Earth's axial tilt of 23.5 degrees and can hardly be more than coincidental. More discussion on Demio 2002. That's the citation for the work or whatever. So this is basically what Miller thought he was measuring: a rotation of the of Earth's axis around the sun through the ether. But let's see, do I have the video? Yeah, we'll close out on the video. So this is what Miller actually measured. So remember, he thinks, through the heliocentric paradigm, he's interpreting it through Earth's seasonal axial tilt. And this is what he actually measured. How do I make this full screen? Shit.
I do think it's great that he noticed that the speed of the ether wind peaked at solstice. So almost like if whatever is in the sun, or the sun is moving the ether is moving the sun, whatever's in the magnetic field that moves with the sun goes with the speed of the sun, and the speed matches the height of the equinox. So when it's furthest out, and then it changes and comes back, and then the speed would, it reaches a peak when it's at the ecliptic, and then right before it comes back, it slows down again. Isn't that marvelous?
Yep. Yep. So this is what Dade Miller measured right here. Like if you were to look at the perspective through the azimuthal grid, right? So as the seasonal changes are happening, this is what Dade Miller measured, right? This effect right here on a stationary topographical plane. So the sun is doing its thing over here. That's 23-degree axial tilt, which intersects with the cosmic background. So the entire universe is in alignment with the sun's ecliptic over the STP, which is which is basically what's causing the motion, right? The universe is rotating around us. There's the translation of motion down to us, which is what Dayton Miller is detecting. And what he found was that at altitude, you get a more consistent detection. So you know how there's a quote-unquote Coriolis effect on the globe with massive tropical storms, right? So these tropical storms would receive this translation of motion and, past a certain distance, let's call it the equator, right? There would be a fall off point in that translation of motion, and then you would basically start to get a counter rotation. So on a planar disk, you would have the same exact Coriolis effects, right? So you would have that, and then what they do is they say that snipers account for the Coriolis effect, which they unequivocally don't. But there is this thing going on with with tropical storms that seems to be consistent with the globular nature. But this is, this is also the same effect of a ether wind going in the same direction, or an ether vortex, rather, with a drop off in the translation of motion, right? So, any
Yeah,
You
you
said
said
there's like so like basically the way you explained it to me once before was like as it gets further out, there's like there's an inverse effect that happens. Kind of explain that because there's like there's a higher altitude to the measurements or something like that. Say. That's why you get the reverse effect of some of these hurricanes.
So as you get further away from the center of the vortex, it's higher up, so less motion gets translated to the ground. So at a certain point, there's going to be like a fall off point, and like that's probably the equator, right? That's where there seems to be these weird effects that happen. So at that point where the ether vortex is still extending over the plane, it's just higher up essentially, and that's what's causing that drop off in the translation of motion. So that's what would produce a counterclockwise rotation in storms like that. So you would get that effect. You would have this like tangible thing that you could attribute to globular rotation or whatever, but it would also be the exact same with an ether vortex. Yeah, kind of exactly what Shane's showing right there in the chat. So as it gets further out, it's it's more it's higher over the plane.
And it's obvious they knew that this is what the effect was that they could observe and attribute to the glob, and say that it's the opposite rotation because it's the glob. So this is a very good deconstruction of the reverse engineering that we're showing. I mean, these are the fireworks we needed for 4th of July. I know it's a lot of information, but these are like massive explosions going off right now. If everyone really reviews this information and capitalizes on what Alan's presenting here. I mean, these are the fireworks right now that we need. It's huge. I mean, it really shows how the reverse engineering and they realized it. They weren't just mistaken. They were just using these things that were common observations and detections that then they could claim. It's so convenient that they could claim it's a ball with all these other things that they could say.
Yeah. So I think that's pretty much everything I wanted to share on that. There was some other stuff I could get into on the Sagnac effect. That's just super interesting little factoids or whatever you could call it. But I've been talking for a while, so if anyone has anything
Can I ask you a question real quick?
Yeah.
Could you talk about anything about the Southern Atlantic anomaly, or possibly about or you know what I'm talking about?
About the magnetic declination stuff.
Just cut out a little bit, Alan. Question.
A little bit. The Atlantic anomaly.
Southern Atlantic anomaly is what you're asking about?
I think so. Yeah. Thank you.
Oh yeah, I'm not familiar. What's the Atlantic anomaly?
I'm just. I've heard that it's like basically it's difficult to operate your radar in that area. Can't penetrate through it. Some
I've
kind of.
I've
Yeah.
never heard of it.
Was
Oh,
that
okay.
relevant or just a random question?
Well, I mean, it has to do with some of the movement of energies through. I thought it may have something to do with the ether.
No
And also,
GPS signal is what you're referring to, right? There's no GPS signal in certain areas.
no GPS signal, but I also kind of tend to believe it's kind of connected to like these oceanic gyres. And it's sort of like whirlpools in the ocean that just that are going all the time. I thought there might be a connection between that and
Probably is, of course, yeah.
Just throwing it out there.
Right. Are there any? I mean, I don't know if Kosho left. I saw he was in here before, but Kosho, he's all about the GPS and that whole thing with the, that this is refuting the speed of light is huge. So like the
Dude,
second
all
part
the
of
Globers left.
Yeah, they left, of course.
Every single one left.
Did they really?
Of course, yeah. Because this is big. This is a big nail in the coffin, and they have. I mean, you're going over the exact. I mean, Dayton Miller. I mean, man, that's huge.
Yeah,
I mean,
yeah,
no
it's
one else
pretty
can do it.
irrefutable, and it's obvious why the Thanks Bob psyop is perpetuated so heavily because it's literally they have ether technology. Like this is all ether based technology, ether measurements, measuring off of ether speed, measuring the speed of light relative to the ether. Like this is how science actually works on the back end before they mathematically role play in their coordinate system. So one of the interesting things about the Sagnac effect is that when you start looking into it, like if you go to Wikipedia, you'll read like, oh yeah, the Sagnac effect was totally predicted by special relativity as it's a non-inertial frame and all this stuff. But no, they actually tried to co-opt the results or whatever to make it fit to everything because they need the sidereal rotation really bad because every time they tried to measure the velocity of the Earth, it was an actual result that like didn't go their way, right? So what they did was using this guy Levine, Landau, Lipschitz. These guys came up with a metric tensor for Einstein's field equations. It's the Levine, Landau, Lipschitz metric, and they use this metric to account for the angular momentum and stuff like that, right? The conservation laws. And this metric that they came up with, they use to explain the Sagnac effect in terms of general relativity. So the rotation of the device, there's like a little length contraction here and there, a little length contraction from special relativity. They kind of mix the two, even though they should be the same. But they don't care. Like they really needed this effect. So when you start looking into it, you'll see like there's like 12 different explanations you can find for it, up to and including up to and including invoking a reference frame of an observer at the North Pole who sees that the lights don't cause an interference pattern because of the invariant speed of light, but you, the observer next to the device, which is seeing the fringe pattern, thus a varying speed of light, is just seeing an optical effect due to relative simultaneity. Because of course, in your reference frame, you couldn't see the light returning at the same time as a hypothetical observer at the North Pole, a place that you can't go to verify that reference frame anyway. But that's the kind of jibber jabber that they'll get into to try and co-opt this effect. And your boy Wang came in and just like a wrecking ball and just linearized the Sagnac effect, showed all that, showed that the GPS stuff like literally explicitly works off of accounting for a preferred direction speed of light in an absolute reference frame. The original Michelson-Gale experiment was derived from classical wave mechanic equations in Galilean transformations, which is in reference to absolute reference frames and relative motion. So, like GG, we'll take all that. All the laser interferometry and GPS now belongs to us. So yeah. Thanks Wang.
Thanks Miller, man. The guy was the actual G, a legend.
Thanks Miller. Yeah, thanks Miller, an actual G. And thanks, Stephen Gift. That guy gets it. Been reading a lot of
Yeah,
his
this
work
really
lately.
needs to be capitalized on. Everyone needs to do like deep dives into these guys and like just use it all the time because that's all they have. And it's just like such a big, huge nail in the coffin. He only had one baller in the chat that was brave enough to even say something. He said, "Hey, they assumed relativity was false before coming to their conclusion. Circular reasoning at its finest." I don't know if that what that responds to. Something Shane posted. Okay, with your posting of the some of the Dayton Miller stuff, but. What does that even mean? I don't even get his comment. Like, why would that?
Yeah, who knows? I mean, the fact that it shows a friendship pattern at all is like directly showing that there's a varying speed of light. So, like, GG, it's been real.
Yeah. So the basics of the whole presentation you could break down. The ether wind was detected and used for the GPS. It was faster. Or it was the speed of light was repeated in what way? Can you kind of wrap that up in a little bit of ether wind and speed of light? Let's get that. How it reduces the speed of light in the measurements, maybe. Yeah.
What's that? I'll be right back. I'm gonna get some water.
Okay, go ahead. Anybody else have comments that are familiar with anything these guys talked about? It's hard. There's a lot of information out there.
Yeah,
But it
I
was
think
one
it
of
was
the
awesome.
complete things I ever heard anybody say about some stuff. That was amazing. I really appreciate that he put the work in for that.
Can I find
yeah.
Or it's probably a lot of people that are helping. I don't know too. It's just like that was great.
Dude, everyone
Thanks.
think of Alan's presentation the next time someone says thanks, Bob.
Yeah, that was some nerdy shit right there. I want to do the Norm Macdonald thing where he's like, I knew that. But yeah, I want him to post the you might have a shade, the one with Miller. You know the screenshot where it's just Miller and it's got writing on it because I want to yoink that. So it had the he had the thing where it said that you got a different reading at a different altitude when they went lower. So, and that's what Bob showed, didn't it? That's what he showed in his. I mentioned that to somebody, by the way, and they were like, "No, that didn't happen. That didn't happen." And I'm like, "I saw it in the video. They showed that in the video." No, that didn't happen.
I took some screenshots. I'll post along the way if any of these help with what you're asking.
One with Miller on it. The one with Miller on it.
To see if any of those have it. I have another one that was kind of a infograph that Alan sent me that I'll repost with some close-ups. Maybe that has it.
Those are the only two I posted.
When Alan gets back, you could ask him for that. I mean, there's PDFs to download, so link put the info links in the chat for everybody up here.
All right, I'm back. Let's see. So you said you wanted the screenshot of Miller and the words. I got you.
Yes,
brother.
please. That'd be awesome. That was a very good presentation, by the way.
Thank you,
Thanks
man.
for that.
Yep, no problem. Yeah, and then anytime someone starts talking about interferon, I mean, like it's over. Like really, like there's nothing. I think I'm sure there's going to be quote unquote refutations to it or whatever, but like it's pretty obvious that we have all the all the evidence and actual science and measurements proves in ether wind and absolute reference frame, all these things, and they've just obscured them and lied about it.
Yeah, so since there's no ballers here, we talked a little bit about this before. Like, what's their expected comeback or somehow like excuse for all of this not being the case? What would be their best baller response?
So for GPS, like that one guy, how he said, why would they make the corrections if they didn't have to? So like that, the refutation would be, why would they make this coordinate system that they have to transfer everything to if it wasn't necessary? But that's really just like a personal belief to choose that you live on that coordinate system, right?
Yeah, it's like we of course we live on a spinning ball, so that's why they make the corrections, not to cover up the fact that you don't.
And no disrespect to that guy, like that's valid question or whatever, because that's what you'd like. Why would they do that? But it's just that they could do it to any coordinate system, and you would never know because you can't see the Earth from that perspective to verify that. Like, oh yeah, you're traveling over a giant curved rock. It would just the coordinate system would be derived in such a way that it would you would be driving over a plane and you would never know that you're actually not on a curved ball, even though you think you're referencing a curved ball coordinate system.
Yeah, that's like what when we started with. Geo was outlining what he knows about the sidereal rotation, and that those have to be taken into account, and they're using that as a way of reverse engineering it, saying it's the spinning of the Earth, but it's obvious the way that you outlined it that it can't be that, because that is, again, the position of A and B would be moving along with each other, and there wouldn't be a difference. But since there is a difference, that means position A is stationary by mere fact.
Yeah, it's like you're truly at rest, right? Not just like hypothetically, oh, you're in motion, but you're also at rest. Kind of like not like you're actually chilling. You're in a state of chill or whatever the kids say these days, right?
The only way it would work, the way that the measurements are taken. So the correction on the back end is necessary for the ball. It's not because it's necessary because we already know we're on a ball. It's necessary so that they can then patch job it and make it seem like a correction because of something we already do. But it still doesn't work because position A didn't move with position B, which would have to be the case if we were moving.
Yep.
Yeah, a lot of ballers are listening right now, and they're not coming in for a very good reason.
I mean, don't be scared, bro. Like it's flat or whatever they say. It's stationary.
Don't make it weird. Don't make it weird.
It is what it is. It's a lot to take in, but when you realize the history of it and what's been obscured and what high level academics are arguing over about the Sagnac effect and how it's like, completely just it's a paradox for them. But the surface level layman narrative on Wikipedia is that it's all good, it's predicted by relativity, et cetera, et cetera. And it's not that at all. It's a complete contradiction and refutation to it. And actually, before when was it? What was it when Sagnac released all that stuff? He had actually won like a Nobel Prize in France, like not a Nobel Prize, but whatever they call it. Like he won a prize over there for discovering an ether and stuff like that. But they attribute it nowadays. They talk about it like that this was an anti-relativistic crowd. Like they paint it like they were terrorists, celebrating something weird or something. It's like they try and paint it in this light that it was like an anti-Einstein, anti-the truth movement, in not the fact that your boy literally measured the ether, or in the ether wind and all that.
Yeah, the preferred direction of light is the big takeaway too. Like the fact that there is, and what was it? What the measurement of it, and how like the fact that there's
west to east.
West to east, yeah. And you said something 0.5. Like give the figures again, and how that again refutes the speed of light. Just wrap it up with that again, if you can.
Let's see. So what they're accounting for with the transmission time and the signal time, so the signal received and the signal sent time duration, they're just taking that time elapsed and they're subtracting it from the speed of light, essentially.
Okay,
and then from that time, right, they can extrapolate the distance in their coordinate system that involves an absolute reference frame.
So the fact that they subtract it is canceling it out, so that they can just ignore it. Is that what you're saying?
No, they're accounting for how much faster it was received, and that affects the distance because that's how they derive it, right? It's not an actual distance measurement; it's measuring the time it takes for the transmission to be sent and received. The time interval to be.
Cut out a little bit. Can you say it one more time?
Oh, one sec. It's still lagging. I can see it. How's it now?
Good.
Okay, so it's a time interval system, right? So it's subtracting the time of the, assumes fixed speed of light, and it's subtracting the time of when the transmission was sent and when the transmission was received. And from that, they extrapolate a distance in their ECI coordinate system, which gives the actual distance to where the person's at, relative to the GPS receiver. So it's accounting for a faster reception or a slower reception automatically in the equation by subtracting the time of reception in or signal sent and reception received from the speed of light. Make sense?
Right. And the ether wind speed compared to the speed of light again?
So the fluctuation difference thing, that gets back into the latitude longitude system. So how they say it's the what is it from the equation? Second.
Yeah, it's really easy to see, like, because of this rotation of this ether wind west to east, it's really easy to see how some of these people that are totally convinced that it's a ball or just assume it's a ball spinning, how some of these measurements and effects that they've reverse engineered to seem like a spinning ball make them stay convinced because of these measurements that are, objective. But the interpretation, again, is what keeps them convinced, but they don't realize that it's a reverse engineering again, just like everything. The explanation is not.
So that right there is how you could get the speed fluctuation to the speed of light relative to your latitude. It's one of the ways that they can do it. And it's basically just accounting for the same kind of effect. You know how they say the Earth's rotating at 1,000 kilometers or 1,000 kilometers a second, 1,000 miles a second at the equator, and then at like the 45th, it'll be like 750 or whatever it is, kind of thing, or 500. And then at the North Pole, you would experience none. So like that kind of it's that kind of equation that you can derive the exact amount that way. But the way that GPS does it is it just incorporates it through extrapolating it from the time of the signal sent and received. So it doesn't even have to it doesn't need like a specific that or anything like that to put into it.
Anybody else have some questions on this? Anybody else? It took me a lot of questions to try to get somewhat familiar with what he's talking about. Such a globe killer. Again, the fireworks for the 4th of July are right here on Earth Awakenings today. Good job.
America or whatever.
Fuck yeah.
America. Fuck yeah. Yeah, it's great.
Right.
Are there any ballers even commenting in the comments? Like,
Negative Ghost Rider.
it's a death blow. Huge. Gio, are you still here? Did you get all that? I'd love to hear Gio's reaction at all at some point.
Yeah, I'm here. That was awesome, bro.
Pretty epic, huh?
Yeah, that was sweet. Good work.
A lot of this stuff you were familiar with, right? And then it seemed like at first, and now the complement to what you were talking about is perfect, right?
Yeah, I'm glad you shared your screen and did a whole presentation because, yeah, I'm gonna go back and listen to it again. Actually, I was listening, but I was also multitasking, and I realized I was like, all right, while I'm multitasking, I knew that I was gonna have to go back. I wanted to go back and go over it. So thanks, man, for doing that. It was awesome.
Yeah, no problem. So, Alex, the translation of motion is relative to the ether vortex, right? So the further away you get from the ether vortex, it's still going to be higher up over the plane. So there's going to be a less translation of that motion. So there's eventually going to be a drop off point where it's going to start providing that counter rotation aspect of it, i.e., at the equator seems to be where that drop off point is, and that's what's causing that, right? So these big tropical storms that are high in altitude are affected by this translation of motion, and that's what's giving them their jump start and their clockwise and counterclockwise respective rotations in the northern and southern, hemiplanes, respectively.
Yeah, because that can be a vortice, a vortex pattern.
Yep.
That's like centered. It seems like if it's centered on the North Pole, or on the equator in some way, to where it kind of like if that's a midpoint of the magnetic field, and then you either get the either clockwise or counterclockwise in the north and south, which is interesting because we see the stars doing that as well.
Yeah.
Man, what a bad day for the globe. I mean, you were really putting it to M. Scott Veach earlier there, and he disappeared on you, Gio. He just like dipped out right when you were like pinpointing, like, okay, so let's get to the bottom line here. This measurement with the planks, and what was it? You were going over the black swan a little bit.
We were going over a bunch of stuff. Yeah, he did disappear at kind of a timing because he was about to respond. Like he asked me a whole thing, and then I laid a whole thing out, and then he just he left right after that. But because I thought he was going to actually respond to it.
Then Alan comes in with this, and they all just disappear. Really suspect. I mean, if they really believed it and they thought there was like irrefutable proof that they're right, they would be sticking around and defending the globe right now, but they're not. Everybody pay attention.
I shared a zip file that has all the sources for everything I was just talking about. So some of these papers are kind of hard to find and put together, but the whole collection is right there available for everyone. And Shane, if you could put that on the Telegram too, or whatever, the unextracted version.
Hey, post your channel with your first part. I mean, you guys did all your interferometry are belong to us presentation.
Oh, yeah.
Put that in there too, just so that it does get to the first part of it at least. And then people can go to your channel because I'm sure you're going to do like the presentation. This is kind of a dry run, I think. And maybe
this was.
So look out for Alan's channel. Have like this whole presentation done properly. Coming up, I imagine.
Nice. I don't know if Kosho's here, but Kosho it does talk a lot about GPS. I'd be curious.
Yeah, that's what I was saying. He dipped out. He just disappeared. He was here, and then he just left. You think GPS, like the GPS with the ether wind and all that, and he would have been like all over it, but he just disappeared. Where are you, Kosho? Oh, he's in the shower, I'm sure.
Well, he's in the VC, but yeah.
Oh, okay. Come in here, Kosho. Come on. I want to hear Kosho's GPS defense. That's what I was hoping for.
So with the GPS, like essentially, do you see it in a way like that essentially it's like creating, like it's not actually measuring distances, it's actually measuring through the time dilation and the theoretical application that they've added to it.
It is definitely.
Sorry, this alarm thing's going off. I need to go across the room to grab it because it's clinging in the background. But I'll just be right back. Just give me 1 second.
Yep.
Yeah, it's definitely not measuring distances, anything relation proportionate to reality. That was like my big epiphany. The first time I heard like Alan give it the presentation, I was like, wait, hold up. So you tell me the way they compute distances is they input two different Cartesian coordinate parameters. If you want to get a distance between point A and point B, you input just the parameters as like coordinates, lat long, right? And then it computes the distance between those two on a theoretical sphere, giving you the pre-geodesic distance between those two.
Right. It almost made me think of like taking like a sphere, like a local sphere, and just placing it over the actual Earth, in a sense, and then using the like not necessarily the distances actually not actually the real distances measured, but the distances calculated through that whole system.
Exactly, and that's what Google Distance and Google Maps and all that stuff does.
And then using like the relativistic theoretical equations to kind of skew it within their model.
Yeah, that seems to be what's happening. If they're even doing it that way at all, because we don't even have like full access to the back end corrections or whatever. This is just what works on the surface level that we can see with the relevant coordinate system being the ECI.
Well, then do you think they could new perspective here?
I'm sorry.
Do you think that they could even to the extreme, like with this? Do you think, for example, like how they claim that they've done this is what Kosho will get all into. They claim they've done it over Pontchartrain, and they claim that they've taken the GPS coordinates and it shows a curve.
What does that even mean?
I know that's what they claim.
That is what? It doesn't even mean anything, bro. That GPS can't measure a curve. It's a time interval system.
They're claiming that the points plot a curve, is what they're claiming.
How does that?
You mean like so when you get like spherical excess, when they take the map of those 4 cities spread over the Earth, and they get the distance between those cities using Google Earth and this geodesic coordinate transformation computation that we're talking about, that's the only way you get the spherical excess between those 4 cities.
Are you saying they do like a reciprocal Zinni with GPS? Is that what they're doing, Shane?
Well, it's calling them now reciprocal Zinnis.
There's this meme that shows the 4 cities. Some glober or anti-flat earther made it, and it like puts the distances on a flat plane, and it goes, "Oh, it doesn't work because we're using the Google prefab geodesic computation distances."
Oh yeah,
that's the only way you get those that imagined excess. Sorry, go ahead.
Yeah, so if you did the measurements, using the ECI and the range measurement equation, and then you compared that against what Google says or whatever, then you could compare and contrast like the reality of the situation, right? Get accurate down to the millimeter.
Yeah, I mean, it is that like what they claim with Pontchartrain is not technically spherical excess, but it is the exact same concept Shane just laid out. Yeah, it is that basic, that same like that's why I brought it up, because like, do you think they would be able to actually have that data showing a curve to those guys that have that GPS data, even though it's not actually curving? It's just that the data in the system basically
it's just a coordinate system transformation. Once they leave the ECI coordinate system and they have their actual distance, they can make all the corrections necessary to be on a globe, right? To conform that to the globular coordinate system. That's what that whole thing is like. That's what Shane basically laid out with it, but with how it works, because it doesn't measure actual distances. So after they transform it, they can just make it fit whatever and tell you that it came from a GPS at 50,000 kilometers and like all that stuff. And we had to correct it by these time intervals because the atomic clock was, it got sweaty up there. The thermosphere got a little hot, but they could just make stuff up and have whatever corrections are necessary for you to, to give that illusion that there's a reciprocal GPS angle. And you would never know. Right? But like the big gravy is that there's a preferred direction, which invalidates their lens of interpretation anyway, right? So like the fact that they're accounting for time dilation effects and things of that nature are just like, it's like once you realize the preferred direction stuff and how it already works out without accounting for any relativistic effects, it's like, what are you guys doing up there? You guys playing Dungeons and Dragons through GPS corrections?
What do you guys think about July 8th? Like 70% of the world is immersed in daylight for a period of time, and it's like 99% of the people of Earth every July 8th.
Is that dude talking about the impossible day on the globe?
Yes.
Did you know how your model's super successful? when you have an impossible day,
when you have multiple paradoxic impossible things to explain.
when you have an impossible eclipse, an impossible day, an impossible GPS correction that shows a preferred direction speed of light relative to an absolute reference frame, like all these interesting things, you know.
I would argue that this is the best argument for flat earthers today, like the July 8th, you know.
Well, the Globers just say the rest of it's twilight, and we did a whole. Dude, it took us 3 hours to even argue it. It wasn't worth it. It's amazing how much they can deflect, dive, duck, and dodge away. The 4Ds of globularity.
Well, it's been said that if you like flash a light bulb on a model globe, it only covers 50% of the Earth. It can't go past 50%. If it goes past 50%, then it's a fucking flat Earth, you know.
Well, they say that it like so. Yeah, dude, I'm gonna guess you, but it wraps around a little bit, and they say that's twilight, and then it always does that. 60% 70% is like if you include twilight in the other one. But it's nonsense. Doesn't make any sense. How can light from one side of a ball wrap around the whole like? And they yell at us for coffee cup caustic. Jesus.
Because the light scatters in the atmosphere.
Got me, dude. I'm going back to the globe. That was beautiful. I never thought about it like that.
They love calling us crazy when it's just so obvious, you know.
Dude just hooked me up with some knowledge. I hadn't even considered that. Thank you so much for your intellectual contribution.
So, Alan, I mean, do you think that if one were to go out with GPS and take very, very rigorous actual physical world measurements, that we would find the discrepancies?
I would assume that you could do it. You could do that if you kept it in the original, reference frame and all that.
Here's some more.
Well, my question would be too, like, how patchwork is their system? You know, like, for example, are there certain areas that would actually match planar measurements? Like, I think about like in cities, you know, where it's like the property lines are very, very tight. It's like, obviously, I haven't personally been able to go out there and measure every GPS signal with every physical piece of Earth, and virtually no one has. That's the thing. So, I mean, whatever they're doing in terms of like, the transition after World War II and the whole scenario of when GPS has been rolled out, who has questioned it enough to go out and do this? But it does work. Obviously, we know like within certain areas, and when you're building like a parking lot and all that, it will be accurate, in those small scales. But then the question is, these discrepancies would be on the big scales. But then it makes me think, how patchwork is it? Like, are there different? Like, we don't know, like you said, what they're doing with the Dungeons and Dragons video game, whatever they're doing up there. We don't like know how patchwork it really is, and whether there could be areas that are actually planar versus areas that have more sphericity incorporated in, and how they've actually patchworked it.
Well, it's interesting that you mentioned that. So you know how they say that we live on an oblate. The part of the fits of that model, there's obviously sphericity to the model, and there's obviously flatness to it, right? So after they've established their coordinate system, anywhere that needs to be, flat or curved respectively, to give that, to compensate for the, appearance of the distance of going over curvature, they could do that. And then when you get into a city or whatever, then you would just apply the factor and all that stuff looks like from the supplementary ephemeris corrections that they use to derive the heliocentric model.
Here's another piece of evidence by word of mouth. Sorry to interrupt. I just have to say this if it's okay. Okay, why is it that if you have a fairly good camera, you can zoom in on the moon as if you're standing on it by perception standards? If it's so far away, then why can you zoom in on it? It's so close. You know what I mean?
Yeah.
Like, I've seen video of this. Someone zoomed in on the moon and it was as if they were standing on the moon. They got so close with the perception of the camera. If the moon is like millions of miles away, like they say, then why is it so close?
Not millions of miles away, but
all right. So the screenshot I just posted is from a book titled "The Explanatory or the Supplementary Explanatory Ephemeris to the Nautical Ephemeris, American Ephemeris, and the Nautical Almanac. Basically, what this book is it's a book about all the correction angles that they have in traverse tables and for sailing and stuff like that. So when you're using a Mercator map and you're using plane or right angle triangles and you're quote unquote plane sailing, you're actually quote unquote sailing on a globe or whatever. The correction angles and everything that are derived come from this book, and it talks about the coordinate systems that they used and what they were derived from. So what you'll see here in the equation for the to correct for the oblate spheroid model, they have an ellipticity factor which they use for, that's when they need to attribute curvature to make an elevation angle correction to make it fit on what it would have to be on a globe. And they have a flattening factor, and they use that for when they want to use a planar surface or whatever for the corrections. So with this with this equation, when you apply it to their observations that they make, you can when you plot that to the initial coordinate system, which is the geocentric what do they call it? Geocentric rectangular coordinate system, something like that. So anyway, once they have that, they can either keep the flatness, apply a certain amount of flatness, or they can make a curvature and fit it to a spherical lat long system, and they derive their correction angles like based off of that, right? So GPS could work similarly, right? So when you're traveling between cities and you're on like a long stretch of highway or whatever, it could be like, look at all this reciprocal zini earth curvature that you traveled between these distances, and then when you get into the city, it switches coordinate systems to a quote unquote flattening factor, right? And then you're in a more planar situation where it's more accurate. Does that make sense?
Yeah, exactly. That's what I was bringing up as well and inquiring about. Yeah, because I've always thought this. I mean, like I said, I can't. It's not that I've gone out and validated everything. No one has really. I mean, ultimately, because you think about in a city, like let's say Los Angeles or something, huge city. I mean, there's so much private land. Who's even measuring accurate distances? Physically at that point,
Right.
to really validate. There's so much private land. You can't just walk through people's backyards. So it does get complicated. And maybe they know this. And at the same time, there is a certain level of accuracy. Of course, the 8 inches per mile square would be pretty minimum as well in a city, just in and of itself. I mean, even for sewer systems and parking lots and things, but I would still think it would make a difference. So
absolutely.
So could it actually fluctuate? Like I was kind of picturing, like almost in my mind, like a false sphere that is kind of overlaying the land in terms of the coordinate system they're giving. Of course, the Earth not being that, like you could only do that, it seems like in a patchwork kind of way.
Yeah, I mean, using that system that I showed in the screenshot there, that's how they that geocentric coordinate system and planar observations. They use that to derive a sphere and a celestial sphere model where this is the person at the center of the sphere and all that. It's literally just transformation equations. Like I think when they realized that they could just transform to a new reference frame, like these people went nuts, bro. They were like, oh no way, we can just do whatever.
Yeah, exactly. They could just invert it. It must have been what really gave them the thrust to even do this. Like they must have figured this out, and then, or in whatever way it came to them, and then, or whether maybe they even hijacked it from others in the ancient past as well that knew about these things, the coordinate systems, and because I don't know how inventive these guys are. They're very crafty at pulling it off, but whether they even came up with this or not is a whole nother question. But yeah, once they figured out they could do that, they were like, let's go full speed. And then after World War I, they had enough control to roll out the Einstein stuff. Because once they had the financial control over the Federal Reserve, then they could roll it all out after World War I, everything that happened then, bring in Einstein. And yeah, like individuals like Dayton Miller that were doing that work. But it seems like, unfortunately, that they were able to just financially, suppress a lot of that and push their narrative, even to the point of World War II, which was crazy. And then right out of World War II, the full narrative being pushed to us with NASA and Disney and right into the 60s and this whole thing that we're in. And meanwhile, hardly anyone even knows who Dayton Miller is. A lot of different actual histories that were occurring.
Did you all know that our American flag is a wartime flag, and it's been like that for I think over a century?
Dude, I wonder what was like in the room when they figured out, like, hey, if we lie about it this way, if we just figured it's a coordinate transfer and we can get them to believe it's a globe. Hey, well, if we coordinate the stars into this, let's see, this azimuthal gray Cartesian coordinate system, we can pretend that all the points are just, if we convert it to a cylindrical system, all the sky points can be infinitely far away. But wait, we'll just make the stars infinitely far away, and then we'll tell them that that's what's happening. It's beautiful. I think that'd be a good skit.
Yeah, I mean, that's basically what they did with general relativity, right? When they
They did it with
realized that they
everything.
didn't, yeah, when they
With so
realized
many
that they
things.
didn't have a mechanism to facilitate the energy transfer for anything that they claim, like redshift and all that stuff, they just started lying about the experiments with Eddington. So if you go to Stellarium right now, you go to May 29, 1919, you'll see that there are no stars near the sun, and the only stars that were displaced, that were actually quote unquote said to be displaced, were in the solar limb, i.e., right next to the sun. So GG, what stars did this guy even see? And then when you get on top of that, right? So he took 16 photographs, and his boy Cromlin took 16 photographs. All of Arthur Eddington's photographs are all but 2 of them were said to be, not usable, and then only 2 survived, which they used to extrapolate these this star displacement around the solar limb. And then to this day, those 2 photograph plates are destroyed, lost to history, gone forever. And the guy that took 16 measurements at a different location, Cromlin, all his photographic plates survived, but they're not usable because due to quote unquote temperature differentials, they produced a displacement in accordance with Newtonian's predictions of how many arc seconds the starlight would be displaced. But again, what stars, dog? Like there's none even at the solar limb. Well, you can look on Stellarium right now. Like it's all a lie.
I predict that we're actually not having a global warming effect on the Earth, and we're not having a global cooling effect on the Earth. We're having something in between where the whole world will eventually become tropical, permanently, like the Bahamas or something.
HU, we can hear what you're saying, but I think maybe no one's responding just because it was a little bit off topic. So just letting you know.
It's like, who are you talking to, man?
Yeah, I have a presentation here on general relativity and the history of it and what they started lying about. Where it got crazy, right? And they really went ham with these Eddington observations because what they were looking for was what was it? Redshift observations to go in tandem with the starlight displacement, and they didn't get any redshift, so they couldn't establish like a cause and effect relationship with the space-time coordinate system bending due to gravitational effects and causing the displacement. If there was any displacement to begin with, so they just started lying about it, boys. So when people were like, Arthur Eddington saw gravitational lensing, and like therefore these James Webb Telescope pictures are all confirmation of gravitational lensing. Not a single person alive to this day has ever looked through a telescope with their 2 oculars or singular ocular if they had some sort of injury or birth defect and seen gravitational lensing. Never, not once. And it's been completely fabricated to give the illusion that this coordinate system bending and warping has facilitated these celestial phenomenon effects that we see.
You're speaking about flat Earth, and every topic I've said has related to flat Earth.
Okay.
So basically, sky tricks in order to propel the propaganda.
Yeah, I mean, they got people to accept the coordinate system with special relativity, right? Once everyone was like on board with the Copernican principle and they rooted out everyone that was possibly like, hey, maybe the interpretation of this experiment is a stationary Earth with respect to the ether motion. Once they rooted all those people out and got everyone on board with the contraction and everything, they were like, okay, now we need to own the sky, right? So they couldn't afford to have the system fail. And yeah, it's basically just a blank slate. Like the metrics that they use to account for the conservation laws, like earlier how I was talking about that Landau, Lifshitz, Fitzgerald, or whatever it's called metric. It's not even derived from the field equations, so it's actually it's the equivalent of a logic fallacy in mathematics. So you know how they say that Newton's equations are Einstein's equations are like a further expansion pack of Newton's gravity and all that stuff. And there's like a covariant relationship. I don't know if you've ever heard that kind of terminology, but that's the way they attribute it. So they look at it as like an expansion pack to mass attracting mass, the space-time curvature, and it's supposed to be that relationship is supposed to be accepted and facilitated by an invariant transformation of the coordinate systems where the laws of physics transfer over to the new space-time coordinate system, and they're able to account for angular momentum and things like that. And they weren't able to really do that, so they had to like basically inject an artificial way to do it within the system. So they started deriving ways to account for it from the other metric in the system. Well, actually, Einstein did this, right? This is the pseudotensor thing. So if you look into this problem, this is the Einstein's issue with Newtonian covariance, right? This invariant transformation of the laws of physics and how they use these metrics to quote unquote account for these effects and satisfy the laws of physics is just a mathematical role play. And people don't really talk about it because no one wants to be the guy that does that. And there's a guy named Stephen Crothers who went to the University of New South Wales. He was getting his PhD candidature in doing a mathematical analyzation of Einstein's field equations and all that. And he actually came across this problem, and other people have come across this problem too, but it's not really widely talked about. But he was basically his PhD candidature sponsor dropped him, so he wasn't able to receive his PhD for criticizing Einstein's work and proving that the math is just it gives the appearance of mathematics, but it's just fake. It's just it's just a blank slate basically for them to role play and then conform the coordinate system to observations, and then they'll just say that space-time is affected differently in this region due to XYZ effects, or like they'll add in some dark matter or whatever, so it's bending differently. Despite the fact that there's no mechanism for dark matter to act through a quote unquote gravitational field to cause acceleration in a system or hold it together, cause acceleration, deceleration, or anything like that. Like they just say these things, and then then it's backed up by the quote unquote mathematic coordinate system that isn't even covariant. With their previous laws and understanding of physics before they jumped onto this new system that's all relative, right? I feel like I was just in a freestyle battle. But yeah, the covariant relationship's a really interesting situation when you get into what are they called? Second.
It's a great night tonight to be free.
Free of concavity? You didn't expect that, did you?
Go to a dentist and get my concavities worked on.
Like, what if I came to like the concave Earth server and then every day told you how
There's
wrong
no
you were about
concave server,
everything?
bud.
Well,
The
exactly.
truth, the truth
Exactly.
isn't popular. You are living in the
Love it.
matrix. The truth isn't popular. I know
That's
it's
about popularity. I love that. It's just a choice, right? I love the concave attitude. You guys are great.
Oh
You
yeah.
think-
Okay. So sorry. Go ahead.
No, I was just going to talk about concavity some more. Go ahead, dude.
Oh yeah. Fuck that. So the first order invariant differentials, right? So this is like the logical fallacy in the math equations. So when they use these to satisfy the laws of physics, right? Because space-time curvature is infinite or whatever, right? Gravitational effects tend to infinity. They propagate forever, and all these things. So they don't adequately describe the laws of physics. So, but that with these metrics that they derive, they act like they've come up with these solutions to it. But what they're doing is they're just doing the same thing. So they're not deriving the metric from the actual field equations. They're deriving it from from a metric that Einstein already made with the field equations. So it's like it's not how it works. So when they do like dimensional analysis on the metrics, it like that's where things start to break down with the metrics, and it reveals the problems or whatever. But this is like stuff that they don't talk about or tell people about, because it breaks the role play, right? It breaks the immersion. And the one thing when you're role playing, guys, there's one rule when you go to a LARP session, boys: you do not break character. So if it has to be facilitated through that interpretation of Einstein always being correct. This is why all these experiments conform to relativity. They just work it out in the math, or they'll make corrections, or they'll account for some new Einsteinian effect and like just back engineer it in.
Like sets up the never-ending back engineering train. All aboard.
Yeah.
Just keep adding cars.
Yeah. Even if you look at the Heffel and Keating experiment, the original data that they posted before they corrected their westward flight, even had the most invariance. The most variance in their clocks, and that has to they attribute that to quote unquote Earth rotation. But now that we know the truth of the matter, that there's a ether wind, like it even shows up in there. Because in their paradigm, accounting for Earth rotation wouldn't even make sense because the plane is rotating with the Earth or whatever, right? So the fact that they do that kind of correction, it's just like whenever it's convenient for them, they'll account for the ether in like a globular way, through a globular interpretation of rotation.
Do you think the ether drift or the ether wind is a sphere or spherically shaped?
Vortexual?
Yeah, or like is the whole thing a spinning sphere to account for the reverse or for is what's allowed them to reverse engineer a sphere out of it?
So I think the translation of motion that we receive is spherical. I think that the ether itself, or the sky or whatever, rotates on a 23-degree axial tilt. And like how that translates to the shape of it, like I'm not exactly sure. The effects that seem to be measured correspond with like a uniform wind going in one direction. Facilitated by a vortex, right? Because you have to be axially aligned with the vortex to get the full measurement of the rotation for the Sagnac effect, or for for the ring laser gyros and all that.
Yeah, I said that to you, Shane, yonks ago on the Tartaria server, and I think you misunderstood what I said. I said it could be a globe around it, but a flat plane in the middle. But I didn't put it like that. I just put it like something like all the best lies have an element of truth about them as well. And you were like, "You're banned." I thought, I don't think you understood what I meant. But yeah, I like the idea of the the think tank kicking the ideas around the room, like you were just saying. Because I often do that with the new liberal fascists, the oxymoron. They must have had fun with that one too.
Bro, they even accounted. Sorry to cut you off.
No, yeah, it's all good, man.
They even accounted for Earth rotation in the Pound Rebka experiment, which is supposed to be a vertical transmission of photons, just straight up and down. So I guess they would be deriving that in the ECI, just saying that they're moving in that rotation. So, like, yeah, they're literally, dude, that's hilarious. They're actually just accounting for an ether wind and like they're like, maybe the Earth's rotating? I don't know. Crazy. It never made sense to me why they would do that. But they did try. They do mention it. And now it's starting to make sense.
Yeah, I've been saying for a while now. They just grabbed a J, scruffed his hair up. They're like, "Who can we get to just push this shit?" Just Einie, the patent guy. You know how many patents he stole for us? Just scruff his hair up, give him a script, push him out front. There he goes.
Mic check.
Kosho.
Hey,
But
just a quick question.
One sec. These people, they can build anybody up. They can build anybody up and knock them down, So, anyway.
They got a lot of power. More power to them.
Kosho, I hope you've been listening for the last 2 hours.
Not really.
Well, you better go back. Go back and review, because Alan did a whole presentation, broke down many components of GPS, and I know that you talk a lot about GPS. So I don't always just recommend like necessarily. Well, I mean, of course, if anyone wants to go back, but I'm saying in specific, this is one time to go back. He did a whole presentation, screen share, and he went through a lot of components of GPS. And I know that you talk about GPS and have your thoughts on it. So there's plenty for you to consider.
I talked to him about it sometime. I'm about to take a shower. But real quick about the Pound Repka. Wasn't that a tower experiment?
Yeah.
Really? Wow. I don't think they were worried about the rotation of the Earth in that one.
They explicitly mentioned that they added that to the calculations, which I always thought was weird. I can see why you think it's weird too. Makes no sense, right? but nonetheless, they calculate, right? BRB. Yep. Oh, okay. Gotcha. I'm on. Okay. Yeah, I gotta go AFK.
Yeah.
For a little bit, but I'll be back in a little bit.
I want to rewatch it too. I listened to it once. I need to listen to it again because as smart as I am, it fucking did not all absorb.
Well, give me the bullet notes, the cliff
Nah,
notes.
I wouldn't want to deprive you of absorption.
I'm not gonna listen. I'll be honest. I'm not gonna know if I can listen to it.
Yeah, because you're a coward.
No, I mean.
All right, maybe you're not.
I'm in here,
but I just like to say that.
I'm just saying, I'm in here, so it's like I have to be in here, and I gotta take time out of being in here to listen.
I know, but you should. If there's anything that like I don't often think like I'm gonna re-listen to that because that information was so good that I need to listen to it again.
Well, here's the same presentation in like an hour that he did a couple days ago, sort of self-encapsulated, and then here's all the references for the PDFs and stuff.
Yeah, that's cool. Then,
Yeah, more digestible instead of streaming through a 12-hour live stream to find it, I guess. Now maybe Kosher will watch it.
I'll watch that 2-hour thing. I'll watch it double speed.
It had like this serious like game over vibe.
Though this one's only an hour. I watched it at like 1.25 to balance out.
Well, what's the gist of it, though? I mean, I like GPS too, man. That's GPS is cool.
Yeah, it's like flat or whatever. Like not
That's
a ball.
what I'm saying, dude. Yeah, I mean, watch one of those, the changes posted, or the last 2 hours here. You'll see if you go back on this stream, right when he first starts sharing his screen is when it starts. So it'd be pretty easy to skim through and just grab that timestamp or just to start there. But I mean, dude, since you talk quite a bit about GPS and you claim a fair amount of expertise in the topic. So there's plenty of
Hold on,
things.
hold on. Listen, because I'm going to be in the shower, but I just want to know very quickly, though. Is there some claim that the GPS will give you some flat, that it's giving you flat coordinates? Is that what the claim is?
So remember that thing what did I send you about like the calculus that JPL does and like the whole thing with that just to like organize the GPS signals or whatever, just to bullshit it. Like,
I remember that
what
thing,
was
yeah.
that? I hardly remember what that was, but I know you
Can't
really
remember
didn't
what
have
it's
anything to
called.
say back. What is
Yeah,
it
I
called?
remember. I bookmarked it. I can't remember what it was called. I gotta take a shower right now.
I feel like I whipped you in the ass with a towel that day. But yeah, send me
I
a
mean,
link.
that was cool. I mean, that was a cool. I didn't know about that. And it's a resource. Actually, you can. Cause that's what I signed up for it. Because you can actually sign up for.
Yeah. You're part of the GPS crowd. I got you. But yeah, just if you can send me that link, I'd appreciate it if you find it. Thanks.
I'll find it. Yeah, I'm gonna take a shower, then I'll find it and
Have
I'll
fun.
send it to you.
All right, front to back.
Coach is one of the only people that discourse while he showers that I'm aware of.
I think I talked to him one morning when he was taking a shower with his girlfriend, and that felt normal. I would do that.
He'll be in the shower, like debating people. Serious dedication.
Yeah, it's admirable. That was great. I found this thing. I guess I was chatting to somebody about just like these telescope observations with this extreme chromatic aberration on them. And like I know because like I build lenses myself, like, and I find that there are incorrect combinations a lot of times. I'll build them from like spare parts, and sometimes I get a lot of birefringence, or not birefringence. I'm sorry. Yeah, chromatic aberration. Where like the colors start going all wrong. But I don't find that every light source gives me like a polarized like red and blue shift, like super like that on that level. So I was just contemplating whether or not there might be like something that we're looking through that is causing like this greater effect than I can muster with any kind of glass that I have. And I've all different types of things that I might try to smash together. I mean, so I should be able to come up with like the worst lens, but I can't even do as bad as these telescopes are doing. So I figure that it's possible that it relates back to this Kerr effect, or something I discovered today, which is like a magneto optical effect created when you're looking through something that's got an electromagnetic charge. Because like cameras and stuff, sensors, the way they're built, they absorb those kinds of energies. And yeah. I don't know. A lot of information today. It's a hell of a force. Thank you, everybody. Times.
I was going to be a real jerk. That'd be like, Snacks, just do jokes. I just like you when you do jokes. Okay.
That's all I want. Yeah, that's all you want from me. You don't want my information. Be a funny guy. Make us laugh, clown.
Andy, always being a jerk.
Snacks, have you read?
Is it because I'm challenging your concave model, Andy? Is that why you're so pissed at me?
Have you read Norm Macdonald?
Sorry, have I read what?
Norm Macdonald, a memoir.
I would like to. I really like Norm Macdonald.
Oh, it's so good. It might be my favorite book, and I'm not even joking. It's just the right amount of silly and clever. I'll fetch you and read your chapter. Don't worry.
You ever see him talk to Larry King? And is he talking about flat Earth for a little bit in there? I'm talking to Larry
No,
King. You ever seen that shit?
no, I have seen it. Yeah.
Okay, yeah, check it out. If you
What I like about that as well is he explains to Larry that he figured out to be the dumb guy in the room. Right? That's fucking awesome. Because nobody wants. Everybody hates the smart guy, right?
Yeah.
And so he was just going to be the dumb guy, and yeah, I love that.
Yeah.
He's like everybody hates the smart guy. He does that with like talks about Letterman, where he's like, I finally figured out that the guest is the joke. The joke's on the guest, and once I figured that out, it was all plain sailing. That's what I was thinking of earlier because he does that interview with Dave Letterman's great, and Dave said something quite complicated to him. I think about his surgery. I forget now. Something about the human body. Can't remember. And Norm was like, "Of course I knew that." And just the way he says it was just, he's so nuanced with Norm. You can't even replicate his jokes. That's why he's so good.
Yeah, Turd Ferguson. It's a funny name.
Turd Ferguson. There's a brilliant interview with like Australian post. I can't remember the thing, but it's like Australian post. He's talking to an Australian for about half an hour. I don't know. I'm just going to say Australian post. I don't know. But he's talking about like trans people, and he's like how he admires them and all this. But then he sort of misgenders somebody by accident. He just goes, "Lady, lady," just when he does it. It's so fucking dumb. I'm gonna have to post that now for you, dude.
It's that whole shtick where he's like so funny and so dumb that people can't hate it, Oh, Norm's great.
Huff Post, that's what it is. Huff.
Oh, the Huffington.
Right, but Andy, you didn't see those interviews with Larry King where he's talking about some flat stuff, I think.
Maybe. I mean, he did talk about the I don't know how to put it. I don't want to say it. That thing that happened in Germany, that did happen. He talked about that quite a lot. I don't know.
We get it, Andy. We know what you're talking about. All 6 million of us know what you're talking about. Don't worry.
I don't want to get cancelled.
You personally, or like the server taken down? Because that gets servers taken down, Andy.
Yeah, exactly.
So what's going on, guys? I just got here.
Yo, what's up? I gotta say something. Like, I gotta connect with you because there was like an evil version of you here. I don't know if you caught any of that, but
Oh no.
It sounds like it's like evil Napalm's back.
Yeah, that was dude. I actually mentioned you in the chat, Napalm, because I was like I do like I'll be listening to a thing and I'll be reading, a thing, and so I'm doing that, and then all of a sudden I say to myself, why is Napalm fucking with Witsy?
Oh, is somebody fucking with Witsy that sounds like me?
Yeah.
Oh yeah,
Nice.
he does.
Who was it?
Yeah, I forget.
I don't know.
That's funny. I hope Witsy thought it was me too, because that would be hilarious.
And I think you came back. Like, were you here today?
I was here earlier in the day when I was cutting my grass and shit.
I don't know. I feel like he was here and then he left, but then you came back and you were just here for a second, and then he came back again, and I was like, my mind's all messed up from all of it. He sounds so much like you.
Was it the guy that to me it sounded like Glat Flobe? Is that the guy you're talking about?
Sounds a little bit like Glat too, actually. Yeah, for sure.
Okay, I thought he sounded more like Glat than me. Because there's a guy over at 24/7 that was talking one time, and I was like, my mic's not on, and I'm not speaking, but it sounds like I'm talking. What the fuck's going on? I think it was Yoke Smasher or something like that. Yeah, I know who you're talking about. He sounded a little bit like Glad to me, and he was like straight up coming in hot. I was about to unmute a few times and be like, hey, buddy, maybe you need to go back to 101 before you come in here, like guns a-blazing.
He didn't do too well anyway, so it was all good. We gotta
Yeah,
sleep, you guys. I'm gonna have to get out of here.
Oh, all right. Sorry. My wife was coming out, talking to me.
Starting to get the yawnies. But you guys take care. Talk to you again.
Yeah. Have a good night, Snacks.
Have an awesome 4th. All right. Peace. Later, Andy.
Hey, Snacks.
Hey, Andy.
Now, remember the good old days when tweeting meant stabbing a hooker? Sorry, that's one of my no jokes.
Thanks, Norm. All right, man.
See you, dude.
Yeah, peace.
I'm in a very silly mood. Sorry, everybody.
Yeah, it's all good, Andy. All good. How was your 4th of July? You celebrating over there or what?
No. Sorry. What's that?
You're not celebrating our fake independence with us?
Come on.
No, I'm not.
It's a day we all pretend like we're independent from something.
Although I did read quite a lot of a Masonic Bible today, sent to me by Smurf. And yeah, it was kind of interesting. I mean, I was just trying to get some sort of correlation between the founding fathers and the signers of the Bill of Rights and all.
Illuminati confirmed.
Well, I have kind of initiated myself in a weird kind of way. I've looked through that much of their bloody stuff. But whatever.
You might be an honorary 32nd degree Mason now.
Yeah.
So I
don't know. I go back and forth with it because sometimes I'm like to me, it's like, you know, I get it. There's hierarchies. I've had to accept this shit. Oh, it does my head in. But you see, when they get this information, they get the knowledge, they got the hidden and I want to peek behind the curtain. But then there's this other thing where I think it's like a child, right? Think of it from an egoic standpoint, right? It's like it's mine, it's all mine, and you can't have it. And that's how I think of it sometimes. We've got the secret knowledge. You can't have it. Do you know what I mean? It's a little bit childish, but then I get it. There's a hierarchy. They have to earn it, you see. You have to earn it. And I was like, okay, yeah. Because I've always had a little thing in me where I hated hierarchy, right? I always want to kick against it. But then I realized, no, there is a hierarchy to this thing, you know? I get it. I was going to tell a joke there, but it's a little bit racist, so I'm not going to do it. Oh, dear.
Well, I think there can be like healthy hierarchy, but also like toxic or corrupt hierarchy. Because like the idea of like a hierarchy in the tribe or in the family system where you have elders and so on, like where that are like actually maintaining wisdom and knowledge and helping carry it through and maintaining like the integrity of the knowledge and of the narratives and lineages of their peoples and all of that. But then you could have this like corrupt version, which I would say, you know, the kind of controllers, whatever this current system are utilizing that same concept of like, oh, hey, we're your authority, we're your elders. But instead of being like a positive type, you know, form of that, it's coming through in a completely corrupted way. But then I think sometimes that's how they get people linked in, because people know like there's something about trusting your elders, but somehow it's like this massively misplaced trust into this corrupt authority, but people kind of treat them like they're almost like you know, can do no wrong or something.
Yeah,
it's not like I was just going to say it's not like the elders or the hierarchical structure in like a Native American system or anything like that, where the elders actually have the best interests of their people and their family at heart. It's kind of the opposite of that, but a hierarchical structure that the masses kind of look to as an authority that they think is benevolent, but may have a little malevolence going on, to say the least.
Yeah, that's why I said I always go back and forth with it, because you know, you think about the Bill of Rights, it's a wonderful thing. You know, they put the power directly in the lap of individual, right? So the groups. That's that's amazing. But then and then I think to myself, well, hang on a minute, it's still one man telling another man what he can and can't do. I struggle with that one a little bit. But then we look at the moon landings and they seem to have the fingerprints all over that thing. And I'm like,
so I think
don't know.
honestly, like, yeah, you're right. Our Bill of Rights and actually the way that our founding documents were constructed, if you had some people that legitimately were well educated and had the best interest of, at that time, was probably a small people group of their family and friends, and they had their best interest at heart to create a country because they knew no different, right? Coming from one country, they felt they needed to establish a hierarchical structure, but wanted to make sure that it wasn't too hierarchical, that the people would be overlooked. I don't think you could get much better than our founding documents. The problem is we've been corrupted into disbelieving those documents and certainly not sticking up and ensuring that that's the only thing that the government should do, which is protect our rights, as opposed to what they currently do, which is violate them. But I think it was probably some really good moral people that did have the best interest of their constituents in mind when they constructed those documents, because I think it's a really good structure, to be honest. That's coming from an anarchist too, by the way.
Yeah. That's why I wrestle with it as well. I think just people knew a lot. I don't know. There seems to be a lot of ignorance and I don't know, apathy, and people don't look into these things. I mean, I don't know. I'm just thinking of like Black's Law Dictionary and all that stuff, and it's like, I don't know, it's a bit boring conversation, to be honest.
Yeah, but here's the kind of the rub, though, in a good way, in the founding documents. If you read the Declaration of Independence, says, "We hold these truths to be self-evident, that all men are created equal, endowed by their Creator with certain unalienable rights." So they knew that if they put it to a metaphysical level, meaning that we are all endowed by the Creator with certain rights that no man can take away, that's very, very powerful. But we do see a large push in trying to convince everybody that there's no such thing as a creator. Thus, there's a dissolution of any idea that you have rights that don't come from another man.
Yeah, because I was kind of, I remember I used to talk about that when I first came on these servers. I was talking about, just because I think I saw some letters from, I don't know, probably Jefferson or somebody like that, where they were saying they were worried about Rome. This is the idea that they were worried about Rome because they knew they were sending people over in droves, and I don't know, because there's another part of me that just says, look, everything you've ever seen, even the so-called declassified shit, that's been put in front of you in one way or another, and look at Washington, how it's designed. You know what I mean? It's like fucking Rome anyway.
Yep.
So, I don't know.
Correct me if I'm wrong, but wasn't Rome initially like a republic that just turned into an imperialist monster, similar to us?
Yeah, I sometimes do question whether Rome actually fell.
We're Rome
the Caesar just
4.0.
became the Pope.
True. And they just walled off the castle there.
Yeah. I mean, the Vatican, that's its own thing, isn't it? I think London is as well, but the Vatican's its own entity, its own police, its own.
Yep. Yeah, you have these city-states, right? So you have the Vatican, you have the city of London, and then you have Washington, D.C., which is segregated from the rest of the United States into a city-state.
That video of that dude, I don't know, it's about like 3 hours long. I ain't seen that for years. That goes back a long time, where he's going through all the sacred geometry in Washington. It's like, what the fuck? It like blows your mind.
Yeah, I mean, just follow the obelisks, right? They're everywhere. Can you hear the fireworks in the background, by the way? Hopefully that's not coming through.
You can hear him a little bit, but it's pretty faint.
Okay, good.
Yeah, it's like they've walled off their control zones.
Yeah, I feel like they do it intentionally, right? Because it's technically like a foreign country, really. Like DC is really kind of a foreign country to the United States because it's not really a part of it.
It's crazy to think that they could like wall off that whole city and like control the rest of the country from it if they had to, which is probably why they set it up that way.
Yeah. So Gio, what do you think is the next baby step in the controller's playbook? What do you think's coming down the pike? Speculation station.
Yeah.
Social credit.
What's that, Andy?
I'm just saying, like a social credit, a bit like I think they've already got it in China, where basically it hurts your credit score if you do say certain things, and yeah, I'm already prepared to keep quite a lot of my opinions under my breath. I won't be airing them in public like this. I'm just enjoying the last hurrah.
So yeah, you're saying some kind of social credit system of some sort that would have more control.
Yeah, it's like you want this. You want to hire this car? You want? Oh, you going on holiday? Oh, oops! You said this thing. I can't have this plane ticket. Sorry.
I mean, that would be insane if it got to that level. Yeah, like you said this on the internet, so now you can't fly or something, or you can't get your driver's license.
It's like that episode of Black Mirror, if you ever saw it, with Ron Howard's daughter, where she's trying to get to like her friend's wedding. She gets frustrated because like her car breaks down or whatever. She says a few cuss words in front of people, and they're like downvoting her. So like everybody around you can vote your behavior. And she got downvoted to where she couldn't even really fly to her friend's wedding. And then nobody wanted to talk to her because her score was so low, and their scores would be affected. Did anybody see that episode? Long time ago on Black Mirror.
Yeah, it's that. I actually, because I stopped watching TV. I can tell you the date I stopped watching TV. Actually, November 28, 2015. I can tell you the date because I stopped drinking as well. But I stopped everything basically. But anyway, so I didn't really see that till years later, until I came onto these servers, funnily enough, and I met Loggy and 24/7 Chill, and he were like, and we just started watching bits and bobs, and I thought, just like that presentation earlier, and just like, this is bloody amazing. This is like, this changes everything. Just watching with other people. I don't know, ridiculous as it sounds. I was just sat there going, "Oh, the age we live in," So I thought I'm going to watch that Black Mirror, and also I was a bit wary, because I'd heard it's the scrying mirrors and all this shit, and I was a bit, because you got to be
Well,
careful.
that's your cell phone to begin with, right?
Yeah.
Whether you're watching
So-
it or not, you got one.
So I was like, I'll give it a go, and it's really good. It's bloody brilliant, in fact. The first, because they've done it another one. I don't know if you've seen I think it's season 6 recently, and I just watched that one.
No. I only.
And
go ahead.
I was just going to say it's not as good as the older ones, but it's still watchable.
So I started watching Black Mirror. I only got like maybe 5 or 6 episodes in before. Like the only time I watch TV is we put TV on before we go to bed. So when my wife would fall asleep, I would change it over to Black Mirror and I would watch episodes. And she was like complaining. She's like, "Please don't watch that while I'm sleeping anymore because like I wake up, it's scary, like you're freaking me out." I'm like, "All right, fine, whatever." So I think I've only seen like maybe the first 6 or 7 episodes of probably season 1, something like that.
Well, the new one, the second one, that's like season 6, I think. Second episode is freaky as fuck. It's like set in Scotland, and like my dad's side of family are from Scotland, and I remember going as a child. We went all around Scotland. I think we did it a few times, but needless to say, it was freaking me out. And I was watching it with this girl, and she was like, she goes, "Andy, pause it." I paused it. I don't think I can watch the rest of this. I went, just get a pillar. Just get a pillar. It's fine. Just grab a pillar. And,
Freaks out the ladies, apparently. Yeah.
Yeah. But yeah, no, I don't want to spoil it. So
Yeah. No worries. I'm the kind of person where by the time I watch anything that people are spoiling, I probably forgot what the hell he said anyways. Takes me forever to watch things. Even though I actually went to the movies for the first time in years and years and years on Monday and saw the new Indiana Jones.
What, the one where he becomes a chick?
No.
Oh right.
No, the new Indiana Jones movie. And the funny thing about it is the relic that standard Indiana Jones, they're after some relic, right? And the relic that they're after is is something that we discuss within these forums often, which I found very interesting.
The anti-Cytherean mechanism thing. Is that the one you're talking about? The new one, right? Oh, okay.
Yeah, the Antikythera.
Yeah.
They call
It
it
becomes a-
Antikythera. They don't call it the Antikythera device or mechanism or any of that. They just call it the Antikythera.
He becomes a chick at the end.
No, he doesn't.
I'm pretty sure they hand the baton over. I thought that was the symbology of the whole thing. No, or maybe I don't know.
No, he does not become a chick in the end.
Dude, look around. That's the way of the world. The dudes are becoming chicks.
Oh, I know. I mean, trust me. The the main chick that's in it is, like everybody these days, questionable as to their gender to begin with. Very, like everything these days.
Yeah, it's funny, but I didn't even really notice the interracial couple thing until Crypto pointed it out to me and Loggy. They were like, "Have you noticed it's in everything? Every TV show, it's an interracial." And I'm not a, people just people to me. That's the way I see it. Yeah, once you see it, you can't unsee it. It's like, oh yeah, it's another interracial couple.
Yeah.
And it's just on and on with the woke shit. It's like, oh man, just give it a rest.
Right.
We know what you're doing, but if you know what they're doing, I don't know. It just doesn't affect
You don't have to. You don't have to check all the boxes all the time. Come on.
Yeah, it's fun to put your Deerstalker on and just be like, okay, let's see what bullshit they're doing now.
Yeah, this is why I
They
can't
push
watch
it.
it, and I don't
Yeah.
watch it. I was actually having this discussion with some neighbors earlier this evening. I have two neighbors that are very, they're pretty much truthers, right? And I don't push things too far with them, but I do to an extent. And they were talking about, like, we don't watch any fucking shows or anything like that. We're so sick of just nothing but nonstop, like, political agendas woven through all the plot lines and the characters and all this shit. And they're an interracial couple. Well, the one dude's like, he's half black, half white. She's white, whatever. They're interracial couple either way, but they're just like, we can't watch television just because of everything's a political agenda. I was like, that's true. Most people don't realize that. Most people just take it all in and don't even realize that they're being propagandized through the plot lines and the people and all that shit.
Yeah, I like that when you get black people that get it when they've just based and they just fucking understand it. It just, I don't know. It's like, think about this is why I appreciated knowing Benjamin. I haven't watched him for a while, but I appreciated the fact that he's like, what? I can't say a word. What the fuck are you talking about? What?
Right.
You take one word, and then what? Then where do we end up? And it's like, yeah, it's just
starts with one word, and then it's two, and then it's 20, and then before you know it.
Just think about what message it sends to black folks, though. They're literally saying, you don't have the emotional maturity to deal with somebody might say a word. Do you know what I mean?
Right.
It's so bad. And they've already got this sense of victimhood put on them. And this is what's funny is the majority of slaves in this realm have been white by a fucking huge amount. But we've not been sold that narrative.
Right. Everybody's had their turn at being oppressed. It's nothing new. There's nothing new under the sun.
Dude, having that victim mentality, that's about the worst thing you could do to a people's. It's a terrible thing.
Yep. It demoralizes them, right? So I think it was a podcast. Maybe it was a documentary. I can't remember. but somebody did a deep dive and a lot of interviews with people that were in college, right? So black people that were in college and talking about affirmative actions and things like that. And they really kind of psychoanalyzed people as to what their thoughts were and what they felt like. And kind of the overarching thing was a lot of people of color that had made it to university, probably solely based off of their own accord, still had in the back of their mind, did I get here solely based on my skin color and not because I was good enough to get here, which played a huge like psychological like it affected their psychology quite a bit. Always having that in the back of their mind, like did they actually earn the achievement, or were they only given, a scholarship or the ability to go to college solely based off of that? And yeah, it was a very interesting documentary because it was almost like even if somebody got there solely based on that reason or mainly based on that reason, is it even an advantage to them, or does it kind of mess them up psychologically and create somebody that isn't necessarily appreciative or feels accomplished and will not and almost doesn't ever feel accomplished because of kind of the way that they're treated, like they're not good enough to begin with, kind of thing. It was a very interesting can't remember if it was a podcast or a documentary, and I hadn't thought about that psychology or that psychological aspect of it, of thinking no matter what you did you get there because of your abilities, kind of thing, and what that can do to somebody.
I mean, I was watching something the other day where I'll tell you what I watched. Emily the Criminal, it was called, and this what's the name? I can't remember her bloody name. It'll come to me. But she ended up in loads of college debt, and she got some sort of lawsuit against. I can't remember the fucking thing. But the point is, I was just saying to Loggy, I was like, "What? I don't understand why they do this to them. So why would they even get into? So if you get there on a scholarship, fair enough. I understand that. It makes sense. But and he was like, well, they're thinking they're going to get a $200,000 a year job once they've, I'm like, oh, okay, but $70,000 in debt or something she was, and I was like, what? Fuck it, that's mental.
Yeah, that's what's going to destroy our countries, these next generations coming up, right? Like I was right on the edge of kind of that whole huge spike in college tuition and the push to think that everybody needs to go to college, and people taking out ridiculous loans and all this kind of stuff. Like I was right on the edge of those generations, right? But these kids coming up now, they all think that they're going to come out of college, like you said, minimum making $100,000 right out of college. Guess what? It's not going to happen in most fields that you go into. You're not going to start at $100,000, but they all expect it. And they've taken out all these loans and they've gotten degrees that are so generalized and everybody has them that it's almost the new high school diploma is a college degree. And I feel bad for the generations that are just saddled with a ridiculous amount of debt. I mean, you're talking I don't even know what the average student loan debt of somebody in the United States is, but I guarantee you it's upwards of $50,000 to $100,000 per kid coming out of college. It's ridiculous.
It just seems like, to me, I think they'll just be like, you go to university to get drunk and have sex.
Mission accomplished.
I don't know. Maybe I'm wrong, but I thought that's what it was all about. To me, you might as well just be a plumber or something. Everybody needs plumbers. Oh, we might not want to sift through shit. Electrician? No, you might die.
Right, but in this country, we have this whole push that like everybody needs a college degree, right? Like even people It's like we're at such a loss for people that are just going straight into the trades. Like, you can make better money than somebody coming out of college with 80 grand in student loan debt, and you have a degree in gen ed psychology, right? Well, guess what? The electrician's gonna make way more money straight out of high school and probably throughout his life. Same with the carpenter, same with the tradesman, like, no matter what the trade. But everybody gets sold this. You need to go to college. Everybody needs that degree. It's crazy.
That's why I said everybody needs a plumber. You know, from one time they're going to need a plumber. So, yeah, I don't know. Anyway, we're going to get these electric, the solar panels on the roof. That looks like the next move we're going to make here. So that seems to be the thing. I don't know. The bills here are just nuts.
Yeah, ours are going through the roof. So, do you guys have to connect to the grid there?
Oh yeah, it all goes back. Of course.
Yeah, see that, dude. I feel like they're screwing us. They're getting everybody to put the solar panels on their roofs to feed back to the grid. So we're paying for our own, like, if it's all connected, and every house starts to get solar panels, you are the solar farm.
Yeah, it's nuts, isn't it? It reminds me of a story my mum told me about. My dad had got this garage. We still got this garage, but back in the day, he got this, like, I don't know, water rates guy came down and came to the garage, and he was like, he's wanting to, give my dad a bill. And my dad's like, well, we've got no toilet here. What's the bill for? And he's like, well, you've got a drum there, and it's collecting water off the roof, the rainwater.
Are you serious?
This is in like 1988 or some shit.
What?
Yeah, he wanted to charge us for rainwater.
I'm sorry. We're here representing God, and we're gonna give you an invoice for that in which He had given you.
Oh
What
my
the
god.
hell?
Yeah. Anyway,
That's ridiculous. That's crazy, man. This is the kind of stuff that happens when we think that other men have authority over us. Honestly, a
okay.
lot of it
My
stems
last
from
thing,
that.
my last thing of the night is you said speculation. What's the next thing? Charging us for air. That's the next thing. I can
Instead of
just see it
bottled
now.
water, we're
It'll
gonna get bottled air.
Yeah, they get bottled air. That'll be the next thing. I just want some air, man. I'll suck your dick.
I got these cheeseburgers. That's funny.
Tell
It's
me
very
you're
possible.
referencing. Tell me you're referencing Spaceballs without telling me you're referencing Spaceballs. What do they have in that one? Cans of air. Yeah, he cracks open the can.
I forgot all about that. Yeah.
Yeah. Our radar's been jammed. Raspberry. There's only one person in the universe I know that would use raspberry jam. Lone Star.
1, 2, 3, 4, 5. Yeah, I used to love Mel Brooks, and I still love Mel.
Could you
Gene
get away?
Wilder.
Could you get away with, like, yeah, she's a druid, so she's a Druish princess. Like, you couldn't get away with this shit these days. Seriously.
Yeah, at least they had a container. Yeah.
They're out there combing the fucking desert. We ain't found shit.
The thing is, like you were asking before about what the next steps, what they might do next, but this is just my sense of it on one level is I feel like they had quite a gusto like going into the whole scamdemic thing, you know, like they were bold, they were ready to go and let you roll it out. And I mean, everybody obviously has different opinions about what all went down during all that, but I have a feeling like it was kind of a failure for them. As much as they pulled off 9/11, you know, so smoothly and these other things, you know, did that one actually go off smoothly or not? And people, of course, may have different opinions. I mean, obviously they pushed it so strong, just in the news and everything, to the point to where it seemed like it was effective to some extent. And they got a lot of people to drink the juice and all that. But how much resistance did we put up that they didn't think we were going to in the end? You know, even though there seemed like there was a lot of compliance, how much actual resistance was there that they were not expecting? And it makes me think if there was a lot more than they might have thought, because they kind of rolled back a lot of the mandatory juicings and all that. It seemed like that was their plan, to roll it out. Like, you know, in order to fly, you had to have it. I mean, that seemed like that's what they wanted. Now you could argue, well, maybe they pulled back on purpose to kind of make it look like they were pulling back, and then they're going to come back with another one in another year or two or something. You know, there's that speculation. But I guess where I was leading, I know it's kind of a positive viewpoint on it, to the point to where, like, were they a little bit stunned? And I don't really mean stunned like blown away. I mean like they're kind of like frozen a little bit after the last few years in terms of how we responded, meaning that it put it into a position where they realize that any next steps they take that are bold might actually blow it for them. Like, it's kind of, I feel like the bar is raised. Like, it's not really just like, you know, back in like early 2000s where you could just do 9/11, just get away with it and, you know, like crazy. Whereas now so many more people are questioning things and at least, you know, willing to at least consider what may have gone on. It's like they were so bold with the pandemic thing that, so yeah, just, I wonder in a sense, like, are they a little bit stunned in terms of, you know, knowing that if they, whatever they do next could really either make it or break it for them, let's say, perhaps. And then makes me think like maybe they're going to delay whatever next event they might have. It's just my sense of it. You know, I don't have any like physical way to validate that, but or are they just going to blast into something else? Because I mean, yeah, there is like a climate change thing they could do. They could do a whole thing with that and try to do lockdowns or something like that.
What do you think about the idea or the possibility that what took place over the past couple of years has just been a analytics test and a check to see if their simulations that they're running, how close they are to actual reality? Meaning they've probably simmed it through AI and a lot of other ways.
That's what I was thinking, you bastard.
Yeah. So it's like a litmus test as to whether or not their simulations, right? They're factoring in, okay, you're guaranteed to have at least 1% resistance. Let's start to get a little grainier on the resistance we're talking about. We'll meet resistance factors up till this point with 10% of people. We'll meet resistance factors up to this point with 25% of people. I think that's kind of what this was, more so than anything. And obviously many other things involved. I think there's many layers to every onion that they feed us, but yeah.
Yeah, for sure. I would agree. Yeah, like a whole kind of flexing test thing, and then to get more data and plug it into their systems. I hear you. I would agree that seemed to be at play. But what do you think the results were? Like, if they're sitting there looking at it all, like, is it looking more hopeful for whatever they want to pull off, or less hopeful?
I think so, because go ahead.
For them, it was positive, wasn't it? Of course it were. Most people went along with it. It's only small. I mean, yes, I know there was like, I don't know, they fudged the numbers, so it's difficult to say exactly how many people were marching and stuff like that. Like they'd say they were like 20,000 when they were like 250,000 in London. I'm talking about. So yeah, I think 1 or 2% is probably a good figure to put up, and I think they would have expected that as well.
No, I hear you on that. Yeah, I mean, you're right. Like most did go along with it during it. It seemed, we like those of us that were calling it out were really in a way the minority, compared to everybody that was totally going along with it. But it seemed like throughout the whole thing, a lot more people ended just like F this. It seemed like a lot of people did. Like, I mean, I know people that like just in my personal life I don't really have to name who they are or anything, but I'm just saying who, family members and whatnot who got the juice and the second juice and the whole thing. But now some of them are like, I'm not getting any more of those things. That whole thing was, now not that they're totally saying it was all BS or anything, but there is this like overarching. Now I know the hardcore ones are still in it. Even now we see them still wearing masks, so we know that those are still in it. But I mean, how many people that would have maybe been more on their side before this whole thing are actually less on their side now? And if that's if there's like a gap in the middle between people that are, aware of what's going on versus people that are just totally still following it, I think that's my sense of it, is that there's this huge like band in the middle now of people that were like, what has been going on? At least just questioning, just the questioning itself.
Yeah, a little bit for sure. Definitely people that are at least starting to question the system a little bit. But I think it was successful for them in a way, because when you think about the resistance that was met, let's be honest, it was very passive and somewhat apathetic of a resistance, right? And I don't think anything that they come with again is going to be on the exact same lines as this, right? Meaning most people think, well, when they do this exact same thing again, then people will stand up, blah, blah, blah. But I think the next thing that's going to come is not necessarily going to be this exact thing. It's going to be a different scare, a different boogeyman, a different thing. And since it's going to be different and not the exact same, I think there's going to be a lot of people that are, again, going to buy into it and blah, blah, blah. And the question is, at what point, how far can they push it without people actually starting to become non-apathetic? And I put myself in that category as well, because I never wore anything on my face. I never did any of that, right? And I didn't really change my lifestyle, even though I was forced to work from home, even though I had already mainly worked from home to begin with. But I didn't go out and march. I didn't get any type of, you know what I'm saying? There was no people's attitudes when you think back. One thing we don't realize, especially in this country, people took to the streets during this thing for a completely different reason. We've all forgotten that. Remember? I can't breathe. That whole thing.
Right.
So, I don't know. I think they got a good gauge of even if we did something that was way more intrusive, way more aggressive, obviously even the people that are totally against all of this and would go against us still seem apathetic enough to where we could probably push it. And I'm not trying to dog anybody because, like I said, I put myself in that category. At least on the most.
Yeah, no, I know what you mean. It wasn't like a resistance in that way. It wasn't like a huge kind of. Although, what do you think about when the truckers were refusing and then they were trying to drain their bank accounts, and because isn't that kind of when it all ended in a way? Like the whole thing sort of resolved around that time, and it was just. I know that was you could think of that as just one story, all the truckers are refusing to, they were all protesting and and I mean, how much would that actually mess up their system? Because the truckers were all refusing to get the juice and all of that. So, I mean,
I honestly think that whole resistance was actually born, bred, and controlled. To be honest with you. I
Okay,
don't
so
think
you
that
don't
was
think that was
grassroots.
legitimate?
No, I personally do not think so.
Yeah, there's definitely some spellcraft as well going on with that stuff, because there's some kind of, there is an upper respiratory thing, and I put it down to smart dust for several reasons. Now, the delivery system, I don't know. I've no idea. I've thought about that for many years, but there's definitely something. I just don't know what it is. I can't go into details of it because I don't really know what it is. It's all speculation. But my brother went for a thing, and they showed like a dark spot on his lungs, and they told him it was this thing due to smoking, and it wasn't. It wasn't that at all. He got a different, like a second opinion, and they diagnosed it as something completely different. And all the while, I kept saying to him, "I'm telling you, this is what it is. This is what's causing the upper respiratory." Because it weren't just us. I noticed this, across the board, everyone. And for us, it was Christmas 2015. 2015, that's when this, whatever it is, came on board, because I was newly sober, and I was very much aware of my surroundings and what was going on. And I remember it very well, because, normally I was shit-faced drunk all the time. And I remember I was terribly unwell I was unwell anyway. I was terribly unwell for a couple of years recovering from that. But I was extra unwell with the whatever it is that they poisoned us with, essentially. And I have a whole thing on this where it's connected to the juice. So, but I'm not going to go into it because it's pure speculation and pattern recognition. And it'd get bad once after the 2 weeks initial period, or a week or something, like a regular cold, for instance. Then what would happen is we got into this cycle where you'd feel like you're getting a cold, but then it'd start to go away. And I kept saying to my family, "Oh," and this is, say, a couple of years. Say after 2 years, I'd go into my mum's room, and I'd be like, "Oh, I think we're finally done with this, forever cold." Because it sort of start to come up, and then I don't know. You'd think, when am I going to finally shake this fucking thing off? And then it just come back with a vengeance, because you'd shake it off, and then it'd come back, and then you'd shake it off, and it'd come back. And I was just observing in many people around me the same sort of cough, and the same. All I can say is upper respiratory issues. So we've certainly been poisoned with something. It's just difficult to break it down. I don't know. I'd put it down to smart dust, but I don't know. I have no idea. But that's what they blame the thing on, and called, I don't want to say the words, but that's what they called the thing. I'll just say the thing. Everybody gets. I don't know.
Yeah, no, I don't doubt like the bioweapons being utilized in different ways, and yeah, you're
It's
saying
just
all the way.
difficult because it's just pure speculation. So it's like, oh, here we go, tinfoil hat. So yeah, I get it. I can only go with what I observed in myself and others. And of course, when you talk to them, they go, "Oh no, I had the thing. I had it. Did you though? Did you have it?" So again, I don't think this is a good topic to stay on, to be honest.
Yeah, Jesse's here.
Howdy.
Morning. It's 10 to 5 here, so I think I'm gonna get off. But I wish you all good night. So
Yeah, have a good one, Andy.
yeah, enjoy.
Yeah. Cheers, Andy. I think napalm in the mayhem categories, destruction and mayhem, if they ever tried to roll those out, like we've talked about, like if they did a climate change type of event of some sort and even trying to accelerate chaotic weather patterns, could be one. And then, of course,
I think they've been doing that.
The old fake alien invasion card as well.
Yeah, for sure. I think weather manipulation has been taking place for quite a while, and I think it's ramped up over the past decade for sure. Just in like flood drought scenarios. I've had a lot of weird weather patterns. Where like down here, we're almost in like a drought situation every year now until the rains start coming, and the rains keep getting pushed back, and they're less. I don't know. So when we get into the rainy season down here, rainy season where I live it's going to rain pretty much every single day, sometime between 4 and 6 o'clock at night. And it's going to downpour for anywhere from 15 minutes to 30 minutes to an hour every single day. And that used to hit a lot earlier in the year. And it was pretty consistent every single day. You're at least getting some sort of precipitation. And it's kind of changed to where now it's like maybe 2 times a week you're getting that precipitation. So there's been a huge shift, like very noticeable within the past 2 years, at least in my area.
Huh. Yeah, it's interesting for that area to have that. I mean, is that I don't really feel like that's common maybe for Florida to have drought issues. Like in
No.
the last decades, I'm saying. You hear that about
Right.
California, they try to claim that, but
No, it's definitely not normal, right? We're definitely behind on rain. So I don't know if that's natural causes or whatever, but it seems like a lot of places are also getting excessive rains. I don't know. Maybe it has something to do. Let's put it this way: if I had the ability to control the weather, I would certainly, if I wanted to make money, be able to place and hedge my bets on some of the commodities markets within farming districts if I know that I can create a drought. Because I could easily short some stuff. I'm just saying.
yeah. Oh yeah, definitely. They could take advantage of those imbalances in the ecosystem.
Right. Like if you know harvests aren't going to be good, you can hedge your bets on it.
Yeah, the climate change has just been such a huge agenda that it would make sense that they would have some, additional event that could be linked with it, just because they've been hyping it up. It's been one of the main, headlining issues, quote unquote, that they've made quite regular on the news cycles.
Yeah, so I don't really watch the news, but do you know what like ESG is? Have you heard of that? So
Not
it's
sure.
it's like this corporate thing, right? Like all the major corporations are getting into. So it's like environmental, social governance score. So corporations are being basically scored on their environmental impact. What are they doing for climate change? Their social impact. What are you doing for diversity, inclusion, blah, 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 all that stuff. Yeah. It's a huge shift in at least in the corporate world, to this ESG initiative.
Yeah, and I was just looking at the Wikipedia. It looks like it was all rolled out in 2020.
Yeah. Right along with the other thing.
Since 2020, there's been accelerating incentives from the United Nations to overlay ESG data with the Sustainable Development Goals, SGDs, based on their work, which began in the 1980s.
So you've been around, right? Remember Agenda 20? This is all that same shit. It's exactly what us conspiracy theorists 20 years ago were talking about with Agenda 20.
Yep. Are you talking like Agenda 2030?
No, back when it was just Agenda 20. Do you remember those days? Have you been around? Back in the 2010 time frame when it was just Agenda 20? Actually, even before that, 2008, early 20s, 2000s, early 2000s.
Well, I guess Agenda 20 isn't ringing a bell. I know there's Agenda 2030.
Yeah, it morphed into Agenda 2030. It's the same thing, really. But back in the day, it was just called Agenda 20. And then when I think they didn't get it all taken care of, everybody assumed Agenda 20 was I don't know, didn't have necessarily a specific date. And then we thought, oh, well, Agenda 20 is going to be by 2020. But I guess that got met in a way that, I don't know. Maybe they just updated it.
Yeah, I was trying to search Agenda 20. I couldn't really find anything unless it's something that wouldn't be just on a regular search. But I did find this thing, Agenda 21.
Oh, yeah, 21. Sorry.
Is
Agenda
that it?
21. Yes.
Well, that rings a bell. Agenda 21. Yeah. That for some
Yeah.
reason 20, I was
Sorry.
my brain was trying to search for it.
Sorry, my bad. Yeah, Agenda 21, which is sustainable. That all those keywords that we are also used to now. But yeah, I found out about Agenda 21 way back in the day.
So are you linking this so if they rolled something out, which they already have all of these corporate, these new structures in place, you're saying that, were you linking that if they rolled out some kind of weather, climate change type thing, that they would already have kind of the noose is already hung, as it were, for the corporations, whatever financial type control that they would then enforce with it?
Yep.
And then be able to be like, oh, all right, your company doesn't match it. Oh, you're the mom and pop store that can't pay for the higher insurance or whatever it is. Okay, you're out. This huge, Walmart. Oh, of course, you pass all of the requirements.
ESG requirements. Yeah.
Yeah.
And then we get the Walmartification of everything, or the Amazonification of everything. Yeah.
Yeah, that'd be crazy if they did that, tried to roll that out.
I mean, a bunch of large international corporations are already doing it. It's already ingrained. I'm not gonna lie, it's on my screensaver at work from my corporation I work for. Yeah. It's already there.
Obviously, all just total speculation, but I mean, if there is some kind of order that they're going to roll, if there is an event linked to climate change, and if there's even a fake alien invasion thing, could make some sense just on a logical level that they would link those, if they were to do sort of a climate thing, which they already have these things in place to limit corporations and to try to control that in some way. to kind of create more of like a flow of products basically and resources to, through these larger corporations, like even more so than is now. And then if that was linked to like financial reset as well, which might hit some of the, more mom and pop shops and things like that. And then if they were to then roll out an alien invasion thing now, whatever resources people are going to be grasping for, or even more so controlled by these big organizations, that'd be pretty dark and evil if that's kind of what they're cooking up.
Yeah, I think that's a bigger aspect than most people think, is kind of the corporate governance side of it. Like, I don't know how tapped into that side of the agenda the whole truth community actually is how ingrained these corporations are in pushing all of this stuff, I guess you could say. Because if everything continues to further consolidate, at some point everybody is reliant upon companies that adhere to this and toe the party lines, whether the people disagree with it or not. Do you want to get paid? You have to agree with it. The corporate governance kind of side of it.
The corporate credit score.
Yeah. I mean, think about it. We're already voluntarily, I say we, but I'm not involved in this, voluntarily linking in with people solely based on a employment scenario, right? So we're linking our social and our employment realms, like the lines between your personal life and your business life are constantly being more and more blurred, especially with sites like LinkedIn and things like that, right? So imagine if the score not only if it trickles down from the corporation to the individual, right? And once it's on the individual level, if everybody's playing the game, what's your alternative? How do you find employment outside of it? You know what I'm saying?
Oh yeah, for sure. It's all interlinked a lot more now than it was for sure, like in the 90s. And
yeah. But think about they're starting out with the corporations that have the ESG score. And then when the individuals start to have the ESG score, then how much different is that at some point than like the Chinese social credit score? Where's the line? When do people start drawing the line? Right now, you can't really draw it if you rely upon the income from a corporation that is towing that line to begin with. And how far away how far away are we from every company having to toe that party line?
well, just totally in speculation, but yeah, if they did roll out some kind of a event linked to climate, would that be a possible agenda of trying to get like every company on board and use the climate threat crisis as a way to kind of force people to take the juice, if you will?
Good point. That's not a bad guess as to what the next play might be, being an environmental, because technically what took place previously could be kind of categorized under environmental, but not really. But yeah.
Well, it was like a product of the environment. Yeah, it was like a control of like stay away from each other and put things on your face and be afraid of your neighbors and all that.
But maybe the next one is environmental. Yeah.
When I meant take the juice, I didn't even mean like an actual juice, like the same juice as before. I'm just saying like, yeah, get everyone to kind of swallow the pill of more control in the financial sectors and the corporations. How crazy would it be if something happened and then it's like we're all just allotted a certain amount of toilet paper from the higher ups? I'm just kidding, but
we get our TP stipend.
Yeah. Well, like the equivalent, I guess, of taking the jab in this last event, if they were to do something like this in the realm of this, is, sort of forcing companies to take these, possibly new regulations built around more financial control and control of the resources could be possible. So whatever that would look like, and forcing companies to get on board with it, in which they can then just kind of separate the classes even more, and then everybody working from home. And like you said, like the last few years kind of was environmental in a way. I know what you mean. Like it's not really like the same way they describe climate change in terms of that environment, but it is like the related to the environment and how we interact with it and how we need to change our lives and restrict our freedoms based upon what they tell us the environment is, the status of it.
Yeah, I mean, I don't think it's any coincidence that the increase of EVs or electric vehicles has come on during and on the tail end of this whole entire thing. Yeah. I think there's many facets to it, and their environmental agenda that, as we all know, has very little to do with the environment is being moved along. I mean, I don't know about where you're at, but the amount of EVs in my area has grown exponentially since we all started coughing.
Yeah, there's definitely a ton of them here as well. Seems like almost every other car is a Tesla, but not quite that ridiculous. But yeah, they're everywhere.
We're getting close here, yeah. Do you think that's a move to... My opinion is that's just the next step before people just decide to not even like actually own vehicles and just start renting rides to begin with on the regular.
Yeah, it could go that direction, like trying to get more people dependent on the system for transportation.
Yeah.
So now you have to be allotted a ride and your TP allowance to even get your TP. Oh, man.
Don't worry, your TP will show up via drone.
Like, I only have 2 rides left this week. We have to get toilet paper, and we also have to get milk. Which one are we going to get? I mean, the most positive part of me, because I know that like they do have the ability to cause quite a bit of mayhem, like a world, like I mean, they could go all out. They could do a World War III type thing, but make it like a climate and then end it in an alien invasion. I mean, they could go pretty crazy, but just for like the sake of trying to focus on the best possible outcome, I'm just kind of praying for them to just sort of delay things for a couple years and not really roll anything out too quick. Like, I mean, it doesn't seem like they're quick to do much after the pandemic, right? I mean, that's just the sense I get. I mean, you said you don't watch the news. I don't either. So yeah, I literally haven't seen the news in forever. I mean, I see news in other places, but I don't sit and watch it. So I don't quite know what the whole tone of it is, but it seems like they're kind of not doing much overall. Like on that level, I'm saying.
I think it's baby stepping in many different facets, right? Just baby steps. We might not see a lot going on right now. Like there was that big push, right, over the past couple of years. So we feel like it's kind of like slowed down a little bit. But I think things are taking place in other sectors right now, like financial sectors and things like that, that we might not be fully aware of, right? That are kind of being set up, the CBDCs, all that kind of stuff. So it's just like little baby steps here and there. You can't overwhelm the people too much.
Yeah, I mean, I think a financial reset is definitely going to happen. What that would even look like, but yeah, with the CBDC situation and the currency in general. I mean, I don't know how soon it would be that they'll do anything major, but it does seem like some kind of shift out of the fiat dollar and into some other currency that would be like kind of linked to it, but not directly connected to it.
Yeah.
Kind of a branch off that would be more able to be controlled. But then I think of, are there other blockchain networks and things that could maintain some level of honesty and transparency of other networks we could use if they rolled something out on that scale?
Yeah, I think the biggest hurdle that's taking place right now, I mean, we see something like XRP having this lawsuit with the SEC that's been dragged on for years, right? At this point, pertaining as to whether it's a security, whether cryptocurrencies basically are securities or are they legitimate, mediums of exchange, blah, blah, blah. I think this is all kind of a ruse or a guise to allow for them to get all their ducks in a row to figure out how they will be able to operate on a system in which everything is transparent. Because right now, the shadiest people with money aren't your neighbor who's running a cash business or anything like that, or somebody in your neighborhood that's trying to avoid a little taxation by maybe saying one or two things on their tax forms that may or may not be correct, blah blah blah. You know what I'm saying? That the biggest players are way more concerned about the visibility into their transactions than the average person is. And they're trying to figure out how they're going to come out ahead by being fully transparent. How are they going to continue to fill their coffers by not being able to play the game the way that they previously did? And I think that's just kind of what's in limbo right now. And once they figure that out, they're still going to be getting theirs. We're all still going to be getting screwed. It's just, how are they going to be able to do it in a transparent way to where we've bought into whatever it may be, a tax on every, like a transactional tax that's going to seem like it's not going to be much initially and people will buy into it, but will eventually be, the stranglehold that they've always had over us, I guess you could say. So their transition into this digital world and how they can continue to fill their coffers with the form of transparency that's required in order for them to control everything that we do.
Yeah, it seems inevitable at this point that they were going to push something within that realm. Like, I don't really see how they can continue the way it is right now into, the integration of systems that they have more control over than they currently do.
Yeah, because the blockchain requires transparency across the board, right?
Yeah, it's like the current systems are too clunky for them. It's too split up.
Yep.
all these different areas and kind of territories of finance. And then if they were, like Andy mentioned, some kind of social credit score thing, which they're already doing in China, and they're already kind of, you're saying the testing ground, they're already rolling it out there. Like, to get into Hong Kong, you have to have like credits. If you don't have enough credits, they don't let you in. You can only stay for a certain amount of time unless you live and work there.
Jeez. Do you think it's going to go full like Brave New World kind of scenario? Or you're going to have people that are going to be part of the system and then people that are just going to be completely withdrawn from it and they're completely isolated in their own sectors?
Well, I've wondered that. Yeah, I mean, just totally in the realm of speculation, thought about like this whole idea of smart cities, and that they want to have these cities that are going to be super hyped up in terms of, just control and, like probably nobody owning a car and having it all just be transportation within the city, and then having like extreme amount of control within those smart city regions. Maybe they could, the air over here is safe, whereas if you're out there, you could get sick or you could whatever. Meanwhile, they're spraying bioweapons and chemtrails out in the rest of the land. Who knows? I mean, there's so many like movie plot level ideas that like could, but I mean, but I was just saying in general, if they did that kind of smart city focusing thing, then could that be even good though? Like in a way where like they kind of leave the rest of us alone a little bit more while they focus on their smart cities, and the rest of us can live, out in nature. Or could it go the opposite way and they could really try to like hard nose everybody, into those regions and then try to make life worse for everyone else, on the outside, as it were?
Yeah, I wonder. So, are you familiar with the book by Aldous Huxley, Brave New World? Have you read the book or seen the movie or?
Yeah.
Yeah. So the thing about that is there's no real he doesn't tell you how they got to the situation that they were in when that book starts, right? So they're already in this kind of utopian-ish kind of scheme, right? Where you have this kind of quasi-fascistic government that's segregating people basically into their own classes, the alpha, betas, gammas, all that kind of stuff, right? And you have this appears to be on the surface the perfect world within these cities and this quintessential utopia, and then you have what they call the primitives, which they actually take not vacations or whatever, but like trips to go see the primitive people, like via like trains or something like that. I can't remember how it is in the book, but they basically take these trips to go visit the primitives or look at them from a distance. And the primitive people are basically people that are what do they call them? Savages? Maybe they call them savages. I can't remember. But they're basically people that are minding their own business, living off the land and doing their own thing. But it doesn't say how those cities were established or whether there was how the divide took place kind of thing. You're already there when the book starts. So I wonder, do you think that's kind of their plan in a very generalized way with these 15-minute cities or these like megatropolises where everybody's kind of crammed into cities, and then you have this complete disconnect between people who chose not to be involved in this system?
Well, it's interesting to think that, I mean, people do talk about Aldous Huxley's kind of connection to Tavistock and some of these other connections, but whether he just pulled that out of the ether or whether it is some deeper kind of narrative that he's connected with. But yeah, it's hard to say like whether it really would go to that direction. I mean, the thing is, there's so many people living all over the place, like outside of cities, obviously. So it's kind of wild to think that something could change that dramatically, to where there would actually be like that level of a divide. I mean, people are pretty spread out in a way. I mean, people are obviously close to cities, but I have a hard time seeing how they could fully pull that off. Although it does seem like the whole concept of smart cities seems to be one of their focuses, and all the terraforming they've already done. I mean, like the city of San Francisco has been totally changed. Of course, San Francisco is the closest to Silicon Valley, so there's a huge desire to control that city. But I mean, even within the last decade, 10 to 15 years, I mean, I have seen it change dramatically, and many other people that live in these areas. I mean, San Francisco used to be a cool, even the kind of hippie town vibe. There was a lot of like open-minded and, artists and creative types. And it was like a melting pot for, spirituality and music and art and all of that. And I mean, within literally a decade, San Francisco has totally changed. I mean, the cost of living has gone so off the charts that only like probably wealthy tech people from Silicon Valley can even live there. Most dramatic, I mean, maybe even 80% or more of people that used to live there that were, musicians and artists and stuff have just had to leave just because of cost and the other restrictions. Like they tried rolling out the juice mandate thing there too. But I mean, San Francisco has changed dramatically, like just in 10 years to where, it used to be, much more of a free, open kind of city vibe to this, like, more of a kind of dystopian undertones. And so, it's crazy just to see that alone, how much that's changed. And now that's kind of one of their main focuses because, of course, it's closest to Silicon Valley, which is the sort of tech control of the world. So, I mean, is that like a small sample of what their larger agenda is?
Possibly, right? So when you think about like what we were talking about earlier with the like ESG and the corporate credit scores and all that, is that if we continue to see the consolidation of more and more of what we are purchasing into smaller and smaller companies, right? Mom and pops going away, the smaller everything kind of going away, and these larger conglomerates, and all of them are on board with this kind of like ESG and these scores and implementing that into their employees. To me, that could be the beginnings of how a divide could take place, right? Because you either need to buy into that system in order to be able to live, or you choose to not be a part of that system as it starts to incrementally be implemented. And I think it's going to be a slow implementation to where before you know it, you're so ingrained, and how do you pull yourself away from it kind of situation.
Yeah, or if you didn't go with it from the beginning, then you're kind of not like grandfathered in.
I think it's fair to say. I think it's fair to say, Napalm, that they're not targeting our generation. They're targeting, the next generation or two generations from now, where we'll be removed from those ideas and they will just simply be ingrained into them. We're not the target.
Correct. I mean, I don't know how old you guys are, right? But I was just thinking about it today when somebody brought up something that was going to happen in 2040. There's some road construction out here, and it's like, oh, we're going to expand this to this area. And I'm like, that's going to be fantastic. And my buddy's like, yep, just got to prove that's going to be in by 2040. I was like, shit, by the time 2040 hits, I'm going to be fucking 60 years old. Like, it's not for our generation. We're going to be on the downslide, and these Fortnite generations are going to be coming up and totally bought into it. I agree.
It's funny you say that. We're in my city here. We're building, the biggest hospital the city's ever seen, and the timeline for the project is 2023 to 2045. So, like, when I'm going through this and I'm thinking to myself, like, how much fucking shit can change between when you start this and when you finish it, that it almost seems like it's going to be out of date by the time it's actually done.
Oh yeah. Yep.
You got to talk about the generational thing. It kind of trips me out when I think about the generation that grew up in the sort of pandemic mindset. And it's like, is that sort of the cutoff point of what they're aiming for? You know, when those kids are all 15, 20, 30.
Well,
Probably.
I think our hope for them is similar to us. You know, a lot of us grew up more on the liberal side of things and being more free flowing. And it's funny how as we get older, we follow the same trend as our parents, and we typically turn more conservative. I think, as you know, the kids. I don't want to say kids, but younger people often have this idea that they don't. How could I say it? They haven't had the value of earning their own dollar. And I think once you start earning your own money and you start seeing your money being siphoned from every fucking corner by different government entities, that you start being jaded. So we can only hope that those younger generations feel that same resentment that we do currently with the way things are, and that you know, that manifests in some kind of worthwhile change. But I can't say I'm hopeful.
Yeah, I kind of agree, but I feel like they're going to be so much more tokenized than we've experienced. And when I say tokenized, I mean the value of their dollar is not going to be like a term that they're even going to comprehend the way that I think they're going to be compensated in the future.
Yeah, I totally agree, and we're perfect examples of it. I mean, $100 to our parents was a lot of money. $100 to us isn't. $1,000 might be a lot of money to us, you know, but $1,000 in the next generation, the way things are going, might not really be all that much. So you're right. Like, there's just a completely devaluing of the worth of money.
Well, that's why they may have to do some kind of financial reset and send it into some kind of a CBDC or some kind of a different digital currency that could relieve them of some of this excessive inflation that's causing more issues for them to be able to maintain that level of control with this level of inflation.
Yeah, and unfortunately, you know, kids they need to learn real quick. Hopefully, they learn this, but they need to learn real quick that they need to start having fucking kids if they expect, you know, these social services. Because if they're not having kids, man, those social services will crumble because nobody will be able to contribute or, you know, actually work in them. Or we go full communist, and it's like, well, if you want to have your universal basic income, well, you're gonna have to work in some shitty ass fucking place that'll get you absolutely nowhere.
So I know you're pretty like strong on the globe idea, but you do think there is like an orchestrating group or cabal or whatever. I mean, you do you're aware of that.
Oh yeah, yeah. I fully believe that there is a group of people. You were talking about those fucking what do you call them? Those I call them the woke points. They're you know, like those companies who basically get kickbacks for being woke. We'll call it that. I mean, it's not really the right words, but like those. Yeah, ESG scores. So those you know, the way I see it is those are deliberately used to control big corporations in a way. And by big corporations, I mean like you have these massive investors that own operating rights to those corporations, and in order to keep them in check, you buy them off with profitability, because what do big corporations care about? Profits. So it's like, well, hey, you know, buy into this and we'll give you tax breaks, or we'll give you this, or we'll give you that, which bolsters, you know, profits. And as soon as you say bolsters profits, you know, those people, any semblance of sanity goes out the fucking window. And you know, this shit allows to happen. Hopefully, with, you know, Bud Light and Target and to a certain extent Walmart, this kind of damage that's been done by this huge pushback against it will maybe have corporations realize like, hey, you know what, I don't actually need this shit to be profitable, and maybe move away from it. But at the end of the day, a $1 billion corporation will want to find any kind of profit it can, and they will use these stupid woke programs to get there. And I think that, to me, is the biggest problem with it.
Right. It makes it very difficult for any other company to compete with them if they're getting those kickbacks. It says right here, this is from the Wikipedia page for ESG. It says, in less than 20 years, the ESG movement has grown from a corporate social responsibility initiative launched by the United Nations into a global phenomenon representing more than 30 trillion in assets under management. In the year 2019 alone, capital totaling $17.67 billion flowed into ESG-linked products, an almost 525% increase from 2015, according to Morningstar Incorporated. So yeah, I mean, how is anyone gonna how is any mom and pop or any other corporation or company, going to be able to compete? That's kind of what happens. Like, slightly different, but like in like chicken feed, for example, like corn, wheat, and soy are like government subsidized. Those grains are subsidized by the government to make the feed affordable for a farmer to then feed their chicken that feed, so that they can put the eggs on the market and be able to compete. But it's like they're cornering you into it. Like, you have to use corn, wheat, and soy to have your eggs cost X amount, XX whatever, to compare with the other eggs on the shelf. Otherwise, if you're trying to feed your chickens not those genetically modified type things, like you want to feed them, sunflower seeds and black beans or something like that, it's going to cost you hundreds of times in total, tens to hundreds of times more money. And then the eggs are going to cost, $40 a dozen. So it's sort of like they pigeonhole you in with their government subsidies and things. So yeah, this ESG thing seems like it could be a huge component, where if like certain products have to be certified through it, and then those companies are getting those kickbacks and getting to the point where they can still be profitable, but other companies that are making products, similar, potentially will be boxed out. I mean, that would be sad if they took it to that next level, because it's already been happening, trying to take out mom and pop shops and all that. But it'd be intense if they tried to do it to that level.
I think this is the platform they're going to utilize to do that, to be honest with you. Because it ticks all the boxes. It's not only environmental, it's social, it's everything, all wrapped into one.
And it allows manufacturing to be funneled into one plant, which it's like, well, these two or three production facilities are going to be taking care of all those products, so that these major investors who are spending these billions of dollars on these production facilities are able to streamline their stuff. And if you buy from that sort of group, if you will, you'll get kickbacks or you'll pay cheaper. I already see that in the construction industry where we are. They form these kind of like buying groups together. So it's like a bunch of companies and contractors will come together and create a buying group that allows them to buy a large number of volume to be able to reduce their cost of material. So on a surface level, we're already seeing that. I can only imagine it'll get worse and worse as they get their grips on our production and because that to me is where the next place it's going is in production, if it's not already there. And to me, this is I'm as a Canadian, I wasn't a huge fan of Trump because I thought he made Americans look fucking stupid. Maybe a little bit less than Joe Biden, but I did think the way he talked made people look stupid. But some of the things he said, man, were so fucking spot on, right on the fucking money. And I think that's part of the reason why he was just so targeted. Apart from the dumb shit he said, but like people saw him as such a threat because he was exposing this bullshit. Even though I think Trump is part of that group, I don't think he's as ingrained in it as some of these corporate investors that have billions tied into these companies. And just a mere fact that before COVID, Trump was like, hey, it'd be smart if Canada, the US, and Mexico come together and create a worthwhile trade agreement between each other. Mexico can more than handle, the production that's being done in China. That's bullshit. China doesn't do it. And for a cost per labor, Mexico is actually cheap and it's much closer, so we don't have to haul this shit halfway across the world. Canada's got an abundant amounts of resources that can sustain all three countries, all the way, or even all five countries or six countries down to the Panama if you really want to, which is what he wanted to do. So it's like, why are we relying on people outside of North America? And then COVID hits and it puts such a spotlight on what he was saying, where we needed masks from fucking China, the country that started all this bullshit to begin with. And in North America we couldn't get fucking masks because we were dependent on who? Fucking China of all goddamn countries. So to me, this is where he was spot on his stuff. It's like, bring stuff back here, quit being dependent on these other countries that have zero vested interest in your future, and take control of your shit. And I apologize. I babble a little bit when I'm stoned.
No, you're good. I talk a lot too. It's all good. No, but you're right. It's I feel like they're starting to equalize globally the haves and the have-nots, meaning a lot of things are transferring to other countries as much as possible to reduce cost for these corporations that are basically most every company that we deal with on a daily basis is it's an international corporation for the most part. It's not just here in the United States. Meaning they're going to source everything as cheap as possible. Everything is
Yeah.
going to reduce here.
And listen, I can't fault a company for doing that, right? Like, I can't fault a company for wanting to increase its market share by going into another country. I don't think that's inherently wrong in the sense of business. But I think those companies should still, go. I think they should still favor the countries that set them up in the first place. And I think that's why I think a lot of places they kind of fail on that. It's like, well, we made it big in Europe, or we made it big in China, or we want to make it big in China, so fuck the U.S. and we're going to focus on China.
Yeah, I mean it's a downfall of an increase in technology, to be honest with you, and it's just a kind of the way things are going to shake out for sure. The more connected we are, the easier it is to shift money towards cheaper markets to be able to supply things back. And I mean, but at some point, when does the demand get reduced so much that everything is no longer? We have such a disparity right now, I guess you could say, between the demand that is coming from some of the Western countries that is being supplied by some of the more third world countries. And when does that shift so much? Meaning, at what point does the average Western consumer become so poor that they can no longer sustain the things that are coming from the third world countries? The third world countries get up to the point where, you know what I'm saying? At a certain point, there is an equilibrium that will be met. And
Yeah,
is that
I totally agree. Pump enough money into a third world country, it won't be a third world country anymore.
right? And
And
then
that's kind
do
of what.
they become the same thing that we are slowly not becoming, right? And then is it the shift to, does the pendulum keep going back and forth?
Yeah, who knows? I have this theory too. I don't know. Maybe you and Gio will like this one. So, I take issue with Western countries posturing their environmental bullshit. And part of the reason why is because what they do is they posture that that they're being environmentally friendly, but they shift all of their dirty manufacturing into third world countries that aren't part of these environmental agreements, and they pollute for us. And I can't remember who it was. It was a president or some head of state in Africa or somewhere, and he gave a speech one time, and he's just like he's like, these Western countries, they come to our country to have all their goods produced for cheap, but really it's not because it's produced for cheap. They could produce it for cheap in their own country. The reason why they don't want to do it in their countries is because they don't want to pollute their own country by making cheap shit. So they come to our country, they think they can run over us, and then they wave the cash around, and they build these factories and dump all their chemicals into our rivers. And when hearing him say that, it just kind of opened my eyes, where I'm like, there is a lot of truth to that. All these, the U.S., all these European countries, Canada included, they wave the virtue signaling flag that they're all for the environment, but really what they're doing is just shifting their pollution elsewhere in the world.
Yeah, no, I agree. That's why it can be quote unquote cheap. What are your thoughts? Your thoughts is, I guess you could say, everything's going to continue to tiptoe, and it's going to be the next generations that are going to feel a major impact, more so than we have.
Yeah, I think I think we're just not the target. They don't really care about us, man. Like I don't know how old you are. I'm 33, so I'm what I refer to as sort of a transitional generation. So I grew up both with the internet or without the internet and with the internet. So I'm like I have experience in both worlds. They don't give a shit about us, man. What they care about is my kid. I have a 5-year-old daughter. That's their target, right? That's the person they can shape. That's the person they can mold into whatever they want in 30 years from now. Me, I'm just a taxpayer. I'm just a cog in the system that makes it go around, and there's really nothing I can do.
Yeah, no, I agree. I grew up generation before you, but yeah, I agree. We are not the target. We will start to feel the pinch, but it's the next generations that they're really working on. They're doing a good job psychologically with these next generations. That's for sure.
Oh, I agree. I agree. My kid is in for a weird fucking world, man. And listen, I'm sure generations before us said the same thing. Our parents who, they grew up most of their life without color TV. Fuck, they're like, oh, TV is going to corrupt the kids, or computer is going to corrupt the kids, and they weren't wrong to a certain extent. So we're going to say the same thing, but it's just, to me, it's at the rate at which it's happening. Because think of all the technology we've gone through. We've gone through no internet to, I don't know what the hell came before dial-up, then broadband, then high speed, and then whatever the level of high speed we are now.
Yeah, I don't even know. Yep, I grew up in zero internet time.
Most kids these days don't have parents that can teach them the basic necessities of life, and that's what's wrong with our current Gen Z population.
I don't know, man. I'm 33 years old, and I don't know too many fucking people that have the basic ways of life outside of the system. Is what I'll put it this way. I know plenty of people who are very successful playing the game, as it's currently played. Take them out of the city, take them out of that system, stick them in a bush. These people are fucked. But how many people are living in the bush nowadays? Not that many.
Yep. Mainly just the homeless population.
Yeah, you sound younger. I'm pretty sure it's your parents' fault, right?
Well, it's always the parents' fault, but it's up to you to change the generational karma.
Sure. Yep. I'd like to think that the average person has the ability to affect that change, but it seems like the changes that our societies take are definitely controlled from the top down. At least the last 4 generations have. Don't think it's stopping.
Yeah, if you like history, it's a bit of a deep dive, but there's a lot of links about, how can I say it? It's fascinating to hear the different stories post World War One versus pre World War One. And I'm not one of them people who thinks that fucking Nazis run the world or anything of that. And I'm not a big conspiracy theorist guy. But I also think that World War II showed every country, whether or not you're friends with them or not, showed every country the absolute power of propaganda and how to use it properly and how to do the slow burn like the Nazis did, and just it kind of showed the world how you can fuck with people and get people to do things that in other cases wouldn't necessarily do it. And just the shift in media, the shift in just the subtlety of it, the slow overexposure to over sexualized things. It's pretty fascinating. You kind of have to spend a couple months looking into it, but there's a clear link to me, in my opinion, post World War II, and how media and how we're communicated through by our governments and media in general.
Yeah, the psychological warfare is it's been perfected at this point through propaganda, through television,
Through
internet,
subtle
social
yeah,
media, all that shit.
yeah, through subtlety, just through quick imaging, just even flashing something for a few seconds can trigger something in people.
Yeah, I mean they perfected that over the years with during wartime for sure, certainly.
Well, it's because they had plenty of ways to test things out on people. Unfortunately, at the cost of a lot of people, but they got a lot of data. Same thing with our medical. You look at medicine in general. The difference between pre World War II and post World War II, man, is absolutely insane. And where the fuck do you think they got all the data to use and what the lethal doses were for all those fucking drugs?
It wasn't from rats, I'll tell you that much.
Yeah, exactly.
Anyways, I'm fading. I'm getting ready to go to bed. Y'all have a good evening.
Cheers, man.
Cheers.
Yo, microphone check. Anyone still here?
I'm here.
Yo, what's up?
Not much. What's up with you?
Just got back. Had to babysit the dogs for a little bit while the fireworks were popping off.
Sure. How's your night going?
Good.
Good. It's raining over here. It's been raining for a few hours. What's your view on the Earth?
I'm actually headed to bed, brother.
No worries.
Peace, G.
Have a good one.